This is a Taiwan coastal defense fast attack craft that we're going to talk about today. They're going to make 12 of these total. They've made 7 so far. It has a unique catamaran design, allowing it to achieve very high speeds due to its powerful engines, water jet, and its lightweight. It operates a 76 millimeter naval gun on the bow and a phalanx 20 millimeter close-in weapon system on the stern. Some of those are the Fang 2 anti-ship missile, Fang 3, which we'll talk about in detail, and the TC-2N surface-to-air missile. They can have a combination of those 3 types of missiles on board, and we'll go over how they set that up today. The Mark 32 triple torpedo launcher is on Hull 1 only, so we'll be talking about that torpedo and that system. Just know that only one of these, of the 12, actually has that. There is a helipad on the aft end, so helicopters can come and go, drop off supplies if necessary, or pick things up, but there's no hangar for it, so there's no place to safely store a helicopter at sea. And these went into service in 2015. Let's talk about the weapon systems first. Here we have the Malera 76 millimeter naval gun on the bow. Amidships, centerline, pointing port and starboard at about 60-degree canted angles, are 4 quad deck launchers. These shoot the Fang 2, Fang 3 anti-ship missiles, and those are 2 different ones that we'll talk about, or the TC-2N surface-to-air missile. And behind that is the phalanx. Here's a great picture of the deck launchers and their configuration. Here you can see how they're very containerized, they're modular, and depending on what module they put on is the system, the weapon that's going to be launched out of it. And you can see how physically different each one is. The Fang's anti-ship missiles are much larger than the TC-2N medium-range surface-to-air missile is, but they use the same mounts, and they're always going to be a quad pack. It could be a 4/4 like we see here, or it could be a 2/2 for the anti-ship missiles. Now let's talk about sensors. We have on the bow, above the bridge, a fire control radar called the Steer EO Mark II. Steer is a single target illuminating radar, but it also has electrical optical sensors to guide it. The SPS-1 search radar is on the mast above that, and at the very top is the SWR-6D electronic support measures, which is a sensor that simply listens for other radar information out there, so they know who's transmitting and who's not. Aft, we have the MPQ-90 multifunction radar, which is an ASA radar, and the Model 90 ALOF's towed array sensor can be dragged aft of this ship. So there is some sonar capability here. All right, Tuo Chiang's corvettes were commissioned in 2014 through 2024. They've built 7 so far. They're going to build a total of 12. All made at the same shipyard. So Tuo Chiang's corvettes, by the numbers, it has 4 marine diesel engines in a combined diesel and diesel configuration. So they could run one, they could run all 4, and they don't need to stop any operation to do that. They can bring these online as they want to. Those diesel engines power not just the ship, but 4 water jets that push this catamaran-style hull through the water at 43 knots. Its max endurance is 4,000 nautical miles, but only at 15 knots at that speed. She has that 76 millimeter Super Rapido naval gun on the bow, the Mark 15 Phalanx 20 millimeter close-in weapon system near the stern. Hull 1 only has 2 triple launchers for a total of 6 Mark 32 torpedo tubes, 3 port and 3 starboard for anti-submarine torpedo launches. The deck launchers are a mixture of Fang 2, Fang 3, and TC-2N surface-to-air missiles. On the sensor side of the house is the MPQ-90 multifunction ASA radar, the SPS surface search radar, and the SWR-6D ESM. The Steer EO Mark II fire control radar is used for directing things like the rapid firing gun. The Model 90 ALOF's towed sonar array is towed behind this vessel. The fixed launchers for infrared flares and chaff are on board as well, but we don't have any photos of that for you. Just know that there is some defensive capability for these ships. She does have mine laying capability, which is important. And of course, the helicopter can come and go, but there's no actual pad for it. They can use their unmanned aerial vehicles, which is basically an unmanned helicopter, to come, or a drone, to come on board the ship. Here is the Marine diesel. It is a 20-cylinder diesel. They have 4 of these. They generate 4,300 kilowatts of power each. The MPQ-90 radar is in-house, created by NCSIST. This is the primary institute of technology that makes all weapons systems and the weapons for Taiwan. It's the primary one. This is a short to medium range 3D air defense radar. It uses an active electronically scanned array, or an ASA array. And the fact that they got an ASA array this small and light to put on a corvette is a testament to how good Taiwan is at miniaturizing this technology. This is a very compact but powerful radar. The maximum detection range is 60 kilometers, and that is used for guiding the TC-2N air defense missiles onto target, and of course, detecting targets as well. Here's the Steer EO Mark II fire control radar by Thales Nederland. It's a combined 3D fire control radar. It operates in multiple bands. 8 to 10 gigahertz is the I band. The K band is 20 to 40 gigahertz. This does have an IR camera on it, as well as the radar itself. It can spin 360 degrees, lock onto a target, and take that fire control information for the target and give it to the combat control system. It's been in service since 1992. Hitting those targets will be this gun here, the 76 millimeter naval gun on the bow. Fires, with the upgrade package, 100 rounds per minute. It fires many different rounds. There's standard high explosive rounds. There is a pre-fragmented round and a SAPOM extended range round. And with that extended range round, they can hit up to 20 kilometers away. But the HE round has a max range of about 16 kilometers. They have 80 rounds stored on board, and this gun IOC'd all the way back in 1963, but of course has received multiple updates over the decades, but is a very reliable gun on many, many ships. Speaking of reliability, the Phalanx close-in weapon system is an amazing, reliable Mark 61 Vulcan rotary cannon mounted on a radar with a electrical optical sensor now that can shoot up to 4,500 rounds per minute, depending on the mode that it's in and what baseline they have installed. This Sea-Whiz, IOC'd all the way back in the 1980s, and it is on every American ship, and many of our allies use it as well. Here's the TC-2N surface-to-air missile, again, created by Shangjiang Institute of Science and Technology. This is a medium-range air defense missile based on the previous one, the TC-2. This has a max range of 40 kilometers. Remember that radar is 60 kilometers. This can go out to 40 of those 60 and hit a target. It is RF seeker and has data links for guidance, which means it can be updated in flight to change targets, among other things, if it wants to. It has a simple high explosive blast fragmentation warhead. It's designed to shoot down drones and planes, and uses a solid propeller booster to launch itself. This IOC'd in 2021. Here's the Fang 2 anti-ship missile, very similar to the Harpoon in capability and appearance as well. This is an anti-ship missile, subsonic, has a max range of 150 kilometers. It is sea skimming, GPS and INS guided. It does have a dual mode seeker head, which is RF and IF, that's infrared, to find its target during its terminal phase. And this IOC'd in 1993. The Fang 3 anti-ship missile is a different beast. This is a supersonic anti-ship missile that uses ramjet propulsion that pushes the missile in excess of 2 Mach near sea level. It has a 225 kilogram warhead, same as the Fang 2, and uses GPS and INS navigation on its way to target. At the end, it has an active RF seeker head to guide in and home in on its target. It is a significantly faster missile than the Fang 2. Here's the Mark 46 torpedo that's shot from hull 1 using those triple launchers. They decided not to continue using this weapon, probably because of its age and the maintenance cost and the weight that it adds. There's many reasons that you may not want to have this launcher on board your corvettes. But Hull 1 does have these, and these weapons run at 40 knots for out to about 11 kilometers. They are both active and passively guided onto submarine targets. And this Mark 46 torpedo IOC'd all the way back in 1979. Now, an interesting twist in today's ship brief is that there is a subclass to this ship. It's called the Aquitaine-class OPV, or offshore patrol vessels. And these are operated by the ROC Coast Guard. So we'll talk about the Coast Guard version of this ship. It does not have the ASA radar and the fire control system that the parent class has. It does have a 20 millimeter twin barrel remote control weapon system. So it does have some lethality, some punch. It can also shoot 70 millimeter Hydra rockets. And on the bow, if you notice what appears to be a gun or a cannon there, that's actually a water gun for shooting water, seawater, onto a target that's on fire, like putting out a ship fire or whatever. That's the primary purpose of that. So this is a Coast Guard vessel that does have quite lethal systems on board, including the Fang 2 anti-ship missiles. So the Coast Guard vessel with anti-ship missiles on board and a couple different weapon systems. This is a great photo that our writer Tefon found, where you can see the water gun on the bow. Right behind that is that 70 millimeter rocket remote weapon system. They have the deck launchers amidships, just like the military version of this has, but these only shoot the Fang 2 subsonic harpoon-like anti-ship missiles. But putting a harpoon missile on a Coast Guard vessel is how you know you're talking about, East Asia, basically. The XTR-102 remote control weapon system is a pretty impressive ballistic system that we'll talk about next. Here is the Fang 2 being launched. Great photo found by our writer. This Coast Guard vessel shooting essentially an anti-ship missile. All right, so here's the XTR-102 remote control weapon system. It has two T-75 revolving cannons on it. 120 millimeter ammunition is shot through here at 3,000 rounds per minute. Each barrel is 1,500 rounds, but there's two barrels, so they call it 3,000. Effective range is about 3 kilometers ballistically, and it is electro-optical guided on the target. Here is the Zenhai remote weapon system, or rocket weapon system. This is a 70 millimeter rocket. It shoots 42 of them in 6 or 7 pods. Here we can see 6 pods. 7 is in each pod. Accepts all types of Hydra 70 rockets. So very similar rocket to what the American Apache and many other systems fire. All right. So this corvette is a very heavily armed corvette, in my opinion. Especially the Coast Guard version. They're putting the Fang 2 anti-ship missiles on Coast Guard vessels. The Navy version of this has the Fang 3 supersonic anti-ship missile. This thing has a lot of punch. This thing weighs, next to nothing. It's like 680 tons and has more firepower than other ships that are of the frigate class, for example. So they've packed a lot of punch into a very fast and small coastal defense package. It's very impressive. The ASA radar that is all built in Taiwan, designed by them, is quite small. It's very powerful, has good range, but is a very compact, lightweight system. And that is very impressive that they were able to come up with that. I would expect nothing less from the Taiwan technology sector. They're among the best in the world. And they have proven it here with this ASA radar that they put on this little corvette. The Coast Guard class, also called the Anping class, is a backup of sorts to the military. So if there is a war and a lot of these ships are destroyed, the Coast Guard will, become involved in military operations. They would, for legal reasons, probably reclassify the Coast Guard vessel a Navy vessel and then go and use it in those capacities. So A very impressive piece of kit that Taiwan has come up with. This is all indigenous. They designed it. They've put the systems on it, all in Taiwan. So this is a great example of what they're able to do if they can scale this up, which is what they're trying to do with the next generation frigate that's coming out. Well, I expect to see a lot of very good systems on that ship as well. And we're working on getting that to you, by the way. So hopefully we'll have the new future frigate from Taiwan out shortly. But this has been the Tuo Chiang class corvette ship brief. Thanks for listening, everybody. Welcome to the Type 45 Daring Destroyer ship brief. This is the Royal Navy's primary destroyer, designed to defend the fleet in any sea around the world. It is very long range, has great endurance, a very unique engine system that we're going to talk about called integrated electrical propulsion, and has a large number of surface-to-air missiles. This is a anti-air warfare destroyer, or AAW destroyer, with some anti-ship capability. We'll go over both the limitations and the offensive capability of this weapon in this lecture here. Let's begin with the weapon systems. The Mark 8 4.5-inch naval gun is on the bow. It's one of the only offensive weapon systems on this platform. Right behind that is the silver A50 VLS. This is the primary purpose of this destroyer's mission, is to launch these surface-to-air missiles out of this launcher. It's a 48 cell VLS. Right behind that are Harpoon Block 1 Charlie anti-ship missiles, in conjunction with a gun on the bow, the only offensive weapon for anti-ship warfare out here. Behind that is a remote-controlled weapon system using a 30mm gun that has already been outdated with the American Bushmaster, but not installed on this one. We'll talk more about that. And the Mark 15 Phalanx 20mm Sea Whiz. They have one port side, one starboard side, 4-point defense against cruise missile and close, low-flying aircraft. The sensors on this are very impressive, though. This ship has an outstanding Samson multifunction active electronic scanning array radar right at the top there, and it is extremely powerful. It has below that an ESM system that is very good. That's for electronic surveillance, and the Type 1048 and 1047 navigation radars. Satellite communication is possible via the two masts there. Above the helicopter hangar is a very interesting radar called Smart M. The Smart L has been upgraded to Smart Modernized on most of these. It's a long-range search radar we'll talk about in detail, and grabs most people's attention because it looks like a bulletin board, but it rotates. They made 6 of these between 2009 and 2013. Those were the commissioning dates there. First one was HMS Daring, and thus the class is called the Daring class. All right. The Type 45 destroyer by the numbers is very interesting and often complicated. The IEP, Integrated Electrical Propulsion System, in 2009 was very new. This was one of the first ships to use it and employ it, and it caused a lot of problems in the development of the Type 45. It broke down all the time and still breaks down in the some 15 years later. So they've had a lot of growing pains integrating this electrical propulsion system, but they've managed to do it and learn a lot of lessons from it. It turns 2 shafts that are controllable pitch propellers. It weighs in at 8,000 tons fully loaded, can do 30 knots, but if it wants to get 7,000 nautical miles before its next refueling, it has to limit its speed to 17 knots. The 48 cell silver A50 VLS is the primary weapon system on board the Type 45 destroyer. It holds those Astra 15 and Astra 30 surface-to-air missiles. Obviously carries 48 of those. Carries 16 Astra 15s, which are medium range, and 32 Astra 30s, which are long range and anti-ballistic missile intercepting surface-to-air missiles. The Mark 8 Mod 1 is the 4.5-inch naval gun that is pretty reliable. The Mark 15 Block 1 Bravo Phalanx 20mm Sea Whiz and the Mark 44 30mm Bushmaster are used for close-in targets. Those are ballistic weapon systems. The cool thing about the 30mm Bushmaster is that it is controlled electronically from inside the ship. You don't actually have an operator out on it. And the Sea Whiz can be controlled in either mode as well, from inside the control room manually or selected to an auto mode, where it just engages targets that are nearby that meet certain requirements in terms of speed and range. They do have a couple mounts for 2.62 millimeter miniguns. On the sensor side, again, we have the Samson Search Radar, which is the primary one at the top. The round cover on it is just a cover for the radar itself. The Smart L Long Range Search Radar and Smart M is the modern version of the Smart L. You may see either one when you're talking about this. The Type 047 and Type 048 are low probability of intercept navigation radars. The Talos BAE Systems 1046 Air Surface Search Radar is on board. Of course, they have the UAT Mod 2 electronic surveillance module, so they can just record and listen to other radars and see what contacts are out there without transmitting anything. They have a Shaman counter ESM, which is used for defensive purposes. The Type 2091 Ultra MFS 7000 hull-mounted sonar is both an active and passive sonar system. They have 2 different SATCOM arrays for communication, and a Sea Viper air defense system is controlling these weapon systems. And the AW101 helicopter is the only anti-submarine weapon system on board. One of the many limitations of this very powerful destroyer is that it has almost no anti-submarine capability. All right, so here's the integrated electrical propulsion system. This thing breaks down a lot because it was pushing boundaries when it was, designed and installed, and it's gotten better. I'll give them that, but it's still a problem for the class. So this arrangement of diesel generators and turbine generators working together generate electricity. That's all they do. That's the generator part of the diesel generator, is to just turn that mechanical motion of the diesel into power. And it's 3-phase electricity that goes out into the bus. The bus is then controlled and diverts the electricity to systems that need it, whether it's ship services like hotel loads and running all the computers and equipment. And then it also diverts some of it to a frequency converter that converts it to DC electricity that turns the motors to turn the propellers. And that's all controlled electronically. Now, it may generate more power than it needs because the power fluctuations may change as equipment comes online and offline and people are operating the ship. So there is an additional energy storage solution installed on all ships that have an IEP. This allows the generators to maintain a constant RPM in the turbine generators as well, so that they're very efficient. And so they can operate at their most efficient RPM most of the time, and any excess energy can be stored for later. But know that the turbine generators can spin up and spin down in different high and low level modes as well. But ideally, you want to keep these generators spinning at their most efficient RPM. So the WR21 gas turbine generator is made by Rolls-Royce. It has great fuel consumption at both low power and high power levels as it goes between those 2 speed ranges. It does have a reduced infrared signature by the way they shield and diffuse the exhaust gases coming out of it. It's very clever how they do that. It spins at 3,600 RPM and generates 25 megawatts. That is a lot of electricity coming out of one of these, but I would expect no less from a company like Rolls-Royce. The Samson multifunction radar is the big ball on the mast over the bridge there. It's the high point of the ship. This controls, or is a component of, rather, of the Sea Viper system, which is the system that controls the surface-to-air missiles and directs them towards their targets, as well as tracking over 1,000 targets. So it can track 1,000 different contacts, we'll call it, and it can shoot down 12 of them at a time. So it's a very capable S-band radar that can look out to just over 400 kilometers in range. That's well over the horizon. Track a target and shoot it. The Samson, the S1850M for modernized radar is the large black rectangle that spins over the helicopter hangar and is often the first thing people notice when they see this ship because it looks like an advertising billboard. But it's actually a very powerful and capable radar. Operates in the L band, which is 1 to 2 gigahertz. can track up to 1,000 targets, and has a 300 kilowatt peak power. So it is a very long range active radar used for supplementing tracking the 1,000 targets that the Samson does. The Type 1047 radar is manufactured by Raytheon. This is a low probability of intercept navigation radar. It finds the coastline, gives the operator a high resolution outline of what the coastline looks like, and also any close small craft would show up on this. The thing that's key about this specific radar is that LPI. It has a very short active pulse, less than a millisecond, and that pulse is very unlikely to be detected by an ESM system on another ship. It can be done, it's just hard to do. You have to have a good operator. All right, the Mark 8 4.5 naval gun is on the bow. This thing shoots 25 rounds per minute out to a range of just over 27 kilometers. That's the ballistic range, by the way. The effective range would be a little bit shorter than that. Pretty reliable, and is the old standby. Again, this ship has been described as a porcupine in that it doesn't really have any kind of offensive punch. It can only reach out to 27 kilometers, and that's with one weapon system shooting 25 rounds a minute. The other offensive weapon system that we're going to get to is the Harpoon, and everything else about this ship is defensive. It's designed to defend the fleet with weapon systems like this. This is a remote control weapon system, the DS-30 Bravo. This will be replaced by the Bushmaster 30 millimeter that the Americans use. But for now, many of these old Darings still have the DS-30 millimeter remote control weapon system. Has about a 10 kilometer range, shoots 650 rounds per minute, has a pretty decent barrel life at 5,000 rounds. You're probably not going to get through that pretty quick. And is being replaced by the Bushmaster 30 chain gun. Cool thing about this gun, it is completely controlled remotely from inside the ship with a joystick. The Phalanx, very similar. This is a point defense close-in weapon system, 20 millimeter, not 30, so a little bit smaller round, goes a little bit farther because it's smaller, faster, out to 3.6 kilometer effective range. This system has been around and upgraded for decades, probably going on 50 years now, because it works. It's reliable. It's iconic in shape. Everyone recognizes it, and they continue to improve it. That's the most important thing. The Mark 15 Phalanx close-in weapon system of today is not your grandfather's Sea Whiz. This is much more capable. It has many more sensors, including electrical, optical, and manual control, different burst fire modes from 3,000 to 4,500, and can shoot at negative 10 degrees elevation down for those unmanned surface vessels that are coming in like they do in the Black Sea to destroy the Russian ships. Well, this system can look down and shoot down and keep that from happening automatically. Or you can take control of it manually. They have two of these, one on each side. The Aster 15 SAM is a medium range, 30 kilometer range, Mach 3 surface to air missile, goes as high as you need it to be, 13 kilometers altitude if you keeping track. This was IOC'd in 2016 and battle tested and proven to be very effective in 2024, where it was deployed and used in the Red Sea, engaging everything from UAVs to cruise missiles. So this is a very successful design, the Aster 15 SAM, and its bigger brother, the Aster 30, which is the same seeker head, but has a big booster motor on the bottom of it, pushing it out of the VLS up to speeds of 4.5 Mach and can reach out to just over 120 kilometers range. And it is capable of intercepting ballistic missiles, and this happened in 2024 in the Red Sea when an anti-ship ballistic missile was launched from Yemen towards a ship. This missile intercepted it successfully. So it is a very successful and effective system. The downside is that the Aster 15 SAM, the shorter range one, is not does not come in quad packs. It is designed, as if it's a larger missile. You buy them one at a time and takes up an entire VLS cell. So it's not as efficient. You could have more on board if they had more space. This thing takes up more room than it needs to, and that's the Aster 15. The Aster 30, because of its increased capability, is worth the space that it takes up. Now, because we future-proof these lectures, we're going to talk about a weapon system that is coming in the next few years to replace the Aster 15. That short-range brother to the Aster 30 is going to be replaced by the AIM-132 because this one comes in quad packs. Specifically, this short to medium range missile made by MBDA will come in a 24 C-Scepter module. And that module can pivot. It's going to be mounted just forward of the bridge between where the VLS is now and the bridge. And it's going to hold 24 short to medium range surface-to-air missiles of the AIM-132, which is extremely accurate missile. So they're going to be able to use all 48 cells of the Silver A50 VLS system for Aster 30 anti-ballistic missile and greater effectiveness missiles, and have these for closer, shorter range and lower priority targets like UAVs. This thing will take out a UAV, leaving the Aster 30 to worry about ballistic missiles and greater threats like that. This is coming down the pipe. All right, the Harpoon. I called this ship a porcupine, which the Royal Navy does not like that description, but it's accurate, and many people use it because it has no offensive capability other than these harpoons. And by the description of where they're putting the Sea Scepter, it's right where these harpoons are located right now. I assume they're taking them off, which would limit the ship even more in terms of offensive capability. But it does have the RGM-84 Delta anti-ship cruise missile, Harpoon, been around since forever, 70s or 80s. But it's been upgraded. This is not your grandfather's Harpoon, just like it's not your grandfather's Sea Whiz, 20 millimeter Sea Whiz on the back. They've upgraded this every couple years for 50 years now, so it's much better. The limitations of the Harpoon are it's not stealthy. Everyone's going to see this thing coming because it wasn't designed to be stealthy. It still isn't. It's one thing they've never changed about it. It does have long range, though, 124 kilometers. Subsonic. It's very subsonic. It's very slow compared to other cruise missiles that are also subsonic. This is one of the slowest anti-ship missiles that's still in use today by major navies, I should say. It does have a 221 kilogram high explosive warhead, which is very interesting warhead. Probably not allowed to talk about it still, but basically it's designed to rip aluminum and thin metal ships apart and then also set it on fire, which is very clever how it does both. And then, of course, the fire is what sinks the ship more than the size of the warhead on this missile. But it's not stealthy and it's very slow, which means any capable Navy is going to see it coming and shoot it down long before it gets to the target. So you're going to want to employ more than 4 at a time against one target. And if you're shooting a fleet, pick a different weapon system. Don't shoot harpoons at it because you're just wasting your time. Everyone's time if you're doing that. But the one great thing to say about this slow, unstealthy missile is that its ECCM is probably the most effective in any Navy. The Chinese have figured this out, and so has NATO. For whatever reason that is not public, even if you jam this missile, it has a high probability of impact on the target, and they won't say why. Something changed over the last 10, 15 years where they've cracked that code, and the Chinese have it too because they put it on their YJ-83 missiles. So even if you jam it, the missile may miss. The jamming may be successful, but there's a greater than 50% chance that even if it's jammed electronically, it will still hit the target. And I can't tell you why because I don't know. Other than that, so if it doesn't get shot down, it'll probably hit the target is my point. All right. I've said that this ship, this porcupine of an air defense destroyer, has no anti-submarine capability. They put a sonar on it. They didn't put any torpedoes on it. So almost as an afterthought, the Royal Navy said, man, maybe we should add a anti-submarine helicopter to it. Of course, they did. They had the helicopter hangar in the design from the beginning. So they chose the AW-101 helicopter. This thing's a beast. I've had the opportunity to get on board a Royal Navy ship and kind of stick my head in one of these that was kind of folded up in the hangar because that tail section folds in whenever it's stowed. And it's big. It's a big girl. Like, I'm impressed this thing gets off the ground. But it does carry 4 lightweight torpedoes designed for anti-submarine duty, destroy submarines. It doesn't have any kind of sonar system itself, so it would be completely reliant on the ship's hull-mounted active sonar to communicate the position of the target, which it does have that capability. That's automatic. It's called data link, and the control and the weapon Sea Viper weapon system. Anyway, and so it can drop the weapon on the target accurately. But it has a surface search radar on board. It can carry up to 4 torpedoes. It has just under 8 hours of endurance of flying time, and has a max speed of 277 kilometers per hour. It is propelled by 3 GE CT7 turbojet engines. Because it's so big, it needs 3 of these things. It's not fuel efficient, but it can stay in the air a long time compared to other American helicopters, the smaller ones, at 7 hours, 40 minutes. So, not impressed with this. A submarine is going to be this ship's downfall. As soon as it comes across a submarine, it had better have this helicopter in the air already, or else it's not going to have time to get it in the air. All right, final thoughts. I am impressed with the air defense capability of the ship. I want to tip of the hat to the designers. They were instructed to build an air warfare defense destroyer, and they did. That was fantastic. They started commissioning these back in 2009. So by today's standards, it's not a new design. And they pushed boundaries on an integrated electrical propulsion system that had not been done before, except for the Americans had done it on the Zumwalt. And so these ships were, coming online and being designed in about the same time, roughly. And so they were willing to take chances, and they did. The smart radar, whether it's the Samson at the top of the bridge or the Smart L, Smart M radar over the helicopter hangar, is an incredible piece of kit. Tracking 1,000 targets is not easy, but they have the capability of doing it. The Aster missiles, 15 and 30, both of them are fantastic, accurate, high-speed surface-to-air missiles. So for purpose, this is a wildly successful destroyer. It will defend the fleet from air attack, whether it's ballistic missile, UAV drones, USVs. It's going to do a great job defensively, which is why it's a porcupine. It won't hurt you unless you touch it. And that's the description of this thing. It has very little offensive punch. It has a 4.5 millimeter gun, and it has some harpoons on it that they're probably going to take off to make room for a 24-cell Sea Scepter. We'll see what they do with that, how they manage to mount that whenever it actually happens. So if they can keep the harpoons, at least it will have some offensive punch. But again, the harpoon is not the best anti-ship weapon anymore. The Naval Strike Missile is, and they are supposed to be getting that. Where they're going to mount it, whether it's on the same mounts as they have now after the Sea Scepter install, we'll have to wait and see. But a fantastic air defense destroyer is the Type 45. And very impressed with her. But she needs to be in a fleet. She needs to be escorted, protected from submarines. And if you're taking her to war, she's going to need to have a carrier or somebody with her to provide offensive firepower. All right. And that's the Type 45, everybody. Thanks for listening, and I'll see you in the next one. Welcome to the Type 052 Delta ship brief. The ship is commonly referred to as the Liu Yang 3, also known as the Red Aegis. This was China's most successful attempt at mimicking a Aegis-class cruiser, or destroyer in this case. It's very similar to the American Arleigh Burke in capability. It's not quite as capable, doesn't have as many weapons, but it's just another step in that generational direction. The biggest difference that you'll see here between the Type 052 Delta over the Charlie is we now have VLS that looks very similar to the American Mark 41. So much so they even use banks of 8 missiles. It is suspiciously similar to what America has developed. So they either somehow got, engineering drawings and copied it, or they just mimicked us and made their own. Either way, it was inspired by the Mark 41, apparently. So this VLS, it can carry a number of missiles. This is the first time where one VLS cell can carry, a surface-to-air missile, can carry an anti-ship missile, can even carry their version of a land attack missile in the VLS here. Something to note right away, and we're going to go over the problems with this ship. One of the biggest ones is there isn't enough depth in the keel below the deck for the 4-in-1 missile tubes. In other words, only 10 of the forward VLS cell of 32 are deep enough, 18 meters down, to hold the larger land attack and anti-ship missiles. So it is likely the majority of these weapons in the VLS are the HHQ-9 long-range surface-to-air missiles. But we're getting a bit ahead of ourselves. Let's go ahead and talk about this ship in general first, and then we'll break down the individual parts here. Where are they made? Well, they're made in the same Shanghai shipyard as all the other Type 052s are. This shipyard's been around for well over 200 years now, and really has a lot of experience, or close to 200 years now. The first one that was made was commissioned and put into the Navy in 2014, and that hull name was Kunming. So you may see this referred to as the Kunming-class. That's not as common as the Luoyang 3, but just know that they're all talking about the same thing. And here's a picture of Hull 1, DDG 172. One of the first things I want you to notice is look at the superstructure right below the bridge. That's forward of the mast there. And you see the Dragon Eye radar panels there. Those are the Aegis radar panels. One of the big improvements that they've managed between the Charlie and the Delta that we're talking about today is those radar panels are now flat. They're not bowed out in an analog arc, a or a parabolic curve. They now can do those beamforming maneuvers digitally. And that is a big step forward in the processing of this long-range Dragon Sea or Dragon Eye radar. The second shipyard that began building these in 2019 rather, it had finished the first hull in 19. It began building it all the way back in 2017, is the Dalian shipyard. And that's the one that's way up north in the Liaoning province. Basically, right across the Yellow Sea from North Korea, to give you an idea how far north this thing is. And so they really like this version of the Type 052 so much that they are now using 2 shipyards to build as many as they can possibly pump out at a time. Here's a list of all the ones that they've built up to the time of this recording. We're going to talk about the first 3 batches. There is a 4th batch that we'll talk about at the very end. It's not built yet, so we're gonna hold off on that. But here you go. You got the first 2 batches are very similar in that it's 13 ships. The second batch added an active passive towed array, which is a significant capability in anti-submarine warfare. So that's why we call batch 2 different than batch 1, because it is likely that every ship after DDG 155 will have an ASW role, because the ones before that had less capable hull-mounted sonars. To be clear, they did have sonars. They just did not have the towed array sonar that is much more capable than any hull-mounted sonar will ever be. And then finally, batch 3, they completely redesigned the rear end of the ship in terms of the hangar and the landing area that you'll see to accommodate the new Z-20 large helicopter. So the first 13 hulls, they can only have the smaller helicopters like the K-28. After hull 14 and beyond, they can have the Z-20, heavy-duty, heavy-lift helicopters. All right, so here's the Luoyang 3 by the numbers. Nice little profile shot, courtesy of seaforces.org. Thank you for that. She's approximately 7,500 tons. This number's varied widely across the internet, but most sources agree that it's somewhere in the vicinity of 7,500. 157 meters long, 17 meters wide, 32 knots max speed publicly. Crew of 280. That's a large crew for this ship, but they that's what they put on it. Co-dog, co-diesel or gas, whenever it wants to run its engines. It is running the QC280 GT gas turbines. We'll talk more about that when we get to the engine part of the brief. The MTU 20s, those are the same diesels that we've had on the previous version of this ship. Nothing changed as far as the diesel goes. And then she does have 2 shafts with controllable pitch propellers, which means that she can change the bite of the blade into the water by changing the angle of it. She has 64 cell VLS. Most of those carry the HHQ-9 Bravo long-range surface-to-air missile. Something specific about this missile. This is the same missile that is used on the Slava-class, just the Chinese version of it. It cannot shoot down an anti-ship missile, a cruise missile that's sea skimming. It does not have that ability. It can, however, shoot down anything in the air, anything above sea skimming, airplanes, helicopters, but it will not defend the ship against a missile attack. Okay, the YJ-18 anti-ship missile and land attack variant is a very capable missile. This missile is terrifying, and we'll talk a little bit about that in detail. But the YJ-18 is probably the most advanced anti-ship missile in the world, and I'll tell you why that is here in a second. They do have ASROC torpedo capability shooting out of the VLSs. Keep in mind, they have 64 VLS tubes, and they can put all these different missiles in it. So it doesn't mean they have 64 of each. It's just a total together add up to 64. And remember, only 10 of those estimated can carry the YJ-18. Okay. Back above the hangar, you see the HHQ-10 surface-to-air missile. That's a very short-range point defense missile, very similar to our REM, Evolved Sea Sparrow defense. And then there's a Type 730. There's also a Type 1130 point defense Sea Whiz. The number 7 and the number 11 are just the number of barrels, okay? So it's the same system, just the 11-barrel variant has a much higher rate of fire. There are 2 triple-mounted torpedo mounts, port and starboard, right there next to the hangar, and 4 decoy launchers, and they can carry 1 helicopter in this variant. As far as sensors go, Dragon Eye radar, those are the big flat panels we talked about. And then they have the same 366 air search radar there on the top. The 517 Bravo air surveillance radar. And then the LJP 340 fire control radar, which controls the Sea Whiz. The 344, which is like bandstand fire control radar for the gun on the front. Active passive towed array like I talked about. And she does have electronic countermeasure called the H726. All right, so here's this engine. There's a lot of naval engineering people online that disagree mightily about this engine. But the QC280, the one thing that everybody does agree on, is an exact copy, down to every bolt and every millimeter and the angle of every blade of the Ukrainian UGT 2500. That's what everybody agrees on. What they don't agree on is what ships use the QC280. The QC280 is made by China. They can make as many of these as they want. Therefore, it is widely believed that they use these in the warships. However, this engine, the QC280, the Chinese copy, is unreliable. It breaks down. It's not as well made as the Ukrainian version. Because of this, a lot of people think that maybe the UGTs, the limited number that they bought in the 90s from Ukraine in early 2000s, are the ones that they use in the warships even today. That's the controversy. So whenever a ship goes to sea, a Type 55 destroyer, the best destroyer in the Chinese Navy, does it have the Ukrainian engine or does it have the Chinese copy? And that is hotly debated amongst naval nerds on forums. I was kind of entertained by watching that. But what I want you to know is that eventually China's going to run out of UGTs because they're not buying them anymore. Hell, Ukraine's not making anything right now. So eventually every engine is going to be the QC280 and it's going to put this debate to rest. But for our purposes here today, it's the same engine. They have 2 of these on every ship, every destroyer that we're talking about today, and they power the engines. The MTU V20s, those are the diesel engines that do both electricity and hotel loads for the ship and can turn the propellers as well. All right, let's talk about this HHQ-9 Bravo. This is basically the S-300. This is a long-range surface-to-air missile, shoots down bombers at greater than 150-kilometer range or whatever. It's a very long-range missile, but it does not have the ability to fine-tune and home in on a small sea-skimming missile. So this thing is very good at shooting down airplanes, helicopters, bombers, you name it, at very long ranges. It's fleet defense. It's cold launch. It's VLS housed, and they can carry one of these in every single VLS tube. There's no limit to these. But this is not a defensive weapon when it comes to defending the ship against an attack, except for shooting down the airplane. It cannot shoot down incoming missiles. The YJ-18, this thing called Eagle Strike, is terrifying. They named it Eagle Strike because it was designed with the idea of sinking American ships, and the way it works is very interesting. It is based on the Russian Club missiles. These are a lot of missiles that we've seen launched into Ukraine, shipborne missiles. It's part of that family. This is the Chinese copy of it. It IOC'd in 2014. And what makes this missile special is that the anti-ship variant is a subsonic sea-skimming missile, much like the Exocet and the Harpoon, that has a range of over 500 kilometers. It is an extremely long-range missile, and it does fly very low to the ocean. It is below, the typical Exocet and Harpoon profile in a calm sea state. But what it does is it sheds its air-breathing turbo engines, jet engine sustainer after the 400 or 500 kilometers is done, whenever it gets into the terminal homing phase. Once it has its target on its onboard radar, it sheds almost half of its own body and goes into another solid rocket booster mode that pushes it forward next to almost to 3 times the speed of sound, Mach 3, and hits the target with that kinetic energy, which will tear a hole in just about any ship, and it has a large warhead to add to that chaos. Because of this delta, this change in speed, as the radar horizon of the missile sees the ship, that means the moment the crew, if they happen to be looking out the window at the horizon, see the missile, by the time they see the missile is hitting them. That's how fast this thing closes on the ship. It is a point defense nullifier. Like before your Sea Whiz gets spun up, before your Sea Sparrow can pop the little missile out, this thing goes from being on the horizon to exploding under your feet. That's what it's designed to do, and it does it very well. At sea testing showed a success rate of 70% in a contested environment. China was testing this missile against ECM on maneuvering targets being towed at sea in several different sea states, and they had a 70% success rate against that. So that is very good in a contested environment. This missile, it will hit what it sees in its terminal phase. If you want to defeat this missile, you have to stop it in its cruise mode. When it's flying low and slow at like 0.8, 0.9 Mach, just below the speed of sound, at about 10 to 15 feet off the water, very low, that's the only chance you're going to have to defeat this missile. Because once it goes terminal and it kicks on that second, solid booster rocket, it's going to be on top of your ship almost instantly. It will appear instant to the human being watching it. And they also have a gun, a big 130 millimeter naval gun on the bow. Basically, it's the same, or a Chinese version of the Soviet-era AK-130. So that's the size of the round, 130 millimeter. Can shoot 1 round a second, and has almost a 30 kilometer range, pretty long ballistic range. Here's that HHQ-10 SAM point defense, very similar to our Evolved Sea Sparrow rim defense missiles here in the United States. ILC in 2013. Short range, point defense, 9 kilometers. Infrared sinking, very similar to the American Stinger. And like I said, like the RM, that's the rolling airframe 116 on the American Navy. Can be put in automatic mode where it just launches when anything that it sees in its detection range. And it can shoot a missile every 6 to 8 seconds, which that's a little bit slow, but you can also take manual control of it and fire as much as you want, and holds up to 24 missiles in a pack. I have seen an 18 missile pack before, so know that there's different sizes of armament. The most common one, though, is 24. Here is that Sea Whiz, the Type 730 that we've seen on all the other variants of this type of ship. Remember that there's a Type 1130 that has 11 barrels instead of 7, and that changes the rate of fire to close to just under 10,000 rounds per minute, which is a pretty insane rate of fire. And the idea there is to just get as much lead in the direction of an incoming missile as possible, because missiles like the Eagle Strike are becoming more and more capable in their terminal phase. This thing IOC'd in 2003. It's been modified and upgraded ever since then, and has both an autonomous mode and you can take control of it manually as well. But here is the big deal about this ship, besides the weapon. As far as sensors go, this Dragon Eye ASA radar is pretty good. It's a flat panel array versus a bowed array on the previous one, but it has the same frequency range and capability, 150 nautical mile range. And it's a wholly digital system, which is a big step forward for the Chinese Navy. They had, early days all analog, and then a hybrid analog digital system with A to D converters. And now it's all digital. They don't need any A to D converters at all. And that's why it's a flat panel instead of a bowed panel, because it is digitally bending those radar arrays around instead of having a bowed array. Very capable radar. So the two things we really want to know about this ship: it has the Dragon Eye 346 radar, and it has the YJ-18 ship-killing cruise missile. Other radars on it are the knife rest and the Type 344 fire control radar that controls the gun on the front. Those two. Obviously, the gun on the front is line of sight, and the knife rest is a very long range, 300 kilometer early warning radar. Basically gives you, bearing and range to incoming air threats. Here we have the Seagull radar. That's the highest mounted radar on the mast. That's that big ball right there. It's the H364 over the horizon surface search radar. And I couldn't find a good range for it, but we know that it's OTH, so it's greater than, say, 20 miles. And on the bow is the Mineral ME bandstand radar. It's for weapons control. Also does data link for the YJ-62 missiles, and it operates in the I band. All right, let's go to batch 2. Batch 2 is hulls 9 through 13, and the only difference here is they cut some holes in the back end of the ship, and that's where they fish in and out a couple towed arrays. But these towed arrays are very capable. They're both active and passive towed arrays. And they trail these towed arrays, 2-3 miles behind the ship. And one thing that makes that very effective is that own ship's noise is very far away from the array, making it like a microphone in the water, a hydrophone in the water, just listening around. Very sensitive. It doesn't have all that interference that a hull-mounted sonar array has. And it can go active. So it can ping out, listen for a return, and it's pretty capable. It's called the H311 towed array. Type 052DL. Okay, so this is batch 3. Batch 3 is often referred to as DL because it has lengthened a hull by 4 meters. So we're going to obviously include this in the lecture because it's still part of the same type of 052D that we've been talking up to this point. So it's a larger hangar. It accommodates the Z-20 helicopter, which is basically an American Seahawk. It is a straight up copy of the Sikorsky helicopter the United States uses. It in every way matches what our capabilities are in terms of efficiency, speed, range, weapons loadout, carry capacity. They basically stole our helicopter design. And it has a new air search radar as well. You can see the knife rest radar now has what looks like a frame around it, and that is the Type 517 Bravo air search radar. Don't have a lot of information on that yet. We assume that it's more capable, but the previous version had a 300 kilometer range, so they're probably not getting more range out of it. They might be getting more fidelity at 300 kilometers. That's a possibility too. But just know that the DL is a longer ship, can carry the larger helicopter, and still continues to have the towed array as well. The towed arrays are on both the batch 2 and batch 3. All right. So that's it for the first 3 batches. Just real quick, these are good fleet defenders for long-range air detection and engagement. That's what they do. They do have a large magazine, so they have 64 of those VLSs. Good for them. The problem is, and maybe you picked up on this, is they don't have the ability to engage cruise missiles that are sea skimming. It is likely they won't even see them with that radar. They'll need to be told about sea skimming incoming missiles from other platforms, whether it's their own helicopter or another ship with an X-band radar that can see it. So not only are they blind to sea skimming missiles, they're also unable to engage the sea skimming missile until that missile comes within range of the HHQ-10 defense, which is very short range, less than 10 kilometers, probably more like a 9 or 7 kilometer engagement range. Remember that HHQ-10 is that Stinger missile, basically. So you got this mount above the hangar looking in the direction of the incoming attack, shooting this short-range surface-to-air missile, hoping to engage an incoming, Harpoon or Exocet or whatever it is. And while that might be successful, it can only shoot one missile every 6 seconds. So you shoot 2 missiles at this thing, it's going to shoot down one maybe. That second one is going to hit before it gets a chance to get another shot off. So it is very vulnerable to cruise missile attack, ironically. And it has very capable anti-ship cruise missiles itself. So that's something that they do address in later versions that we're going to talk about in future videos. But the Achilles heel of the Type 052 Delta is the anti-ship cruise missile, even the old Harpoon subsonic ones. It simply doesn't have any system capable of engaging it over the horizon. It has to wait until the Harpoon gets within less than 10 kilometers before it can begin engaging. And that means it can be overwhelmed with as little as 2 or 3 Harpoon missiles because it doesn't have the time to engage all of them. And that's how you sink this thing. So the Type 05 Echo is going to replace the Seagull. This is also called Batch 4. Okay, but we're not going to do a whole lecture on the Echo. We're done with the Type 052s as of now. The 052 Echo isn't built yet. Okay, but the idea is they're going to replace the air search radar with an X-band radar. And this will provide the ability to detect and track those sea skimming missiles outside 10 kilometers and provide targeting data for semi-active homing missiles to shoot them down. Okay, so when this is built, that's what the next version is going to have. That's the Echo or Batch 4. Echo will also have the additional helicopter hangar space. Will be 2 meters longer than the DL, so a total of 6 meters from the original length. It may have all-electric propulsion. A lot of navies are going to this, including the United States Navy, where you just have generators on board that power everything, including your own propulsion system. No more steam generators going to reduction gears. They're removing all that complicated engineering that makes noise, requires maintenance, is very expensive, and just putting in big electric motors that turn shafts based on power. And the more power you can generate, the faster you can go, and the more systems you can support. And this is the beginning of energy, offense, and defense weapons as well, because the larger electrical capability we have on board any ship, including this one, via generation and storage capacity, can power future optical systems like lasers, and that's going to be the next big thing. And this is just another step in the very capable Type 052 series. This ship is very good. It's not the best. We're coming up on the best ship in the Chinese fleet soon, but this is very close to an Arleigh Burke. All right. Well, thanks for listening, everybody. I appreciate all the Patreons here, including Scott Borg, Fraser Disney, Harpoon Henry, William R. Collier, Jr., Sean O'Neill, Robbie Stahl, Josh Warwick, Jordan Vazraka, Brendan Ferry. I need to mention him. I always give Scott Borg and Sean O'Neill credit for being the very first division officers. I noticed that Brendan Ferry's name is on the very first division officer slide as well. So I think I've been selling Mr. Ferry short. I apologize for that. He is one of the OGs division officers going way back, all 3 years now at time of this recording. Thanks also to Alexander Huff, Joel Corrent, and DJS 4000 supporting the Sub Brief Project. We will see you next month with the next ship brief as we continue our way through the Chinese PLAN. Have a good one, everybody. Hello and welcome to the Type 053 Frigate Ship Brief. Before we get into the meat of today's briefing, we need to take a look at the history of the ship because this one's been around for many decades, going all the way back to the 1970s, when the ship was a simple frigate with a twin rail launcher on the bow for air defense and a couple of guns for gun action. And it just wasn't very capable even by 1970 standards because the twin rail launcher took so long to reload. It effectively only had 2 shots in a contested airspace. It was good for fleet defense, which is the role of the frigate. Really, you tend to put frigates out on the picket line, the outer rim, if you will, of the fleet. But in the 1970s, China didn't have like massive carrier fleets. They had more, battle groups that would go together with, a destroyer or with a couple frigates and go out. And that would change significantly over the decades. But even for the 1970s, the Type 053K version of this frigate we're going to talk about today was not very good. A replacement was ordered for the Type 053K. This was called Project 055, and this came along a little bit later on in the 1980s. This had replaced the twin rail launcher with that 6 HQ-61 Bravo launcher that we'll get a close-up here for you in just a second. And but it used the same missile, so it was not really an upgrade. They could just fire 6 before they were Winchester versus 2 on the older model, which had to reload, which took a very long time by today's standards. They did fire the Type 053H2G, did shoot the YJ-8A anti-ship missile, had a 42-kilometer range, so that is a significant upgrade there in anti-ship capability. But keep in mind, this multi-role frigate was often used as air defense, and in that role, she was very lackluster with this less than 10-kilometer range surface-to-air missile. NATO name for this old version of the frigate we're talking about today is the Jianghui 1, or just Jianghui. So this is the Type 053H2G frigate. This is the frigate that replaced the one that was in 1970s that had that twin rail launcher. It kept the same Type 79 100mm twin gun, which is a significant amount of firepower if you can get that gun within range of something. Shooting 2 100mm guns puts a lot of shells down range. And you can see the HQ-61 Bravo there. That's the capsulized surface-to-air missile. But again, very short range, less than 10 kilometers. And behind them is the 37mm AA guns, the PJ-76s. So keeping with the Type 053H2G frigate, you can see the YJ-8 Alpha anti-ship cruise missiles. They had 2 box launchers of 3 apiece for a total of 6. 3 facing port, 3 facing starboard, and the PJ-76 37mm guns, again air defense weapons essentially on the back there. So these 2 previous frigates, even though one was an upgrade of the other, were in my opinion failed designs. The Type 053K in the 1970s and 80s, and the Type 53 H2G frigate, which just gave them more of the short-range missiles and some significant surface anti-ship capabilities with that missile. It's still not a very good air defense frigate, and so she was more effective, I think, with her multi-role than she was with being the picket air defense role. She did, I should mention, have the helicopter pad on the aft end, and they did operate the Russian K helicopters off that. Now, on today's lecture, they have upgraded that to the new Z9 helicopter. So this is the Type 053H3 Jianghui 2 fast frigate helicopter mod. That's what the H3 means. All right, so 10 053H3 were commissioned between 1999 and 2005, and this is the modern iteration of this frigate here. 2 of the 10 that were built for Bangladesh, well, sold to Bangladesh. I believe originally they were meant to be used for China, but Bangladesh cut a deal and got 2 of them. And those are still in active duty today, by the way. Bangladesh continues to operate this ship that you see here, but in their Navy under their flag. So the 8 remaining that were built do serve in the PLAN. That's the Chinese Navy. So significant improvements from the air defense from that old HQ-61 was the HQ-7 SAM. And if you watch this series at all, you're very familiar with the HQ-7 already. This is the Chinese copy of the French Colette surface-to-air missile. And they did increase the anti-ship missiles from 6 to 8, but it's still the C-802, which is that subsonic long-range sea-skimming anti-ship missile. Think of the Exocet, essentially, is what it is. So, a lot of French influence on this upgrade. If you think of the time in the late 90s, China is putting a lot of money into infrastructure and its military. This is what's creating a booming economy in China, is a lot of these internal projects, these works projects employing millions of Chinese people that are either building large buildings all around the country and dams and other huge infrastructure projects, highways and whatnot to connect everything together. And then military. They're building a lot of tanks, planes, and especially ships with programs like this. So the midlife upgrade, we'll talk about briefly. That happened in 2015, so keep that date in mind. These ships date all the way back to basically 2000, but they did get a midlife upgrade that improved their ESM capability and point defense. And only 2 of the 8 have been modernized at the time of this recording. All right, so they're built in the 2 main shipyards. Keep in mind, China has many, many shipyards, but there's 2 very large ones. One is in Guangzhou and one's up north in Shanghai. This is where a lot of the warships are built between these 2. So, Zhanghui 2, by the numbers, I've highlighted the modernization, which is the second item under each one of these colored boxes here. So they're starting with the diesel engines. They have 2 shafts that can push the ship up to 27 knots. 27 knots would be considered slow by European and American Navy standards, but the ships that operate even today in the 2020s often are limited to about 30 knots, and that's pushing it in the Chinese Navy. They haven't figured out speed yet. They've got a lot of other things figured out, but efficiency and speed is not one of them. YJ-83 anti-ship cruise missile, they have 8 of those. And then they have the HQ-7 SAM, that's the copy of the Colette. The modernization gives them the HQ-10, and we'll go over these, of course. The HPJ-87 100mm gun is a single gun, 56 is the barrel. 2 twin-type 76A 37mm guns were replaced with modernization by the HPJ-12 30mm point defense mod. And this is the insane weapon that shoots out a huge number of rounds per minute point defense, 2 type 87 6-barrel fixed ASW mortars. This is the same that they have on their destroyers as well. This is the standard ASW rocket bomb unit, RBU, that Russia uses. China has a copy of it as well. 6-barrel and 26-barrel chaff decoys. These fire combos, chaff and flare for every decoy. And of course, the Z-9C helicopter. This is a very versatile helicopter. It can do land attack, ship attack, and ASW warfare. Very, very multi-role there. Over on the right-hand side, we have a lot of their sensors, like the Type 517 Bravo Knife Rest Air Search and the Type 360 Seagull Air Search. These 2 are absolute staples in the modern Chinese Navy. You'll see those 2 sensors on just about every ship. Right below that, we get into fire control, which can vary a lot. We have the Type 343GA, which is for the guns, fire control, and the Type 345 fire control for the HQ-7, until the HQ-7 got replaced by the HQ-10. And then the Type 344 SSM is for the surface missiles. That's targeting, by the way, initial targeting before it gets launched. It has a different connection after it's launched. And then guns mod. The SR-210 is the ESM. The 981-3 is the noise jammer. We don't have any specifics on these. These are very sensitive instruments that there is no public data on. Just know that it's capable of electronic monitoring. It can record radar emissions. It can also jam radar emissions within spectrums. And it has a deception jammer, so it can make itself look like another unit. It can radiate as if it's, a destroyer, or some other ship. The Type 341 Rice lamp is the point defense radar, as well as the Rice Bowl. The 347G is the upgraded one. The Echo Type 5 hull-mounted medium frequency sonar. We're not sure what it is, but it seems to be pretty close to bull or steer hide and bull nose. It's probably a Chinese version of those systems, but we're not sure. And then finally, this is all connected. Everything here talks to each other through the ZKJ-C3 fire control system, and that's the ship-wide system there. All right, so here are the diesels. This is the Type 12 E390VA. So 12-cylinder, E390 would be like the size of the block. V is the configuration of the cylinders. Like, all those letters mean something. But just know that it's, it's got two of these medium speed diesel engines. Each, turns a shaft. They can also turn a generator, make electricity for the ship. Keep that in mind. 12-cylinder V configuration, and does 7885 horsepower at 480 shaft RPM. And that's a 4-stroke. So the cylinder firing rates, is less than that. There is also an 18-cylinder one that's obviously longer, but I could not confirm if it fits in this ship. So we know that it at least has 12 cylinders, but there is an 18-cylinder version of this engine, and if they have that, that's almost 13,000 horsepower, but unable to confirm that. If you just say 12-cylinder, you're going to be fine. Okay, Type 517 Bravo Knife Rest Air Search Radar. You've seen this before. It's just about in every Chinese lecture. This thing is the mainstay for air search because it works. It's long range, pretty high fidelity for what it does. Very reliable. Probably reliability is probably the biggest thing here. So it's 300-kilometer range, 100 hertz pulse rate, peak power 75 kilowatts. These are all public numbers. Keep in mind the actual numbers may be a little bit better. Beam width is 21 degrees, and it can be stationary or it can rotate up to 6 rotations a minute, to give you an idea of how fast this thing can turn. And there she is, just aft of the smokestack. All right, here's the Type 360 Seagull radar. This is your typical, banana-shaped radar that spins round and round, and it can track both air and surface contacts. So this is a good backup for the air radar in case the knife rest fails, and it can do both air and surface. So 250-kilometer range air, very good radar. All the way up to, 10,000 meters, almost 100,000 feet in altitude, so it's doing a full spectrum search. 140 kilowatts power with 28 dB gain, which by today's standards is pretty good. It's not great, but keep in mind, this is an old radar. And again, it works because it's reliable. They put them on the ships and has 900 pulses per second. Here's the Type 345 Castor 2. This is the MR35 fire control radar. This will direct your point defense stuff. Castor 2, and also the missiles. This is a 30-kilometer anti-air range. The Castor missiles will take this data and fire off in that direction. They can detect sea-skimming incoming missiles out to 15 kilometers and uses the KU band radar. Now, I'm going to be honest with you here. I've not heard of KU before, but I've heard of K-band, so this might be a typo on the sources. I'm using Jane's Fighting Ships for this source. So I'll say it's a K-band radar, but according to Jane's, it's KU. It also has IR tracking. That's what little camera-looking thing on the right-hand side is infrared. Is 30 kilowatt power, 21 decibels a gain, and look at the repetition rates, 7,200 pulses per second. That gives you an idea of the range of the radar because it is relatively short range compared to that 250 kilometer we just talked about. This one's only going out to 30 kilometers, so it doesn't take that long for that radar pulse to get out to that range. Therefore, it can start a second pulse, and it does this 7,000 times a second. Very fast update radar, which is what you need when you're trying to shoot down highly, high speed, high bearing rate, especially incoming. If it's an incoming weapon, you want to get a missile on it quickly, right? And so it's got that high update, right? So the missile has a better chance of hitting it. Here's the Type 343GA Wasp head, because if you look at the picture on the right there, it does look a little bit like a bug head. This is the fire control radar for the 100mm gun. It's also called the Wakwan radar. Fire control is for the HPJ-87. It also provides initial targeting data for the YJ-83 missiles. This is a very interesting looking radar. The Type 344 or MR34. This is the fire control radar for the 100mm gun and the SSMs. This replaces the radar we just looked at. So this is the modernization. Remember, only 2 hulls got this so far. So it replaces the 343GA. It's a multifunction fire control radar developed internally by China, by the Xi'an Research Institute. It is an IJ band radar, which is typical for gun control radars. That's the frequency range that you would expect to see, but also has TV and laser rangefinder. This tells us that the guns can be targeted manually using the TV camera and the laser rangefinder to direct the barrel. Track shells and targets. It tracks shells and targets at the same time, so the radar can watch the shell flight as it gets close to the target and then make adjustments accordingly. And that's a pretty advanced capability for the 2000s when this is on board. Type 341 Rice lamp. Remember I told you this was for the point defense. Believed derived from the U.S. AIM-7 Sparrow air missile system. So that's because it shares a lot of the same performance characteristics as the U.S. one. And it also tells us that this is a semi-active homing radar. So it's going to highlight the target with a continuous transmit beam that changes in pulse so that the range can be calculated. And that's going to direct the weapon system. So the I-band fire control radar is similar to the Soviet shipborne Hawk Screech, which is a 60s and 70s era radar. So because they worked with the Soviet Union for so long, it's entirely possible that they got this from the Soviets in terms of design, concept, and performance. But guess where the Soviets got it from? That's right, they got it from the AIM-7 Sparrow. So in the end, all roads lead back to the AIM-7 Sparrow for the system. Using it's used to direct the Type 76A 37mm guns, and those are going to be replaced with modernization. But those are the twin barrel, short-range anti-air guns that are rapid-fire 37mm, trying to shoot down airplanes, helicopters, and incoming missiles. Here is the Type 347 Gulf Rice Bowl fire control radar. Replaces the Rice lamp we just looked at, and it directs the HPJ-12 30mm point defense weapon, the one that spits out thousands of rounds a minute. This is the G variant of the gun. Remember, I told you there's lots of different variants of the Type 347. I've told you that in the past. So this is the G variant, standing for gun. X-band radar. X-band, very high frequency, extremely high update rate. These are short range, high precision radar bands. Anytime you see X-band, think high precision, short range, because that's what X-band does so well. A 30-kilometer anti-aircraft range, 15-kilometer anti-missile range, and 150 kilowatts of power. Here's that HQ-7. This is the old school one. Remember? Borrowed, copied, licensed, and then mass-produced from France by China. This is an 8-cell SAM launcher. This has an interesting backstory that I've told before, but I'll repeat it again, is they were working with France to have French systems on board their ships in the 80s. And they straight up copied this, and France forced them basically to pay for the license, and they did, which is not something China would do today. They've demonstrated over the last 30 years, they'll just straight up copy something and not pay for the license, of course. But in this case, they did, at least for a couple years before they just started producing these things in mass and putting them on their ships. And these are all being replaced now, by the way. But the HQ-7 is still on a handful of these frigates as the time of this recording. This missile system, ILC 1992, based on the French Curtal system, 12-kilometer range, very short range, 5-kilometer in altitude. 6.5 effective range against sea skimming missile. This is your last chance to destroy that incoming harpoon or whatever exoset, right? Before it gets into point defense range of your cannons, right? You're going to get one shot at this. Now, it's 6 to 10 seconds between launch, which is why you're only going to get one shot. Because if you're shooting that harpoon at 6 kilometers and you're waiting 6 seconds, you're not going to get a second shot off before it's been determined if that harpoon's going to hit you or not. Yeah. So single target track system shoots one at a time, and that target must be engaged before it shoots again. This leads to the 6 to 10 second launch time between missiles. If it were to switch targets and shoot again, that first missile would just become, ballistic. Wouldn't have any guidance. All right. Eagle Strike. Boy, the Chinese are really proud of this missile. It's an exocet copy, in my opinion. Extended range, long range exocet. It's the YJ-83 Eagle Strike anti-ship cruise missile. NATO name is CSS-N8 Cicada, or Cicade. ILC in 1998. Has 180 kilometer range. Subsonic sea skimming, active radar homing. It's self-homing. Doesn't need any assistance once it's launched. Semi-armor piercing 190 kilogram warhead, which is pretty much the same as the exocet. It is literally, it's just a copy. Turbojet propulsion with a solid rocket booster motor to push it and get that turbojet spinning. And then the rocket booster falls off after about, 4 seconds and splashes. If you're a sonarman, you got to listen for that splash. And then you watch the rocket go with the turbojet the rest of the way. And there they are. They have 2 quad launchers, one facing port, one facing starboard, total of 8 missiles. All right. The PJ-87 100 millimeter naval gun. This thing's a mess, jams a lot, but it's a 100 millimeter gun. If that thing hits you, you're going to know it. It's based on the French model 1968, 17 kilometer effective range against surface. 12 kilometer effective range, 17 kilometer ballistic range, but you're not going to hit anything at that unless it's a stationary target. Keep that in mind. If you're doing shore bombardment, 17 kilometers will work for you. But if you're trying to hit a ship or anything that's moving, 12 kilometers. 6 kilometer range if it's trying to shoot down an aircraft. If you're using this gun against an aircraft, things are not going well. It does have different types of burst of fire. It can do single, 2-round burst, 3-round burst, or 6, all the way up to 6. This equates to 20, 45, and 90 rounds per minute. So pretty respectable rounds per minute, assuming it doesn't jam. You're not going to get 90 rounds out of this gun without it jamming, in my opinion. It does have different rounds, high explosive round, an anti-air round, which is it's like a big shotgun shell. It has pellets that kind of burst into a cloud, and that cloud will rip through an airplane or an incoming missile. And then also has illumination rounds, a la World War II. Those are still effective. There's times when you need the illumination rounds. If you're supporting troops on the beach, you're going to have illumination rounds over the troops, or at least over their targets. And there at the bottom, I say it jams frequently because that cannot be overstated in this case. It jams a lot. Okay. Twin type 76, 37 millimeter guns. These were the ones that were directed by that radar we were just talking about, the 7. Okay, 4 twin barrel turrets, 750 rounds per minute combined rate of fire between the 2 different barrels. Here you can see the picture of the barrels just smoking like a madman because they had just completed a long burst. There you can see what looks like a rice bowl radar. And 4.7 kilometer effective range. It is auto-fed, 360 degrees of capability. Spinning this thing around, of course, that does not account for any kind of superstructure, in the way. They have these basically on the 4 corners of the ship. You have 2 forward, port and starboard of the superstructure, and then 2 aft, port and starboard of the helicopter hangar, right on the top. And so they have good fields of fire, 360 degrees capable, and fire control radar only for these in the point defense mode. Okay, HQ-10 SAM point defense. This is a new upgrade. This ILC to 2013 was installed in 2015. This is a copy of our, technically not a copy. It is very similar to the US RIM 116 RAM system. And the only reason why it's not a copy is this missile doesn't roll. It doesn't spin as it comes out like the American one does, but the performance is very similar in terms of range and rate of fire. And the mission's the same. It's not a long-range missile. It's to go very fast, Mach 2, out to 9 kilometers, and hopefully hit something along the way, like an incoming attack, whether it's a helicopter or it could be a cruise missile. And you can see there it has a limited magazine of 8 shots in the one photoed right there. So this is much more reliable, much more likely to hit an incoming cruise missile than any ballistic system. And this is why they went with it. But it's heavily influenced by the United States RIM 116. All right. The HPJ-12 30 millimeter point defense. This thing is a monster. It has 7 barrels that rotate Gatlin style, shoots 5,000 rounds per minute, has a 640 round magazine, which means it's not going to be firing long, but it's just point defense. It's going to do its mission, or it's going to fail and be exploded by an incoming attack. It doesn't need a lot of rounds. There are reloads for this on board, of course, but the magazine is pretty much the only rounds you're going to have in a fight. And then you can, if you survive the fight, you can reload it. It is both radar and optical guided. They can put this in manual mode and shoot surface targets at close range. We saw them do this off the coast of, off the coast of Africa, the Horn of Africa, near Somalia and Yemen. They're fighting pirates and stuff. They would fire warning shots with those. And the only way to do a warning shot across the bow would be to do it manually, because the radar, all it would do is lock onto the target. Well, then you could add an offset. So you could do shots across the bow with the radar, but you would have to enter how far in front you want that to be manually, or you could just grab the stick yourself and do it yourself. But this has been employed against pirates in the Sea of Yemen, near Yemen. Okay, the Type 87 240 millimeter anti-sub rocket bomb. These are basically rocket bomb units, RBUs, from the Russians, but this is the Chinese copy of it. IOC'd in 1992. Man, rocket bomb units have been around since World War II. You know, think of a depth charge, but with a little rocket on the back of it that pushes it, 5 kilometers, out to a fixed range. So here you can see it has 2 fixed launchers on the bow. They look like they can rotate, but Jane says they don't. So we're going to go with that they're fixed. And so if you want to turn them, you got to turn the ship. That just could be a publicly declared capability, when the actual capability is they do pivot, but publicly they're fixed in this position. Has a 340 kilogram warhead, 36 total if you count the reloads, and a 5 kilometer range. If you let the ship get this close to you that they're firing this at you effectively, you've messed up. So this, in my opinion, as an experienced submariner, not a useful weapon at all. Probably more likely to be used against an incoming torpedo to try and break it up with the pressure wave that this thing would create. But that would be a very lucky shot, because this thing is not aimed by any sort of sensor. It is fixed in one position. You point the ship and it shoots 5 kilometers rather. I almost said 5,000 yards. Anyway, here's the helicopter. Arguably the most effective thing on this platform is the Harbin. The Z9C can be piloted by one man if necessary. Has a max speed of 190 miles per hour, but cruises at 162. 5 hours endurance as long as it's not hovering. And the reason why that's important is because whenever you're doing ASW warfare, you're hovering a lot, which would significantly reduce your endurance time. It has a 15,000 foot ceiling, pretty standard for a helicopter. That tends to vary between 15 and 20,000, depending on the helicopter we're talking about. And you can see that it still uses the Thales, or a copy of the Thales, HS-12 dipping sonar. I have no information on whether or not this is licensed or a copy. I have a hard time believing that Thales is still supplying China with dipping sonars, but so it might just be a copy of it. Just know it's based on that. The KLC-11 J-band surface search radar. This extends the targeting capability of the ship to over the horizon. This is how it would probably employ that anti-ship cruise missile, the Eagle Strike, out to its maximum range. If it didn't have any other sensors, i.e. it's not with a fleet, which is very unlikely, you're probably not going to see this ship by itself unless it's transiting somewhere. Just to get from point A to point B. If it's on a mission, it's going to be with either another frigate or another destroyer or even more ships. But if for whatever reason it was the only sensor, it would put out this helicopter in the direction of the target and just get some good search data there. It could use the Seagull radar, but it's more than likely that they would use this because the Seagull would give the ship's position away immediately, whereas the helicopter would not. So tactically, this would be much more likely to be used. It does have a pylon rocket system. It can shoot, or drop rather, torpedoes, but it also has a gun pod. So you could strafe, targets with this if you want to. It does have a TV-guided C-701 anti-ship missile. I am told that this missile is not used anymore, but it is capable of firing it. I don't have any data on it, but apparently it's not very good or very reliable. The TY-90 air-to-air missile can be put on one of the side pylons. I assume that's similar to a Sting or a Sidewinder missile. All right, and that's it, folks. Man, that is the Type 053H3, the Zhanghui 2 fast frigate helicopter mod. This is an effective update from earlier designs, even without the modernization in 2015. They just finally got to a build that could effectively detect surface and air targets out to a long range, which is its purpose. This is an air defense frigate with multi-role capability. Okay, but it's just not good at anything else. It's got a helicopter that's pretty good for ASW and maybe some over the target horizon, but you're basically putting this ship out there, one, to be a target for the Americans or whoever's searching for you. They're going to shoot this thing first, probably because they're going to see it first, but it's got a long-range radar, so it can see, hopefully, those American F-18s coming, hundreds of kilometers away so that they're aware of them. We don't have any data on the performance of this radar against the F-35, of course, but it's probably not good. The F-35 is probably a ghost on these older radars, I would assume, but we don't know that for sure. So take that with a grain of salt. That's just a little bit of my opinion, my final thought on how this ship would perform in modern warfare. It would detect a F-16 and F-18, not an F-35 at 100 kilometers, It is a cheap air defense. These ships are cheap. They could have kept building many, many more of them. What they seem to have done is they've shifted to a modernized corvette, which is going to be the next lecture, by the way. We have the Chinese PLAN corvette coming up for you, and that has a lot more modern systems, has the same mission or similar to mission to this ship, and is a little bit cheaper and more modern. But for the time, for the 2000s, this was the best that they had for picket defense, air defense in a picket position, which is critical to fleet defense. And like I already said, it's multi-mission capable. It does have a sonar system. It's just not very good. I bet you the helicopter probably has a better sonar system than the mainframe is. So I really want to bang the drum on the helicopter. The two big things that this ship brings to the fleet is that long-range radar capability for detection and the helicopter for over-the-horizon surface targeting and ASW search. All right, thanks for watching, everybody. Thank you, Patreons. Thank you, YouTube members. You guys are the best. This is the last lecture I'm writing myself. After this, it is a collaboration between me and defense industry professionals. So we will see what that brings us next time when we talk about the Chinese modern corvette. I'll see you then. Thanks for supporting us. Bye. Welcome to the Type 054 Alpha Frigate Ship Brief. This is the Zhangkai 2 class. Let's get started here. So, the Zhangkai 2 was an improved version of the Zhangkai, and we first saw her modification in 2008. With improved sensors, they had changed some of the radar's topside, like we'll talk about today. Point defense was greatly improved, and the radar signature was further reduced with more superstructure topside, covered in like a uniform, angled, superstructure like you see in modern warships now. And the big thing is the VLS. The VLS system on the first one was so bad, they just brought it all below decks, which is the best place for any weapon system to be in the modern era, because weapon systems have a lot of corners and angles and, has a very large radar signature. And if you can hide that below decks like the American ships do, and the NATO countries do, the better. So that's kind of what they did with this, is they removed that horrible SAM launcher that was on the bow, the French one, and went with an indigenous VLS design here. So it is a multi-role frigate now, but primarily the purpose and the way that it's employed is as an air defense frigate. You know, it's out there, it's on the perimeter of the fleet, and it's looking as far as it can with that big freaking radar that we'll talk about, and tracking, you know, airplanes, bombers out to almost 300 kilometers, and cruise missiles out to about 30 kilometers, and fighters are somewhere in the middle there. So it can track up to 40 targets at a time. Engagement range is estimated to be 120 kilometers, and that greatly depends on the system that they're going to use for this. It does have a 76 millimeter gun, 10 kilometer range with that. Shoots 120 rounds per minute, so 2 rounds a second. Pretty rapid fire for a large caliber round like that. The Sea Whiz shoots 5,000 rounds per minute. There is an upgraded one that shoots twice as many, 10,000 rounds a minute, which is insane. We'll talk about that. ASW rocket system is the same. Basically, RBU, same as the Soviets used in the Cold War, and they still have on their current ships as well. It's basically a depth charge, you know. This one is fixed, so they have to maneuver the ship a little bit to aim the RBUs, and it has a max range of 1,200 meters. And they do use the Z9 ASW helicopter. The Z9 has multiple configurations, but ASW would be the primary purpose of the helicopter here on today's frigate. So the Zhao Shan 529 is the first hull of the Zhangkai 2 class. And she was launched in 2006, but not commissioned until 2008. So about a 2-year turnaround here to get these new ships deployed. Very similar to how long it takes us to get an Arleigh Burke built, essentially, except they're building these things in batches of, you know, 6 or greater a year. Just last year for 2022, China built 24 ships, commissioned 24 warships into their Navy. That's 2 a month, 1 every 2 weeks, commissioned a new ship. To give you an idea of the rate, yes, it takes 2 years to build these ships, but they have so many dry docks and so many shipyards that are so huge that it's like an assembly line, and they pump out a warship of one variety or another, an average of every 2 weeks. All right, so the Zhangkai 2 class has quite the historical deployments here. They've been patrolling off the Gulf of Aden since 2017 consistently. They usually send 3 to 6 ships over there. They have a base in Djibouti, so they can, you know, pull in and repair and rearm and then go back out again. And they escort ships that come out of the Red Sea across the Horn of Africa into the Indian Ocean. So they are providing, you know, an important service, to give them credit. They don't just, obviously they're there to protect their Chinese ships, yes, but their presence keeps the pirates away from other ships as well. And they did participate in the evacuation of Chinese personnel from Libya, whenever Libya collapsed almost a decade ago now. They scrambled some ships up, you know, went through the Suez Strait, went over to Libya, and brought those civilians on board and brought them out of harm's way. So a bit of a rescue mission there. And that was highly publicized. You know, it was good of them to do that. So they are, you know, doing good things for Chinese people, Chinese citizens, globally and in that region of the world. Originally, the Zhangkai had 30 hulls planned. It looks like they might be building 50 of these because they haven't slowed down. And they're coming up on 30 now. So we're thinking this version of this ship may just continue into the future. But officially, on paper, they're only planning 30 hulls to be built. It is known, the American, you know, admirals call this the blue water workhorse. That's also what Jane's calls this, Jane's fighting ships. This is the ship that's dependable, it's got great range, you know, and it can operate in all environments. And because it's multi-role, it's like a Swiss Army knife of a ship. It can perform anything. You know, it's a great air defense frigate, but it can also do ASW if that's what you need it to do. Pakistan ordered 4 of these. There's some question as to whether or not Pakistan can afford 4. but I believe they've already received 2, so they must be paying some money to China. Pakistan operates a version of this ship as well, an export version. All right, so the shipyards are the same as last time for the Zhangke 1, the Type 054. So all he did was use the same shipyard, same dry docks, same ship workers, just made a better platform. And here's what that platform looks like. It's 3,900 tons, so this is fully loaded, like with weapons and fuel and everything. Can do 27 knots. There's a lot of some misinformation out there, probably Chinese propaganda saying that this thing can go greater than 30 knots. That's untrue. It's not true at all. The top speed of this ship is only 27 knots. And that's really the only problem with it, is it cannot keep up with modern ships. The standard has been for a long time now, warships can sustain 30 or more knots. And unfortunately, the China's ships can't do that. They just simply don't. Now, to be fair, because all their ships are limited in this 25 to 30 knot range, it kind of doesn't matter. They're just not as fast as everybody else. And there's something to be said about fuel efficiency too, because if they're doing 18 knots, they can do 3,800 miles between refuels. It is the Kodag diesels that we saw in the previous class, previous version of the same class. 2 shafts, 28,000 horsepower. They have the frigate MAE top plate radar. That's that big long-range air search radar. It's a Russian radar, so this is one of the systems that they still use from Russia, but obviously they're just manufacturing it themselves now. The Type 364 Seagull C is a 3D air and surface search radar. Front dome radars are for the point defenses. Mineral E is called Bandstand. That's for the surface-to-air missiles, the HHQ-16s. Bandstand also provides the data link for YJ-83. That's that anti-ship missile. That anti-ship missile, as it's in flight to target, over 100 kilometers away, can change its target. They can maneuver that missile in flight. But it does not come from the radar that gives it its initial target solution. That's the Type 344 radar. This is probably the most misunderstood thing about the radars out there, is that one radar gives the target to the missile before it's launched, and that's the Type 344. But to communicate with the missile, they have to use the Russian Mineral E, which means the YJ-83 probably has some Russian electronics on it still to give it like a waypoint, tell it to steer and whatnot. Continuing down the list, we have the Type 347G2 radar. That's the radar that controls the 76 millimeter gun on the bow there. And it does have a hull-mounted sonar with a VDS on hulls 18 and above. Remember I said they build 30 of these. So hulls 18 and above are actually a different batch because they have a variable depth sonar hanging off the back. Was unable to confirm that it's still bullhorn or steerhide. It probably is a Chinese version of that. But because I wasn't sure, we didn't put those names in here. Just know that they do have a Chinese version of that old Russian sonar. On the weapon side of things, they can shoot 8 YJ-83 anti-ship cruise missiles. And on the bow, right behind the main gun, the 76 millimeter gun, is a flush with the deck VLS that has 32 cells. And these 32 cells can carry 2 different types of missiles, or rockets, whatever you want to call them. The HHQ-16 SAM, which is a surface-to-air missile, they could have 32 of those if they wanted to. Or they could have the CY-5 YU-8 rocket-assisted torpedo, which uses a YU-11 torpedo as a payload. So the CY-5 is the missile body. The YU-8 is the rocket. The YU-11 is the torpedo that's dropped. Okay. And they could have, as many of those as they want to, but there's only 32 cells. So there's a combination of these rocket assisted torpedoes and HHQ-16 SAMs. They also have the HPJ 26 76 millimeter by 59 gun and the HPJ 12 30 millimeter Sea Whiz. And as we go into this lecture, there's actually 2 versions of that. There's an HPJ 11 as well that has 11 barrels instead of 6. It can shoot 10,000 freaking rounds. So that's a crazy, crazy Gatling gun. But it's really good for point defense. They also have torpedo tubes. We finally found a picture of them after searching high and low. So we'll show you the triple mounted torpedo tubes. They have 3-port, 3 starboard in this pyramid shape, 1/2 basically. And that shoots the YU-7 torpedo. A different torpedo than the YU-11. YU-11 is a lightweight torpedo. YU-7 is also lightweight, but it's shot from from on board the ship, not from a rocket-assisted motor. It has 2 Type 87 ASW mortars, like we showed you on the bow, at 1,200 meter range, and that's fixed. So they got to kind of maneuver the ship a little bit to aim those. And a Type 726 24-barrel decoy launcher. And those are combo launchers. They do smoke, and then chaff is all in one deployed charge. And it's pretty neat to see them shoot those, because it puts out a huge cloud of smoke. It's pretty impressive. All right. Like I said, same engines as the Jiangkai 1. So we're talking about 2,800 RPM. 2,800 horsepower, 1050 RPM with 2 shafts. And there you can see it. I had to desensitize this slide for you, but there you go. And that's what biologics looks like there on the right. You see how they're kind of wiggly? Yeah, that's because that's organic and not machine related. Anyway, the top plate radar, this is one of the major differences. This is one of the biggest upgrade in terms of sensors that they did. This is an E-band 2-channel radar, has a max range of 300 kilometers, but it's got to be a really big target, like a B-52. It would see a B-52 at range of 300 kilometers. It would see the F-A-18 at about 180 kilometers, and it would see an incoming Harpoon missile or Exocet missile at about 38 kilometers. This radar right here. Big improvement for China. And it weighs 9.1 tons. I thought I'd just throw that in there for you. It's a heavy piece of kit. All right, here's the Seagull C3D air search radar, air and surface search radar. This is the same as the Jiangkai 1. S-band, 75 kilometer range, 60 kilowatt power with a 38 decibel gain. So, it's reasonable. Gain doesn't tell you everything about a radar, but it gives you an idea of just how strong it is. It is IFF capable, so this will ping, other aircraft and ships and anything really out there with an identify friend or foe code and look for the response. And it turns at 30 RPM rotation, 30 rotations per minute. Here's the bandstand radar. This is on top of the bridge, essentially, right above where they drive the ship. This is an HI band radar, 250 kilometer range. This is provides guidance for that HHQ 16 SAM, can track 30 surface targets actively. And here's the big thing. It's also like an ESM receiver. When it's not transmitting, it can just listen like a passive sonar system, but it's radar, and track 50 targets passively. It can also monitor up to 200 targets. So I believe the difference there is monitoring means it can display it, but not provide tracking information, which would be, altitude, speed, course. It apparently wouldn't give those on 200 targets, but it would do that for up to 30 active targets. It provides data link to other ships, as well as the YJ-83 anti-ship cruise missile. Type 344, or the MR-34, which I believe is the Russian name for the same radar, is a fire control radar for the YJ-83 anti-ship cruise missile. Multifunction fire control radar developed in Jian Research Institute of Navigation Technology. IJ band radar has both a TV and a laser rangefinder. So that tells me that this could also be used for the gun. And but according to Jane's Fighting Ships, where I got this information, even though it has that TV and laser rangefinder capability, on board the Jiangkai 2, this is used to give data, initial targeting data, to the YJ-83 anti-ship cruise missile before it's launched. So the Type 347 G2 rice bowl radar, because it looks like a rice bowl. That's literally why they gave it that name. That's a lot of times that's how this works. NATO just looks at the picture and be like, hey, we'll call it rice bowl. Makes it easy to remember. It's an X-band radar. X-bands are, high repetition rate, relatively short range. Power can be as much as you want to send to it. This one's 150 kilowatts. But it's because of the high repetition rate, it's really good for point defense and very pinpoint, positioning of a missile, or in this case, a ballistic round. It can shoot down aircraft up to, or detect aircraft up to 30 kilometers and detect incoming missiles up to 15 kilometers, assuming that they're sea skimming missiles. This is the YJ-83 I've been talking about. China calls it Eagle Strike because it's designed to hit American warships. It is essentially the Exocet missile. It's the Chinese version of the Harpoon. Yeah. NATO name we'll call it is CSS N8 Cicade. So if you hear of a Cicade, they're talking about this thing. It's a subsonic, radar homing missile. They just basically ripped off the Exocets, what they did. Yeah. You can see the box launchers there. There's 8 total launchers, but 4 are facing port, 4 are facing starboard in these quad launchers. HHQ-16 surface-to-air missile. Pretty, effective surface-to-air missile. It'll reach out and touch a target to 21.8 nautical miles. It's about 40 kilometers. Mach 4.5, man, she's fast. She'll get there in a hurry. Yeah, and it has a 70-kilogram warhead. And this is a great shot. You can see the flat area of the VLS there, just forward of the bridge superstructure and aft of that bow turret. Yeah, it looks a lot like the Mark 41 VLS, the ones on the Arleigh Burke. Very similar. CY-5, a YU-8 rocket-assisted launch torpedo. So like the CY-5YU is the body and the rocket motor, basically the back half of it. And that front half is a YU-11 torpedo. And it'll separate. Its parachute will deploy and drop it into the water at a range of 16 nautical miles, which is pretty formidable. If you think about the sonar systems, they probably have, in good conditions, a 16 nautical mile range. Probably. Deep water, if there's no problems, you have a convergent zone, they're probably going to detect an active target on their active hull-mounted sonar at 16 nautical miles. So it doesn't need to be any longer than that. 45 kilogram warhead, just enough to punch a small hole in a submarine, make that submarine fight for its life, and has a 600 meter max depth, which is deeper than any military submarine will go. HPJ-26, 76 millimeter by 59 gun. That's the big gun on the bow. So the big thing they did here with this gun is they made the turret, they gave it like a stealth cover. You see that angled top that it has? So they reduced the radar cross-section of this topside deck-mounted gun. Shoots a 5.9 kilogram shell, a low radar signature on the turret itself. We got lots of cool photos of that turret, by the way, in the photo section, if you want to go check that out on the Patreon. HPJ-12 these are the point defense guns. So you have HPJ-12 has 7 barrels, and then the HPJ-11, which is the upgraded version of it, has 11 barrels. And the only real difference is because it has more barrels, it can shoot a lot more rounds. So you're going from 4,200 RPM to 5,000, because there's different modes for these. So you could maybe squeak 5,000 out of the PJ-12. And the PJ-11 straight up will go all the way up to 10,000 rounds a minute. That's emptying a ton of ammunition into the air in the direction of an incoming missile. So if it's a subsonic missile, they've got 10,000 chances to hit it, before it hits them. So we have 2 of these 324 millimeter triple mount launchers. As you can see, it's hidden behind a door here. And so that's why you don't see it normally. This door is normally shut, but they must have been doing some kind of test or something, because there is a tube that is clearly empty. So it's been expended. These are reloaded from inboard, so they can reload these. And it shoots the YU-7 active passive homing torpedo that does 42 knots, has a 45 kilogram warhead, and about a 14 kilometer range. I'm telling you guys, an American submarine will simply outrun this weapon. Yeah, this weapon will never hit an American submarine. Okay, the Type 87 ASW mortar launcher, another weapon that'll never hit an American submarine, has a range of only 1,200 meters. Our subs are not going to get that close. But if they stumble upon a submarine that's not paying attention, I suppose they could actually use this. Russia tries to use these RBG rocket bomb units, RBUs, as anti-torpedo weapons. They see an incoming torpedo, they'll shoot these mortars in the vicinity just to hope the shock wave of the explosion will dislodge or damage the electronics. causing the torpedo to miss, right? That's basically what Russia has begun trying to use these for in war games and stuff like that. China hasn't demonstrated anything like that. Just know that these are a very short-range anti-submarine weapon. And then their effectiveness is very questionable. Okay, the 24-barrel decoy launcher. This one is pretty cool. They can shoot a ton of decoys. They have 2 of these, by the way, so it's like 48 barrels. 2 port, there's one facing port, one facing starboard, and just one charge will cover the ship in smoke and chafe, and it has a little IR flare-looking thing that goes all over the place. And it's pretty spectacular, and it's designed to just obscure the ship enough that the missile has a chance to miss. It may go up over the ship. It may, lock onto one of the flares if it has an IR seeker, like a lot of the Russian missiles have, and just completely miss the ship entirely. Of course, Raytheon, American missile manufacturers, know this, so there's means and methods that make this ineffective. But hey, it's a good idea to have, and they have 24 of these that they can launch from each side. Yeah. All right, here's that Z9C helicopter. I told you can be configured in multiple different ways, so I kind of listed them out here for you. One, the cool thing about this helicopter is you don't need a co-pilot. You can jump in this thing one man and go out and drop your torpedo payload somewhere. It has a 9,000-pound lift capacity, so it could carry troops if they wanted to. It's kind of like a workhorse helicopter. I believe it's based on a French design, the Dauphine-class, which it kind of looks like a little bit. The nose of it does anyway. It does have a max speed of 190 miles per hour, but it usually runs around 160. Has a 5-hour endurance, and that's if it's not hovering. Hovering apparently takes up a lot of fuel, but if it's just transiting, it can transit for 5 hours. It does have the Thales HS-12 dipping sonar, which I'm pretty sure is a NATO one, but they must be making a Chinese version of it. They have the pylon rocket pods. Where they can have 2 Yu-7 torpedoes. You can see one of the torpedoes mounted right there. Those are the same torpedoes that they're launching from on board the ship, the triple mount launchers. It has a TV guidance for the C-701 anti-ship missile. That's very similar to the Penguin. It doesn't look like the Penguin, but the performance is similar to the Penguin missile, which is a very old school 1970s anti-ship missile, questionably effective. And the TY-90 air-to-air missile. This thing can get an air-to-air kill, but I would not want to talk to the pilot that got shot down by a helicopter. But it does have essentially, a Chinese Sidewinder on it. Can have. It cannot have all those things, by the way. Yeah, it's just, that's the different number of things that it can have, up to 9,000 pounds, including the pilot for 9,000 pounds. Okay, so I added this slide here at the last second because there is a brand new version of this ship coming out. And this might be Hull 31 to 50. Remember I said we might be going to 50 on these? So a next generation frigate is under construction right now in Shanghai, and it has a number of improvements to its mast and antennas, and like the smokestack and all that's been reconfigured. So they further reduced the radar signature. There's also a lower number of topside weapons. They've reduced the number of point defense to just 1, so that reduces the cross section as well. And they went to the rolling airframe point defense missile, similar to what the Americans use. We still use Sea-Wiz, of course, but some Sea-Wizes have been modified to also shoot rolling airframes. There's also a rolling airframe only short-range surface-to-air missile to shoot down incoming missiles, and that's what it looks like they're going with on this. So a more stealthy design of the same frigate. It's not clear if we're going to call this the Type 057 yet. That's why I put the question mark up there. Once it's done and at sea, the experts that make those decisions, whether it's a Type 54 or a Type 57, will make that public. We don't know yet. But it is definitely going to be a better Jiangke 2 than the one that they're making now. More on that as it becomes available. All right, my final thoughts. Man, this ship is actually very capable. They're building a lot of them. They're reliable. They're blue water. They're multi-role. America needs a frigate like this, and we don't have one yet. But the Chinese have 30 of these, and they use them. They're very modern. It's a modern design. They have modern weapon systems. This is a real warship. This is what, instead of building LCSs, we should have been building. And it bothers me that China's got it and we don't. China figured it out. So primarily air defense, multi-role frigate, like I said, fielding these ships with, systems that are on par with the American systems. And I'm not including Aegis in that. I'm just saying they can shoot at up to 30 to 40 targets at a time. And that is enough to get the job done. Think of, an overmatch situation where you have multiple incoming anti-ship missiles from different directions. Well, you can assign this one ship to take out 30 of them, and they're going to be fielding multiple of these. So it's not Aegis. It's not that capable, but they're getting there. They're getting there, folks. All right. The top speed being 27 knots really is the Achilles heel, but because all the ships in the Chinese Navy are slower than American ships, it's really not that much of a big deal. If you put this ship with the American fleet, then yeah, it would be more impactful because it wouldn't be able to keep up. But all the Chinese ships are slow, so it doesn't matter. All right, and short range, 3,800 nautical miles at 18 knots. The standard really is 4,000 to 5,000 nautical miles, so it comes in just under that a little bit. But they can get from, their friendly ports in mainland China all the way around to Djibouti, because they do this regularly, and then operate out of Djibouti for 6 months, up to a year. So even though that's short range, it just requires more at-sea refueling is what it is. All right. And that's it for the Type 054 Alpha frigate, everybody. I want to thank everybody for supporting us on Patreon. For those of you that don't know, we finally, legitimized everything, and Subbrief LLC is a registered company in the United States now, and you guys made all this possible. It took me 6 years to get my act together, but we're finally here, and I can't thank you enough. Thank you so much. And I'll start working on the next one, guys. Have a great day. Bye. Welcome to the Type 052 Bravo Liu Yang class multi-role destroyer. And I want to say at the output here that we've had to break this lecture up into 2 or maybe even 3 different lectures because it's so long. The Liu Yang class destroyer shares the same name with 052, Charlie, Delta, and the future Echoes that they're going to build. So don't be surprised when we use the same name in the next lecture. Okay, but this is the Bravo version of the Liu Yang class. Let's get started here. All right. This is basically just a continuation of improving of the Type 052 that we talked about last time. They continue to decrease the radar signature by simply copying what they see happening with European frigates from the FREM to France to the UK. They're increasing the angle and reducing the number of topside corners, if you will, on board these ships, and this has a collective effect of reducing the radar signature of these ships. So this is just a continuation of that. And like our previous one, they only built 2 of these before they made so many improvements. They had to go on to the 052 Charlie, which we'll talk about in another lecture. But for the 2 ships we're talking about today, they were completed in between 2002 and 2004. So they pumped them out pretty quick for being, a big change from previous classes. Both were built in the Shanghai shipyard called the Jiangnan. They're equipped with Russian sensors and Ukrainian engines. Remember, they're stepping away from using Western equipment because of sanctions. And so they're trying to literally connect Russian sensors to their weapons, and they could not do it using Western equipment. The one thing that is completely indigenous, though, are the close-in weapon systems, and we'll take a closer look at that in today's lecture. All right, so here's the shipyard I'm talking about. You can see it on the zoomed-out map there that it is in the the northeastern part of China. This shipyard's been around forever, since the days of sail. It was founded in 1865, and it primarily produces civilian ships, car carriers, cargo ships, oil tankers like you see here. But they also have a dedicated wing that does nothing but build warships connected to the shipyard there as well. China's zero COVID policy continues to hamper production, and we're seeing a lot of problems with them pumping out the units as fast today as they had been, in part due to their zero COVID policy. And that is, it's affecting them the way it is affecting a lot of other countries, but it seems more so in China because they can't seem to get past this COVID issue. And it is affecting their production. But that's where these two ships are made, northeastern part of China, very close to the Yellow Sea in Japan. Pumping them out up there. Now that's not where they're going to end up being stationed, by the way, so stay tuned for that. All right, so here is the 052 Bravo by the number. She's 153 meters long, just over 16 meters wide, 1,600 tons. So a good size ship here, and she has quite a punch. Her endurance is about 14,000 miles if she only makes 14 knots, and that's sailing in a straight line. Obviously, whenever you get into combat operations and you're doing anti-submarine warfare, that range severely comes down. It's probably halved just because of the maneuverability that they have to do and speed changes they have to make to accurately, one, defend themselves and also prosecute, unknown contacts. Her crew is about 250 people, give or take, a few here and there. She has the SAN-12 SAM system. This is similar to the one that we've seen before. But she has 4 quad launchers of the YJ-83, so a total of 16 of these anti-ship missiles, which are pretty capable whenever they're fired in numbers. And that's what the ship is designed to do, is to shoot many anti-ship missiles at once in the same direction. She has a 100 millimeter dual purpose gun on the bow there, the Type 730 Sea Whizzes, 2 of those, and the 4 ASW rockets. I do have a correction coming up on this because I think I used the wrong picture on a previous lecture, so we're going to correct that today. And she has the same helicopter, the Z9C ASW, which is based on a French design. I believe it's the Dolphin is what the French call it, but they made their own version of the Dolphin, and they use it in the PLAN. So the Russian sensors we talked about, they got the top plate 3D radar dome, the bandstand radar, and the front dome fire control radar for controlling their missiles. So that's both search and fire control systems there. All right, so the first one is the Wang Hu DDG 168, commissioned in 2004, and she is stationed in the South China Sea where she does her patrols. The second ship is also in the same area and looks identical, just it's hull number 169, and the name is the Wuhan, PLANS, that's PLAN ship Wuhan, DDG 169. And they both operate there close to the Philippines in the South China Sea area. So this is one of the big changes that they made. You remember the previous ships were using the American LM 2500 engines. They decided, because they couldn't get those anymore, that they would make a deal with Ukraine. And keep in mind, this is going back to the 2000s, so obviously they couldn't do this deal today. And get their DN80 gas turbine engines, which are used in a lot of ships. This generates 3,200 megawatts. China propaganda brags that this is the most, but it's actually not as much as the LM 2500 or even the Rolls-Royce one that the Royal Navy uses. But they claim that it puts out more megawatts. It's simply not true. But it's a good engine. It has the same benefits as all the other turbine engines in that it's quick to start up. So you can take your ship from being tied to a pier and have it going down the river towards open waters in about 20 minutes with whoever's on board. And that's a big plus for these types of engines. This is why everybody's using them now. They're also very efficient too. She has a total shaft horsepower of 57,000, and that's a reasonable expectation for her max speed of around 32 knots. The maritime diesel is a 12V1163 diesel engine. Again, a Ukraine engine. 6,300 kilowatts, 1,200 RPM, so set your sonar systems to search for that. And hotel loads, in other words, it provides electricity as well as can provide power for the propulsion. So you can expect to have at least one of these diesels operating all the time when she's not in port, because that's how she keeps the lights on. So keep an eye open for that 1,200 RPM. All right, so the top plate air and surface search radar, and this is important to understand, this radar does both. It does air search and it does surface search. Very capable, very common radar used on even the smaller ships in the Russian fleet. The MR-750 is very, very common. It's a D and E band radar for those of you that follow radar frequencies, and has a 300-kilometer range. Obviously, for cruise missile detection and stuff, that would be a lot closer. Fighters would be a little bit closer, but large bombers operating at 40,000 feet would be detected at about 300 kilometers. Keep that in mind when we talk about these radar ranges. It is very dependent, a little bit on conditions, and then a lot on what the target is, what it's trying to track. The front dome fire control radar is MR90 or MR90. It's an X-band targeting system. X-band, generally higher frequency, because of that little bit shorter range, but also very precise. And that's the kind of precision you need to guide a weapon onto a target. And that's what this thing does, out to 30 kilometers. Very good radar, used in the entire Russian Navy and the PLAN as well. Here we have bandstand, and the top of the bandstand dome kind of blends in with the background here. I apologize for that, but it literally looks like a bandstand, and that's why we call it that. That's the NATO name for it. It is the type 366 is what China calls it. Russia calls it the MR331 mineral, and the ME is just the variant of it. It is over the horizon capable, which is very cool. It's something that sonar systems can do too. And we'll just leave that there, I guess. But they do the same thing with radar systems that sonar systems do. 35-kilometer range, active and passive modes, and it can detect an incoming cruise missile skimming the sea at about 20 kilometers. So keep in mind, if that's a subsonic missile, they got time to get weapons on range. If that's a supersonic missile or even hypersonic, you're going to have moments, absolute, seconds before it hits. And so keep that in mind whenever they're trying to power up one of these, because she has 2 of these single rail launchers. Now keep in mind, the United States was building single rail launchers on our Oliver Hazard Perry frigates, back in, what was that, the 70s? So they're still, with this design in the 2000s, early 2000s, they're going with these single rail launchers that take a long time, upwards of 20 seconds to get a new missile up onto the rail before they can fire it again. So if they're only detecting those incoming missiles with a fire control radar at at 30 or 20 kilometers, they're going to get one off if it's on the rail. And they probably won't have time to even get a second one loaded. But they do have 2 of these, okay? So keep that in mind. So they could get, if they have 2 missiles on the rail, 2 off with no problem. This uses the Russian Buk missile. This is actually the naval variant. This missile is widely used in armies and navies rather. It's configurable for all sorts of environments. So whenever you see the land version, we call that the SA-11 Gadfly. Whenever it's the naval version, we call it the SAN-12 Grizzly. Same missile, different small changes, obviously, for being attached and talking to the fire control systems on the inside, and that's why they're 2 different variants. But everything else performance-wise is the same missile. The range is out to 32 kilometers, so if it detects that incoming, they could preemptively fire this missile to engage as the missile and the target come into range at 32 kilometers. The ceiling of this missile is about 45,000 feet. These are all public numbers, by the way, so take these with a grain of salt. The performance, generally speaking, is greater than what the public numbers are, but whenever we're talking about regimes like Russia and China, it could be the opposite. They could actually inflate their numbers to make them appear stronger than they are. So we're just going to go with the public numbers, and I'll let you decide how far up or down you want to make these. She does have a 70-kilogram warhead, and again, like I said, single rail launcher. All right, we have the YJ-83. This is the missile in the box launchers. Again, 16 of these things. This is probably the most capable weapon on board. She is an anti-ship, primarily multi-role destroyer. She can do it all, but anti-ship, I believe, is her primary role. These missiles came into service in 1998. We call it the CSSN-8, the exact same missile that we had on the previous lecture. So nothing has changed here. It's still a subsonic, turbojet-driven, sea-skimming, long-range missile. 180 kilometers. That's a very long range for one of these. All right. On the bow, we have the Type 210 100-millimeter naval gun. Again, a copy, a ripoff, if you will, of the French 100-millimeter gun, and it's not very good. This thing has a problem with jamming after just a few rounds all the time, which is part why you see the freaking door open in this picture, because there's always a crew member going in there having to clear freaking jams. It does shoot 90 rounds a minute whenever it doesn't jam. It IOC to 1982, has a ballistic range of about 17 kilometers. Effective range, because of the unreliability of it, is only about 12 kilometers. So if it's going to hit something reliably, it's going to be a lot shorter than 17 kilometers. It does have different modes of single fire, and then it can individually select 2-round burst, 3-round burst, all the way up to 6-round burst. So that's interesting. And it has a poor reputation among naval communities because of its jamming problem. If they would get that fixed, then it would be okay. All right, same torpedoes and ASW rocket bombs as other destroyers in her class. Has the triple launchers on both sides, 324 millimeter torpedoes, and then the rocket bomb units, RBUs, on the bow there. This is the very impressively looking, anyway, CIWS, the Type 730. The Chinese did develop this on their own. Well, they claim to, and it does look kind of unique to China. Now, it can be multiple, guided via multiple things. It can be taken over manually and driven by a joystick by an operator. Or it can be radar controlled, and it can has several modes. It has anti-air mode for point defense. It can be put into a surface mode as well for engaging close by, unmanned drones that are in the water or whatever. Has about a 3-kilometer range. The magazine, relatively small, 640 rounds. It'll burn through those quickly. It is completely autonomous, and a closed loop system is important here in that it does not rely on other fire control radars on board the platform to hit its target. It's completely self-contained. And that's really important for these defensive systems, because if they're being employed, that means you're under attack. And it's likely that the ship may have suffered damage and a loss of capability. So as long as it keeps its own radar or optically guided, it can still operate. All right, here we have the 18-cell decoy launcher, and this is where I want to make my correction. I used this photo, or a photo of these launchers, as a ASW launcher, I believe, in a previous video. So please know that these are chaff launchers and combo launchers where they can do flare and chaff. Okay, so those are the Type 726 decoy launchers. This class only has 18 of these. Further modifications will increase this to 24, but here you can see the 18-cell launchers, and that's one way you'll be able to tell this, 052 Bravo from, say, the other ones, is by looking at the number of launchers they have on these things. And there you can see on the bow it has the SAM launcher there. Okay, this is it in profile, and here you can see they have 2 SAM launchers, one forward, one aft, single rail, primarily self-defense, launchers in my opinion. And the SSM missile launchers there are midships. That's her primary, that's what she brings to the fight, is those missiles are going to go out, 180 kilometers and hit something at subsonic speeds. A very utilitarian ship. Everything on this ship has a purpose. You can see clearly that they've got the sensors where they need to be, the weapons where they need to be. It doesn't have a lot of anything except the anti-ship missiles. In my opinion, 16 is quite a bit. And yeah, final thoughts. This relatively short lecture as we go through the 052 variants. They were required to move away from NATO systems because of sanctions, but this was also good for China because they're increasingly trying to become self-dependent, using indigenous systems as they go through this century. That's one of their big goals, is they're tired of being reliant on diplomatic relations with other countries to maintain a weapons supply line. If they ever go to war with someone supplying them equipment, well, they're not going to have that equipment anymore, right? So they need to be able to build their own ships, their own systems, and this is just another step in that direction. The next step is going to be an Aegis-style system, but that's going to come up in the next lecture. Again, that gun on the bow, it might as well be a ballast. It can shoot a couple rounds, and then you can expect it to stop firing until they get someone out there to clear the jam on that loader. But this is the foundation. This is the beginning of a very capable ship coming up called the Type 052 Charlie, where we will greatly improve the performance of this ship. And I look forward to bringing that to you in the next lecture. All right. And that's it. Thank you again to the Patreons here. We have so many people donating and just keeping this project going after 3 years. We're going into year 4 here soon. Actually, yeah, we're over 3 years now, so we're going into 4. And we have Scott Borg and Fraser Disney, those guys writing big checks every month. Thank you so much. You guys, I'm humbled. I don't deserve it, but I appreciate it. And it keeps the family very happy with your support. Okay, department heads, Harpoon Henry, William R. Collier Jr. Appreciate you guys. And, of course, the entire wardroom with the division officers rounding out Alexander Huff, Brendan Ferry, Joel Corrett, DGS 4000, Raging the Cajun, Jordan Vazraka, Josh Warwick, Robbie Stahl, and Sean O'Neill, the OG. We all know Scott Borg, Sean O'Neill. All right. Hey, we'll see you guys in the next one. Thanks for watching. Bye. Bye-bye. Welcome to the PLAN Type 052 Charlie ship brief. All right, so this ship is very significant in the history of the Chinese Navy. The ship has been referred to as the Chinese Aegis. This is their entrance into the world of fleet protection, fleet command, if you will, command and control in the modern era. So the main difference between this Charlie and the 052 Bravo is the significantly upgraded ASA radar that was developed by Nanjing Research Institute of Electronic Technology. And it is based on the American radar and some of the radars that were coming out of the West, like France's radar as well. And they just tried to mimic what we were doing. And they were pretty successful at it. This radar is capable. It has long range. It can track multiple contacts across a wide frequency, which we'll get into. And adding command and control fleet command to a non-aircraft carrying, or larger ship is significant here. So this destroyer, 7,000 tons, fully loaded, can coordinate an entire fleet. And that is the big difference that we're going to talk about today. And here's a picture of Hull 1. This is the Lanzhou, or Zhao, Lanzhou, I believe is the proper pronunciation there. I'm getting better at my Chinese here. And it was Hull 170. So what's important here is they were made in 2 batches, the Charlies. There was 2 ships that were built practically parallel next to each other. And then they waited a couple of years. They made some improvements, and then they made a second batch, but it still falls under this class. And then we'll quickly talk about the second batch at the very end. But just know that there's not much difference between the 2 other than some minor improvements that we'll go over. But this is the ship we're focusing on today, the Type 052 Charlie. These were all built in Zhonan shipyard in Shanghai, China. Just the same shipyard that was built in the Bravo series. Just know that the Charlies are built here as well. Same data points here as the last lecture, founded in 1865. This is an ancient, shipyard that's been modernized, has been around for centuries at this point. Primarily builds civilian ships, but it does have a segregated portion that does nothing but military ships, and the 2 shall not meet. They don't mix and match. One side and the larger side is civilian, and the smaller, more condensed side builds a lot of warships, including the ones we're talking about today. Here's Hull 2. This is the Haikou, DDG 171, and it is exactly the same as Hull 1. These were the only 2 of batch 1 that were built, and we're going to break these down by the numbers. Like I said, it's 7,000 tons. It's 155 meters long. So this is a long girl. She's 17 meters of beam and can go in excess of 32 knots. She has a 4,000 nautical mile range at 18 knots, which is significant. So she can get outside that first group of island chains. And that's going to become more and more important as we talk about this fleet. China needs to operate past on the eastern side of Taiwan, on the eastern side of the Philippines, and stay there and maintain force protection in those regions. That's the goal. That's what we're working towards. We're not there quite yet with this, but this is a step in that direction. Crew is 220. She has 2 of the UGT Ukrainian 25,000 GTs in batch 1. They made a copy, and this is the big difference between batch 1 and batch 2. They made a Chinese version of the Ukrainian UGT domestically built in China called the QC280 GT. And that is significant that they don't need to license or purchase this power plant from Ukraine anymore. This is back in 2005. We're talking here. So obviously not current events, but they knew that eventually they wanted to get away from dependence on any other country, including France, which that they've been dependent on for a long time, and America up until 1989. And they're just continuing that into the 21st century. They want to build their own ships with their own technology in their own shipyards using their own workers. And they're doing that with Batch 2. Batch 2 will come about a little bit later on. Their diesels are no, I apologize. The diesels are not the same. The MTU 20 valve or 20 cylinder V956 TB92. That's the diesel that can run the propulsion and also does the hotel loads on board. So it's CODAG or CODOG rather, combined diesel or gas. Has 2 shafts, 5 blades CCP, which means that it's controllable pitch propeller, CPP. On the weapon side, this is a huge difference. This thing has got weapons all over it. And because it is a fleet command ship, it participates, it's ready and able to participate in any long range fight. The primary weapon of this destroyer is the HHQ-9 surface-to-air missile. This is a very long range surface-to-air missile based on the Russian S-300 Fort, which is on the Slava class. But this is a Chinese version of it, and they put 48 of these on that. And unlike other VLS systems like in the West, these are dedicated surface-to-air missiles with this specific kind of missile. They haven't quite got to the point where they can take a VLS and put a Tomahawk or a Harpoon or some other missile in it. These are strictly surface-to-air missile silos. On the bow, they have a 100 millimeter naval gun. That's the same gun as the previous 052. The Type 730 Sea Whiz protects it. There's one forward, one aft. And the big anti-ship missile, the YJ-62, greatly increases its capability over its previous variant. And they carry 8 of those. These are very long-range, subsonic, surface-to-surface anti-ship missiles. She has 6 torpedo tubes, 3 on each side in that little triangle shape. She also has multiple decoy rockets and a helicopter hangar that she can stick a helicopter in. She can operate Russian helicopters, and they did originally in 2005. They had the KA-28, I believe it was the Helix. But now they operate the Z9, which you see here in the picture up there, which is a copy of a French helicopter. So the radars, we're going to break these down for you, but just to list them here, we have the Type 346. So whenever you see H/L and then the number, commonly spoken, that's just called type. So I did the printed version for you here, H/L JG346, but whenever you talk about it, it's called the Type 346. So Type 346 ASA radar, that's the big Aegis radar, can go out hundreds of miles and shoot down airplanes. Also detect surface ships, multi-beam, can track multiple targets. Also with that is the Type 517 Bravo air search radar, very long range, like 300 kilometers, something nuts. She has the Type 364 over-the-horizon surface search radar, the Type 344 fire control radar for the gun, the Type 349 Sea Whiz, that's the little radar on the Sea Whiz, I even added that. She does have the Type 9 Hall active passive sonar. We don't have any data on that. China's very close-lipped about what that is, so we won't be going into that, or the ESM and ECM suites. That is the Type 726 ECM. So here's a picture of it. Broadside, you can see up front, we have the 100 millimeter gun. Right behind that are 6 sextuplet surface-to-air missile VLS launchers. And each one of those has its own hatch. It does not need to rotate like the Russian SF-300 Foxtrot does. So they can launch a little bit faster than even the Slava can, because there isn't that mechanical delay of rotating the revolver-like system on the Slava class. This one, they open the hatch, they cold fire the missile, which means it's just pneumatically ejected with air. And once it's above the ship, the rocket motor kicks in and throws the missile downrange. Behind that is one Sea Whiz right in front of the bridge. If you go aft of the stacks and the superstructure, we'll see the surface-to-surface missile launchers. Instead of being box launchers, these are round, but they're positioned topside. Vertical launch system above the helicopter hangar. It takes up almost half the hangar, so they only have space for one helicopter on this platform. So it's the same system as on the bow, except instead of having 6 sextuplet launchers, they have 2, for a total of 12 missiles in the aft battery. And right behind that, above the hangar, mounted facing aft, is the second of 2 Sea Whizzes, the Type 730 Sea Whiz. So they have good point defense, they have good long-range air defense, and good anti-ship capability with these subsonic weapons. Here are the engines that they use. This is the Ukrainian UGT 2500 gas turbine. Makes about 26 megawatts. This number fluctuates between sources. I put the megawatts here for the Chinese version, which is a little bit less than the Ukrainian version. So just know that whenever the Chinese copied this, they didn't get the efficiency that the Ukrainians had. But they didn't have to depend on the Ukrainians anymore, so it's good enough. And sometimes that's what they're looking for. Good enough. And the diesels are the MTU V20, V956, TB92. All those numbers mean something, but what it means to us is it can generate 4,900 kilowatts at a 1,500 RPM. So set your sonar systems to look for 1,500 RPM because these run at a constant RPM. The load may change. They may change speeds. They may change the electrical bus may need more power, less power. The RPM of the diesel stays the same. HHQ-9A, this is, like I said, similar to the SF-300F. Is actually based on that. The actual missile is. The launching system's a little bit different. IOC'd in 2004, has over a 100-kilometer range, used for fleet defense, sextuplet launchers, 36 forward, 12 aft, for a total of 48 of these missiles. They have to pull in to reload these. So they put a lot on it so that she could stay at sea, stay in the fight, even after initial engagement. Here you can see what I mean by a cold launch on the left. You can see the missile above the deck, approximately 15 feet or so. And all that gas that's around it, that's the pneumatic launch system. That literally just pushed the missile out vertically. And the moment the missile stops rising is when that rocket motor kicks in. There's a little sensor in there. It says, oh, not going up anymore. Fires instantly to keep it falling back onto the ship. And I put a picture there on the right showing you the aft sextuplet launchers as well. It's kind of hard to see, but it's the best photo I had there. All right, let's take a look at this naval gun. Same naval gun as we had last time, based on the French design, 100 millimeter naval gun. Computer controlled, IOC 1982, 90 rounds per minute, has all sorts of different settings. It can fire 2 rounds at a time, 3 rounds, and then stop, all the way up to 6 round burst and then stop. It suffers from the same problems as it had before. They have not fixed the jamming on this. They're going to end up inventing a whole new gun because this thing, their copy of the French gun, is even more unreliable than the French gun is. Here's the YJ-62 launchers. Like I said, they are round, but technically not called box launchers because they're not boxy, but they are external launchers. They're not below the deck, and they're just big round tubes. 4 facing port, 4 facing starboard, but they're bundled together topside. These IOC'd in 2005. They are subsonic. 400 kilometer range though. This is a long range missile. And it carries a significant warhead, 4 and 10 pound warhead that's semi-armor piercing high explosive. That will get the job done. It's going to set a ship on fire, whatever ship it hits, and let the fire burn the ship down. And it does use Beidou GPS, which is the Chinese version of GPS. It's probably pronounced different, but it's spelled Beidou, and I think that sounds cool, so I'm going to call it Beidou. So Beidou, spelled B-E-I-D-O-U for those listening to this, is the Chinese GPS that it uses. It also uses the American GPS, but it knows in a fight with the United States, that's going to be encrypted, so they can't rely on that. But it also has internal navigation, INS, to keep it from spiraling out of control and into the water. It can do mid-course correction, just like the Harpoon. Think of it as like an extended range Harpoon. Yeah, that's how I would describe this missile. All right, the Type 730 Sea Whiz, IOC'd in 2003. This is the same one that they're going to have on all their ships of this era, early 2000s. 640 round magazine, completely autonomous, doesn't depend on any ship systems to operate. Once it's put in, kill mode, if it sees something, it shoots it. It does have an anti-surface mode, I should point out, but it's primarily for point defense against missiles and low-flying aircraft. They're coming too close. About a 3 kilometer range for these rounds. All right, so here's some close-up of this ASA radar, this Type 346. NATO name is Dragon Eye, or I should say the American name, but we'll call it NATO designation Dragon Eye. The operating range of this is 3 to 3.4 3 to 3.4 gigahertz, because it's a radar, and 5.25 to 5.95 gigahertz. Like I said, it has two different radar ranges, and it can designate multiple contacts inside those ranges. So it searches with a frequency, it tracks with a different frequency, and it can track lots of different contacts in those frequency ranges, designating a specific frequency to each detection. And that's the beautiful thing of Aegis. This was groundbreaking technology in the 1970s. It was off the chain whenever we developed this in the United States, and now the Chinese have a version of it. It can see out to about 150 nautical miles, and it is a wholly digital system. The Type 344 fire control radar, you see circled there, simply line of sight fire control radar for the bow gun. So anywhere the bow gun points, that radar can pivot and point to give range information, speed, so it can do a proper calculation of lead time for the shell and all that. That is the Type 344 fire control radar mounted above the bridge. The Type 364 OTH radar, NATO name is Seagull, is a surface search radar, and this is an over-the-horizon radar. The surface and air detection, but it's primarily a surface search. I couldn't find any reasonable data on this. I saw a lot of numbers that were really high, some that were obviously not right. So I'm just going to say, as far as ranges go, we don't know. China's not being honest with that on any of their websites. Surprise, surprise. All right, the Mineral ME, that's also commonly called Bandstand. Bandstand was on the previous units of this class as well. Does weapons control and data link for that surface-to-surface missile, the YJ-62, giving targeting information as the missile flies through the air. And that communicates in the India band. So that's the band you want to be looking for if you think you're under attack. You might be seeing some India band along with other radars coming at you in your vicinity. Knife rest. Knife rest is the large radar that is near the stacks just after the superstructure. As the Type 517 Bravo, the Bravo version's on this ship. It operates in the VHF band and has a very long range. It's 300-kilometer early warning radar. Type 349 Sea-Whiz radar, IOC'd in 2003. This gun has, like I said, 5,800 rounds per minute, 3-kilometer range, but there's a picture of the radar right above the gun dish focusing forward. I should point out, next to the radar, that is the optical sensor. This gun can be optically controlled with a joystick in the CIC area. So very good point defense gun, rotary style, very similar to the Phalanx in the United States, or the Goalkeeper in the UK Navy, Royal Navy. And it is completely autonomous, like I said. So all these systems are on both batches, the one exception being the change in the engine room. The batch 2 has the Chinese version of that gas turbine. So they made two ships with the Ukrainian engine, the Lazu and the Haku, and then they created four more, DDG 150 through 153, and they operate in different navies. China has a South Sea Navy, and they have an Eastern China Sea Navy, Northern Fleet. And that's where the four batch 2 ones operate. They're all up there operating near Shanghai, patrolling the East China Sea typically. And batch 1 is down in the south, around the South China Sea area. So it kind of gives you an idea of how they operate. And because they have different maintenance requirements for that propulsion system, it makes sense that they would be home ported together and separately. Together being the batch 1 together, batch 2 together, but the batches themselves are separate. Here's a picture of that engine that they copied. You can see the Chinese officer there, very proud of his Ukrainian engine that he calls the QC-280. It powers all sorts of ships now. Like we're eventually going to get to the Type 055 destroyer. That's the really new one. That's going to be exciting to talk about. This engine powers that as well. So they're very proud of this. It is it's not quite as efficient as the Ukrainian one in my opinion, but it works, and that's really all that matters. They also put this engine to power the conventional Type 011 aircraft carrier, and we'll probably eventually get to that ship brief as well. But I thought you might like to see what it looks like on board the ship. Remember, 4 hulls of Batch 2 are the ones using this engine. All right, final thoughts. Man, this was a huge step forward for the Chinese Navy, the PLAN. These were built over a 10-year period from 2005, and then they took a little break, a couple of years off, and they built 4 more all the way out to 2015, total of 6 ships. And this is a significant increase in capability as far as fleet control, command and control. That's very important, talking about communications and data links, sharing of target information, and it has very long-range air search radar and can defend the fleet. This is really the first fleet defense destroyer in the modern PLAN Navy. Ironically, whenever this ship came out to little fanfare here in the West, there wasn't a lot of reaction publicly. I'm not privy to any information about how the Pentagon reacted privately, but as far as any public statements or changes in policies, there is no record of that anywhere. So it seems like this kind of fell under the radar, literally, whenever they built this. I don't think the United States understood the significance of this ship. You could attest that to maybe it not being the same because it carried the same name. It's still a Type 052, but instead of a Bravo, this one's a Charlie. And I think that was a mistake. The reason why they did that was because of the propulsion system. The prime mover, we call it in naval circles, is the same. And prime mover is what dictates the class of ship above everything else. But the capabilities of this ship are so far and beyond what the Type 052 Bravo has. It's really intense and impressive. And this will be the foundation for the Delta. The Delta we're talking about next will continue to improve on this design. But this really is the first one that the United States Navy should have taken a longer look at, because this one is very similar in capability to our early Burks, like maybe the Flight 1s or maybe the early Ticonderogas without all that firepower, but the same, sensor suites. And keep in mind, this is the time frame whenever the United States is involved in 2 land wars, Iraq and Afghanistan, and we're building Global Hawks and precision strike missiles that can hit cave entrances, and then we pat ourselves on the back for blowing up goat farmers. And we're building in the Navy the Zumwalt and the LCS class. We are not paying attention to the PLAN enough. I'm sure some department in the Pentagon probably was, but the people that make the decisions were not. And we're paying the price now because they have moved on from this, which we'll talk about next time. All right. Hey, thanks to all the patrons out there. I really do appreciate it. Scott Borg, Fraser Disney, Harpoon Henry, William R. Collier, Alexander Huff, Brennan Ferry, Joel Cornett, DJS 4000, Jordan Vazraka, Josh Warwick, Robbie Stahl, and Sean O'Neill. You guys are the best. All right. We'll see you in the next one. Thanks for watching, everybody. Bye. Welcome to the Type 054 Bravo ship brief. This is the brand new Chiang-class frigate China's building right now. So they've added a lot of new equipment to it, and that's what we're going to talk about today. This is being built by one shipyard right now. It's the Hudong Zonghao shipyard in Shanghai. The weapon configuration right now is still unclear, but we have enough visual evidence to have a good guess at what's going on. And that's kind of what we're talking about today. So I do want to caveat today's briefing with, we are recording this as it's happening. This ship was launched about 4 weeks ago. So she's not even commissioned yet. And they're building 4 of these. So we're not, we haven't seen any performance at all at sea. Sea trials have not even started yet at time of this recording. So this is basically an initial briefing, and whenever she is operational, which could take a year or more, we'll probably do some kind of follow-up. All right, but let's talk about what we do know about the brand new Type 054 Bravo, the new version of this Chiang-class frigate. We're going to call it Chiang-class 3 because it's the new one. This one displaces 6,000 tons, 30% heavier than the previous one. The last one was about 4,000. This one is 6,000. Much larger hull. It displaces a lot more water. Okay. And with that, she has a lot of new weapons. 32 cell VLS on the bow, capable of shooting medium-range surface-to-air missiles and anti-submarine torpedoes. She has a 24 cell SAM launcher on the rear end for point defense. And she has 2 quad-launch anti-ship missile racks amidships. Probably YJ-12s, but we'll see what she actually has. We'll break down, we'll treat it as if it is a YJ-12 in this lecture. So she's heavier, longer, wider than the predecessor. All right, let's start on the bow, talk about weapons here. We begin with a HPJ-26 76mm gun. This one does look a little bit different. The housing's a little bit newer. So this may end up being a new version of the PJ-26, but for today's purposes, 76mm gun. That's all we need to know. Behind that is a 32 cell VLS on the deck for the surface-to-air missiles or a anti-submarine torpedo. Behind that is a Sea Whiz. This is a major difference here from the previous version. They did not have this close-in weapon 30mm gun on the Zhang Ke-2. They do have it on this one. This is the Type 1130. The 11 means it has 11 barrels on it. Very rapid-fire point defense weapon. Amidships, and you cannot see it because it's hidden by the hull right there, but there are 2 quad launch rack mounts. The launchers are not even installed yet. That will house the YJ-12 missiles there. Behind that, we can see where there is a door that opens up to allow torpedoes to come out. There's one of these on the port side, one on the starboard side. Shoots a 324mm torpedo. That's usually a lightweight torpedo. Could either be the YU-7 or the brand new YU-11 that we'll break down for you in this lecture. And then behind that, on the roof of the helicopter hangar, is an HQ-10 SAM. And that is a point defense, very short range SAM designed to intercept incoming cruise missiles or low-flying aircraft that are near the ship. All right, let's talk about sensors. Starting in the front, we have a Type 349 Alpha fire control radar. That's for the 76mm gun. It is completely independent of all other radars. At the very top is a new S-band ASA radar. We know it's an ASA. We don't know what power levels it has or any kind of data. As soon as she goes to sea and fires that thing up, we're going to know a lot more about her. But all we know right now is that it's an S-band radar. All right, it's a Type 751 ESM there on the sides and 7263 ECM. So ESM is for sensing and the ECM is for countermeasures for electronic warfare. Behind that, on the large mast center of the ship, is the TACAN, comms, VHF, UHF antennas. So that's how she's going to communicate. They may end up putting a shroud over that, but that's it without the shroud. Behind that superstructure is the Type 7264 Bravo decoy launchers. There's one port, one starboard. These shoot combination chaff flares up into the air to mask the ship's signature. And the helicopter hangar there on the back is where she's going to house a Z-21 Foxtrot Marine helicopter. It is essentially a Chinese copy of the American Seahawk. And you'll see a picture of that here shortly. On the rear end there, you can see the door. It is currently shut for the towed array sensor, towed array sonar, and a variable depth sonar. So VDS would be deployed out, and it would have little fins on it. And as they move forward through the water, the control fins can push it down and change its depth. The idea is to get the VDS below the thermal layer where it can then transmit active sonar. It does have a towed array as well, passive towed array. All right, here is the visual difference between the previous version and the current version. You can see the one on the bottom is the new version. On the bow, it has that point defense gun right there. The superstructure is a little more compact and has a little bit larger VLS there on the bow as well. Notice that they removed the RBU 6000s. Those were the depth charges. No longer needed. That's how much confidence they have in the torpedoes now. All right, Type 054 Bravo, they're building 4 of these in the same shipyard. I should mention that this is the first in what appears to be a competition where the Chinese central government is asking each shipyard to come up with their best version of this frigate in terms of, effectiveness, firepower, ESM, and then of course cost, and getting them into the water quickly. So the other shipyards have not built their version yet. So this is the Hudong version of this frigate. And they're going to build 4. 4 are under construction right now. And that's where they're being built, right there in Shanghai. Okay, let's break it down by the numbers. This is the Zhangkai 3 class, is what we're calling it. It's the code LAG. Propulsion has 2 shafts, so that has the gas turbine on it with the diesels. It has it's 147 millimeters in length, 18 millimeters across, and displaces 6,000 tons once it's fully loaded with equipment and whatnot. It has 2 quad-launch anti-ship missiles, a 32-cell VLS on the bow with a 24-cell short-range SAM above the helicopter hangar, a 76-millimeter gun on the bow with a 30-millimeter Sea-Whiz right behind it. It does have port and starboard torpedo tubes and a Z-20 Foxtrot ASW helicopter. As for sensors, it has the S-band ASA radar like we talked about. It has the Type 349 Alpha fire control radar above the bridge to control the 76-millimeter deck gun. It does have an electrical, optical, and infrared director. We don't know the number on it yet, the version yet, so we're still waiting on that. It does have ESM and ECM of the 751 and 726 family. It does have a navigation radar. Not able to confirm it yet, but it's probably the same navigation radar they've been using. That doesn't appear to have a big upgrade visually anyway. It does have the decoys, port and starboard. I told you they shoot the combination chaff, flare, smoke, are all available, and that's 122 millimeter shells that they launch up into the air. And she does have towed sonar array with VDS capability. So quite the frigate here. This is an actual warship. Look at the number of sensors and, weapons on this little 6,000 ton ship. All right, here's a Type 349 Alpha fire control radar developed by Zhan Navigation Technology Research Institute there in China. It's independent of all other radars on board, has the sole mission of directing the 76-millimeter gun. It is an X-band frequency, high repetition rate, very accurate. You need that to control weapons. There's an electrical optical sensor on this as well. Has a range of 18 kilometers and can track 1 target at a time, which, since it's only directing 1 barrel, it makes sense. It does have 360-degree coverage, minus the superstructure that's right behind it. Here's the decoy launcher we were talking about. Great photos of this, by the way, brought to you by Tayfon Osbrick, our researcher for these lectures. So this is the new variant of the 726 Mod 4 decoy launcher. It has 3x8 tubes for each launcher, 122 millimeter trainable, IR flares and chaff, fires anti-torpedo decoys and HE mortars, and that's the new upgrade to this launcher. Is now it can throw decoys into the water, not just smoke, flare, and chaff up into the air. Very flexible loadout. They can put whatever they want in each one of these tubes, and combat mission system is completely integrated with this. So the same system that is communicating with the radio room and getting messages and targeting from, say, other platforms, including their helicopter, is also in control of the weapons and this decoy launcher. It's all integrated, all together. So here's the HPJ-26 76 millimeter naval gun. The housing is a little bit different on this one. It's more stealthy. They added, fewer corners to it. So it's locally produced AK-176. That's the Soviet version. It has an effective range of 15.7 kilometers and has a selectable rounds per minute of up to 130. So it can fire pretty fast. We'll see how much of this thing jams whenever it gets out on sea trials. That'll be interesting to find out. They've had a history of problems with jamming these guns with the high fire rates. Muzzle velocity is 980 meters per second. Can shoot nearly straight up to a plus 80 degree and a negative 10 degree where it's blocked by the deck itself there. Has 2 types of rounds. It has fragmentation for use against ships and airburst against aircraft and incoming missiles. So you will see this gun trying to defend the ship in a missile attack. Alongside of it, or literally right behind it, is the PJ-11. This is the Type 1130 Sea-Whiz, developed by the 713th Research Institute. Has 11 barrels, shoots 10,000 rounds a minute, does not jam as much. as the deck gun may. It has a muzzle velocity of 1,150 meters per second, so it's pretty high. Again, can shoot nearly straight up and negative 25 degrees down. In the event of a UUV attack, this is the gun that's going to defend the ship right here. You would think the gun on the big gun on the deck, the 76 millimeter would. If the UUV is detected far enough away, then yes, that would be the case. But close in, surface attack UUVs, they're going to employ this gun to try and defend the ship. Can shoot HEI frag and frag T and APF SDS rounds. The sensor's a J-band radar with electrical optical fire control system as well. You can see the little ball on the left-hand side of the turret that's next to the radar dish. That thing flips 180 degrees and has a little lens on it. It's in the stowed position right now. All right, let's talk about the YJ-12. This is a nasty anti-ship missile. It's the YJ-12 Ying Ji means Eagle Strike. So they've literally named this to go against the United States, in my opinion. The dimensions are, it's 8 meters long, 480 millimeters in diameter, and 2,200 kilograms. Can reach a peak speed of 3.3 Mach. This thing is incredibly fast. It's designed to just burn through, with speed alone, any kind of point defense. You know, you shoot these in mass, and there's only so much time inside 5 kilometers that the point defense can actually target and adjust. And so the idea is, yeah, you may get one, but you're not going to get all 4 that are coming at you. So the max range is 500 kilometers. That's 290 kilometers if they have the export variant, because they do sell this missile to other nations. The warhead is a 250 kilogram HE semi-armor piercing warhead that is impact fused and time delayed. They can choose one or the other. The guidance is active radar and internal navigation sensor as well. Has a solid propellant booster with a ramjet sustainer and has been in service for about 20 years now. Here's the HHQ-16, Sam. That's that medium-range surface-to-air missile that's on the bow, right behind the 76 millimeter gun. Has a range of 40 kilometers, can shoot up to 15,000 meters in altitude, has an HE fragmentation warhead. The reload time for 8 cells is only 90 minutes, so you can reload this thing pretty quick, but you do have to pull in to a port to reload it. They're not reloading these things at sea yet, but like the United States, we're working on it. See, reload time is 90 minutes. Guidance is semi-active homing, radar, inertial guidance, and command updates. It gets mid-flight command updates towards the target. It is cold launched, which means it's just ejected with compressed air, and then the motor ignites. And the fire interval is 2 to 3 seconds. So it can put out a lot of missiles very quickly. In the same battery, it could choose to shoot, instead of the HHQ surface-to-air missile, the YU-8 CY-5 rocket-assisted ASW weapon. So this is essentially a torpedo with a parachute and a rocket motor. And it's pretty effective. It definitely works. They've used these in war games for years reliably. So it's a lightweight torpedo that once in the water can search out to 2.5 kilometers. It has a 45 kilogram high explosive warhead, and it's only 0.85 meters in diameter. The maximum range, if it runs in a straight line at medium speed, is 16.2 nautical miles and can go down to 600 meters in depth, which is deeper than most submarines can. So it's going to get you if it sees you. Now here's the YU-7 lightweight torpedo. These are the torpedoes that are not vertically fired. This would be shot from the waist torpedo tubes, port and starboard. And the YU-7 is the older variant of this lightweight torpedo. It's been around since the 90s. Only does about 43 knots. Modern submarines will just outrun this thing. It's got a 45 kilogram high explosive warhead, has a range of 14 kilometers, but unless they drop it right on top of you, or if you're a diesel boat, you could be screwed. But any nuclear submarine is just going to crank up the reactor and get the hell out of the way if this thing starts tracking them. That's why they built the YU-11. This is the big brother, the new variant of the YU-7. It is launched from the same launchers, port and starboard, same size, but has a little bit heavier torpedo and a lot more fuel and a much stronger engine. This one uses auto fuel. Instead of being electrically driven, this one is gas driven, or monopropellant driven to be more precise. It has a 2-speed reciprocating external combustion engine, just like our modern torpedoes here in the United States. has a range of 30 kilometers at 23 knots, which is it just fooling around. When it gets serious, it can go up to 50 knots, but its range is reduced immensely to 11 kilometers. So a lot of limitations there. Obviously, I can't talk about how to evade this torpedo. Just know that the only way this torpedo is going to hit a modern nuclear submarine is if it's very close. The submarine would have had to make a terrible mistake to get that close to a ship when it doesn't need to. And that's all I'm going to say about it. All right, let's move on to the HHQ point defense, Sam. It's very similar to the rolling airframe 116 that we have here in the United States, but it's not a copy because, ironically, this missile, when it's fired, it does not spin like a spy rolling football like the American one does. This one just ejects it straight out, and it goes after the, whatever target. Because of that, it's not that accurate. It's not that steady, at least in the initial flight. It just ejects the missile in the general direction and hopes the seeker picks up on the target. It does have a max range of 9 kilometers for subsonic targets and 6 kilometers for supersonic. Again, that's the advantage of that supersonic missile coming in on you, because these weapons systems take time to lock onto the target before engaging. And that millisecond is 3 kilometers. All right, the Z-20F helicopter is manufactured by AVIC. This is the ASW variant of the Z-20 helicopter, and you can see by the picture on the right that it looks very much like the American Seahawk. And they've made some minor changes to it, so you could say that they've put a Chinese spin on it, but everything from the engine housing to the pilot to the main carriage it's all American. All right, so this is equipped with a surface search radar and can deploy sonobuoys and torpedoes. Has a max speed of 190 knots, very similar to the American one, with 160 knot cruising speed and a range of 30 nautical miles. Service ceiling of only 20,000 feet. This thing will come out and get you. And that, ladies and gentlemen, is the Zhanghe 3, what we know about it so far. Again, just launched the first one. They're building 4 of these, 2 at a time. So there's 2 in progress right now. This is a 70-year update from the original Type 054. It's 2,000 tons heavier, like I said. All ships are being built in China, and all 4 of this variant are being built by Shanghai. So other shipyards will probably have their own versions of this, and when that happens, we'll update that as well. So the Type 054 Bravo frigates will feature less radar cross-section and less IR signature, so they're more stealthy. Propulsion is assisted by the combined diesel-electric and gas turbine arrangement. That's the COD lag that I talked about in the beginning. And the first 2 were launched in August 2023, about 3 weeks ago. So we will see where this leads us. I'm kind of excited about this. I know China is a near-peer nation that we don't have good terms with, but I'm still impressed with their shipbuilding capability. I can't help but be impressed by what they're doing over there in China. They're building these ships quickly. They're putting a lot of capability into only 6,000 tons, unlike what we're doing here in the United States. We're building slower, less, and heavier ships. And I think China's doing it right. All right. Thanks, everybody. I'll talk to you next time. Welcome to the Type 055 Destroyer Ship Brief. This is one of the strongest ships in the world right now. It's also the best destroyer in the Chinese, or PLAN, Navy. PLAN is People's Liberation Army Navy. This is a Chinese equivalent of our Ticonderoga class that we're decommissioning. When I say we, I mean the United States. It's very similar to it in terms of number of weapons and sensor capability. It's arguably not as good as the Ticonderoga, but the truth is we don't know enough to say for sure that it's not as good. So we're going to go with what we know today and talk about the capabilities that we're aware of, its limitations as well, we'll point that out, and what we don't know. So the NATO name for this ship is the RERUN. They have built 8 of these in batch 1. They are building a second batch of 4, 2 of which are under construction right now in 2 different shipyards. So its primary role is air defense. However, it carries enough weapons to sink ships, a fleet, and land attack, and obviously air defense as well. And we'll go over each of these systems. So it's a 112 cell VLS broken up into 2 batteries, one on the bow, one amidships. It has anti-submarine capability, a ASW helicopter in the back, and is stealth incorporated into its hull shape and design. And it has the most powerful at-sea naval radar the Chinese own and operate, and that's called Dragon Eye. We'll talk about Dragon Eye during this. So let's talk about the 8 that they've built and the 2 that they're under construction and 2 that are under contract, the Type 055 Renhai. Let's begin with the weapon systems. On the bow, they have a large bore 130 millimeter naval gun. Behind that is a 64 cell VLS that can shoot everything in the Chinese naval arsenal, from land attack missiles to anti-ship missiles, their new hypersonic missile, their long range and medium range anti-air missiles, and a torpedo can be vertically launched with a rocket that then parachutes the torpedo on a target. Behind that is a 1-point defense gun. It is the Type 1130. An easy way to remember this number is the 11 stands for the number of barrels on the gun. The 30 is the caliber, the millimeter. So it has 11 barrels of 30 millimeter close-in weapon system. Behind the superstructure is the second VLS cell, and this one is 48 cells, but shoots the same cadre of weapons, pretty much everything. And behind that is the helicopter hangar, where we see the Z-90 helicopter. And on top of that is a point defense missile system, which is a short-range line-of-sight 24-cell surface-to-air missile system called the HHQ. The sensors on this thing are very advanced for China. First is the Dragon Eye radar right on the front superstructure. It's called the Type 346 Bravo ASA radar, and I'll be referring it to Dragon Eye from now on. At the very top of the mast is all the ESMs and ECMs and X-band radars. X-band radars are used for high update, close-in weapon system support in terms of self-defense and controlling the deck gun, including the Sea Whiz guns. On top of the mast is the communication ESM, the CSM. And what that is it's good for collecting intelligence, bringing it into the CIC, where the computers use AI to help decipher it. And we'll talk about that in detail. And also in this family of Type 726 sensors are jammers, and those help protect the ship from incoming weapons and also obscuring its location to search radars and whatnot. Behind that on the missile deck are multiple Type 726 decoy launchers, and they can shoot everything out of these launchers. I'm talking chaff to obscure the ship from radar, flares to obscure the IR signature, and torpedo decoys now. They can launch torpedo decoys into the water around the ship so it doesn't get hit. And inside that hangar is one Z-20F ASW helicopter. So here's the ships that have been built. There's 2 different shipyards, the Jiangnan and Dalian shipyard. The first ship was laid down in 2014, and the last of batch 1 was commissioned in December 2022. There are 2 under construction right now, and there are 2 more under contract. So there will be at least 12 total of these. Here are the shipyards where they're being built. One is near Shanghai, and the second one is up near Beijing in North Korea area. That's the Dalian and Jiangnan shipyards. All right, so Type 055 by the numbers. It is a COGAG drive system. That's combined gas turbine and gas turbine. It has a total of 4 QC280 gas turbines, producing 150,000 shaft horsepower. That is a lot of shaft horsepower, but it comes at a cost of fuel efficiency. These are not very fuel efficient. The 2 gas turbines on each shaft for a total of 2 shafts, and their controllable pitch, which means that they can change the pitch of the propeller blades to not bite as much water or grab as much water. The reasons they would do that are multiple, but one reason it would obscure the speed from sonar. They could be making turns for 10 knots while actually be only making 6 knots, and that would drive the sonarmen crazy because it would keep throwing off their solution. That's just one reason to have a controllable pitch propeller. It is a total of 13,000 tons. She's a big girl. She can do 30 knots at a great cost of fuel. If she wants to maximize her range of 5,000 nautical miles without refueling, she can only do 12 knots. And that's a severe limitation. That's a huge limitation for a warship in the 21st century, that their efficient speed for range is only 12 knots. If they go faster than that, that range drops dramatically and quickly. But she can also receive fuel and supplies at sea. So as long as they have a support ship with her, and their support ships only do about 18 knots, then she can go, as long as that support ship has fuel for her. So that's something to consider about this. We're going to talk a lot of great things about the Type 055 today, but always know that she is very limited in speed and range compared to modern NATO warships that average 32 knots easily at much better efficiency. Okay, let's move on to weapons. 112 cell VLS total, shooting the CJ-10 anti-ship missile. I'm sorry, that's land attack missile. The YJ-18 is the SSM surface-to-surface missile. The YJ-100 and YJ-21 is the hypersonic missile. The HHQ-9 Alpha Bravo is the surface-to-air missile. We're going to break all of these down for you. The CY-5/YU-8, that's the rocket that pushes the YU-8 torpedo out of that vertical launch tube. The HPJ-38 is the 130 millimeter naval gun on the front, and the HPJ-11 is that Sea Whiz right behind it. And of course, they have the ASW helicopter. That's the weapons. Let's talk about sensors. Of course, they have Dragon Eye, ASA radar, long range, highly accurate, can track over 100 contacts simultaneously at over 100 miles. It's huge. Very capable radar. They also have an X-band radar for more close-in, high update, direct the gun in the right direction, also intercept incoming missiles, X-band radar suite. The Type 726 electronic warfare suite is a collection of sensors that will intercept radars and classify them automatically for the operator, communications as well, whether it's voice or data, and attempt to decrypt them for the operators, and also radar intercept and direction finding. That's really big. So they know within a couple degrees, depending on the radar that they're detecting, where it's coming from. And it gives them things like signal strength, so they can make an educated guess as to maybe how far away that radar is. There's different ways of doing that, but signal strength is an important value that they can collect. And of course, they can jam radars too with this Type 726 system. 726 also includes the trainable launchers. Those are the decoy launchers that can shoot the chaff, the flare, and torpedo decoys now. And she has a full sonar suite. We're talking a hull-mounted sonar, a towed array, and a variable depth sonar that they can put down below the layer and search for submarines. So this ship has everything. Tons of weapons, and all the sensors China has is on board this 13,000-ton ship. Here's the QC-280 gas turbine. This gas turbine has quite the origin story. So originally, this was the GT-2500 American gas turbine that was built in Ukraine as the GT-25,000. And that's the export number or model number of this engine. So this engine originates in the United States, is in a lot of ships around the world. This particular one was built in Ukraine, and China many years ago, over 10 years ago, back before they started building these ships, bought a license and 10 copies of this from Ukraine. So Ukraine shipped up to 10 to China. It's not clear if all 10 were ever delivered, but before they got to the 10th one, China had already reversed engineered the GT-25,000 from Ukraine, which was built from the GT-2500 from the United States, and they called it the QC-280. So essentially the same design, millimeter by millimeter, but not as good construction material and quality. And one of the big problems with this gas turbine, because they put it on more ships than just the Type 055, trying to put this on their other destroyers as well. And the blades that you can see here in the picture at speed would disintegrate. They would fly apart, ruining the engine. And a couple of smaller destroyers of a different class were in port for many years trying to figure this problem out. While they could copy the design, they could make exact copies, reverse engineering these engines. They could not hold up the same build quality standards that Ukraine and the United States had, and it showed for years. But they have worked that out. They make these engines now, they don't fly apart anymore, and they're putting them on the Type 55. So they've seemed to have fixed that. Now, the efficiency here is only 36% efficiency for this engine, and compared to the efficiency that we're seeing in the United States that use a similar engine, even though it's an exact copy. We see much more efficiency here in the United States than NATO ships use. So they still haven't figured out the efficiency problem yet. They're still only getting 5,000 nautical miles at 12 knots. But if they increase that efficiency, obviously that could change. So that's the story about the engines. Let's talk about this Dragon Eye radar. This thing is impressive. This was manufactured by the Nanjing Research Institute of Electronics and Technology. It's a advanced, updated version of the Type 346 Alpha. It has both separate S-band and X-band Planear ASA radars there that you can see in the photo. So NATO calls S-band F-band. What you need to know is for air surveillance, it's 2 to 4 gigahertz transmitted frequency. And for air surveillance and mid-missile course correction, it's 8 to 12 gigahertz. Those are the frequency ranges that are going out, and those are the purposes of those two different frequency ranges. So this is both air and surface search and ballistic missile defense. They can track ballistic missile trajectory with this. We haven't seen an at-sea test that's successful of an intercepted ballistic missile from the Type 55 yet. But we know that they have the equipment to do it. They just haven't demonstrated the capability yet. The range is about 260 nautical miles. The azimuth is, basically 0 to 90, which is, from straight out to the horizon to straight up. And it's a 120-degree facing array, so they have 4 of these arrays around the ship. Very similar to the Aegis system in the United States, which we believe is what they're copying here. It does use a solid-state transmitter. They are upgrading that to digital, but there's some problems with that. I've pointed this out before in previous lectures. The solid-state transmitters that they use tend to fry, and they're replacing them frequently, but that's a small consideration, seeing how they can replace them and keep these ships at sea. All right, the 726 Electronic Warfare Suite. Like I said, it's a collection of instruments that do multiple things. The 726-1 is the radar interceptor. 726-2 is its direction finder, tells what direction the radar is coming from. 726-3 is the combined radar jammer. So once they figure out who it is, where it's coming from, they can jam that direction, obscure the location of the ship. And then finally, 726-5 is additional radar intercept and classification. The really big thing here is the operator console that we'll talk about in more detail in a minute. But a lot of the work that was done by human beings is being done by these computers now. So that's really the big advancement in the Type 726, is they can find a Chinese farmer, send him through the equivalent of boot camp, put him on board this ship, and he can spend a week learning how to operate the console. And in that time, he goes from boot camp to 1 week of training to becoming an electronic warfare suite intelligence collection officer. It's because the computers and these sensors do most of the work with AI and the ability of these sensors, the sensitivity of it. And so it just tells the radar operator or the intercept operator what he's looking at. What is the message? What is the classification? So he doesn't need to know that already. He just needs to be able to read the display and operate his console. And that's really the big step forward here with this Type 726 Electronic Warfare Suite. Here's that decoy launcher. Soft kill countermeasures, 122 millimeter in diameter. It has a 24 barrel trainable launcher. Trainable, this thing can pivot left, right, and center. And they have a lot of them. There's 4 total of these, but each one has, 24 barrels, and they can reload these at sea. So it's a lot of decoys. They also have the new floating decoys that we first saw the Royal Navy and Naval Group from France develop, where they'll launch a decoy into the water to attract a anti-ship missile, and it looks like a big floating, bounce house basically, and they will throw those into the water from this ejection suite and leave it in the dust. And with jamming the ship's position and those floating radar reflectors in the wake will attract incoming anti-ship missiles. Those types of decoys are what this thing shoots. On the bow, let's talk about this HPJ-38, the 130 millimeter naval gun. This thing is impressive. It is a large bore, put a big hole in your ship gun, and it's got pretty decent range. It looks like it's a reverse engineered version of the Russian AK-130, which means it's water cooled, has a range of about 15 and a half miles, firing rates 40 rounds per minute. But when it's a 130 millimeter round, it doesn't need to be that rapid. Each one is going to be a devastating round if it hits your ship. So it does have the ability to launch rocket extended range guided artillery shells. Those are the ones that are very precision orientated, GPS, or the Chinese version of GPS guided, and have a range of more than 100 kilometers. But they're very expensive rounds. So it's not clear how many of those they would have on board. And this gun, IOC it all the way back in 2005, predating the ship by 9 years. All right, CJ-10 cruise missile. This is a land attack cruise missile, Chinese version of the Tomahawk. The Terracom uses internal guidance and satellite references. And then it's also literally looking at the terrain as it passes over it to make sure it checks with where it thinks it is. It's pretty advanced. You know, the United States had this back in the 1980s, but we've got, or the Chinese have it now, and they're shooting it on board the ship. It's called the CJ-10 cruise missile. It's 1,000 nautical mile range. It's subsonic, think Tomahawk, and it is nuclear capable. They can put a nuclear warhead on this thing. Here's the YJ-100 cruise missile. This thing is pretty nasty. It has a 432 nautical mile range. It is subsonic, but it's also anti-countermeasure resistant and can be deployed with the H-6 bomber or the Type 055 destroyers here. This is an anti-ship cruise missile. So it's inertially guided. It can do mid-course updates. It does have satellite reference, which means not only can it get the updates from the satellite, but it can use GPS, or the Chinese version of GPS. In the end, it's active radar and IR homing in on the ship, and that can be defeated. But this thing is a long-range, like I said, over 400 nautical mile anti-ship cruise missile, subsonic. The YJ-18 Alpha is also an anti-ship cruise missile. Its name is Eagle Strike, and they named it basically after the United States, after shooting the United States ships, it seems. It is a speed of 0.8 Mach, but the range here is 220 to 540 kilometers, depending on the variant. This one is vertically launched, so they can put a lot of these in the air rapidly, assuming the attempt would be to overwhelm a fleet's defense system to just burn through with a number of these subsonic missiles. What's really cool about the Eagle Strike is its terminal phase. Whenever it decides that it's got a target and it's going to, burn through the point defense of the fleet, it goes from subsonic to 3 times the speed of sound, Mach 3 on its terminal phase. So once it knows where it's going to hit, it zooms, it just boosts into the target from over the horizon. So the Americans, or the target, we assume it would be the Americans, would see the missiles, a cloud of them, up to 112, if they shot the entire arsenal, coming over the horizon at 0.8 Mach, and then just one after the other, every couple seconds, each one would zip into the fleet from, 10, 15, 20 miles out and hitting the ships, in just a few seconds. That is an easier, or a practical way rather, of defeating point defense, because point defense can only shoot down so much so fast. And so point defense being anywhere, from range 0 to range, 10 to 20 nautical miles for point defense. And that's assuming they're using the deck guns to reach those kind of range. They're only going to hit a couple of targets. If these things are sitting at the 15-mile point and accelerating, changing speed, the delta in speed is what's hard to calculate. Going from 0.8 to 3 Mach 3 is going to take, a second or two. And in that second or two, that's going to throw off fire control solutions. And then once they reestablish the solution, then the point defense can engage again accurately. But by then, the missile is not at 15 nautical miles. It's at 5, and it's doing Mach 3. It's going to hit you in less than a second. So that's the effectiveness of the YJ-18 Alpha. It's this terminal supersonic boost phase that's going to disrupt point defense. These missiles have to be destroyed in the cruise phase, because once they reach terminal phase, we're going to take hits. The target is going to take hits. Here's the YJ-18 hypersonic anti-ship ballistic missile. This missile can be launched from mobile shore launchers, truck launchers, and from the Type 055. So it's based on the DF-21 Delta. That's the land-based version. Cruise speed is Mach 6. Terminal speed is Mach 10. It is cold launch, 2-stage propulsion, goes up into a suborbital altitude and just come down from space like a meteor. And you can shoot it down but you're not going to stop it from falling. And it's coming down, in a trajectory that's very vertical. So these are interceptable. We have the technology. The Aegis system can shoot this down, but it can't stop it from falling out of the sky. And so this is a very concerning weapon. We've only seen a couple launches. They have the ability to hit static targets, and they've shown the ability to hit a moving target on a land-based target range. Other than that, we don't have a lot of details. So this is a scary weapon. It does work. It does hit targets on target ranges that move, and that's all we know about it. And the United States and NATO in general, we do have ballistic missile defense on our fleets now. So these can be intercepted, but we have yet to see any case study of how effective this would be against an anti-ship ballistic missile defense. Moving on to the HHQ-9 surface-to-air missile. This is the long-range, medium-range fleet defense missile. HQ stands for Hong Kai, or Red Flag. It's designed to be a high-performance, or to shoot down high-performance aircraft, cruise missiles, anti-ship missiles, and tactical ballistic missiles. So, like I said, the Dragon Eye radar can track ballistic missiles. Those be the tactical ones are the ones that are shot out of North Korea, for example. Relatively short range, not even suborbital, just basically a very high trajectory artillery ballistic arc. This missile can reach up and grab that. So the max range here is 81 nautical miles, and it's a proximity fuse, so it doesn't have to actually hard kill or direct hit the weapon. It can just explode near it and destroy the ballistic missile. This one, we first saw it in 2004, and it's been improved ever since. So at this point, 20 years later, it's probably pretty good. So we're going to assume that this thing can shoot down a ballistic missile, even though we've not seen an at-sea demonstration of this missile successfully intercepting a ballistic missile test. All right, the YU-8 CY-5 rocket-assisted ASW weapon. This basically is a YU-8 torpedo that's sitting on a CY-5 rocket, is all it is. And of course, they have a little parachute to keep the torpedo from just falling into the sea and breaking apart. So this thing will be vertically launched. It'll reach out to 16 nautical miles, drop the torpedo. That will then do a spiral search all the way down to the bottom and back up again and sit there and look for a submarine. Now, something about this weapon that is very important to understand is it doesn't have to hit your submarine to achieve its mission. This is also an area denial weapon. So if there's an area that they don't want a submarine to be in, for whatever reason, they'll shoot this weapon into that area and just have it spiral for 20 minutes. And of course, the submarines won't be able to get into that region. So think about these weapons as more than just, I'm trying to sink a submarine. A lot of submarine or ASW warfare is making sure a submarine is not here. It could be anywhere else, but we know this place is safe because our weapon's over there. All right, the FL-3000 point defense system. This thing is a complete ripoff of a French system called the Corvette, and you'll have to forgive my pronunciation of that. But it's also very similar to an American system called the RIM-116, which is a rolling intercepting missile, rolling airframe. The only difference here between the American system and the French system is this airframe doesn't actually roll when it is ejected, which affects its performance. This is a heat-seeking missile, an IR missile that is very short range. They point this launcher that's on top of the helicopter hangar in the direction of the attack. And when incoming weapons or low-flying aircraft get within its weapons range, it can shoot this essentially sidewinder missile in the direction. For subsonic targets, it can reach out to 9 kilometers and get them. For supersonic targets, it's 6 kilometers. And this is a great example of why supersonic terminal phase is a big difference. It's the same point defense, but look at the effective range difference. Because you have a higher incoming speed of a supersonic missile, the time it takes to lock onto that target, that supersonic missile has already closed 3 additional kilometers than the subsonic missile has. So you're effectively, if you're shooting 3 missiles at this ship, you're getting 1 past this system based on 3 subsonic missiles because of that range difference. So it also has a 3-kilometer max altitude, and it's a Mach 2 missile. But think of a shoulder-launched surface-to-air missile that you may see in other footage. It's a very similar operation and range and effectiveness. All right, the Z-20 Foxtrot helicopter. This is a good ASW helicopter of the Z-20 family. It's very large. It appears to be a copy of the United States Seahawk helicopter, but it's bigger and heavier and not as efficient because that's the way China builds things right now. But it has a lot of the same capability. It has a surface search radar. It has a sonar, dipping sonar, including magnetic anomaly detection, MAD detector. It can drop torpedoes. It can drop sono buoys. It also has ESM and satellite communication. So all the sensors, whether it's a sonar buoy or it's that surface radar, search radar, all the sensor data that it collects is radioed back to the ship where it is then processed, and the information is given to operators there. Now, there are operators on board this helicopter, but all the information is also shared with the ship in real time. So max range of this helicopter is 300 nautical miles. That is significantly reduced every time they have to dip their sonar and hover. Hover burns a lot of fuel, and so that reduces their range. So, but know that its max speed is 190 knots, and 160 knots cruise is what you're normally going to be seeing it as. All right, folks, that is the Type 055 destroyer, PLAN's strongest Navy asset, in my opinion, in terms of the large surface combatants anyway. It's got everything. It's got the best radar China makes. It's got all the weapons, 112 VLS cells. It has all the ESM, the latest decoys, including the new floating decoys, anti-submarine or torpedo decoys, as well as the traditional chaff and flare and smoke for obscuring the target. They threw everything on this ship, and they're building at least 12 of them. So 8 destroyers are in service now, and that is a problem for all the other nations that are going against China. You know, for instance, Taiwan is trying to build some submarines now to try to counteract this increasing fleet that we're seeing come out of China. But it's with the ASW capability and the weapon systems on board this ship, I'm afraid that one of these is comparable. In my opinion, I wouldn't say it's comparable to the Ticonderoga. I'd say it's more comparable to the Arleigh Burke, maybe the Flight 2s, which is still a very good ship. The problem is they've only got 8 of them compared to the Arleigh Burkes. We have like 70, the United States does. So we still have a huge advantage over China, but this ship is a very capable Chinese warship, and that needs to be understood. This is no joke. This is not a disposable ship. This is a real capable warship that has some range and fuel efficiency problems, but they're also not going very far right now. They're worried about South China Sea, Taiwan. You know, they're keeping these ships close to home. And so that's negating that inefficiency by them not needing to go very far. And they can refuel and resupply at sea. So that also limits that as well. So just remember, main propulsion is co-gag, incorporating 2 gas turbines on each shaft for a total of 4. They have the extensive sensor range, and it is the most powerful warship, surface combatant, large surface combatant in the PLAN. All right. Well, thanks for watching, everybody. I appreciate all the YouTube members and Patreon members. You guys are the best, and we'll see you next time. Welcome to the Zumwalt-class ship brief. So the Zumwalt-class is a very unique design added to the United States Navy, going all the way back to the 1990s when they were designing LCS and Zumwalt at the same time. For the upcoming century, the new Navy was going to be escorted by these large-sized destroyers and escorted by many LCSs, accompanied eventually by unmanned surface vehicles to be the new American fleet around our nuclear-powered carriers. That was the vision, and the Zumwalt was the destroyer, the large surface combatant of that vision. Well, things didn't work out the way that they intended, the Navy intended, and they ended up only building 3 of these destroyers. And we're going to go over the systems and capabilities of this destroyer, which is very modern, very capable, especially being designed in the 90s, and the things that also did not work, and the changes that are being made to the Zumwalt now to correct those. So this is the first surface combatant to employ the integrated power system. What that means is the prime mover, the engines, the turbines that would normally be mechanically linked to the shafts are not. There's no mechanical linkage between the engines and the propellers. there is, in between those two things, the IPS, the integrated power system that stores electricity made by those turbines, literally turbine generators, and then distributes that power to the screws, the hotel loads, the combat system. IPS is the heart of the ship, and we're going to go over that in detail. They did plan on building 32 of these monstrously large destroyers, but for cost reasons and some system design failures, they only built 3, and then they stopped. They stopped the program. No more Zumwalt-classes are ever being built again. Now, the weapon systems that they have are very unique. They have 80 Mark 57 VLS cells. They can shoot 80 vertically launched missiles of all sorts, including the ESSM point defense missile that is a 4-pack. So you get 4 missiles in one of those 80 VLS cells. They have 2 of the Mark 46 30-millimeter gun systems. That's the same 30-millimeter gun system that's used on the LCS. And it suffers from similar problems. We'll go over that. But the big one is the 255-millimeter AGS naval guns on the bow. The guns work great. They're installed and work fine. The thing that does not work fine is how much each round cost. The round that is GPS guided and rocket assisted that gives it such enormously long range, over 150 kilometers, and a pinpoint strike capability at that range because of its technology, cost $1 million a round, which is ridiculous. The Navy said no. That triggered all sorts of tripwires in terms of cost overrun that forced the Navy to take this weapon system off this platform, and they did. That's happening right now. They're replacing it with conventional prompt strike, CPS, hypersonic missiles. And all 3 of them are getting that installed. So the weapon systems, as of right now, are the AGS 155-millimeter gun on the bows. Those are underneath those triangular pyramid-looking covers to give it low radar observability. Along the side is the peripheral VLS, peripheral meaning along the side of the ship. We'll talk about the pros and cons of that. And then finally, behind the superstructure but above the helicopter hangar are the 2 Mark 46 30-millimeter gun weapon systems. For sensors, she has the standard kit, a sonar system on the bow called the SQS-60. It has both medium and high frequency. The Spy-3 radar, which is the specific variant for the Zumwalt of the Spy system. Spy-1 going all the way back to the Ticonderoga. Spy-6 is on the new variant of the Arleigh Burke. Spy-3, Zumwalt. Above that is the SPS-73 radar. This is the navigation radar that's on over 100 U.S. Navy ships right now. It is the standard navigation radar, but it has a lot of capability. And we'll go over that in detail when we get to it. The little balls, if you will, that stick out from the side of the Zumwalt superstructure is the electronic warfare suite. This is the SLQ 32 Alpha version 6 with the SWEP Block 2 upgrade, which is the second most advanced upgrade in the Navy right now. This is what protects the ship from being detected on radar at all. And then if it is attacked by a missile or other sensor, it can obscure its IR signature. Obviously, its radar signature is obscured. It can even obscure the visual shape of the ship if the sensor is using thermals or some other than visual spectrum. It is very advanced and also very secret. We can't talk about it, but that's what those balls are. They're to defend the ship from electronic eyes and sensors. And then off the tail end, you can't see it because it's below the waterline, is the SQR towed sonar array. It's part of the SQS 60, 61, 62 sonar family. All right, Zumwalt-class destroyer. They built 3 all in Austell, USA. That's down there in Mobile Bay, Gulf Coast. They commissioned Zumwalt in 2016. Her sister ship, the Mansour, in 2019. The Lyndon B. Johnson commissioning was delayed because the decision had already been made to take off the guns of the bow and put in the CPS hypersonic weapon system. And so the Navy made the right choice, in my opinion, to not commission a ship, assign a captain and a crew to it when it's just going to sit in the shipyard for the next couple years getting these weapon upgrades. So that's why the last of the Zumwalts has not been commissioned yet. It's literally just like a manning issue. Also, a rare example of common sense being exercised by the U.S. Navy to not stick 150 sailors on this thing and sit in a dry dock while shipyard workers finish it. Well done. Okay, the Zumwalt-class destroyer by the numbers. The heart of the ship is the integrated power system. It is powered by 2 Rolls-Royce MT-30 turbine generators. They control everything on the ship based on IPS. Remember that, because all the ships building going forward in every modern Navy is integrating their power systems and becoming essentially electric boats, electric ships. So this 16,000-ton ship can be pushed with this electric motors to 30 knots. That's the public number. Obviously, it's a little bit faster. But the endurance range, look at this, 20 knots to go 4,500 nautical miles is really very efficient, especially in a ship that's this size and displaces 16,000 tons of water. That is a very fuel-efficient endurance range. Normally, you'll see these knots measured in 15 to 18 knots, not 20. And that may not sound like much, but over 4,500 nautical miles, those extra 2 or 3 knots means an entire day. It means a lot. So the crew, like I said, is about 150 people. That includes officers and the enlisted. They have room on board for an augmented crew of about 28 to 30 people. That would be the mission supplemental crew. And the way the Navy works now, and this is kind of a modern version of how we used to do it, is when we go on mission, we would bring on additional specialists. Sometimes they would be civilian with very high clearances too. And we would go off the coast of another country and we would just do our mission over there, and the specialist would do their job in secret. Like, we weren't even allowed to talk to these guys. And then if they needed to use sonar, they had free reign of the entire ship. You know, they could do whatever they wanted to. So that's what that extra 28 is. That's just a specialist attachment to a ship temporarily for a mission or a deployment. The 80 Mark 57 VLS can shoot, like I said, the Tomahawk, all the standard missiles, including the ESSM point defense missile, and the ASROC VLS, which is a vertically launched torpedo. It has 2 Mark 46 gun weapon systems above the helicopter hangar, 1 port, 1 starboard. And it is currently being installed as a large missile vertical launch system, LM-VLS. So they have the PVLS and the LM-VLS, easy for me to say, whenever it gets finished. Okay, the Spy 3 multifunction radar is the specific spy variant for the Zumwalt. SSQ-90 tactical sonar suite is what you call the suite that connects the towed array to the hull array to the high frequency and medium frequency sonar systems. If you're talking about all those as one suite, it's the SQQ-90, and then each subsystem has its own name. SLQ-32 Alpha Suite Block 2 obviously is the ECM I talked about, and she can also take on a helicopter and 3 MQ-8 Bravo Fire Scouts, which are UAVs, unmanned aerial vehicles, or she could just have 2 manned MH-60R helicopters. Either way. Most likely, if the Fire Scouts are available, she'll go underway with them because it's more efficient. Those things can stay in the air like 15 hours compared to like 3.5 for the MH-60. All right, the integrated power system. This monumental shift in thinking about how to propel and power a ship at sea, including submarines now, was just amazing. It just changed the way you think about ships, essentially. And the Zumwalt-class was the first one to implement this from original design to implementation. And there were lots of hurdles to overcome, and she did. And having the reliability of a Rolls-Royce MT-30 gas turbine engine that, simplified, if you will, this process was a great benefit. Very expensive, yet very light and powerful turbine generators. The Type 45 Daring British ship has the same IPS system using the same Rolls-Royce engines. And together with our UK allies, we implemented this type of propulsion and power generation, if you want to think of it that way, on our ship simultaneously. So we learned our lessons together and shared information. Here's the Rolls-Royce MT-30 gas turbine. It is the world's most powerful marine turbine generator set. It's derived from the Trent Aerospace engine that Rolls-Royce builds, and it's fully electronically controlled. It produces 360 megawatts of power, which is insane. That's a lot of power for a relatively low weight engine, which is what you want. You want high power, low weight on any vehicle. And that's what they have here. And it spins about 3,300 RPM. Here's the Spy 3 radar. Those are those flat panels you see around the top of the ship. So this is a 3D radar. It's ASA, which means it's an active electronically scanned array. It sees in all directions, and it doesn't have to sweep like you would think of a typical radar. When it's in volumetric mode, it sees all directions all at once, and so there's no lag between the updates, which is extremely advanced. It has 5,000 transmitters and receiver elements, which means when one element fails, you can literally pull out that one specific element and replace it instead of having to replace the entire array. That is a huge advance in terms of logistical support and keeping the ship operational. You don't lose your entire array if you lose one or more of your elements. The range of this radar is in excess of 300 kilometers, which is quite a long distance. And while it's scanning this huge area of airspace and surface, it can track surface contacts too. It can track hundreds of targets while also launching missiles and directing those missiles onto multiple targets simultaneously in this huge volume of air and sea space. And those missiles can be the SM-2, the SM-6, ESSM. Tomahawk missile doesn't need updates like that. It works differently. A key benefit of this system is that when she's in a fleet and they're linked together with their combat information systems talking to each other, she can instruct another ship to use its payload, and that can be an unmanned ship that accompanies our fleets now, to use their ordnance so that Zumwalt doesn't use its own, forcing it to have to go back and reload. So it could tell an unmanned sea truck, essentially, launch your SM-6 at this target. Sea truck does that, and sea truck is unmanned. Sea truck expends all of its ordnance, and unmanned goes back to San Diego and gets new weapons while Zumwalt stays on station the entire time. That's the vision. That's what we're looking for. And that's actually what the Navy is achieving here. An Aegis destroyer can do the same thing. The new Constellation-class, even the LCS, is at sea right now with unmanned sea trucks with it that carry weapons. So this has all been implemented. This is one of the success stories of the Zumwalt-class and this new way of thinking that the Navy did. All right, here's the SPS-73 version 12 now radar. This is the navigation radar of the U.S. Navy. It's the way to think of this. It's extremely accurate, powerful, high fidelity, which is what you want when you're operating near a shoreline, because you don't want to get, crept up on by, say, a buoy that got knocked loose of its mooring and is just out there floating around. You don't want that banging on the side of your ship. I've seen that happen before. Whenever you're going in and out of port, they have channel markers, which are buoys that are big metal things that float a couple hundred yards apart from each other, and you're supposed to go in between the middle of them. This radar will light up those buoys on the radar display like it's a Christmas light. And so you can see very clearly where the channel is. And if you're starting to stray towards one side or another, this is the radar that shows you, hey, you're a little too close to the port buoy, come starboard a little bit. That, for example, that's how this radar is used. But one of the great things about this radar is it can track contacts that run at speeds up to 210 knots. So those are drug-running go-fast boats. Those are unmanned surface vehicles that are being very effectively used against the Russian Navy right now. It can see all of those. And even, of course, helicopters at 210 knots. So very capable, over-the-top with options navigation radar. The Mark 50 PVLS is developed and manufactured by Northrop Grumman. Stands for Peripheral Vertical Launch System. It is basically just an advanced VLS. This is specific for the Zumwalt-class. They don't have this on any other class right now. It has 80 cells in total. There's 20 bow and 20 on the stern, and then you got port and starboard sides, total of 80. It shoots everything, SM-2 to SM-6, the Tomahawk missile, and even the vertically launched ASROC missile, which is the vertically launched torpedo. This ILC'd in 2016 with the commissioning of the USS Zumwalt. The system, again, is not on any other ship at this time. Now, a a pro and a con to this design. This was very controversial whenever they designed it. The Navy approved it and said, we're going to try this on this ship. By having your missiles outboard of your vessel like this, they are more susceptible to direct fire damage and fragmentation damage. If you get into a firefight, a near miss can still damage one of these cells of missiles. So a block of missiles would be 20. They would be divided into 5 different cells of 4 missiles apiece. Typically, that cell shares the same fire control intricate circuitry in the VLS. If that VLS cell is damaged, all 5 of those missiles no longer function, even if they're not damaged. So you could be knocking out chunks of missiles 5 at a time if they take any damage at all to the internal components. On top of that, these things are missiles. They have rocket fuel on board. So obviously they could burn easily, and the warheads are designed to burn and not explode if it's just fire. But if you add concussive force to that fire, they most certainly will explode. So you're putting your vertical launch system in a position that is the most vulnerable place on the ship, outboard. Now, the benefit to this is if it does take damage and it catches on fire and it even explodes, the force of the explosion is directed up and out away from the ship. You're not ripping your ship in half because of a magazine explosion. That's the benefit. Weapons slightly more vulnerable to damage and loss of chunks of missiles 5 at a time. But you're adding to the survivability of the ship by not having a catastrophic explosion to a magazine failure. Those are the 2 perspectives on this. Feel free to argue which is better at your will. The reality is this is what we have on 3 ships. All right, here's the AGS 155 millimeter naval gun. Not a lot to remember here because they're being taken off, but I figured you should know that these are 62 caliber barrel guns, basically a very large artillery gun. They shoot 10 rounds per minute. Obviously, they have an autoloader in there. And they shoot the LRAP ammunition, which is GPS and INS guided. That's internal navigation guided. And it's rocket assisted, which means after you shoot it, it's got a little rocket to push it even farther. And that's how you get these ranges of like 150 kilometers. And with the GPS INS guidance, you get pinpoint accuracy. You get the best of both worlds. Shore bombardment was the dream in the 1990s with these shells showering specific targets. So you did not need to bombard a beach like they did in World War II. You would shoot 50, 60, 80 of these things in a 10-minute period and completely wipe out any kind of beach defense, and then push the Marines on the beach when the beach defenses have been significantly reduced in capability. That was the idea. And it works, by the way. So why'd they rip them off? The reason why they did is because the projected cost of each shell was significantly less than $1 million. I forget exactly the number, but it was relatively cheap. And the Navy agreed to pay that amount. But that was assuming that BAE and making these shells would be making shells for 30 ships, which is a lot of shells. There was cost savings in volume because you weren't paying as much in supply chain costs to make a limited number of shells. Because they reduced the number of ships to 3, the number of shells that they were going to end up making went from being tens of thousands to just a couple hundred, which jacked up the cost for each shell to be close to $1 million. So because of that, that triggered all sorts of budgetary red lines that said, if you go over this cost on all these different systems, then take the system off. Well, that cost per shell forces the 3 Zumwalt-classes that we built to take the system off and replace it with something. The Navy decided to replace it with the conventional prompt strike missile, hypersonic glide vehicle. That's the story behind the removal of these naval guns that do work, but it's just too expensive to shoot. All right. Another gun that works very well is the Mark 46 30mm gun weapon system. This thing is the Bushmaster Mark 44. The Army uses it on some of their vehicles. The LCS uses it. This thing is really reliable. It puts a lot of weapons, a lot of lead downrange. 200 rounds per minute of a 30mm shell is quite something. The muzzle velocity is actually higher than the guns on the bow at 1,200 meters per second and has a range of just under 7 kilometers. Very accurate. The downside of this gun is the same downside as it has on the LCS. It doesn't have much depression. It can't look down and shoot down. So if you get an unmanned surface vehicle within a couple hundred yards of the Zumwalt, nothing on board the Zumwalt can defend itself from it. And that's what's happening to the Russian Navy and the Black Sea Fleet right now, is these unmanned surface vehicles that are very small and fast and attack at night, and they're hard to find on the radars that the Russians have. They are able to get close in and then detonate alongside the ship by ramming it. This ship, the Zumwalt-class, is vulnerable to those attacks if it doesn't destroy those UAVs before they get within 5 kilometers. Look at the minimum range of this gun. You get within 5 kilometers of this, nothing on board this ship can touch you. Unless a man comes out with a sidearm and fires at you, which is literally what the Russians are doing to defend against USVs right now. There is no close-in weapon system on the Zumwalt. All right, SM-6 SAM. This is manufactured by Raytheon. This is the holy grail of all surface-to-air missiles. It can shoot down the most advanced fighter at ranges in excess of, I'm going to say 100 nautical miles. The actual range obviously is not public. It's very long. And I don't care what generation fighter it is. The SM-6 has a very good chance of shooting down a maneuvering F-22. There's no guarantees in that, but that's what this thing is designed for. It'll shoot down whatever's flying, including ballistic missiles. It also has a mode that if you wanted to, you could shoot a ship with this thing. And it has enough kinetic energy and a medium-sized warhead to do some damage. I don't think you'd be sinking a ship with it unless you hit it multiple times. But you never know. So the range, yeah, here it is, in excess of 100 kilometers with the booster motor, which is in the picture you see here. 30 kilometers in altitude, so obviously all the way up to where ballistic missiles are going to be. The max speed of this missile is Mach 4.5. Obviously, it doesn't do the entire flight at that speed. It just peaks out at that speed and then maneuvers. It does have mid-course guidance and updates and its own terminal RF seeker. Like whenever it's in ballistic missile mode, the impact vehicle has little propellant jets around it to kind of force it into the kill window. And it's a kinetic kill, hard kill vehicle. It is a very good missile, but it's also the Navy's most expensive missile at $5 million each. So even testing these is an enormous cost. But we do have them in the fleet, a limited number of these. Here's the RGM-109E Tomahawk Block 4. This is the long-range land attack missile that's been around for decades, very reliable, relatively low cost compared to the other SM missiles, and very accurate. I IOC'd in 2006 as this block variant. Obviously, we were using Tomahawk missiles all the way back in the Gulf War of 1991. I'm not aware of any earlier uses than that. There might have been, but this missile's been around a long time, and it's extremely accurate, which lowers collateral damage. It hits military targets, and not much else is the idea. And the Zumwalt was really going to be used, in my opinion, to support land attacks with those guns that could precisely demolish a beach defense, combined with this Tomahawk missiles. You know, out of the magazine of 80 missiles, say 60 of them were Tomahawks. You know, this one ship could support a Marine landing, you know, in it. Also with all the other Marine amphibs, ship supports a very likely chance of success of the Marine landing happening. So this, in my opinion, really is a land attack ship first, which is a change in paradigm thinking from the Navy. The Navy's always been air defense and then anti-ship, anti-submarine. And then this ship is clearly anti-land warfare or support the Marines on the beach warfare with also air defense capability. So it is a very interesting way of thinking. It's a wonder what would happen if we did actually build 30 of these and then support our Marines around the world, if there would be more land action. I don't know. That's a counterfactual at this point because it's not happening. But we're building 3 of these, and the Tomahawk, I think, was going to be the primary weapon of this ship. All right. She also has the capability of shooting torpedoes vertically with the VL ASROC. This is basically just a Mark 46 or Mark 54 lightweight torpedo on top of a booster that you see there. And it goes to a specific distance and drops in the water with a little parachute. And then once the seawater hits the torpedo, that torpedo has a seawater activated battery. So the seawater gets in there and gets the anode and cathode going back and forth, which produces power for the little motor. And then it just starts spinning, looking for targets. And that's kind of how that works. All right, here's the conventional prompt strike missile developed by Lockheed Martin. It's a lightweight hypersonic glide vehicle. They're going to have 4 missiles per module, and they're going to have 3 modules on each one of these. So 12 missiles is what I'm told right now. Obviously, these haven't even been installed yet, so we'll see how many there actually are. And we'll have that number updated whenever the first one comes out and is tested. The reason why I'm hesitant about that is because they could do 4 missiles per module, and the Chief of Naval Operations told Congress that there would be 12 missiles, but he might have meant all 3 ships are going to get 4 missiles leading to 12. That is another possibility. We won't know because it's not public until they actually build it and test it. And then we'll be able to look at it and be like, yeah, there's 4 tubes right there. So we will see. Either 4 per ship or 12 per ship. We'll know whenever they do the testing in a couple of years. All right, here's the MQ-8 Charlie UAV. Remember, they can have 3 of these and a MH-60 helicopter working together. This is the unmanned helicopter. Can stay in the air for 15 hours. Has a starlight radar option, including electrical optical sensors. This is great for doing missions that require close to visual investigation without risking human life. A common practice or employment of this type of unmanned aerial vehicle in the United States Navy, in the 5th Fleet, which is Middle East right now, is the ships, fishing ships off the coast of Yemen that are seen trafficking towards the Strait of Hormuz, Iran, and back again, will be followed and inspected by unmanned aerial vehicles like this, because those ships are likely to be carrying weapons. And one way of catching that is by employing this UAV, seeing that instead of fish on the deck, they have weapons crates under cover, and then they conduct a boarding action and confiscate those weapons. That has been a successful use of this UAV recently. She can obviously do many other missions, but I wanted to give you an example of a real-world employment of the MQ-8 Charlie. Now, that was done from another vessel. It wasn't done from the Zumwalt-class. All the Zumwalts are in dry dock or preparing to go to dry dock to get these weapons installed right now. All right, final thoughts. Man, okay, multi-mission ship, focused on land attack, but had the ability to control airspace and even ballistic missile defense. Cost overruns reduced the number of ships from over 30 to 3, which pushed the cost per unit up significantly because of supply chain efficiency cost. And that triggered the removal of the gun system on the bow. That's how bad it got, because each round became too expensive to shoot. You know, every time you wanted to test you were spending millions of dollars on just the round. You know, it was ridiculous. And so obviously the Navy wisely and Congress wisely said, all right, if we can't use the ammunition, we can't use the gun, let's replace it with something. And hypersonic technology is coming in to operational availability now here in the United States. A few other countries already have it. We're getting it on our ships now. So we'll see how that goes when those tests are made public, which should be in a couple of years, and we'll bring that to you here, okay? All right, everybody, this has been the Zumwalt-class ship brief. Thanks for watching, and we'll see you next time. Bye. Welcome to the Atago-class corvette ship brief. So this is an interesting series of Turkish ships that are designed and built for Turkey's defense industry and to meet that country's specific naval requirements. These corvettes are designed to operate in various maritime environments and fulfill a wide range of missions. Very similar to an offshore patrol vessel. These corvettes are fast, heavily armed, and have lots of good communication and sensors on board. And they drive this stuff around the coastline, just keeping an eye on things. So the corvettes are developed and produced under MIL-GEM, which is an abbreviation for National Ship in Turkish. So this MIL-GEM project plays a significant role in enhancing Turkey's naval capabilities, promoting self-reliance and supporting its defense industry. These warships contribute to the maritime security, regional stability and provide a platform for Turkey to protect its interest and project power effectively. And as we'll see, also make a little bit of money because we're selling some of these to other countries, as we'll get into. So here's the MILGEM project as it stands right now. We have the Ada-class corvettes that we're talking about and the I-class frigates that are under construction. So they've already built 4 of the Ada-class. Those are in service, and that we'll talk about. Now this program started all the way back in the early 2000s with Under Secretary of Defense Industries. The government agency responsible for this defense procurement got the money for this and put the project together. The goal is they want to design and build their own ships. This is like the holy grail of every country. You know, India notoriously has been trying to do this for a long time. Build their own ships that are, you know, very capable and modern and use modern systems. Well, Turkey's doing the same thing, and they're doing it very successfully here. So overall, the MILGEM project represents Turkey's commitment to developing an indigenous defense industry and archiving self-sufficiency in naval shipbuilding. It's been played a significant role in strengthening the country's naval capability, and that also spills over into its diplomatic strength. So the stronger a nation's navy, the more diplomacy, the more gravitas, one could argue, that they have. And so that's the transformation that Turkey's been going through recently. These are pretty capable ships, as we will find out today. So let's talk about the variants. So the Ada-class corvette is what Turkey uses for its own navy, but also has the Babur-class for the Pakistan Navy, which is just a variant of the Ada-class. It's got a VLS fitted on it. Arguably more capable because it has more weapons. Also uses a different weapon sonar suite. The Iranian Hetman the Ivan Hetman for the Ukrainian Navy has not been built yet. I believe the hull might be constructed and in the water, but it's not finished. Let's put it that way. And then the Turkish Navy is building its own offshore patrol vessel called the Hazar-class. And if you guys are interested, let me know. We can certainly do a video on that. But it's just a variant of what we're talking about today. Okay, so let's take a look at the weapon systems on this. We got the rolling airframe launcher, the RIM 116 there above the helicopter deck. That is for point defense primarily. The nice thing about this point defense, short range, very fast missile system, it's infrared guided. So you just point it in the direction of the incoming threat and the missile guides itself. It's very fast because of that. There's no integration with any other system on board other than turning it and aiming it in the right direction. There's a remote control weapon system that is a 12.7 millimeter cannon. This has an optical sight on it, can be remotely controlled from inside the ship, and is for point defense. They do shoot the Mark 54 torpedo here, which is really cool. This is the most modern lightweight American torpedo, and they use it in their torpedo tubes to pneumatically launch out just like they did the old Mark 46s back in the day. But in 2023 and beyond, we're shooting Mark 54s now, which is basically a very smart, fast, and relatively inexpensive compared to the Mark 50 lightweight torpedo. They shoot the Harpoon Block 2 or the ATM-ACA missile. That's the anti-ship missile there for anti-ship defense, or offense rather, and the 76 millimeter auto compact gun on the bow. So she can do it all. She has, surface to air capability at very short range with that point defense surface to air missile. She can launch torpedoes, anti-ship missiles, and of course has a gun. Every warship needs a cannon, and this one has it. Let's take a look at sensors. So they pack a lot of sensors onto this little corvette. This is something like, whenever I think of the American LCS, they should have done something like this, but they didn't. So the Turkish, give them credit, this corvette is more capable than our LCS by a long shot. Let's begin back aft with the forward-looking infrared. That's a steerable sensor for infrared targeting and surveillance. They have the Sperry Marine Vision Navrad, and we're going to break all these down, by the way. They have the Smart S Mark II radar on top, the LPI radar right below it, the Sting Mark II fire control radar, and for sonar, they have the YAK-MOS hull-mounted sonar. Very good stuff. Now, the sonar, my opinion is it's medium frequency and not that good, but it's a Corvette, so these things will be working together generally with other Corvettes and can cover a large area despite the capability of that sonar system. Okay, Let's move on to electronic warfare and countermeasures. How's this thing going to survive a fight? Because obviously a corvette doesn't have a whole lot of hull. If it takes a hit, it's probably, it's unlikely to survive anything larger than a single shell, right? So we have the laser warning detection receiver. So if anyone's getting, laser range finding data on it, and a lot of modern missiles do that themselves now, this thing will give a bearing and a direction and alert signal. It has a chaff launcher, Mark 36. We'll talk about that. The Sea Centaur anti-torpedo countermeasure is very capable at confusing the hell out of modern torpedoes. And they have the Ares 2N ESM right up there on the mast, just below the radar. This is it from the bow. Very smart looking corvette. I like this. They built 4 of these from 2011 to 2019. They were commissioned. They were built from 2007 2017. Pretty good rate of return on this. Keep in mind that this is a new class, so it takes a little bit of time to get that first one out. But then they pumped them out every it's like 4 to 5 years after that. The last 2 were almost back to back, practically in parallel. This is where they're stationed out of. They're made in Turkey and stationed in Turkey, right near Istanbul. You can see a picture of them there in the part. Really good stuff. All right, so let's break this thing down, man. What is the Ada? What are we talking about here? And how is it indigenous? How much of it is indigenous? This is the question. So let's just say that the indigenous part means that it is designed and assembled in Turkey. Okay. But the design said we want to use the American GELM 2500 gas turbine because it is reliable and very good on board ships. It's also relatively inexpensive way to move your ship quickly. So yes, it's going to be using a lot of American and European systems on this Turkish vessel. It's still domestically built, okay, despite it calling for other systems made in other countries. So let's just make that clear up front. That's what we're talking about here. It has 2 Rolls-Royce MTU 16V diesel engines, which makes this thing co-dag. So it can use both those to get up to full speed of 29 knots. It shoots 4 of the Harpoon Block 2s or the ATMAC's that's the French F514 missile. It has the Raytheon RAM Mark 31 missiles. Those are the rolling airframe missiles. The same thing that we put on our ships over here. Only they shoot the Block 1A, which is probably the export variant. The 76mm main gun on the bow, and they have 2 point defense weapons that are remote control weapon systems shooting 12.7mm rounds. They have 2 port and starboard, 1 port, 1 starboard torpedo tubes that shoot the Mark 54 lightweight torpedo. It is the same diameter as the Mark 46. So they could shoot that as well, I suppose, if they want to save a little bit of money. But the Mark 54 is the standard now. Okay, so the helicopter pad, they can obviously use any helicopter that will fit on it, but they've bought the Seahawk S-70 Bravo, which is a good ASW platform. That is going to be their primary way to prosecute submarines. That hull-mounted sonar is, limited in its effectiveness, but at least they have it, unlike the American LCS. At least they have a hull-mounted sonar. Okay, back to the radar systems. We have the Smart Mark II air surveillance radar. That's the one at the very top of the mast, long-range air detection and tracking. It's a 3D radar. They have the Sting Mark II fire control radar. They're just forward of that mast. The Ares 2N ESM. That's for electronic surveillance. The ALS APR LPI navigation radar. That's just so they don't run into things like the coastline. And 2 Sperry Vision master navigation radars. The ALS FLIR I showed you was 1 port, 1 starboard, and they can look around at night, see things. Forward-looking infrared. Don't be confused by the FL in forward-looking infrared. It can look in many different directions. They have the Mark 36 SRBOC chafe. That's to confuse incoming radar-guided missiles. And the Sea Centaur, which is that torpedo countermeasure. That's probably the most impressive defensive thing they have, in my opinion, because the Sea Centaur is pretty capable at confusing incoming weapons. It's more of a jammer than a masker, and we'll talk a little bit about that. And then you have the Yakamos hull-mounted sonar, which, as I've already talked about, is limited in capability, but at least it's present. Here's the gas turbine that their GM's building, that they're buying from them. Only about 4.7 tons, so it's a lightweight. 3,600 RPM, generates 32.8 megawatts. So lightweight, high power generation. This is perfect for Navy ships, which is why a lot of ships have this LM2500 across all navies. Well, mostly NATO navies. But yeah, we've seen this gas turbine just about everywhere. The diesels they use are made by Rolls-Royce, and they put out quite a bit. It's 8.6 megawatts, and a 16-cylinder 4-stroke diesel engine running at 1,800 RPM. So that's what you want to set your sonar system to if you want to detect this thing running. And they can run both those at the same time. You get up to 29 knots. Pretty quickly, too. That's the big thing about that GE LM2500 is it can spin up and be ready to go in about 10 to 15 minutes versus a boiler system from a cold start could take 48 hours, but from a warm start would still take a couple hours. So that's the nice thing about having these turbines. Okay, on to the surveillance radar that you're looking at now. Like I said, this is a 3D radar. It does both air and surface search for target designation. It is a S-band, which is the Echo Foxtrot NATO band, 2 to 4 gigahertz. Instrument range is greater than 135 nautical miles for air targets and 43 nautical miles for surface targets. Again, that depends on conditions, but we're just giving you the unclassified ballpark numbers. It's a 360 radar up to 70 degrees elevation. So that's a little bit less than I would expect. A lot of modern radars go closer to 80 to 85 in elevation, but hey, it can track a capacity of 750, I guess, targets, which is more than enough, no matter what you're going to be, no matter where in the world you're going to be operating. Accuracy is to 20 meters at range, and it's been in use since 2007. Very capable radar. One could argue in peacetime, this is the reason why they put this thing to sea, is so they can put this radar out off the coast of Turkey and just keep a good eye on things, on what's going on around the country. You know, that's step one. That's mission one of this platform. All right, so here we have the fire control radar. Now just forward to the bow, or forward to the mast rather, above the bridge. This looks a lot like Rice Bowl radar, the Chinese radar, but it's funny because the Chinese have ripped it off so many different people. But this one's actually made by Talos, which is spelled Thales, but I've been told it's pronounced Talos. I'm trying to remember how to say it. This is the NATO IK band, so very high, frequency, short range fire control radar. That's what you need because you need rapid repetition on these close-in radars here. Frequency is up to 40 gigahertz, which is insane. Has an instrumented range of 65 nautical miles. So, you can get out there. I'm sure if it's 65 nautical miles, it's probably using the 8 to 10 gigahertz frequency just to get out that far. Otherwise, you'd be melting the radar with the power output if you're trying to do that at 60 gigahertz. Target capacity is 1. Yep, 1 at a time because it's directing the gun to shoot 1 target at a time, so it doesn't need to be more than that. It is ECM resistant, which is boilerplate speak for those trying to sell the system overseas. Any radar can be jammed, but this one's resistant to it. It can spin 360 degrees, but of course the gun is blocked by the hull of the ship. And the elevation is negative 30 to plus 120. And it's ILC to 1992. All right, take a look at the navigation radar. This is the Don't Run Into the Coastline radar. It's the next band, IOC in 2011. And it's a frequency modulation continuous waveform. So it's just out there constantly transmitting and just getting range off of the frequency change. So the way this works is kind of interesting, is that the frequency looks like a ramp. So the frequency is always going up and up and up. And whenever it gets a return, let's say it returns at 8.5, gigahertz or whatever, it knows what time it transmitted 8.5 gigahertz because it's ramping up. And that's how it gets the range calculation to the detection. And then it plots that on the plot for the navigator. Has a range of 36 nautical miles and rotates greater than 20 RPM. All right, Sperry Marine Vision Master. This is another S-band radar here. Frequency up to 9,400 megahertz, very fast. It's an LPI frequency hopping low antenna with side lobes and sector blanking, which means that it has really good beam forming is what it's saying. Instrumented range out to 96 nautical miles and antenna rotation of 45 RPM. This is a very good radar. So this is the Marine Vision Master. This will pick up other ships, and it's very small ships too, like a dinghy in the water, maybe even at X-band levels, a man in the water, you know. So this is what they would do for a high fidelity picture of what's around the ship. All right, speaking of picture, forward-looking infrared 300T EO system. This is Esalan company I struggle saying the name with. Anyway, they're mounted on, this sensor's mounted on the mast after the helicopter hangar there. It's a high-resolution IR camera, laser illuminator, color TV camera, long-range identification. Has really good resolution, can track 6 targets optically at the same time with its IR sensors and so forth. It can swing 360 degrees, but it's blocked by its mount to a little bit less than that. And it can zoom in to 50 and 20 times. And that's really important at sea because a lot of your initial detections are going to be at very long range. So being able to zoom in and get a close-up of it is really good. So this is a really good capability for a coastal defense, you know, any kind of offshore patrol vessel or corvette like this is. You'll want a system like this. And these are becoming more and more common too. All right, let's talk about the electronic warfare suite. Very sensitive information, so we only have very general stuff here, but it does have, you know, a radar electronic support countermeasure, and for surface ships and submarines. Like if a submarine radar were to sweep it, it would classify the radar for it. Say, hey, you got a sub out there with its radar on. Let's see, its frequency is 2.2 to 18 gigahertz. Pulse length is up to 100 milliseconds. Pulse repetition is 20 milliseconds. This is on the Milgem corvettes, and they're doing the 2 NCL for the I frigates and the 2 NS for submarines. So they're going to put this electronic warfare suite on all their platforms eventually. These are all, this is a Turkish design, Turkish system, so that's why it's going on the Turkish I-class frigates as well as the submarines. Very good stuff. Like I said, we don't have a lot of details about it because it's all sensitive. Anytime you talk about electronic warfare, you're not going to get a lot of details publicly. Okay, so the Ultra C sensor countermeasure system. This is a really good anti-torpedo system. So it's a sense to effect solution for torpedo engagements, which means that the decoy has a sensor itself can get an idea of where the torpedo is coming from. And it replaced the Nixie. So this is kind of a, not just a masker, but a jammer as well. So it will provide like lots of false targets to the torpedo as the ship drives away from it. So the torpedo, if it's successfully countermeasured, will circle this decoy thinking it's the ship trying to blow it up. And it'll just be stuck in a loop or a figure eight. Sometimes it's a star pattern, depending on the type of torpedo we're talking about. The point is it's not hitting the ship, and that's the whole purpose of this thing. And it's pretty good at doing it. It's kind of a crapshoot now anymore when you shoot a torpedo at something. A lot of these countermeasures are kind of coming into their own here in this decade, and then this is one of them. So pretty good. I imagine the most modern American torpedo would be able to defeat this, but it's not 100%. It never is, really, with this balance of countermeasure to weapon system technology that kind of swings back and forth like a pendulum. Well, the pendulum is definitely swinging in the favor of countermeasures at the moment. So we'll need to build better weapons to get around this thing. All right, the torpedo countermeasure system. This is similar to the Nixie, but it's much more advanced. So this is a threat torpedo system that detects an incoming torpedo and gives information about the direction that's coming from, how far away it is. You can even classify the torpedo based on a lot of different things. So low frequency, 3 kilohertz, can detect out to 12 kilometers, was established during trials. That's what they actually saw. And the tow cable has a very strong or a very long tow cable. And you can see the systems there. This is a package deal. Whenever you get this, not only does it shoot the expendable decoys, but it comes with the winch that puts out the towed array that has a decoy on it. That's the Nixie part that I compare it to, but it's much more effective, like I said. And so this thing will defend your ship as well as give you all the information you need about the torpedo that's coming at you. Let's talk about Surbach. This is a A chaff and decoy countermeasure system. So incoming missiles and stuff, they would launch these when that missile gets into its terminal phase to try and confuse it and mask the silhouette of the ship itself through IR and radar diffusion. It has 630 millimeter mortar tubes that can be reloaded. Has a launch speed of 75 meters per second and used by many navies worldwide. And here you can see a great picture of it. It's pretty standard stuff. A lot of modern missiles, are designed to defeat this. But like I said, it's going to be, some will be more effective than others. If you get enough missiles shooting at you, this may not be enough to get away. But it's better than not having anything. And here is the iconic 76-62 millimeter gun that is on many ships, including, I believe, even the Americans now were using this one, or one made by this company. This IOC all the way back in 1964, but has been updated many, many times. It is extremely reliable, lightweight, rapid-fire naval gun. And that's why it's so popular, is that it's proven, right? And if you can get something that works consistently, even though it may be an older design that's been updated throughout the years, it's better than what China's putting on their ships right now, because that stuff is jamming all the time. It's brand new design jams. This does not, at least not nearly as much. It does have 80 rounds in the mount, which means it can go through those 80 rounds immediately if it needs to. 16-kilometer range, that's pretty standard for ballistic trajectories coming out of any kind of naval gun, of this size anyway. And weighs 7,900 kilograms. So relatively lightweight, and every warship needs a cannon, and this has got it. The RIM 116 Ram Block 1A. This is the point defense that I was talking about earlier. This is infrared homing, rolling airframe, has 21 missiles in the pack, and it has a combined IR, like I said, an RF seeker system. So it just homes in on that missile that's coming in, because that missile typically will have, among other things, a radar of its own to help identify targets and get to the ship. Well, this thing will look for that radar and home in on it as well as the IR signature. And this thing works pretty well in war games. I know, because it's an American design, we use it in the American war games, and it's pretty consistently reliable. It will shoot down all sorts of target decoys. So probably would work the same at sea in wartime as well. Max range of only 9.6 kilometers, point defense. Altitude of up to 12 kilometers. In height, warhead is only 9.3 kilograms. Okay, here we have the anti-ship missile. Basically, Turkey's version of the Harpoon, in my opinion. The ATMACA. I'm sure people from Turkey will argue that. They'll say that that's not true, but just look at it, man. It's a freaking Harpoon. Okay, this IOC in 2022. It's 350 millimeters in diameter, 750 kilograms, has a 220 kilogram warhead. It's a Harpoon, range of 220 kilometers, 0.8 Mach. It's turbofan propelled, and yeah, booster launched. God bless Turkey for copying our system. I'm sure they licensed it. I'm not saying they stole it, but hey, it's reliable, right? It's a subsonic anti-ship missile, and that's what this does. It'll sink a ship out to 220 kilometers. It'll just take a little time to get there. All right, Mark 54 torpedo. This thing's a beast, man. What they did was what is the Mark 54? Well, it's a combination of the Mark 46 and the Mark 50. So Mark 46 American lightweight torpedoes, been in the inventory for decades, like back to the 60s or 70s or something. Very, very good torpedo. But it has its deficiencies, right? Basically in the nose. So America developed the Mark 50 torpedo back in the 90s, and that was much better. Fast, quiet, target identification. It will call your mom before it shoots the submarine. It does it all. Wi-Fi, Bluetooth enabled. But it's so expensive. Even the Americans can't buy the Mark 50 because it's so capable. So America was like, Raytheon, please, stop bleeding us with all this expensive weapon system. And they're like, all right. We're going to take the engine from the Mark 46 and the nose cone from the Mark 50 and put them together and pass the savings on to you, taxpayer. And that's how the Mark 54 was born. Yeah. So the Mark 54 is the Mark 46 engine pushing the Mark 50 nose cone around the water. So not as fast as the Mark 50, but just as smart. in terms of identifying the target, learning your Wi-Fi password right before it sinks your submarine. It's a very smart weapon and very capable. I OC'd in 2004. I might have had something to do with its development in my time in the Navy, but that's still classified, so we can't talk about that. I can confirm it's freaking good. It's a scary ass weapon if it's coming after you, because it doesn't see decoys, but it does see submarines. It's one of those weapons. Anyway, this thing can go out to 20 kilometers, has a warhead of 440 kilograms. That's enough to punch a hole in your submarine and let the seawater do the rest. It is acoustic and proximity fused, which means it doesn't have to physically hit your submarine. It just gets close by, explodes, and it blows a hole in your boat, Lets all the seawater in. It's bad. It doesn't even have to go active. It can home in on your ass without pinging. This is 2023, ladies and gentlemen. Torpedoes don't have to ping anymore. And guess what? They're quiet. They're not like movie torpedoes. You may not even hear this thing before it explodes. Yeah. All right, I better change topics. Let's go. Stamp 12.7 millimeter remote control weapon system. This is a stabilized machine gun platform. They have one on each side, one port, one starboard. It's electronically or EO powered and remotely controlled, is what I'm trying to say. They carry both 7.62 machine gun rounds, 7.62. They could have a 40 millimeter grenade launcher on board, or the GAU-19 Gatling gun for all your destruction needs. The fire rate with a 12.7 on it, as displayed here, is 1,250 rounds per minute, which is enough to get the job done. It can traverse 360, but again is blocked by the hull because it's mounted on the side of the ship. Can elevate -20 and +60. Shoots 200 rounds a minute. Unless you put that Gatling gun on it, it's more like 5,000 rounds a minute. This I will see it all the way back in 2007. This is really good for just, small boats. It's more than just point defense in terms of shooting down incoming missiles and stuff. If you need to take out a small boat that's nearby, this will do it in a hurry. You don't even need that 5-inch gun. You just train one of these things on it and it'll punch a bunch of holes in it. And then finally, arguably the most capable thing on this little corvette is the S-70 Bravo Seahawk. This thing is a beast whenever it comes to pretty much any kind of mission that requires a helicopter, but it's really good at the ASW platform as well. Range is 450 nautical miles. Max speed, cruising speed, I believe is the 146 knots. I think it might go a little bit faster than that, but okay, we'll say 146 knots for those of us that are civilians. It can shoot the Penguin missile. Now, I thought the Penguin missile was out of service, but it might still be in service in Turkey. So keep in mind, this is an American helicopter, right? But it's possible that Turkey still shoots the Penguin missile. They certainly shoot the Hellfire missile out of this thing. A Hellfire will blow up a small boat as much as a cruise missile will. So, and then it does launch both the Mark 46 and Mark 54 torpedoes. It does have the AQS-18 dipping sonar, and that's what I think it'll primarily be used for. Besides over-the-horizon targeting, it does have an ESM, the LR-100, and of course the APS-124 surface search radar, which is a really good radar. It's really good at detecting periscopes too. So, even though it's a surface search radar, it's part of the ASW package because you get a diesel boat out there snorkeling at periscope depth or any other boat just poking up a periscope. Well, this APS-124 is probably going to see it. Yeah. And they're just going to fly over you and drop a bunch of torpedoes on your butt. So very good helicopter to complement what I think is a very good corvette. A tip of the hat to Turkey, man. I think they did it. I think they did a good job. They built 4 of these. All right, final thoughts. Milgem. It's the backbone of the Turkish Navy renewal program. This is how they're going forward. Like I said, they're building the I-class now, which is the frigate version, a larger version of this. It is a multi-mission stealth corvette. Its main mission is anti-submarine warfare, and I think it's very good at that with the helicopter. Big caveat. Okay, they do export things to the Pakistani Navy, and they will be, at least one ship is going to the Ukrainian Navy, but as of time of this recording, that's still in limbo. They've built the hull. I don't believe they've completed it, and I'm not sure what the current status is, because there's an ongoing conflict in Ukraine, and a NATO nation supplying a ship to Ukraine in the middle of that conflict could cause trouble. So I don't have the end story on that. As far as I know, it's still sale pending or delivery pending right now. Okay, so the frigates will have deep strike capability. That's with the Harpoon, and I suppose you could argue the helicopter as well if you put some rockets on it. The main propulsion is code DAG, like I said, incorporating. It's only got one gas turbine, but it's a corvette. It doesn't need more than one. And that gas turbine can get it to sea in 15 minutes from being dead at the pier, with only a couple people on board. Start up the gas turbine, you have enough electricity and propulsion to get out and go pretty quickly. And of course, diesel engines, you can start those up anytime. So, fourth corvette is powered with the Advent CMS, which is compatible with network-centric warfare. What that's talking about is integrating your systems with other ships and incorporating their targets at their range, even from their own helicopters. That's skipping the signal from ship to ship back to this corvette. So you could launch a Harpoon from a corvette, the fourth one, to a target that's being tracked by a helicopter from another ship using that other ship's fire control system. Yeah, think of it like the Aegis system, but they call it the Advent Combat Management System. Okay, very good stuff. And I do want to say thank you real quick to our researcher, Tayfon Osbrecht. He's a very good researcher. He did a great job on this, and I appreciate all the work that he does. Thank you again, Patreons and all the YouTube members, for supporting and paying for all the great work that Tayfon does. All right, we'll see you guys in the next one. Welcome to the Admiral Sergei Gorshkov frigate, Project 22350 ship brief. Our design for this ship begins back in 2003. The Russian Federation decided it wanted to replace its aging Krivat-class, so it came up with a new design. This design would use composite materials, an aluminum alloy composite for the superstructure specifically, that would be designed to not just reduce the energy of radars, but also help deflect energy radar emissions away from the receiver to give the ship some stealth-like characteristics. But just to be clear, this is not a stealth ship. She simply has characteristics designed to reduce her radar signature. She'll also be able to shoot the latest cruise missiles in the Russian Navy, the Onyx and the Caliber cruise missiles, including an ASROC variant, a Russian version of the ASROC. And in 2023, she'll be shooting, or at least equipped with, and testing the Zircon hypersonic missile. A couple of long-range radars on her is the frigate M2EM3, and we'll talk in detail about the electronic warfare suite on this ship. And the long-range sonar is the Mineral ME, bow-mounted and VDS sonar system. So where is she being built? Well, Northern Shipyard, St. Petersburg, Russia. One of three shipyards here in St. Petersburg. And she's the newest of the three. And surprisingly, I found in my little research here that she's not self-contained. She's not self-sufficient. The Northern Shipyard needs to outsource a number of basic shipyard tasks to outside contractors, like pipe working, including pipe cutting, pipe fitting, and metal welding. So basic shipyard functions are outsourced to local contractors. Some of the capabilities of this shipyard are for covered slipways that have 50-ton lift cranes. So that's not the limit of the ship that can be built. That's the limit of each component that needs to be lifted onto the ship as it's being constructed. So she also has 4 open-air slipways that are 100-ton crane lifts, so they can carry much larger components, entire sections of a ship essentially, placing it on the slipway for construction. And there's also a floating dry dock, one that hasn't managed to sink yet. It has a 10-ton crane on it, so the size of the shipyard limits the size of the ship that it can take into the floating dry dock, and that crane itself can only support relatively light loads when compared to like the 100-ton construction crane. All right, so the Gorshkov by the numbers. So what are we talking about here? We're talking about this frigate. This Russian frigate, it's a modern 21st century frigate, so it's multi-mission. It can do everything. It can do air warfare, surface warfare, support troops on amphibious operations if necessary, even though that's not its primary task. It has a good ASW suite, very modern one anyway. The equipment is good. Whether or not the sailors know how to use it is questionable. But the equipment on this ship is new. It's top of the line. And she can fight in all domains, including information warfare. She can connect via data link, satellite sensors with local fleet commands, and act as a host or a mothership if she needs to for communications. Her weight comes in when fully decked out, fully loaded, 5,400 tons. She's 132 meters long, 16 meters beam, and is a CODAG system. That's combined diesel and gas, turning 2 shafts, 5 blades apiece, at a speed of 29 knots when everything is cranked up to maximum. She has a crew of about 200 people. The first 4 hulls only have 16 VLS tubes. Every hull after that has 32, but they all shoot the same missiles. The Onyx anti-ship missile, the Caliber anti-ship and land attack missile. There's also a Caliber anti-submarine missile. It's like the ASROC, but it's the Russian Caliber version. And of course, the Zarkon's coming early next year, 2023. The 9M96 SAM missile Redoubt is the VLS there just forward of the sail and behind the turret. Can shoot a number of different SAMs out of this VLS, which complicates its loadout. It could have a lot of very small short-range missiles, or it could have a few very powerful long-range missiles. And we'll go over all that in detail when we talk about the SAM suite. On the bow, you see a 130 millimeter gun, and that's an A192 dual-purpose cannon. It can shoot 30 rounds a minute, has a magazine about 500 rounds rather, and 130 millimeter hole is pretty big. So this thing can put a lot of metal down range in a hurry. It is a very large shell compared to modern NATO guns. She also has 2 Palish Sea Whiz cannons on the back, just forward of the helicopter landing area on the superstructure. She also shoots 2 quad torpedo tube launchers that are 324 millimeter torpedoes ejected out of there. She normally carries a helicopter K-27 maritime variant of that very capable helicopter, but we've also seen tests, as we'll talk about today, of the K-52K attack helicopter being operated in testing and in war games only, not deployed with yet, from this ship. And we'll show you a few pictures of that. She uses the Furky 3D air search radar. She also has the Zalsan air search and surface search radar. The Polomit AESA radar, which is a very advanced phase array radar, best Russians have right now for these ships, and the Monument A radar complex. She has the Zyra M sonar and a MTK-201 electro-optical targeting system that she can use to target things like the guns and the point defense optically if she needs to. And this is all connected by a new Sigma combat system, specially designed for the Gorshkov-class. So let's talk about the CODAG first, what makes this ship go. They have 2 of the Colmena 10 D49 diesels. These are commonly spoken D49 amongst Navy nerds. Very common diesels, been in service in one way or another for decades, going all the way back. But this is the modern version of it. Extremely reliable, puts out about 5,000 shaft horsepower per shaft, and they have 2 of these diesel. So this is the prime mover for it. Anytime it's at sea and it's moving through the water, this diesel is running. If she wants to go fast, though, she's going to turn on her Saturn M9 FR gas turbines, and this thing will push it up to 29 knots. And these push about 27,000 shaft horsepower each shaft when these things light off. The problem with this engine for Russia is it's made in Ukraine. They're not getting parts for this anymore, much less any more deliveries. So that's complicating things. Russia needs to find a new source for this engine, for the ship, or redesign the ship for a different engine. All right, let's start with some sensors on the top. We're going to work top to bottom here. For K4 air and surface search radar, it's the 5P27. It does just what it says. It's a long-range air search radar, and it's linked to fire control. Going down the mast, just below that is the Polomit phased radar. This is the ASA. These are 4 single-faced active phased radars. They don't move. They digitally steer the beams, so they don't have to spin like an old-fashioned radar does. They can track and engage targets, provides fire control data, and can engage a high number of contacts. I couldn't find a specific number. One source guessed that it could engage 50 at once, but that is completely unverified. Okay, the Mineral E surface search radar. This is an I-band radar. It can receive over-the-horizon targeting from the helicopter. That's where the helicopter, if this thing is not transmitting, it can be put into a receive mode. And so the helicopter, as it goes out over the horizon with its surface search radar and sonar, can ping targets and relay that data back to the ship via this array. But whenever it's not in receive mode, it's in transmit mode, and it can detect things like anti-ship missiles, surface ships out to 20,000 kilometers, sorry, 200 kilometers, Jesus, and about 50 kilometers for missile detection. So that still gives them plenty of time to get self-defense spun up and defend the ship 50 kilometers. This one can track 50 targets passively, 30 targets actively, and engage 10 of those targets simultaneously, while having data link to up to 9 other ships, or to be more specific, receivers, because that data link doesn't have to be a ship. It can go to a satellite as well, or an airplane, or a helicopter. Here is the optical, electro-optical guidance. This is the MTK-201ME multipurpose TV system. This allows operators to simply look around if they want to, but anything that they find with their thermal imager and get the range with a laser rangefinder, they can also send that data to guns. So they can track objects optically, which is a passive way of tracking. If you're tracking, say, a helicopter or an airplane optically, they're not going to know. There's no indication on the airplane side or the target side that this sensor is tracking them. And then this data can be fed to the weapon systems, combat systems, for engagement if necessary. Here is the Zorya M bow-mounted sonar. This is part of a suite that includes a VDS and can communicate with the helicopter here. I found a fantastic photo of this console with some of its displays on, and it's very advanced. There's a lot. I recognize the displays right now, and they have a lot of the capability we had in the 90s here. I'm looking at the 1990s when I look at this console, and so they are coming along. The Russians are trying to catch up to us, but just to give you an idea of how far behind they are, that is the 1990s capability right there. Okay, Gratch interference system. This is their Dazzler, their laser that does not destroy things. It's not that powerful. This will not hurt human vision if it's shown at a cockpit, for instance, but it will confuse and dazzle sensors from drones. And if you aim this at a pilot, it's not going to feel good, but it's not strong enough to blind anybody. And that's intentional, so they can use it in peacetime if necessary. So this won't shoot down a drone, won't do anything like that. It won't defend against a missile, but it will disrupt and even damage sensitive sensors on drones. And that's what they use this Dazzler for. The PUKT-216 countermeasure launchers and the PUKT-308 there. These are different types of countermeasure launchers that shoot a combination of smoke and flares, and generally shroud the ship from any kind of sensors, including visual. Like a launch of these will shroud the ship in a smoke that can last up to 15 minutes is what it claims, but that would really depend on wind. I suppose if there's absolutely no wind, which is unlikely, the smoke may hang in the air for 15 minutes. But it's a long duration smoke screen / infrared, masker with flares and chafe for radar deflection as well. These two, they have 10 shots and 12 shots depending on the type of launcher they have. And they have multiples of these launchers on board the ship. The Sigma combat system. There's a special version of the Sigma combat system just for this class. Here's a couple photos of it. Pretty standard stuff. This allows the sensors and the weapons to talk to each other. This is where it all comes together. It's a very important system to get right. It takes a highly skilled operator to operate this. Honestly, in the United States Navy, it's often an enlisted man that operates this until we go to battle stations, and then that workload is shared with officers. I'm not sure how they do it in the Russian Navy. This sailor here, I don't see, oh yeah, I do see boards on him, so it does look like an officer is operating this. And during battle stations, that would be normal. So here is the A-192 artillery system. This is the radar and fire control system that directs the gun with radar, not the optical one like we had just seen. It controls the 130 millimeter gun on the bow. And those are some of the power and data crunching units for it, displays. It also controls the point defense system on the rear. So you can control both these manually. They can be in automatic mode. Just tell them to engage the target, and it automatically calculates range, trajectory, the whole works. Pretty capable system when operated properly. So here's a good photo of the gun at near full elevation, just firing 130 millimeter shells into the stratosphere there. 23 kilometer surface range. If it's doing like shore bombardment or whatnot, that's its maximum ballistic range. If it wants to engage air units, which it can shoot at, that range is limited to about 18 kilometers. It can shoot 30 rounds per minute. This is a new generation artillery system. It has a number of different rounds it can shoot, including airburst, fragmentation, high explosive, you name it, the works. It's lightweight, rapid fire. Reliability on this has not been great, but it's been getting better. So I would just assume that it's a reliable gun. And if you find yourself in engagement with it and it breaks, you count your blessings. But in the beginning, this gun entire system did have reliability problems. All right, here's the Palash, if I'm saying that correctly, point defense system. Basically dual 30 millimeter cannons, can spit out 500 rounds per minute. They have 500 round cartridges that get reloaded rapidly. So yeah, it's an interesting design. The loader is an auto loader, but I don't know how fast the auto loader is. And this can shoot incendiary rounds, tracer rounds, and then a fragmentation high explosive is the most common one because it's used for point defense, shooting down incoming missiles or low-flying helicopters and airplanes that get too close. Pretty mean looking system. Shoots a lot of lead downrange. All right, so the UKSK VLS, besides the gun on the bow, this is the primary weapon, is this UKSK. And that can shoot the Onyx, the Caliper, and in the future, the Zarkon hypersonic missile. Now, just forward of that is the surface-to-air missile battery that shoots the 9M96 family of surface-to-air missiles. And those can be long range, they can be short range, or any in between. And that's called the Redoubt. So that has 32 VLS cells. So here's a picture of the Onyx anti-ship missile. NATO name is Strobel. Pretty capable, supersonic missile. It does something pretty interesting towards the end. As it gets close to its target, it does speed up. It changes its speed, which makes intercepting it interesting. Not impossible, but you got to be ready for that because this thing is not a constant speed weapon, and that's intentional to make it harder to shoot down. It can receive its targeting guidance mid-flight from satellites, so not even a human in the loop. It can get updated targeting data from satellite. It can see-skim and hit a target at 120 kilometers, or you can get more range out of it if you fly it higher in a different mode and get 300 kilometers out of it. It does 2.5 Mach, has a solid rocket fuel booster in the beginning that you can see here. By the way, the photo on the bottom is photoshopped, but I left it in because I want you to see the trajectory. The launch of this missile is very distinctive. It doesn't arc like an American or NATO missile. It goes up a couple hundred feet above the launching platform where vernier jets kick in and tip the rocket over on its side in the direction of where it needs to go. And that's when that booster kicks in and pushes it up to speed, and then the liquid fuel ramjet kicks in after that. Very interesting way of launching a missile. It's very effective. It gets the missile going in the right direction very quickly. All right, here's the Caliber missile, NATO name Sizzler. It's a long-range, low-flying cruise missile. This thing has all sorts of variants. It can do land attack with precision, anti-ship, and even an ASW version that has a little torpedo on the bow. So rocket assisted there. Very similar to the American ASROC. And the ranges are for land attack, 2,000 kilometers. A ship can be hit up to 660 kilometers. And for submarine, it's a 40-kilometer maximum ballistic range. They shoot it in a ballistic trajectory for that. Okay, terminal phase accelerates to supersonic speed. That is for the ship variant, anti-ship. Also uses coordinates and can optically guide on its target. So it has a little IR sensor in the front. It sees the outline of the ship, and it can recognize the difference between a large surface combatant and a small one. Not necessarily the difference between a carrier and a Ticonderoga, but definitely between a carrier and a littoral combat ship. It can tell the difference, and it will choose its target accordingly. Has a 1,000-pound payload, except for the torpedo. That's a small 330 millimeter torpedo, small one. Okay, so the readout VLS, this is that SAM battery. As you can see, they have a bunch of cells up there on the bow just behind the turret, and they can shoot the 9M96E, which is the S-400 variant. Very long range, technically capable surface-to-air missile. But it takes up the entire VLS cell to shoot one. So they can put in the 9M100 variant, and they will get 4 missiles per cell, but they're extremely short range, very short range missiles. About 40 kilometers. So basically point defense, and maybe defending a ship that's right next to it from missile attack. So I would imagine they have a combination of these two different types of missiles in these VLSs. Let's talk about torpedoes real quick. They do have waste launchers that are behind doors, so you don't normally see them unless they're shooting. Very similar to the old pirate and sails and wooden ships days, where they would open up a door and roll the cannon out, and the cannon would shoot the cannonball. Well, not quite as simple as that, but this torpedo tube is a quad launcher. They have one quad launcher on each side, and it's a 330 millimeter launcher that has a 324 millimeter torpedo inside of it. And it's pneumatically ejected there. You can see some fire coming out. And it's bearing only. Like, you point this torpedo in a bearing and it just runs. It'll do a snake search and all that. It'll do the search you tell it to do, but there's absolutely no fire control data. There's no wire guidance going to these torpedoes after they're launched. It's a relatively short range fire and forget torpedo that runs out to about 10 kilometers. There is some talk that this torpedo may have anti-torpedo capability, because it does have an infrared sensor to assist it in homing in on its target. And because of that, it is believed that it could home in on a torpedo, because torpedo runs very hot as it's going through the water. So it would definitely be visible to the sensor. That is, however, completely unconfirmed. Helicopters. Let's talk about helicopters. K-52K Kamov, this attack helicopter that carries a ton of weapons. There's a maritime variant that you can see there. And they've been practicing using this ship and the helicopter together in war games in the Barents Sea and coming down Norwegian Sea. So they're trying to make these two work. And the Kamov comes in multiple different configurations. But the maritime one has extra gas tanks, a surface search radar, can drop torpedoes. And on the right-hand side, there's the rather old school now, K-27 Helix, that's been around for decades. Very reliable. This one gets the job done. It can stay on station long periods of time, has over-the-horizon targeting. It links up with the ship, to provide data. Very capable helicopters, both of these. All right, so let's talk about Hull 1, the ship that the class is named after, the Admiral Sergei Gorshkov. Hull number 417. They did recently change the hull number. Russians do this. What's the new hull number here? Let me look this up real quick. I may have to edit this part out. But yeah, they changed the hull number. The new one is hull number 454. So if you see hull number 454, it's the same as hull 1. She's laid down in 2006, launched 2010, began pierside trials 3 years later, and then sea trials in 2014, where she underwent 4 years of sea trials. And this isn't unique to this ship. The Russian Navy especially, but not only, will spend a lot of time in sea trials for its lead ship. But from the keel being laid to it being commissioned, being some 14 years, or is that 12 years? Yeah, it's a long time. Long time before this thing finally got out. After she was commissioned, she was transferred to the Northern Fleet, where she operates today. And during that transit, she was observed as doing 26 knots, not the 29 knots everyone assumed or expected that she would get out of her power plant unit. Now, she may have just been going 26 knots because of weather conditions, or that's as fast as the captain felt like transiting, but it is interesting that during her transit from one port to another in open waters, she was not transiting at her full speed. And that may mean nothing, but it could also mean that maybe she's not as fast as we think she is. And the speeds between 25 knots and 30 knots are vital in modern naval combat. That's the speeds between being, an effective surface combatant that can fire and maneuver and being a slow surface combatant that's going to be back with the support ships. Those are very important 5 knots. All right, let's look at the ship build schedule. There are 2 ships built at the time of this recording. The Kasatonov is already built, and she's going through her, her paces. She's already commissioned. She's in the Navy, but she's being used as well. The Admiral Golovkov was the 3rd hull that's supposed to already be built, but something has gone wrong where that's been delayed, and I don't have an actual commissioning date for her, although it could be very soon, maybe even at the time of this recording. But something has happened to where her commissioning did not go on as planned, and there's a 4th one expected to be commissioned as soon as well. Remember, these have the 16 VLS tubes. The next variant that we have here, the enhanced Gorshkov, these have the 32. They doubled the number of VLS tubes. Here, of course, that's going to change the weight, but none of these are built. They laid the keel, I believe, on 4 of these. Yeah, 4 of these. So 4 of these are under construction at the moment. I guess you could say 6 if you want to count the 2 that aren't commissioned yet. But these guys are still being built, and these do have the additional VLS tubes. By all accounts, a very modern, with new equipment, frigate warship. She is technically capable. Large gun on the bow. Lots of missiles. For land attack, long-range ship attack, satellite guidance, satellite targeting. She has everything she needs to be a very successful ship, including a good point defense. Those point defense cannons are no joke. And that helicopter hangar and that helo capability really extends her usefulness to the fleet at sea, especially in an anti-submarine role, but she's not limited to that either. This is a good multi-role ship. The question is, based on recent performances, is can the Russians operate it to her full technical capability? And that has yet to be seen. We don't know. But this is a new ship with new systems that appear capable. And they've been tested at sea during sea trials and whatnot, and they do work. But they just haven't been tested in battle yet. We'll have to see if that happens. But in my opinion, this is a good ship. This is a good, large surface combatant ship. All right, I want to say thank you to all the new and existing members of the Patreon. You guys make this possible. Executive Officer Scott Borg, sir, I salute you. Thank you for all the support. Scott doesn't say much on the Discord. I don't even know if he hangs out there that much. But when he does say something, I do appreciate having conversations with him and his alter ego, Harpoon Henry. He's so generous that he's got a couple different accounts that support us. William R. Collier Jr., thank you, sir. Consistently a department head for years now, so appreciate that. And the division officers as well. We have one new division officer I want to point out by name, Mr. Raging. I'm going to have to come up with a nickname for you, like Raging Cajun or something. Raging joined the Patreon division officer wardroom right before the last video went public, so his name was not on the credit board there, so I made sure I got it on this one. Thank you very much, Raging. And of course, to all of the old school division officers been here forever: Alexander Huff, Brendan Ferry, Joel Corrent, DJS 4000, Jordan Vazraka, Josh Woolrich, Robbie Stahl, Sean O'Neill, the OG, him and Scott Borg, very first Patreons, and Mr. Fraser Disney, who seems like a genuinely happy person every time I see a picture of him. Thank you all. Thank you to all the Patreons. I enjoy doing these. Now that I've got good source material with the Jane's fighting ships, I can go through the entire Russian Navy, the entire Chinese Navy. We have so much more to bring to you over the next couple years. This is going to be great. And I couldn't have even afforded this book. It's so expensive, but I did it with you guys. And so this is how your Patreon is making these better. Is I found a number of things online, big things that were wrong about this ship, that because I had the Jane's fighting ship, the gospel of open source intelligence, I was able to correct this this presentation before it went live. All right. So, hey, if you guys read stuff online that counteract what was put out here, it's probably wrong, because I read it too, and I was shocked whenever I compared it to what Jane said. So we're going with Jane's as the main source going forward, and everything else online we'll just take with a grain of salt. All right. Enjoy the rest of your day. Thank you again. I'm going to start working on the next lecture, and we'll see you guys in September. Have a great weekend. Bye. Welcome to the French Aquitaine-class ship brief. This is also known as the FREM, multi-purpose frigates. This is the French version of what the Italians have built, and we talked about that in a different lecture. So this is the French version of their modern frigate. The Aquitaine is one of two classes. Like I said, Italy and France each have their own version, but there's also two versions of this class for the French. One is the FASM, and then there's the new modernized Freda or FREM, F-R-E-M-M frigates. And we'll go over those differences here in today's lecture. They also built some of these for Egypt and Morocco, so they have an export version of these. So these do shoot the Exocet French anti-ship missile. This is the Block 3, which is the modern one by 2024 standards. It has a 16 silver A70 VLS. Those are in two different VLS cells. And it has 16 silver A43 VLS that shoot the Astra 15 and Astra 30 surface-to-air missiles. Now, the anti-air variant does have a 32 cell A50 for the Astra 30, so more long-range missiles in that AAW variant. And of course, it is stealth design. You can see that just by looking at the shape of this thing. And we're going to go over all the different bits and pieces of it here today. Let's start with the weapons, and we're going to begin on the bow. They have the 76 millimeter rapid firing gun there. Behind that are the VLS. They have the VLS is broken up into multiple different cells, and they can load the Astra 15, which is a medium range surface-to-air missile, Astra 30, long range surface-to-air missile, and then they also shoot the land attack Scalp missile. Behind the bridge is the Exocet's MM40 Block 3, like we said, anti-ship cruise missile, subsonic. I've always compared the Exocet to the Harpoon because they're similar in performance, but the modifications and improvements they've made over the years to both of those have made them diverge a little bit in capability. So the Exocet is very good at not being detected, so it can't be shot down. It's very stealthy for a cruise missile, but it is still subsonic. So once it's detected, it's game on. All right. They have the Eurotorp torpedo launchers, the MU-90 port and starboard. There's a twin launcher port, twin launcher starboard. And on the helicopter hangar where the helicopter is housed, there are two remotely operated weapon systems. And we'll talk about them. All right, so those are the weapons. Weapons stem to stern on this thing. Very good stuff. Now let's talk about sensors. Sensors on the bow above the bridge. There are a number of different things here. All the way forward is the navigation radar. That's the Terma 2001. Very good at what it does. Behind that is an optotronic director. So that is something that is, optically guided. They can look around. It's got different settings for thermal and camera and IR. The Thales Heracles 3D radar, that's that ASA radar. It spins, it looks like a pyramid, and it just spins rapidly over the bridge. And that's what that is. That is a 3D radar. Behind that is the large mast that is full of sensors. These are passive sensors, just listening for everything. All the way at the very top, we have the RESIM and CSIM. So that's radar ESM and communications ESM. And this is the antenna that detects those signals, sends them down inside the ship for processing, when they can be recorded, analyzed by the crew. And machine learning is involved in that now. As we work our way down this large center mast, we have what's called IRST. That's the Thales Artemis system. And below that, port and starboard, is the Nettuno 4110 ECM. That's electronic countermeasures. Moving after that, we're now above the helicopter hangar. We have the Canto 5 decoy launchers. And we have, behind that is another Thermoscanter 2001 nav radar. So the nav radar above the bridge and another nav radar behind it. It makes sense when you look at the positioning of these radars that there's a shadow zone, which is the superstructure of the ship itself, which is why they have two nav radars, so that there isn't a blind spot. And then finally, below the helicopter landing pad is a large open area where they keep the CAPTAS 4 variable depth sonar, which is a fantastic system. And we'll go over that as much as we can here today. Here are the ships that they've built. They began commissioning these in 2015. They just commissioned the most recent one in 2023, just a few months before this recording. And they continue to make improvements on design. And I'm sure this ship will continue to be built in some variant or other going forward. But this is what we have right now, all being built by DCNS Laurent, now Naval Group Laurent. That's there in France. All right, let's break these down by the numbers. This is code log, which is combined diesel, electric, and gas. So they got a gas turbine plus 4 diesel generators, and they can use them all simultaneously to push 2 shafts with controllable pitch propellers and 1 emergency propeller, which is it's also called an auxiliary propeller for emergency handling. It's not emergency like high speed. It's emergency as in nothing else works. Let's be able to turn the ship a little bit type of propeller, you know, or limp home if you have to. If you have to limp home on your emergency propeller, pack a lunch. It's going to take a while. It's not very fast, but it's there, you know, just as in case everything else fails. All right, so the total weight of the ship is just over 6,000 tons fully loaded, and it's 142 meters in length. It can go 27.5 knots. That's the public speed. But if it wants to make maximum endurance of 6,000 nautical miles, it can only do 15 knots. So I assume, this is my opinion on this, that the 15 knots for max endurance would be just running the diesel electric generators, because those are probably more efficient than the gas turbine is. But going down from that, we have the 16-cell silver A70 VLS. This is for the older FASM variants. Those are the ones that shoot the MDCN cruise missile, land attack missile, and the silver A70 VLS are where those are housed. Right in front of them is another 16-cell silver A43 VLS, where they put the Aster 15 medium range and Aster 30 long range surface-to-air missiles. Now, for the FREM, which is the 2 most recent ones, instead of breaking it up 16 and 16, they have 32 cells of Aster 15, Aster 30 surface-to-air missiles. So they just have more surface-to-air missiles in exchange for the Scalps, the MDCN land attack missiles. Now they all have the Exocet missiles amidships, 8 of them. That's the MM40 Block 3 or 3 Charlie. Of course, the 76 millimeter rapid fire gun on the bow, and 2 Nexter Narwhal remote weapon systems, 20 millimeter above the helicopter deck. They can shoot the MU-90 torpedoes. And Thales, for sensors, they have the 3D multifunction radar. That's that pyramid thing that spins rapidly. It does spin at different speeds, but usually they have it going pretty fast. Thermoscanter 2001 surface search, navigation, helo control radars. They have 2 of those, forward and aft. The Sperry Marine navigation radar as well is above the bridge. The Segma Vigmi MM Optotronic Director. We'll show you a picture of these in just a second. They have the Artemis IRST system and the Thales Sigint CSIM and RESIM suites. Those are for communication and radar ESMs. Nettuno is a 4100 jammer. The Sagmon NGDS is a 12-barrel trainable launchers. So the launchers are mounted, but they're not fixed, which means they can pitch up, down, left, right, and then launch their decoys. They do have the slant alto torpedo warning system, so that detects common machine speeds for torpedoes, whether they're electric or thermal. And then, of course, any active sonar, whether it's waycombing or actual active for detection. The alto is designed to detect all of that and alert the crew that there is a torpedo detection. In the U.S. Navy, we call that the torpedo alarm, and it's very loud and annoying. And when it goes off, it gets everyone's attention for good reasons. Two launchers are the Canto torpedo countermeasures, along with the NGDS 12-barrel trainable launchers. Torpedo countermeasures obviously go into the water, where the 12-barrel trainable launchers are for smoke, flare, and radar obscuring into the air. And on the helicopter deck, she can have two NH-90 or one NH-90 plus one AW-101 helicopters. And those helicopters have different purposes, and so that's why they could go with either one of those. All right, let's break all these down in detail. I just fed you a lot of information. Let's begin with some common ground. Most of you are very familiar with this by now, and that's the LM2500 G4 gas turbine, manufactured by General Electric right here in the good old United States. We sell these things all over the world because they're fantastic what they do. Very efficient, high power, very reliable, easy to maintain. And if they completely break down, you can rip one of these out and put a new one in a day, easily, if you're pierside, in a day. And they've become the standard. LM2500 has become the standard turbine for modern naval ships. All right, here's the Hercules 3D multifunction radar. This thing's wild. It does operate in the S-band, which is 2 to 4 gigahertz. It is air and surface surveillance and fire control, which means, it can direct weapons, while it's tracking, airplanes and surface ships. It does it all. Has a range of 43 nautical miles in surface search, 135 nautical miles in air search, and spins at 60 RPM. So that entire pyramid is spinning 1 per second. And it's pretty impressive when you see it spin. It's very distracting. It's very obvious. It can track up to 400 targets at one time. It does have track on jam, which is a matter of just marking a bearing that you have jamming from. And the elevation is up to 70 degrees, up 360 degrees. And IOC'd in 2007. Here's the SAGM Optotronic Director. I told you this was the optical tracker that they have above the bridge that has, thermal scopes, night vision, and so forth. Has both short and long range detection. It can track objects that it detects. And that is a very cool feature of this, is that once it identifies a shape, whether that's a small boat or a helicopter, it can maintain track visually of that shape. Here's the fire control radar. This is the Steer 1.2 EO radar. Operates in the X band, which is a very high frequency, high rapid update rate, which is what weapons need for guidance. So it operates in the 8 to 10 gigahertz and then the 20 to 40 gigahertz. That 20 to 40 gigahertz would be the terminal homing, that's the radar frequency that's going to the weapon to make sure it hits the target. That's that high update rate. So X-band is accurate out to 65 nautical miles. K-band is 19 nautical miles. Missile guidance is out to 16 nautical miles. And low RCS aircraft, low observable aircraft, 27 nautical miles. We're putting warheads on foreheads at that range there. Target capacity is 1 per. So it's going to shoot down one weapon or one target and then move to the next one. Don't confuse that with the 3D radar. 3D radar is tracking 400 some targets, and then it feeds a target one at a time to this and says direct the weapon to hit this target. Once that's done, it chooses the next one in the queue. So these radars are working together through what's called a combat system that links everything together. It is ECM resistant, 360 degree coverage, and elevation is from 30 to 120. I'll see it in 1992. Don't be fooled by that year. It's been updated for right regularly since then. Here's the Scatterand navigation radar. Nothing really fancy here. It works well. It does have pulse compression, which means it's very accurate, and it could be hard to detect if you're not paying attention, but they're going to have this thing in continuous transmission. So it's not like they're trying to be stealthy with this, in my opinion. Helicopter control for short range ops is interesting. So from the helicopter, they can designate targets and stuff. How that works is very sensitive, but just know that it's communicating. It's working with the helicopter when the helicopters are airborne. It does have ECCM, which means countermeasure. So when someone else has their countermeasures up, it has modes that it can use to try and burn through those countermeasures. And it operates in the X-band, which is interesting for a navigation radar. X-bands are usually exclusive to weapon systems. But perhaps that's available for the helicopter and how it works together. I don't want to go into any more detail about that, but just understand that X-band for a navigation radar is complete overkill. And that might be the point. All right, here's the Thales, or I always say this name wrong. Talos. Thales is pronounced Talos. Artemis IRST detection system. This is an infrared search and track system, covers 360 degrees, long range. This is great for UAVs. Modern warfare is heavily dependent on unmanned systems. This system is designed to detect them and provide targeting informations for them. The field of view for each sensor is only 120 degrees, but they have multiple sensors in various directions, providing 360 degree coverage up to a 25 degree elevation. Here's the Altis Communications ESM. Basically, electronic support measurement and communications intelligence system. Operates at 500 megahertz, has an accuracy of just over 1 degree. So whenever there's data link communicating out there and it detects it, you'll get a bearing and a half. So Altis uses upgraded digital technologies and more intuitive interface. The interfaces of these have really come a long way to where you can minimize the training of a sailor past boot camp to just an orientation course, essentially. Stick him on board the boat. And after a couple of watches using it, he would be familiar enough to operate this system, which is very different than the way it used to be. And this is something that can't be overstated. Training competent communication ESM technicians used to take more than a year to help understand the theory and how all the side lobes and frequencies work, on top of all the other encryption training that they need. All of that is done in the computer now. So you can take a sailor and train him on the ship and he'll just get better. And that's a huge step forward, not having to spend a year or more on a sailor before he becomes proficient. So here's the Thales RESM. This is the radio or radar ESM. This is good for ELINT, recording and measuring radar pulses and, different modes that radars are in. You can tell a lot about what an airplane or whatever radar platform is doing by what mode the radar is in, whether it's in track, scan, search, high update rate, high PRF. Tells you a lot about a target, and that's what this thing does. It listens to all that. Operates from all the way down at the 0.5 gigahertz to the 18 gigahertz mode, very wide band. Is able to detect LPI, which is huge. LPI is when someone's doing less than a millisecond pulse, and they're just trying to sneakily transmit radar and turn it off again in under a millisecond. And that is very hard to detect. Well, this is designed to be that sensitive. So performance is negative 60 decibels with wideband processing, which is pretty incredible. I don't have anything good to compare that to, but just know that it's extremely sensitive. So even if that LPI, that very short pulse length, is very low power, it's likely to detect it anyway. Yeah. This thing I OC'd in 2003, by the way. My point is, it's had 20 years to get better, and it has. All right, here's the Talos XCESM again. Okay, yeah, so this is for communication. This provides comment, radar ESM, early warning capabilities, things like that. Can record audio and signal transmissions 24/7. This is just essentially a detection antenna for most things, UHF, VHF, and high-frequency communications, all the way up to 30 megahertz. All right, here's the Net Tuna 4100 ECM. This is the Naval Electronic Countermeasure System, fully integrated into that combat system that I told you about that communicates or links everything together, allowing radars to hand off targets to other radars. Well, this links the ESM and CESM as well. This has 360-degree coverage, has an elevation of 50 degrees, and can track in excess of 100 targets, IOC'd in 2010. Here's the CAPTAS 4 sonar. This thing is incredible. What a wonderful sonar system they've come up with here. So good that the United States is buying this system from Talos Underwater Systems. It is low frequency, obviously variable depth, so they can change at what depth it transmits at, which is key. It has 4 wideband and a free flood transmitter rings. That yellow portion helps with its depth control, maintaining depth and changing depth. That's what that part is. The number of beams is 280. It also has torpedo warning and torpedo alarms on it, and it's roll stabilized. And that is the big thing that this system does that the American system that ended up being canceled did not, is we could not roll stabilize ours, which is extremely important whenever you're talking about beam forming and getting accurate bearings and stuff. This is very stable, and even as it's moved around, the system compensates for it, which is what the roll stabilization is. So this does work in continuous wave, frequency modulation, and combination of that. What that means is CW is the ping that you hear in the movies from like World War II, just out there pinging. FM sounds like musical tones. Well, it slides. It's imagine a harp going through its entire keys, all the keys. Frequency modulation just means that it's changing frequency over time. So it's a slope up, a slope down, and then they can combine the two. CWFM, very common. And there's different advantages to each of those, and that's beyond the scope of this. Just know that this system can do all the sonar things, which is why it's so good. And it's not that big. You could put this on a frigate, which means it will fit on everything else. So frequency response is 1 kilohertz to 4 kilohertz. Range scales, all right, it's 71 nautical miles, but that's going to depend, obviously, on the environment. And I assure you their range scale is actually longer than that. But that's what we're putting out for public consumption, is 71 nautical miles on this thing. Here is the hull-mounted sonar. This is the underwater system. It's on the bow. There is a small bow dome, and this is for long-range area surveillance. 4.6 kilohertz to 6.1 medium frequency transmission. Basically just a very loud ping centered around 5 to 5.5 kilohertz. Number of channels is 48. That's kind of important, so we can do multi-track. And it is an active and passive system. These systems, passive mode, pretty useless because of the flow noise over the bow. This thing is mounted right on the bow. It's like a little chin. And the system IOC'd in 2001. It's important to have this, but really the VDS is the star of the sonar show for this here. All right, let's talk about Astra 1530. These are the short and medium long-range surface-to-air missiles. The Astra 15, the Astra 30 have the same components in terms of warhead and stuff. The big difference is the Astra 30 has a booster motor, like you see here in the picture, that gives it additional boost speed equaling range. So the Astra 15 has a range of 30 kilometers and a ceiling of only 14,000, whereas the Astra 30, because of that booster, can go Mach 4.5 and reach out to 120 kilometers and 22,000 meters. And just knock anything out of the air there. So 14,000 meters for Astra 15, 22,000 meters for Astra 30. These are very good combat tested and proven surface-to-air missiles. They can take anything out from a drone to a anti-ship ballistic missile and hit it with confidence. You don't need to fire, multiple of these. One-on-one will do you. We've seen this recently in the Red Sea, that performance. All right, Scalp naval missile. This thing has been used in Ukraine against the Russian Navy in their ports in Sevastopol and other places as well. This is a subsonic cruise missile. It's fired from the A-70 Silver VLS. That's the one right behind the VLS that's shooting the Astra surface-to-air missile. It does have internal and intercom guidance, electric-optical terminal homing, Of course, at the end, max range is 1,000 kilometers, about 540 nautical miles. 300 kilogram warhead with a penetrating and blast fragmentation phases. So a complex warhead, to say the least. It is turbojet propelled, and it is subsonic at 0.9. IOC'd in 2015 and has seen action in the Ukraine-Russian war in the Black Sea. All right, the Exocet MM40 Block 3 Charlie. This is manufactured by MBDA, which is the primary manufacturer for many of the systems we're talking about today. This is the most sophisticated recent update of the Exocet missile family. It does have digital radar with a coherent radar processor, high-speed, high-fidelity processor for a digital radar that is digitally steered, so it's not mechanical. It weighs about 780 kilograms. 160 kilograms of that is the warhead itself that has both impact and proximity fused, and it can be shot at targets as close as 3.7 kilometers, which is important when you're in close engagement, or it has the ability to fly out over 200 kilometers and still hit a target with its INS GPS guidance system, its active radar terminal guidance system, and it is solid fueled propelled. This delivery of this version is 2023. All right, 76 millimeter rapid gun on the bow. This one's manufactured by Leonardo. It's on many ships. A lot of NATO ships have this as well because it's lightweight, it's reliable, rapid fire. You get a good bang for your buck, quite literally, for this. 120 rounds per minute, can shoot up 85 degrees and down towards the water 15 degrees. There's 80 rounds in the mount and has a 16 kilometer surface target engagement range. It does have a special round that's like a flechette or shotgun round that is accurate out to 8 kilometers for air targets. That would be great for drones and UA systems, unmanned aerial systems. Here's the Narwhal. This is the remote weapon system that they have above the hangar, port and starboard sides. This is a 20 millimeter gun. Elevation can go up to 70 degrees and down to negative 20 to shoot those close-in unmanned drones that are coming at it. Can traverse 360 degrees, but obviously the hull will get in the way of part of that. Can shoot 800 rounds per minute and has a muzzle velocity of 3,400 feet per second. Pretty high muzzle velocity, which means when you shoot, it's going to hit the target pretty damn fast. Which makes it more accurate. That's why that's important. Muzzle velocity increases accuracy because there's less time for the round to go wrong. You don't need to lead as much. Effective range is 1,500 meters. So like a close-in weapon system. All right, we have the MU-90 lightweight torpedo developed by Eurotorp. This thing will punch a hole in a submarine in a heartbeat if it catches up to you. I want you to notice the picture on the right, the top one. Look at how it is gas propelled, gas ejected off the ship. You can't even see the launcher because it's completely hidden by the hull of the ship. And that's to keep maintain the stealthiness of the ship. The big door that's open has nothing to do with this torpedo launch, by the way. That is for small boat deployment and recovery. Completely different from the torpedo. They could launch this torpedo by opening up the small door that has a little puff of white gas coming out of it and then close that door right back again. This torpedo has a 50 kilogram warhead. It is a shaped 350 shaped charged impact fuse acoustic homing electric torpedo, which means it gets up to speed quickly, which is 26 meters per second, and has a range of 12 kilometers, or you could reduce the speed and it could search out to about 25 kilometers at minimum speed. This one's the NH-90 or NH-90. Has a max speed of 162 knots, has an endurance range of 621 nautical miles with a surface ceiling of just under 14,000 feet. The Talos ENR surveillance radars on board. It does have a dipping sonar, which is why you would want this one. If you're in your ASW role, you're going to want to have the NH-90 on board. Can carry 2 MU-90 torpedoes or anti-ship missiles. This I was in 2006. All right, the French version of this Frem here is really good. They have weapons stem to stern. I'm really impressed with this. They have 8 total frigates, not counting the ones that they've exported. 6 of those are the ASM versions. The two freighter versions are the more modern FREMS. All these ships are built by Naval Group in France, for France. Remember, Italy's building their own version. France is building this version because this is the French Navy one. These frigates are ASW capable, anti-surface capable, and have deep strike capability with that Scalp missile, that long-range cruise missile that has been proven to work quite well in the ongoing Ukraine-Russia war is on board this. Main propulsion system is combined diesel, electric, and gas. Uses that LM2500 and 4 diesel generators. The Aquitaine-class frigate has extensive sensor capabilities, as we've said. Everything from communication ESM to radar ESM. It can also record and process all those signals, which is very important to understand. It's not just out there listening, it's understanding what's going on in the electromagnetic spectrum around the ship. So it's very good at data collection. And it is the backbone of the French Navy's surface fleet. This has been the French FREM Aquitaine ship. Thanks for listening, everybody. Bye. Welcome to the Atago-class destroyer ship brief. This is the anti-air platform of the 3 destroyers the Japanese Maritime Self-Defense Force operates. They currently have 2 Atago destroyers in their fleet. Both are made by Mitsubishi Heavy Industry in Nagasaki. And this is simply a modified version of the Congo-class destroyer. And its primary purpose is air defense, including ballistic missile intercept. But it also has 8 surface-to-surface missiles of the Harpoon variety, also called SM-2 or Type 90, which is a Japanese version of the Harpoon. Very similar in capability, as you will see today. They have 64 VLS forward on the bow and 32 VLS for a total of 96. The 32 is above the helicopter hangar back aft. From those VLS, they can shoot a combination of SM-3 missiles that are the ballistic missile interceptors, the SM-2MR, long-range anti-air, and the RUM-139, which is the vertically launched torpedo. These have been in service since 2007. Here we have a great view and breakdown of the weapon systems on the Atago. On the bow, we have the Mark 45 Mod 4 5-inch gun, and right behind that is the 64 cell Mark 41 VLS, with the SM-2s, 3s, and ASROCs loaded. The Mark 15 Phalanx Block 1 Bravo Sea-Wiz is mounted elevated, but just in front of the bridge. On the waist, amidship, we have the HOS 302 torpedo launchers. Those shoot the Mark 46 Mod 5 torpedoes. Also amidships, but just aft of the torpedo launchers, are the surface-to-surface missile launchers with the Harpoons or the Type 90-17s loaded. Behind the stacks, aft and above the helicopter hangars, is the 32-cell Mark 41 VLS that shoot the SM-2, SM-3, and the vertically launched torpedo ASROC. Protecting that is another Mark 15 Phalanx Block 1 Bravo close-in weapon system. Switching to the sensors now, we have a wide variety of very capable sensors, as you would expect with any Aegis-based destroyer. Beginning at the top mast, we have the OPS-28E Surface Search Radar. Supporting that is the SPG-62 Fire Control Radars. Those radar dishes are required to guide the SM-2 missiles onto target. The NOLQ-2 Bravo ESM system is a very high quality and capable recording and receiving radar system, but it also has some jamming capability that we'll get into when we talk about that in just a few minutes. Below that, mounted on the superstructure, are the Spy-1D air search volumetric fire control radars that are connected with the Aegis system, and those will assist in targeting hundreds of targets and engaging them simultaneously. It's a very capable radar system. The SQS-53 Charlie sonar is mounted on the hull forward of the VLS. Made in Japan, the Mitsubishi Industry in Nagasaki builds both of these. Here you can see one under construction. Both of these are in service now, so this is an older picture, but this gives you an idea of where on the island of Japan these are made. The Atago-class destroyer by the numbers. So this is a co-GAG system. That's combined gas turbine and gas turbine. There's a total of 4 GE LM2500 turbines that turn 2 shafts, just like the American Aegis-class destroyers. This is very similar in build, capability, speed, operation. It's essentially their copy of it. It displaces about 10,000 tons. It has 541 feet length, almost 69 feet wide or beam, and drafts about 20 feet. She is capable of doing 30 knots and has 96 VLS cells, like we said, that shoot the SM-3, SM-2, and the Mark 46 in a vertical ASROC payload. She has 2 triple torpedo mounts. One of those is port, one is starboard. She has the Mark 45 Mod 4 5-inch gun on the bow. And for close-in weapon systems, they use the Phalanx. The Spy-1D air search and volumetric search radar is mounted on the superstructure. The OPS-28E is the surface search radar component. There are 3 SPG-62A fire control radars for directing the SM-2 surface-to-air missiles. NOLQ-2 Bravo is the electronic support measure system for recording electronic emissions and analyzing and classifying them as well. The SQS-53C Charlie sonar system is a very capable hull-mounted sonar system, and that she employs that. The Lockheed Martin Aegis Baseline 9 is the Aegis version that this build uses. The Mark 99 MFCS is a fire control system, and the Mark 36 Serbach decoy launchers are used for chaff flare combination, including torpedo decoys now as well. She has the USC-42 satellite communication system, and she can carry 2 SH-60J or K helicopters. Here's the LM2500 gas turbine manufactured by IHI General Electric. This is a partnership between GE and IHI. It's derived from the GE military TF-39 and the commercial CF-6 high bypass turbofan aircraft engines. It's essentially containerized and then mounted in the ship to provide power for the ship, including driving the ship through the water. It turns 2 shafts and has axial flow and is a simple cycle turbine engine. Very efficient. Outputs about 33,600 shaft horsepower. You may also see this as 25,000 kilowatts is its rating. It spins at 3,600 RPM and makes that energy from that. Weighs less than 5 tons. So power to weight ratio, fantastic. The Spy-1D radar. This is the heart of the Aegis system, and this is an anti-air destroyer. So this is very important to this ship. Manufactured by Lockheed Martin, but parts are made by Raytheon, and Computer Science Corporation makes the software, all working together to make this one of the most capable radars in the world. It is a 3D multifunction search, detect, track, and identify, and also engage air targets, including missiles. It's a component of the Aegis system, like I said, and operates in the 2 to 4 gigahertz range. Its public range is 89 nautical miles, and it has 360 azimuth coverage with 4 plates facing at 90 degrees apart from each other. Average power is only 64 kilowatts, but peak power can be as much as 4,000 kilowatts. That is generating an enormous amount of energy projecting out in a direction. And it can guide the SM-2 and ESSM surface-to-air missiles. ESSM, something I haven't mentioned yet, is a vertically launched quad-pack, very short-range surface-to-air missile typically used for self-defense against incoming close airborne targets. And this radar is deployed on over 130 ships around the world. IOC 1986 and has continuously improved. The current baseline version is baseline 9. SPG-62 fire control radar supports directing missiles onto target once they're in flight. That's the purpose of these dishes. Manufactured by Raytheon, this is a continuous wave, 3-dimensional illuminator. Operates in the 8 to 12 gigahertz, has a 72 degrees coverage, and they have 3 of these, so they have full coverage, and associated primarily with the SM-2 missile guidance. Projects about 10 kilowatts. The OPS-28E surface search radar is made by Japanese Radio. It's a low altitude surface search radar, uses pulse Doppler in the C band. The traveling wave tube, which is the long rectangle shaped thing, gives 360 degrees coverage because it spins out there. And this IOC'd all the way back in 1990. This current version is from 2007. Like I said, these systems are always being modified and upgraded over time, generationally. The Mark 36 Serbach, which this is by BAE Systems, and it's a super rapid bloom offboard chaff system. They can also shoot combinations, which makes chaff and flare together. It presents false targets, false signals for incoming weapons. The Mark 137 launcher has 6 130 millimeter mortars and can launch 12 to 36 rounds depending on the load. And these are hand reloaded at sea by a sailor. NOLQ-2 Bravo R ESM for radar ESM. This is created by Mitsubishi Electric. It's integrated electronic warfare suite. Detects, classifies, analyzes all sorts of threat radars out there from the 2 to 18 gigahertz range. But this system also combines the Fujitsu OLT3 jammers. So even though this is an ESM system, it does have some ECM capability because of this additional equipment they've added to it. This Fujitsu OLT3. Acts as a decoy, can make the target hard for radars to pinpoint, causing the weapon to miss. That's kind of the idea behind that. And this is also responsible for operating the SRBOC 36 decoy launchers. So whenever this system is enabled, it will determine when is the most effective time to launch countermeasures. SQS-32 hull-mounted sonar, very popular, capable, efficient hull-mounted sonar system, operates around 3.5 kilohertz. The bandwidth goes all the way down to 1.4 and up to 4.0. 7 channels, active transmit, can process 4 bands at a time. Operating range is going to be out to just over 18,000 meters. And then in CW mode, which think of that as like really deep water mode, you can see all the way out to over 63,000 meters. And that's just a special mode that they can operate in. And it's really good for a hull-mounted sonar. That's why we keep this thing around. I IOC'd all the way back in 1975, which sounds ridiculous. Keep in mind, again, they're upgrading this, but the principle of hull-mounted sonar has not changed since 1975. Physics is physics, and water is water, and so is energy. And so all they can do is refine the beamforming, the equipment inside, make that better, but you don't need to reinvent the wheel, or the sonar system in this case, to make it better. So don't let the IOC date change your opinion about this. It's still a very powerful, capable, long-range, hull-mounted sonar system. The Type 9017 anti-ship cruise missile, developed by Mitsubishi Heavy Industry, also called SSM-2, and I'm seeing SSM-2 a lot now in media whenever they refer to this, so just know that that's the same missile. This is based on the Japanese Type 12 missile, which is the SM-1 Bravo. Again, we're doing generational capability leaps. Operational range is 150 kilometers. The warhead is 225 kilograms of high explosive semi-armor piercing, blast fragmentation. This is essentially a harpoon. I mean, I'm describing a harpoon for you right here with 0.9 Mach. The altitude is 5 to 6 meters off the water, but this one is made by Mitsubishi Heavy Industries. And it is INS guided, has active homing radar. It also has the IR seeker in the terminal phase. So, if they're jamming the radar, they can still home in on the IR signature of the target, if you can still see it. And this IOC'd in 2016. The SM-2 surface-to-air missile, manufactured by Raytheon. This is a fleet area air defense missile. It's designed to shoot down airplanes, helicopters, anything flying, essentially, including sea-skimming cruise missiles coming towards the target. Japan operates the Block 3 Alpha and 3 Bravo and 4, which is the RIM 156 Alpha. The length is 4 meters, except for the Block 4, which is 6.5 meters. Significantly bigger missile. The speed is Mach 3 and can reach out to about 92 nautical miles, except for the Block 4 can go all the way out to 200 nautical miles. It's a very capable long-range missile. And so, like I said, this Atago-class is an air defense destroyer, and it's really showing its capability right here. The warhead is 150 kilograms of high explosive blast fragmentation and is semi-active radar homing. That's why it requires the SPS 62 radar to illuminate the target for it. Here's the SM-3. This is the RIM 161 and its variants. These are anti-ballistic missile kill vehicles. This missile will go up and ram a dense object into a ballistic missile in flight, destroying it. That's how this works. So it's manufactured by Raytheon. Aegis-equipped ships can launch this because they have the right radar to target and then send the missile up to it. There's 3 variants, 1 Bravo and 2 Alpha, one Alpha as well. The SM-3-2 Alpha is being co-developed by US and Japan for being deployed on the Atagos and the American ships as well. Just a more advanced design. Like I said, it can do Mach 3. The range is over 1,200 kilometers, can reach an altitude of 200,000 meters because it needs to get up into the near-Earth orbit to shoot down ballistic missiles if they're at their apex of flight. And the warhead is a simple 32-kilogram kinetic shape that it will ram into a ballistic missile payload and destroy the payload. The payload would, at the speeds that we're operating at, it's just going to shatter the payload. Quite effective. Here's the Mark 15 Phalanx Block 1 Bravo close-in weapon system manufactured by Raytheon. It's based on the M61A2 Vulcan rotary cannon, shoots a 20 millimeter round. On board has just over 1,500 rounds ready to fire, can be reloaded at sea, but by hand. Muzzle velocity is over 1,000 meters per second. This thing shoots down close airborne targets within about 1.5 kilometers with rapid burst fire. Here's the Mark 45 Mod 2 127 millimeter gun, 5-inch gun essentially. Manufactured by BAE Systems. It's a medium caliber dual purpose gun. What this means is it can shoot surface targets and land targets as well as airborne targets with an airborne shell. Those are the different mods for it. It can traverse about 340 degrees, so almost to 360, but not quite. And it fires up to 20 rounds per minute. And depending on the mod that it has, it can shoot out to 36 kilometers for surface targets, and 15 kilometers is for any mod for air defense. So this is going to be very effective against slow-moving drones. You get a slow-moving drone within 15 kilometers of the ship, they load the special air defense round, which is essentially flak. Think of flak from World War II. And it has a high probability of kill inside that range. Here's the Mark 45 Mod 5 torpedo made by Raytheon. Surface ship and air launched as well. It's a deep diving, high speed, lightweight, anti-submarine torpedo. This thing has been modified over and over again over the years. It's pretty capable. Range is about 10 kilometers, maybe 11 kilometers. The depth that goes down to 450 meters, which is deeper than any military submarine is going to be diving. So you're not going to outdive this weapon. Your best chance really, because its max speed is limited to 45 knots, is to hope that you have enough of a head start to outrun it. Get outside that 11 kilometer range is your most effective evasion against this thing if it finds you. The guidance is active and passive acoustic. So the nice thing about passive acoustic is the target may not realize, one, that there's even a torpedo out there because it's not pinging. And if it does realize the torpedo is running out there, this torpedo can track a target without using its active sonar. It can just home in on it. And then whenever it feels it needs to, it will use its active sonar. But if it can destroy a target without it, it'll try. And it's pretty good. Here's a Type 7 VLA manufactured by Mitsubishi Heavy Industries, vertically launched anti-submarine rocket. The RUR-5 rocket is attached to the bottom of a Mark 46 lightweight torpedo. And then it just drops this into anywhere in the water within about 30 kilometers. And the weapon can swim from there and search for submarines. It's a very nice standoff ASW weapon. The other excellent ASW weapon they have is this SH-60K Seahawk helicopter. Now, this is a multifunction helicopter, but primary role is anti-submarine warfare. It does have a surface search radar. Operating speed is about 140 knots. Ceiling is about 13,500 feet. And operational range would be 600 miles if it's ferrying. You normally measure helicopter endurance in time, but that greatly depends on if it's hovering or if it's transiting, also the payload weight. But if you had an idea, if you just put a 600-mile circle around the ship, the helicopter could go out to that and come back. The sensors, it has the APS-124 surface search radar, the AQS-18 dipping sonar, the HLR-108 ESM, sonar buoys, and some ECM capability that they don't go into detail about. She can carry up to 2 Mark 46 torpedoes or depth bombs. She can carry Hellfire anti-surface missiles or air-to-surface missiles instead of the torpedoes. So multifunction role. You can see in the picture we have for you, there's a magnetic anomaly detector. That's the red and yellow cone-shaped thing on the starboard side winglet. And they'll drag that out behind them as they fly over the water, looking for any kind of big metal things in the water, which might be a submarine. That's what that detects. All right, final thoughts. The Atago-class destroyer is a very good destroyer, very good at air defense, as it's designed to be. And with that anti-ballistic missile capability, it has a very high demand role for Japan because their neighbor to the west, North Korea, loves to shoot ballistic missiles into the Sea of Japan. Sometimes they go over Japan itself, which is very provocative with their ballistic missiles. And so this is designed to prevent that from happening and prevent, obviously, a ballistic missile attack from happening from their Korean neighbors to the west. 2 of these are in service. I don't believe there's any intention to build any more of them because, again, this is one of 3 destroyers that they use that we're talking about in this series. So along with the Maya-class and the Bergamini-class, the Atago-class is a good deterrent, and it's a good multi-role destroyer. Looking for submarines. It has an anti-ship and surface attack capability, but its primary mission, if you had 1 Maya, 1 Megami, and 1 Atago, the Atago would be responsible for air defense. All right, and that's been the Atago-class ship brief, everybody. Thanks for listening, and we'll see you in the next one. Welcome to the Carlo Bergamini-class ship brief. This is the new Italian FREM multi-purpose frigate, and it looks pretty good. This is one of the 2 main classes of FREM that are being used. This is a joint venture by France and Italy. These frigates are the Italian version of what we're talking about. We'll have a whole different ship brief on the French versions. So there's 3 configurations that the Italians are using. There's general purpose, which is anti-ship, anti-land attack, and there's anti-submarine warfare version, and then there's a GP enhanced version, which combines general purpose land attack capability with some ASW functions. So we'll detail each one of these 3 different variants of the Bergamini-class or Bergamini-class Italian frigate. 2 of these ships were exported to Egypt, by the way. You should know that. Those were GPs that they bought over there. So this ship will shoot a 2x4 Tesso Mark II anti-ship missiles. That's 8 missiles total. Or with the ASW variant, it'll have a 1x4 launcher, so 4 missiles total for an ASW missile. An ASW missile, in short, is simply a missile with a torpedo in it instead of a conventional warhead. The missile will go to a predetermined point and then drop that torpedo with a parachute into the water. On the bow, it's going to have a 16 silver A50 VLS that shoots the Aster 30 long-range air defense missile. It has stealth design features engineered into it with a low radar cross-section. 8 of these ships have been commissioned are in service right now in the Italian Navy. 2 more are under construction. All right, let's go over the weapon systems. This is for the general purpose configuration. The Leonardo 127 millimeter lightweight naval gun is on the bow there. Right behind that, you see that rectangle of white boxes. That is the 16 silver VLS, A50 VLS system that shoots that long range Aster 30 surface to air missile. Moving back from the bow, we can see on the port side here, and there's one on the starboard as well, the 25 millimeter remote control weapon system. Behind that is the Tesso brand Mark II anti-ship missile. Moving back to the second mast now, on the port side, you see the slant torpedo decoy launcher. That's a decoy that will go into the water to prevent torpedoes from hitting the ship. And right next to that, moving aft, is the Selex Sklar decoy launcher. That's for anti-ship missiles. Launches chaff, flare, obscures the infrared signature of the ship, which is already pretty low. So those 2 launchers work side by side. One's for torpedo decoying and one is for anti-ship missile decoying. Finally, behind that is the aircraft hangar, can hold up to 2 helicopters that we'll talk about. On the roof is the Leonardo 76 by 62 millimeter Stralis naval gun. And this gun is special. And we'll talk about that when we get to the gun part. Let's talk about sensors. A lot of sensors on this ship. All the way up forward is the Selex RAN 30X radar. This is the primary radar for the ship in terms of 2-dimensional long-range air and surface detection. There is a better radar coming up, but just know that the 30X radar is very long range. Okay, the Selex NA-25X fire control radar, very short range, is used for directing the guns forward and the one above the helicopter hangar. Mounted on the port side there, right behind the bridge, is satellite communication antenna. Let's get to the first mast now. Working aft at the very top of the first mast is the Kronos multifunction ASA radar. And this would be like the primary newest radar of the class of the ship. This one is electronically steered. It's ASA. It's very high fidelity and it would be the primary radar for the ship. But the Selex 30X radar has very long range compared to this. Mounted right below that is an octagonal shape mount that the Kronos ASA radar sits on. That mount is actually an ESM and ECM used for monitoring other transmissions, whether it's radar or any other kind of electronic emission that might be coming out of another platform. Below that, and it's really hard to see, is the Selex SASS IRST, and that's an infrared surveillance system. We're going to talk about that in detail in a second. Let's move back to the second half of the ship. Look at the second mast. That's the Thales Altessa CESM, communication ESM, used for recording, information gathering, analyzing of radio and other communications data streams. Every Navy that's modern now is connected via some kind of data link network. Part of monitoring that network would be this CESM. Behind the mast, the second mast, is the second of 2 fire control radars. This is the Selex NA-25X fire control radar that controls the 76 millimeter gun mounted on top of the helicopter hangar. This is the same fire control radar system that is used on the bow, but know that there are 2, one on forward, one aft. Okay, let's move to the total number of ships built. These are all built by Fincantieri. They were initially laid down in 2008. The very first one was commissioned all the way back in 2013. And since then, they have commissioned 8 of these. There are 2 more under construction right now. And those are the GP Enhanced, where they combined some of the ASW features into the GP purpose of the ship. So you don't necessarily have an ASW dedicated platform anymore and an anti-ship land attack platform. You have 2 new ships that are not commissioned yet that can do both. All right, the Carlo Bergamini-class by the numbers. The prime mover here is called COD lag. That's combined diesel and gas. And it's 1 diesel turbine and 4 diesel generators working together. They don't all have to be on at the same time, obviously, but they can be. And that's a significant characteristic of this ship, is you can turn all these on and power everything and go very fast. It has 2 shafts that are both controllable pitch propellers and an auxiliary propeller that is retractable. They can deploy it if they need it, but it's used for auxiliary movement. It is 144 meters long and weighs or displaces 6,700 tons once fully loaded. All of that being pushed by that COD lag system can go up to 27 knots, probably 30, but 27 knots public. If they want to go for endurance, range, they want to get across the Atlantic or Pacific, it can move 6,000 nautical miles at 15 knots before needing to be refueled. And of course, these can be refueled at sea. Getting to the weapons, there are 2 launchers, 2 box launchers that have 4 missiles apiece that are anti-ship missiles. These are the Teseo Mark II anti-ship missiles. And that's for the general purpose and the general purpose enhanced edition. If it is the ASW variant, it does not have those. It will have instead 1 box launcher of 4 anti-submarine missiles. The bow VLS, the A50, is the same 16-cell silver A50 VLS on all variants. The Leonardo 27mm lightweight naval gun on the bow is only on the GP and GP Enhanced series of ships. The ASW series has a 76mm gun on the bow. So one of those on the bow, one of those above the helicopter hangar, and that's a significant difference. One of the reasons for that is the sonar system that's on the bow with all the equipment weighs a lot. So in order to compensate for that, they reduced the size of the gun and the magazine supporting the 127mm gun. They reduced that down to 76mm. There's also a 2x2 torpedo tube for MU-90 torpedoes. Those are lightweight torpedoes. And the helicopter hangar can support up to two helicopters. As far as sensors go, it has the Kronos multifunction ASA radar. It has 2 of the Celex 25X fire control radars, one for each of the guns. The Celex SAS IRST we're going to talk about in detail. The Thales Alta Communication ESM is for detecting and recording data link and voice and radio communication. Anything that links ships together and voice is recorded there. The SMQ-765 RESM, that's used for detecting radar signatures or some kind of detection, electromagnetic, transmission, and analyzing them too. This is not just recording and detection. This is picking them apart and figuring out how to best jam them if necessary. Below that, we have the Electronica Nettuno 4100 jammer, which would be used to jam said signals. The Salex RAN 30X radar is a very long-range, 2-dimensional radar. And then finally, for the ASW and the GP Enhanced version, they have a Thales UMS low-frequency hull-mounted sonar, which is a very good sonar. All right, let's begin with the engine room, the LM2500. If you're familiar at all with any ship briefs that we do, you know this engine very well because it is used in most modern navies. Even China made a copy of this and has their own version of it, sold from Ukraine. So a lot of modern naval ships use this GE military engine derived from the TF-39, which is also a CF-60 high-pass turbofan aircraft engine. It has 2 shafts, axial flow, simple cycle, easy to maintain, also easy to remove in and out of the ship, which is what makes it so good. It's perfectly fitted for naval propulsion. We're just producing power because these engines produce electricity that is then turned into either a hotel load or pushing the ship through the water. It makes 25,000 kilowatts, spinning at 3,600 RPM. This is the Kronos multifunction radar. This is active electronically scanned, or ASA radar, which means it doesn't have to physically move. It digitally steers the beams back, forth, up, down, left, right. And it does that in the 4 to 8 gigahertz range of frequency, very high frequency. It can see 162 nautical miles, very long range. 60 RPM, can track up to 30 targets at once, and it's probably more than that, but these are public numbers. It does have track on jam. This is a very interesting technology. It's been around, I think, since like the 60s, but it's gotten better. It's very good now, where if someone is jamming your radar signal, you can actually lock on to that and monitor it and get a good idea of where that transmission is coming from, down to about 4 degrees, depending on how low frequency the transmission is. It can be between 1 degree of accuracy and 4 degrees of accuracy. So even if you're trying to jam this, you're still giving your position away, essentially, is my point. It does have a solid state transmitter and has an elevation of up to nearly vertical. It's 85 degrees elevation and 360 degrees, of course, of scan. Now the Celex NA-25X fire control radar, these are used to control the guns. Each one can control up to 3 guns. So if they lose one, they can use the other to control everything if they need to. Operates in the X-band radar, as you would expect a fire control radar to operate. That's very high repetition, high scan rate, so that you get updates frequently on the target you're trying to hit. And so that's between 8 and 12 gigahertz. There's also a TV and infrared optical component to this, so you could track things visually if you needed to. There's a laser rangefinder, and it does have countermeasure and counter or anti-clutter measures. So when you're trying to jam this radar, it can still give its best guess as to your position and put fire on that target. This system IOC'd in the year 2000. All right, here's that RAN 30X radar. This is basically the Italian Navy's version of the American SPS 791. Again, it's an X-band radar up to 12 gigahertz. It does operate in 4 modes, and this is what I like about this radar. One, it's kind of old school, but in surveillance mode, it can operate or see up to 100 kilometers range all around. But then when you're close to shore, you can put it in navigation mode or helicopter control mode if you're doing an ASW pursuit, and it gives you a limited 40-kilometer range, but a much higher repetition, a clearer picture of what's around the ship. You could also set it into over the horizon mode, and you get greater than 200-kilometer range, but a much slower update rate. And in this way, it's really not as good as the Kronos radar, but it is it's multifunctional is what it is. And it can go into air defense mode too, which gives you a very low range of only 25 plus kilometers, but a very high update rate and a very clear picture of what's close to the ship inside 25 kilometers. I also did it in 2001. All right, so here's the Silent Acquisition and Surveillance System, the SASS. I love this system. This thing can passively detect, track, and target anything it can see, essentially, whether it's in the infrared band or visual, just literally seeing the shape of something. It can track it and then calculate its position three-dimensionally and put rounds on target. That's what this thing does. It's very good. It has it can track up to 100 targets simultaneously within its field of view, which is 360 degrees all the way around. And it's a very, very good system. That's the Salex SAS IRST, infrared surveillance system. Thales ALTC XC ESM. This is the communication ESM. This is on that second mast, the one that's behind the large radar mast on the bow or near the bow. This is a communication electronic support countermeasure system. It is used to monitor radars and early warning, provide early warning capability to anything that's out there. It has a wide and narrow band recording capability, so you could listen in as you record other communications. The frequencies here are off the scale. You can go all the way down to 30 hertz, which is extremely low. Like think of bass in your, in music or something, and then all the way up to like 30 gigahertz. So extremely wide band. And direction finding capability is what I was talking about earlier. It can see, depending on the frequency that it's monitoring, all the way down to 1.5 degrees of accuracy. And then if it's a little bit lower frequency, which would be RMS HF, that becomes about a 4-degree margin of error, but still gives you a good direction of where something's coming from. And this I also did in 2015. Let's talk about guns. The Leonardo 127 by 64 millimeter lightweight cannon. 127 is the millimeter, by the way. So this is an alternative to the Mark 45 family 127 naval gun. This one shoots 32 rounds per minute, but can also shoot the Volcano long-range round or the GLR, which is the guided long-range round. Muzzle velocity is like 82 meters per second. And it holds 56 rounds there in the turret. So if you kept her fed, she can go for a while. With the Volcano rounds, she can lob those things over 100 kilometers away. This would probably be used for some kind of land support, shooting land targets with this gun. Very long range. This IOC'd in 2019 with the Volcano ammunition. Now, the Leonardo 76. This is the smaller gun that's mounted above the helicopter hangar and in the ASW variant on the bow as well. The ASW gets 2 of these things. This is a super rapid firing 76 millimeter gun that's capable of close-in weapon system with the dart ammunition. This dart ammunition has a muzzle velocity of, listen to this, 1,100 meters per second. that is extremely fast. It's like shooting a laser beam. And because this dart ammunition is so fast, it is very good at point defense because it doesn't need to lead the target. It's point at the target goes away. The guided round can maneuver up to 40 Gs to compensate for any error that changes between the time it's shot and the moment immediately following when it hits its target. It has onboard radar air defense and guided dart rounds to onboard radar air defense will guide the dart rounds to the target. It can shoot, or it has 89 rounds ready to fire, and it can shoot 120 rounds per minute if you can keep it fed. Now the range here, obviously this is a high burning powder that pushes this thing. Its ballistic range is limited to 5 kilometers, so it is a point defense weapon. But know that anything within 5 kilometers is probably going to take a hit on round one cold barrel because of the velocity of this dart round. And the 76 millimeter gun is capable of firing the volcano round, just like the 127 is. And that range is 40 kilometers. And this has one aft for the general purpose and the GPE. Again, the ASW variant has 2 of these very capable guns. That dart ammunition is amazing. All right, the Oto Malera KBA 25 millimeter remote control weapon system. This is developed by Leonardo as well. And that's really important. And I'll probably go over this at the end as well, but just notice how many systems are connected to Leonardo. That's because this is an Italian ship doing its best to build everything indigenously. Even though this is a joint venture with France, they are trying to build everything else in-house. And they've succeeded with this. All right, so this 25 millimeter remote control weapon system can be controlled from inside the ship, shoots up to 650 rounds per minute at a 2 kilometer range, and has dual feeds of 126 rounds per box. Keep this thing fed, and it can just shoot for a while here. This is really good for small boats, if you're doing pirate activity, pirate patrols, or if you're trying to shoot that incoming USV like we're seeing in the Ukraine-Russia war right now. This gun is really good at eliminating those small, fast, maneuverable craft. The MU-90 lightweight torpedo, anti-submarine torpedo. This is a pretty rapid, a pretty fast little torpedo that can go out to 12 kilometers, relatively short range, at its max speed, or you can tone it down a little bit to, we'll say, a medium speed, and it can go out to 25 kilometers and just search for a submarine in that area. And that's almost like an area denial weapon whenever you use it like that, because this weapon, among many features, has a ceiling, which means it will not come above a certain depth, which means after you shoot the weapon, you could take your fleet and this ship and just drive into the area and know that this torpedo, even though it may see your ship, won't target it because it's only looking for submarines below a certain depth. So in that tactic, you can use it as an area denial against submarines, basically making a body of water 25 kilometers long, eventually, as the weapon gets out to that range, free of any submarines. A safe zone, if you will. It is acoustic homing and electric propulsion, which gives it its range and its speed. This IOC'd in 2008. Very common torpedo, by the way. We see the MU-90 a lot in all of the European navies. Here's the Aster 30 long-range surface-to-air missile. This is an impressive battle-tested now surface-to-air missile. The HMS Diamond, which is a Royal Navy ship, has been using this in the Red Sea at the time of this recording to shoot down drones coming out of Yemen. So this system is battle-tested now. It does have a range of over 100 kilometers. It has a max altitude of over 30 kilometers in altitude, which is very high. Max speed of 4.5 Mach. It is a radar seeker head that operates in the KU band and has the KA band for the second variant, which is a Block 1 NT. The PIF-PAF maneuvering technology combines aerodynamic design and thrusters on board the missile itself, the missile body, to increase its maneuverability in flight. So this is a very agile missile and long range. Two things that you want in a missile. Traditionally, if you had a long-range missile, you would often sacrifice maneuverability for that because it was much larger. Well, not this missile. You get both long range and high maneuverability, high accuracy, and it's battle tested. Aster 30. The Automat Block 4 anti-ship missile is made by MBDA, also named the Teso Mark II. You may have heard us call it that at the beginning of the lecture because it is also known by the name Teso. This is a subsonic missile. It has a 210 kilogram high explosive warhead, but it's designed to penetrate. It's a penetrating warhead, and it can penetrate up to 80 millimeters of steel. It does have an RF seeker. It is GPS guided and inertially guided. It does have a land attack capability, so you could shoot this at a fixed target and it would hit it. This I see it in 2007. Helicopters. Let's talk about the NH-90 MIT helicopter. MIT stands for Maritime Italian Tactical Transport. The MIT adds special forces support and other features to this ship. So if the ship was operating with their version of the Navy SEALs or Army Rangers, this would have the equipment on board to support them in the field. So not just transporting them to the battlefield. While they're in mission, it can stay near them and support them with communication and other things. Very capable tactical helicopter. It does also have the 360-degree surface search radar mounted right below the cockpit there that you can see. Its endurance is only 5 hours, which is comparable to the American Seahawk. It can carry 2 torpedoes, the MU-90s that we saw earlier, one on each side, or if it's in a surface attack role, it can take on the Marta Mark II medium-range anti-ship missiles. It does have door-mounted machine guns and a nose-mounted electro-optical system for surveillance. The second helicopter is the EH-101, and they may pair one of each with this ship because they have different capabilities. This helicopter has a max surface ceiling of 15,000 feet and a range of 540 nautical miles, slightly longer than the other one. Its endurance in the air is 7 hours, 2 hours longer. It has the same 360-degree search radar and is capable of transport of troops up to 25 or greater than 25, I should say. It has ASW roll capability and anti-surface ship roll capability. It can launch the same MU-90 torpedoes, carries up to 2, or 2 of the Marte Mark II medium-range anti-ship missiles. In addition to a troop-carrying capability, this one has the L3 HELRAS dipping sonar. So this would be great in anti-submarine warfare. The anti-submarine variant will almost certainly have one of their helicopters be this EH-101. In addition to all the other sensors, it does have a Star Sapphire forward-looking infrared as well as ESM capability and Marconi decoys. All right, final thoughts. This is a great ship. Italy did 2 things that were really smart here. One, this is almost entirely an Italian systems-based ship. Even though they designed it with the French, and the French will have their own version, this Italian version uses a lot of in-house technology, so they're not depending on anybody in time of war for parts. They're going to make the parts themselves. They were also very wise in combining the roles of anti-submarine warfare and general-purpose land attack into one ship instead of making them 2 separate ships. So we're going to have 4 anti-submarine warfare's variants have already been commissioned. 6 general-purpose land attack versions are being built, and 2 of those are going to combine ASW with general purpose. Very well done. Very good system. I'm also highly impressed with that 76 millimeter gun that can shoot the dart ammunition. That is kind of a game changer because for ballistic point defense, CIWS systems have typically relied on 20 and 30 millimeter high firing rounds or gun systems, which are extremely inefficient but effective. With this dart ammunition, you don't use nearly as many rounds and you can get kills on round 1 cold barrel. That's something that you're not going to get on the traditional CIWS 20 millimeter systems. Very impressive system. Combining the ASW and GP together was really good, but they've gone a step further here, and this will be a different lecture. The FREM EVO configuration is the next generation after the GP enhanced version. And I'm excited to see what Italy and France has done with that ship. But that's going to be its own lecture coming up. So, like I said, these ships have a high ratio of Italian manufactured equipment on board. So whenever they go to war, they don't need to depend on anybody else for parts. And Leonardo is the primary contributor to that. MBDA is the other company that supplies a lot of the systems for this as well. And it is a very good Italian ship. All right. Thanks for listening, everybody. Have a good one. Welcome to the Chiang Frigate Ship Brief. This is the backbone of Taiwan's anti-submarine warfare operation, this series of frigates. This is a series of 8 that the United States sold to Taiwan after the Soviet Union collapsed in the early 1990s. 5 of the 8 remain in service. They do have some limited anti-air and anti-ship capabilities, but they are primarily a anti-submarine patrol vessel, patrol frigate at this point. The SPS-40 radar was replaced by the DAOA, and the SPG-53 is now replaced by the separate target illuminating radar called the STIR, also called the SPG-60 in the United States Navy. And they have 10 standard SM-1 medium-range missiles on top of the helicopter hangar in a very unique configuration that is not common on any other vessel. We'll take a close look at those and their capabilities. It does have the Mark 42 127 millimeter naval gun on the bow and a Mark 15 phalanx on the stern. She does have additional Mark 46 torpedo launchers port and starboard, but can shoot the Mark 46 torpedo mounted on an ASROC rocket called the RUR-5 in a turreted cell launcher on the bow that can also shoot the Harpoon missile as well. And we'll break that specific turret down for you so that you understand how that works. This ship will be replaced by ships that are already under construction in Taiwan called the Taiwanese Light Frigate. Those will come into service as early as 2026 and will continue to be built through the rest of this decade. All right, let's talk about the weapons and countermeasures on board this ship. She has the Mark 42 127 millimeter, that's a 5-inch naval gun on the bow. Pretty standard armament for ships of this era. This ship originally was a Knox-class frigate, if it looks familiar to you, that served in the U.S. Navy for years in the 1970s before becoming part of the Taiwanese Navy. So that's why this looks like an American ship, because it was. The Mark 16 missile launcher, it's also called the ASROC launcher, shoots the RUR-5 ASROC or the Harpoon. And it's got 8 cells that it can do either one of those 2 missiles. The Mark 36 Serbach is a chaff and decoy launcher that works with the electronic warfare system. The SM-1MR SAM system, there are the box launchers canted at approximately a 45-degree angle, pointing port and starboard and forward at angles. Those shoot surface-to-air missiles. And then on the aft end, you see the Mark 15 Phalanx 20 millimeter Sea Whiz. We have the ANSQS-26 bow-mounted sonar. It's under the waterline. You can't see it. A very powerful but old sonar system. Up on top of the bridge there, we have a couple radars. We have the Steer fire control radar. And on top of the mast, we have the SPS-10 radar and the DA-08 radar. Those are surface and air search radars, respectively. Just below them, but near the mast, are the SLQ-32 electronic warfare systems. These have not been upgraded. It is the original SLQ-32 electronic warfare suite. And then on the rear end, we have the SQR-35 variable depth sonar system, along with an SQR-18 passive towed sonar array. So that's really what makes this primarily an anti-submarine warfare ship, are those 2 arrays. While the bow-mounted sonar system is great in active and passive mode, these 2 systems being towed by this ship are real modern submarine detection systems. So this is primarily an ASW frigate. The 5 that are remaining in service are named here. They were commissioned between 1992 and 1998 and continue to serve to this day. All right, let's go with Chiang Class frigates by the numbers. They have 2 steam boiler turbine propulsion systems that spin a Westinghouse turbine gearbox that is connected to one shaft. That shaft has a controllable pitch propeller on it that pushes the ship through the water at 28 knots. It can go 4,000 nautical miles in a straight line at 22 knots. Its optimal speed, should it choose to. That's called its endurance range before it needs to be refueled. The Mark 16 ASROC harpoon launcher is that 8-cell turreted launcher that's on the bow behind the main gun. It shoots the SM-1 medium-range surface-to-air missile. It has 10 of those. The Mark 42 127mm naval gun is the 5-inch gun on the bow. And the Mark 15 phalanx system is a 20mm close-in weapon system, completely independent of any other radar or weapon system on board. CWIS can always operate independently as long as it has power. It shoots the Mark 46 torpedo as well. It can do that whether it's on RU-R5 ASROC rocket or be dropped from the helicopter or just be launched from one of the waste launchers. It can shoot the Mark 46 Mod 5 torpedo. The Signal DA-08 2D air surveillance radar is on the main mast that is paired with the SPS-10 2D surface search radar. Signal builds and supplies the separate targeting illuminating radar, the fire control radar above the bridge. Very close to that is the Marconi LN66, which is a relatively short range but highly precise navigation radar. It's essentially used not to collide with other ships or the shoreline. The Mark 36 Serbach is the chaff and flare decoy combination launcher that works hand in hand with the SLQ-32 electronic warfare suite that is used to protect the ship from attack through jamming radars and using the Mark 36 Serbach for defense. The SQR-35 towed sonar array is a variable depth sonar, and the SQS-26 bow-mounted sonar array is an active and passive hull-mounted sonar. It uses Link 16 to connect with the helicopter and other ships in the fleet. That's a very common data link system. Has the Mark 68 gun fire control system that is linking the steer fire control radar with the CIC and, of course, the main gun on the bow. And it has the FIST, the Frigate Integrated Ships Board Tactical System. That is essentially the system that connects all the radars with all the systems together as one, not just the gun fire control system. And it has one light helicopter. So the Westinghouse turbine, this is a steam turbine, generates 26 megawatts, very efficient. It's powered by steam boilers. This is very old school. This is very 1960s, even 70s technology. Taiwan did consider replacing this system with diesel engines, but decided not to because it would be too expensive and take too long to make those replacements. They instead took that money and time into designing a new light frigate that is being built now in Taiwan. Here's the DA-08 air surveillance radar. This is a two-dimensional air search radar, which means it gives you the bearing of a contact and its range. It does not give you altitude, which is kind of important in modern day warfare, but it's just a 2D radar. Its peak power is 145 kilowatts, and its rotation speed is 10 to 20 RPM up there physically spinning. Its instrumented range is just a little over 100 nautical miles. The SPS-10 radar, this is a 2D surface search radar. So this is for looking for those ships. Its max range is only 64 nautical miles. Its peak power is 190 kilowatts, and it operates in the G and H bands, the 4 to 8 gigahertz bands. This radar IOC'd all the way back in the 1950s and is still in operation today. Here's the steer fire control radar. That stands for Separate Target Illuminating Radar. In the United States Navy, we also call this the SPG-60. This is the fire control radar for the Mark 42 naval gun on the bow. In order for that gun to operate, it has to have this radar targeting information. So you point the radar at the target, illuminate it. It gets the range of the target that's on the surface, and then it also measures, speed and things like that, and calculates a ballistic trajectory with the fire control computer to then engage the gun and fuse the shell properly for when it should detonate. The system IOC to 1970. The LN-66 navigation radar, manufactured by BAE Systems Canada. It's a general surveillance radar, has a range of 20 nautical miles, operates in the 8 to 10 gigahertz band, and it's very precise, can detect even very small targets inside 20 nautical miles. It is primarily used for collision avoidance. You know, you're navigating through waters with other ships. There could be shoals, obviously a coastline. You don't want to hit those things. Those things will show up on this radar. That's what it's for. It's for navigating. IOC to the 1970s as well. Here's the Mark 42 naval gun. This is the older version of the one we use in the Navy now. Is 127 millimeter, 5-inch gun essentially. Shoots 28 to 40 rounds per minute depending on the mode that it's in. It does shoot a high explosive time-fused shell. You don't have to time fuse it, but you can. And the time fuse is done with the calculations made by the radar on how far the target is away. The Mark 16 launcher is a very early version of what became the VLS in the United States Navy. But before we had VLS, we had this 8-cell turreted launcher. This launcher can spin 360 degrees, and then each cell pairing, because there's 2 cells in each arm there, can lift up or rotate up at about a 60-degree angle up angle. And you see that here in this picture here. These are reloadable at sea. This is a big difference between the VLS we have today that cannot be reloaded at sea and this Mark 16 launcher that can be reloaded at sea. So what they do is they have either an RUR-5 ASROC torpedo in one of these that can be launched out, or a Harpoon missile. And there is a magazine on board with additional missiles. So as they expend missiles from these launchers, they can spin the turret to a specific direction, have the box rotate where it's completely vertical, and then they will hoist from the magazine that's below it a missile or an RUR-5 rocket with a torpedo on the front up into the cell itself. So while it does have 8, they can be reloaded. So they actually have a lot more than 8 missiles available to them. Modern day VLS systems in the United States Navy in 2025 cannot be reloaded at sea. That's the big difference here. But just know that they only shoot 2 types of missiles from this weapon. One is a torpedo on top of a rocket called the RUR-5 ASROC. And the second one is the RGM-84 Delta variant Harpoon. Here's the Mark 15 Phalanx close-in weapon system manufactured by General Dynamics. Just about every ship has a close-in weapon system like this. Obviously, all the American ships have usually multiple of these, and the ones that we sell to our friends like the Taiwanese have them as well. This one has one. It's on the stern. It's a Mark 61 Vulcan rotary cannon, very reliable. Shoots the 20 millimeter APDS round at 3,000 to 4,500 rounds per minute, depending on the mode that it's in. It only carries about 1,500 rounds on the magazine, but like the Mark 16 ASROC launcher, this can be reloaded at sea. It just takes a crew member and some time to get out there and do it. The effective range of this round is 3.6 kilometers, which is not bad for a 20 millimeter round. This is radar guided, and it also has electrical optical systems that you can see there on the left-hand side of the radar dome for guiding the gun onto target as well. This can be operated manually or in automatic modes. The SM-1 medium-range surface-to-air missile. These are canistered missiles that are mounted topside on the helicopter deck that we showed in previous pictures. They have 10 individual canisters. This missile has a range of 21.6 nautical miles and a ceiling of 24 kilometers. It reaches a max speed of 2.5 Mach along the way and carries a 115 kilogram high explosive fragmentation warhead. This is a semi-active radar guided missile. IOC to 1967. The RGM-84 Delta Harpoon is an anti-ship missile manufactured by Boeing for surface-to-surface attacks, also called the Block 1 Charlie. This is launched from the Mark 16 ASROC launcher and has a range of 124 kilometers. It's 221 kilogram HE warhead is designed to shred ships, hull and lagging, and then set it on fire. That's the secret behind the harpoon, is that it leaves behind it a fire that then does additional damage. So don't just look at the warhead size and calculate that as the effectiveness of it. It is this warhead that is designed to set the ship on fire as well. It is GPS guided and also internally guided. It has an active radar seeker for its terminal phase at the end of its run. While this missile did IOC in the 1970s, this variant is from 1985. The Mark 46 Mod 5 torpedo is a lightweight torpedo that is launched on board from either the turret on the front or the waist launchers port and starboard. The 232 kilogram weight is the total weight of the weapon itself. It does run on liquid propellant, autofuel 2, has a range of 11 kilometers, and has a speed of 40 plus knots is the public number. It is both active and passively homing, and this IOC'd in 1971. It is a very good weapon of its time, but this has been superseded by not just very new mods, but new weapons like the Mark 50, Mark 54. But the Taiwanese Navy still shoot the Mark 46 Mod 5. All right, so final thoughts on the Chiang frigate is this frigate was strictly an ASW frigate and would be a real vulnerability or very susceptible to air attack until they installed the SM-1MR missiles on top of the helicopter hangar. That was a big upgrade. So that was very important that they did that. They added 10. I'm sure if they had more room, they would add more, but they had room for 10, so they added 10 to it. So this does have some self-defense capability out to about 21 miles if they are attacked. Let's see, the frigates have been in service for longer than any other Knox-class frigate, because remember, this was a Knox-class frigate that IOC'd in the U.S. Navy or commissioned in the U.S. Navy in the 1970, 71 era. And so it's been in service since then. The United States Navy, and then transferred over in 1992 to 94, went all the way in 1998, and still in service in Taiwanese Navy. So that is some 50 years of service. These ships are getting old, which is why they're being replaced by the light frigate. The Taiwanese light frigate is being built now, like I said, and will be coming online between now and 2030. So these will be rotated out as those come on. One of the Achilles heels is the Yingling does lack modern sensors. They did upgrade the ASW system with that SQS-35 variable depth sonar, which was a very good upgrade, but she's still extremely limited in her role as anything else other than a submarine chaser because of her lack of sensors, lack of electronic warfare defense, leaves her vulnerable to attack, in my opinion, and she has very few weapons that can actually defend herself outside a range of 20 nautical miles. So the ship will be replaced. The light frigate has two variants that are coming up to replace it. There is an anti-air warfare, or AAW, variant. There's also an anti-submarine variant. Both will be commissioned to the Taiwanese Navy and replace these. So this is, for now, the backbone of the Taiwanese ASW fleet, and a very good ship of its time, but its time is past. Welcome to the Constellation-class FFG-62 ship brief. This is the newest American warship that is beginning construction this year. So we're going to do a ship brief now with all the design documents of what they promised us, how much it's expected to cost, and when the ship begins testing in 2026, about 4 years from now, we'll do another video, a follow-up, and see what we actually got and compare it to this one. All right, so let's get started with this sub-brief. First, my sources. This is an open source intelligence briefing, which means it's all public knowledge, unclassified. My sources are the Navy itself, Navy.mil. I also use the Congressional Research Services and budget offices for cost information, estimated cost, because they tend to be a little more reliable than what the Navy puts out. We'll talk about that in this lecture. BAE Systems and seaforces.org had great individual systems information and pictures, so we use them for that. WarriorMaven.com, fantastic website. He is the chief editor for nationalinterest.org as well. I recommend you check out both sites. He has a great article on this ship. And then Defense Today, Korea, and sociallinks.io, we got some graphics from, so credit to those websites for that. Our story begins in April 30th, 2020, when the DDC contract was awarded to Finacateri Marine Marriott, or Marriott Marine in Marriott, Wisconsin, was awarded the contract. The initial contract is for 10 ships, and it's a 1+9 optional, whereas they build one, and they're going to do some land testing before they build it, and then after it's built, test it again. And if everything's fine, they're going to go ahead and continue all the way up to 10 ships with this initial contract. Now, a extension on this contract of up to 20 ships is already going through the works and is going to be expected to be approved. So you may see some reports out there that we're going to initially build 20 ships. That will be true eventually, but not at the time of this recording. Okay, this is a blue water and littoral water warship. So this is a great replacement for the littoral combat ship. It has a lot more capability in terms of offense and defense than the LCS had. And it can do a lot of the shallow water missions that LCS was very good at. And it also has a blue roll capability. So it can be with the fleet, high speed, and perform that function. We're going to break down all the systems here, but this is a multi-role ship. Imagine it as a little bit smaller Arleigh Burke, because it's very capable. All right, so we went with the parent design approach for this. That means you start with a ship that's already built and functioning in another Navy, or even in our Navy, a parent ship, and then you change that ship, the hull of it, to fit your needs. So you already have a lot of the systems already tested. You don't need to create the wheel again. We're using the FREM frigate as a baseline for this, and we're going to make some minor changes to it, like lengthening the hull to 496 feet from its original length, and increasing the displacement to up to 7,300 tons approximately. And that's going to depend on if all these systems that we're going to talk about today get installed. They've added a lot to this little ship, which is, after the LCS, is a great choice. Okay, so here were the Navy requirements whenever people were making their bids for this design that Finacateri eventually won. They want the Enterprise Air Surveillance Radar installed. So that's the miniaturized version of the Spy 6. They come in 2x2 blocks, like we'll talk about. We're going to break all these systems down for you, so don't worry if you don't understand these right away. Baseline 10 Aegis combat system is our most capable combat system. It fits on board this ship, and it's pretty incredible. It's going to have the Mark 41 VLS on the bow, like you see there. It's going to carry 32 vertical launch missiles. There was a proposal to increase this to 48 missiles, so you may see 48 in other future lectures as well, but right now that's not approved. It's 32. Amidships, the box launchers topside are for the Naval Strike Missile. 4 box launchers of 4 missiles apiece, facing port and starboard. On the aft superstructure topside, you see the 21-cell rolling airframe missile launcher, holds 21 missiles. It's only about a 5-mile range. It's more like for point defense or fleet defense than anything else of incoming air, whether it's missile or helicopter or airplane. And then the Mark 110 57mm gun on the bow. Very reliable. It's been used for years gun. That's really the hallmark of this ship, is they're taking systems that have already been in service for a long time and putting them on here. There's no new systems on Hull 1. You know, we're learning the lessons of new technologies on new ships and just making sure that we don't put anything new on this ship. Everything's already been built and is already in use. The Hilo or Seahawk capable helideck is on the back. We also have a rib boat mission module, as you can see there. And it will have a towed array. I believe I know the towed array, but they didn't make it public. So whenever they do, we'll talk about what that is. And the electronic and information warfare suite. This ship does have an information warfare role, and that is highly sensitive. It is not public, so we will not talk about that at all. And of course, it does have comms and countermeasures. Countermeasures being chaff and flare, and of course, electronic warfare, like we mentioned. All right, so the Enterprise Air Search Radar, or ESAR, combined with the Baseline 10 Aegis combat system, is a 1-2 punch for surveillance and, counter detection of other targets, whether it's, a surface contact or an air contact. This radar is very accurate, has a high fidelity rate. It's ease of use and integration for the operator. It's our top of the line, and it looks great. So this is what they're putting on the ship here. The module blocks are in 2x2 foot sections, and this one's going to have a row of 3x3 for a total of 9 mounted on the ship there. And it's got 360-degree coverage. It can engage multiple targets at the same time, whether they're coming from space like a ballistic missile or if it's engaging a ship simultaneously. Yeah, very capable. Here's the Mark 41 VLS. Like I said, it's going to have 32 vertical launch missiles. It can shoot the Tomahawk missile, all the standard missiles, whether it's 2, 3, or 6. It's got a vertical launch anti-submarine rocket, which is basically an anti-submarine, can either be a bomb or an airdrop torpedo. And the evolved Sea Sparrow, which is a surface-to-air missile. The Naval Strike Missiles, again, one of the newest anti-ship missiles in the United States inventory. It will have a deck-mounted box launcher. It is sea-skimming, subsonic, goes about 100 miles, and has multiple ways of homing in on target, one of which is infrared homing, and it uses a proximity fuse. It does have stealth-like characteristics, but all of that specific information is not public, so we won't talk about it. 21 cell rolling launcher there. You can see the picture of it. This is installed on a lot of American ships already. Tested system, works very well. 21 shots. And it does radar homing and also tracks infrared too. And has dual use, can do both at the same time to make sure it doesn't miss its intended target. And on the right, you see there the Mark 110 57 millimeter gun. Commonly spoken, Bofors 57. And so you may hear that around. It's the same gun as that if you hear that. 220 rounds a minute, pretty rapid fire. Shells can go up to 9 miles. And it is radar targeted, but you can also take manual control and have your way with it. So the future small surface combatant force levels, the Navy eventually wants to build up to 60 small surface combatants. So they don't all have to be this particular frigate, but this frigate will take up a good chunk of the 40 to 60 goal that the Navy has of these SSCs by 2050. This will require increased production to greater than 2 a year, which means they're going to bring on a second shipbuilder. It could be and probably will be Astral USA, because they're currently building the other LCS class down there in Mobile, Alabama. That class is being decommissioned and discontinued. That opens up shipbuilding dry docks to build something different. So Austral has experience with small combat vessels. They have the availability, which is really important right now. So it looks like they're going to be the ones that get the contract, even though it's not approved yet. I would keep my eye on Astral USA. Other shipyards that already build really good warships for us is General Dynamics and Huntington Ingalls. So you could see them in the mix as well. There is talk that if they're going to build up to 8 a year, which is not the plan, but if they want to go that route, they will have to bring on a third shipyard. So my money is on Astral USA getting the second contract, and either General Dynamics or Huntington Ingalls getting a third if they go that route, depending on availability. And I'm talking about the availability of assembly buildings to build this, because that's really where we're limited. You know, we've got the money, we're willing to spend it. We've got the people, we've got the intent. We just need the dry docks and the assembly buildings to get these things going. And then there's a proposal out there in the Navy to go to a 2-crew system, and I really like this. This worked really well for our ballistic missile submarines. And what this means is you have a blue crew and a gold crew for one ship. And there's some downsides to that, but the really good upsides is that ship comes into port with a crew that's had it to sea for 5, 6 months, you know, however long, basically a whole deployment, could be 9, 10 months. And they come in and they're pretty exhausted. They do a crew turnover over a couple-day period, and they begin a refit process. That's where they do all the maintenance together as 2 crews, you know, helping each other. One crew doing like painting and shipping and taking care of the hull that our ships desperately need, and the crew that just took responsibility for the ship would be doing all the system maintenance and stuff, because they're going to be the ones operating the ship for the next, you know, 9, 10 months, however long the next deployment is. And then whenever that ship gets out of that refit period, whether it's 1 month or 3 months, and deploys again, you know, that's a quick turnaround versus having an older rotation where a ship would go to sea once every other year or once every 18 months. You're getting a ship to sea, back to sea in a couple-month period. That's a big benefit. It also gives the crew a break away from the ship so they can go into the classroom environment and the simulator environment and train and hone their skills and learn new qualifications that they then, when the ship comes back in 9, 10 months and they become the operational crew, they're still fresh and they have new skills, classroom, you know, textbook skills that they can bring on board the ship and employ. Those are the big benefits. A higher operation tempo, you get more sea time out of your ship, the crew is rested and ready, and the ships are better maintained because you have more people with more time doing it. The big downside to that is the manpower. You literally need 2 crews, twice as many people, officers and sailors. There are 2 captains, there are 2 cobs. It's complete two different crews. And so manning could be an issue preventing that. If you're going to build 40 to 60 of these, that's 80 to 120 crews. That's a lot of people. So we'll see if they actually go that route. It works for the ballistic missile submarines, but we only have a couple, just over a dozen of those, right? And we're downsizing that actually with the Columbia-class. Okay, so let's talk about procurement costs real quick. Like I said, no new technologies, no new systems. There is very little risk, or it's decreased the risk of something going wrong with the systems because of that. In 2020, the very first hull was funded. The Navy said it would take about $1.3 billion to get Hull 1 built. Congress, accepted that on face value. And then the next year comes along, and they're saying because of the lessons learned, or we're going to learn on Hull 1, the next 2 hulls will be a little bit cheaper, mostly in manpower savings, because we're going to get better at building these ships. And that's reasonable. That history does, reflect that. But that's in 2021, Congress, learning from the LCS program, said, we're not going to accept even Hull 1 until you, project leader, do some land-based testing with these systems, working together. Even though these systems are already out in the fleet, we want to make sure that these things are working together on a land-based simulator or trainer, or in a war range, before we take the first one. And then that's when they approved the $1.1 billion for Hull 2. This year, 2022, they did fund another Constellation-class, and that will be $1.1 billion. These are all Navy numbers. The Navy thinks that's how much it's going to cost. So I go over to the Congressional Budget Office, and we'll see what they say after reviewing the Navy's requirements and the number of systems that are going to be on this ship. They believe, the CBO believes, the cost will actually be 17% to 56% higher than the $1.3 billion cost for Hull 1. And that's going to be averaged out over 10 hulls. So it's going to be that much higher for each hull. And so that's up to, $60 million in additional cost in 2021 dollars. They're using previous year dollars. Keep in mind, for 2022, we've had an inflation spike, which is going to drive this cost up even higher. Okay. And that also doesn't take into account year-to-year inflation. They went out 10 years using 2021 dollars. So obviously, this 17 to 56% is going to go up every year. All right, that's a lot of money that is not accounted for yet in the budget. So in April 2020, the contract was awarded for 10 ships, but the contract to Fincantieri was only $5.6 billion. That is approximately half what even the Navy said it was going to cost to build 10 ships. And this part confuses me. I cannot find an answer for this. So if anyone knows why the contract gives the shipyard half the cost, is it going to be, amortized over the next 10 years, the remaining cost? That's what I suspect may happen. If anyone knows, put it down in the comments for us, okay? And Congress's response is requiring land-based testing, like I said, to try and make sure the system actually works on day 1. But I don't know why the initial contract was for only half the expected cost. All right, so Captain Kevin Smith, he is the frigate program manager. He is the sole person responsible for making this program work. So if anything goes wrong, we know who to go to. And I wouldn't want to be Kevin right now. I hope he does a great job. I hope he's already got a great tool set. We're off on a good path. Everything looks good on paper, but so did the LCS. Okay, I remember that distinctly in the early 2000s. So hopefully they can get this ship. I wish Captain Kevin Smith all the luck in the world to make sure that this ship gets out of the dry dock and into testing with all the systems on board that we've talked about today. And it's his responsibility to do that. Something that they've added to the contract was a $5 million per ship warranty repair by the shipyard. But after some further investigation, I found that the Department of Defense, as a guideline, generally on all contracts, does not require any warranty repair work. But in this program, there is a $5 million warranty repair that the shipyard will pay for this $1.3 billion ship. So I guess they'll take care of minor repairs. After that, the Navy is on the hook for the rest. All right, so there it is, folks. This is our new FFG 62 class. the Constellation-class, a modified FREM frigate, and we'll see what they come up with in a couple of years. So we'll revisit this topic a few times. And we expect the ship cost to actually be anywhere from $1.1 billion on the low end for hulls 2 and 3, all the way up to $1.7 billion per ship on the high end. And we'll see what the cost actually comes out to. All right, this has been the Constellation Ship Brief. Thank you for watching. Take care, everybody. Bye. Welcome to the Aradi Ship Brief. My name is Aaron. We're going to talk about one of the newest ships in the African region. This one operates out of Algeria, which borders the Mediterranean Sea, and is one of the most modern, well-armed frigates in the region. It's a very good ship. Let's talk about the Aradi. So it's based on the Mako A200 ship design. AN stands for the Algerian variant of the Mako A200. And the first ship that has been named for the Algerian fleet is Aradi. Therefore, this is the Aradi-class. And that rolls off the tongue a lot easier than Mako A200 AN. So the proposal was to initially buy 4 of these. These are built in Germany, by the way. But for whatever reason, they've only bought 2 instead of 4. I assume that has everything to do with cost and not capability, because this is a great ship, but they are expensive. On board this ship is a very unique propulsion system that is becoming more and more popular, so it's not going to be unique for long. And we'll break that down whenever we get to it. As far as the weapons go, it has 16 Saab RBS anti-ship missiles that can reach out in excess of 300 kilometers and blow a ship apart with a 200-kilogram warhead. It is very capable in that sense. It also has 2 16-cell VLS surface-to-air missiles using the Umkhonto IR Block 2 SAMs, and those are good as well. It is stealth designed. It has an X-shaped hull and rudder that reduces the IR signature, and a very unique exhaust system that helps reduce infrared from the engine exhaust as well. The lead ship was commissioned in 2016, and it is the Aradi. Let's go. Let's talk about weapons. Starting in the bow, we have the Leonardo 127mm naval gun. Right behind that, port and starboard, we have 2 mass decoy launchers. Between the decoy launchers is the Block 2 surface-to-air missile VLS systems. Right behind that is the MSI 300M remote control weapon system. This is a Bushmaster 30mm cannon that is remotely operated. Behind that is the bridge where you can see all the sensors. We'll talk about those in a second. Behind the bridge, but before we get to the superstructure, there is a small area where we keep the anti-ship missiles. These are the Saab RBS-15 Mark IIIs. There are 4 batteries of 4 apiece. This carries a lot of anti-ship missiles for a frigate. And behind that, on top of the helicopter hangar, is an MSI 30mm remote control weapon system as well. So they have 30mm guns forward and aft, a large cannon on the bow with both surface-to-air missiles and anti-ship missiles in between. This is a firehouse of a weapons platform. Now let's talk about sensors. They did a great job putting on some very modern, capable sensors here, beginning at the top of the mast center line. In the very middle of the ship, the highest point on the ship, is the Indra Regal Communications and Radar ESM system. This is mounted as high as it is so it can detect signals from as far away as possible and bring those signals into the ship for the operators to process so they know who's out there. Without transmitting anything themselves, they just listen, and they can listen on communications and radar and even jamming ESM, other countermeasure systems, and classify them with this Indra Regal system. Just below that and a little bit forward above the bridge is called the Sea Giraffe ASA radar, and this is the same ASA radar that we use on our Freedom-class LCS. It's one of the highlights of our LCS. It's a very modern and capable radar. This is their version of that same system. In front of that is a small navigation radar called Vision Master Nav Radar. Very high quality, has a declutter phase, which is very important, so you can run very close to shore and see all the small jetties that may come out from a shoreline, so you don't run aground. and of course, all the small vessels and the USVs that are running around perhaps trying to come close to your ship will show up on this navigation radar as well. Below that are the fire control radars, forward and aft. That's the CROS 200. In front of that, on the bow, is the electrical optical system, EOS 500. And then between those two systems is the Indra Regal EA system. And we're going to break all of these down for you. So don't worry if you don't recognize one of those names or even all of them. Here are the two ships that they built. Hull numbers 990 and 991 were both built in the same shipyard in Germany, the Kiel shipyard. They were commissioned in 2016 and 2017. Both these ships are in service in the Algerian Navy today. This is where the shipyard is located, with a nice little picture of the ships, at least one of them there under construction. The other one may be a different class, but that gives you an idea of what it looks like. All right, the Aradi-class frigates by the numbers. One, they're powered by two marine diesels. These are 16-cylinder 1163 TB93 diesels, and in addition to one LM2500 gas turbine that work together. So that is a combined diesel and gas system. They can have the diesels and the gas turbine on at the same time. What is new here is the warp, and this is a like a water jet propulsion system that the gas turbine moves water, pulls it from the bottom of the boat and pushes water out the back of the boat like it's a jet ski. And that also cools the exhaust of the LM2500. So it's very easy to miss this ship if you're just looking at it from an infrared point of view, because it hides its exhaust in the water that it's using to push it through the water. So it has two shafts, controllable pitch, plus a water jet. It is 3,700 tons fully loaded with all the weapons and crew and food on board, and it can go up to 27 knots max speed. That is the public number. I can guarantee you that it's at least 30, but publicly it's 27 knots. It can do over 7,000, almost 8,000 nautical miles if it limits itself to 15 knots, and it has two batteries of 8 RBS-15 Mark III anti-ship missiles and two 16-cell VLS Block II surface-to-air missiles. On the bow, it has that Leonardo 127 millimeter by 64 naval gun, and it has two DSM-30M Mark II 30 millimeter remote control weapon systems. That's that Bushmaster that I told you about, and we'll get a close-up look at that here in a second. It has two torpedo tubes, two banks of two, one bank of two port, one bank of two tubes starboard that shoot the MU-90 lightweight torpedo. And that's a very similar to our Mark 46/Mark 54 here in the United States, if you're familiar with those systems from our other lectures. It has room for two Leonardo Super Linux 300 lightweight multi-role helicopters. As far as the sensors go, again, the Saab Sea Giraffe multifunction AESA radar is the big system here. It can detect both air and surface contacts over 100 and track them at the same time. It's also capable of tracking a ballistic missile, not necessarily shooting at it, or doesn't have the update rate to put a weapon on it, but it can see its trajectory and inform other platforms that do have that capability of a ballistic missile launch and track it. It has two Saab CROS 200 fire control radars, one forward, one aft. It has the Saab electrical optical system 500 on the bow in front of the bridge. The Regal radar electronic attack and electronic support system, that's for detecting other radars and also jamming and defeating them, especially the high repetition X-band fire control radars and weapon radars that are mounted on the weapons themselves that have the high update rate. That Indra Regal system is part of defeating that. The Northrop Grumman Vision Master navigation radars operate in both the S and the X-band. Those are for navigating close to shore without running aground. And the Atlas Electronic ASO hull-mounted sonar. All right, let's begin with the diesel engines. So they have two of these. This is the 16 cylinder in a V configuration, 1163 TB93 diesel engines. Very common diesel engine, very reliable, which is why it's common. Can produce almost 800 horsepower, 8,000 horsepower with its 16 cylinders. and operates around 1280 RPM. Very typical for corvettes, frigates, and patrol boats. The LM2500 gas turbine, again, very common in Western navies. This is built by the American company called General Electric. It is derived from the TF39 and the commercial CF6 high-pass turbofans. So originally these fans or these engines were designed for airplanes, like the TF39 is a trainer that militaries use to train pilots before they get the ticket or the keys to an F-16 or an F-15 or an F-14. They'll fly the TF-39 first, or a plane that has this first. They made a marine version of this engine, which is what we're talking about today, the LM2500. They mass-produced these things, and it's very popular. It has 2-shaft axle flow and a very simple cycle system. Sucks air in, expands it with fuel and fire, and spins turbines that generate power at the back. That's really how it works. Very simple design and very, very reliable. All right, here is a great photo, and credit to Tefon Osbrecht for getting this to us for this lecture. The Kodog warp propulsion system combines propellers and a water jet for increased efficiency at specific speeds. So every propulsion system has a band that it's very efficient at. And so if you can get 1 or 2 bands or a large band that is very efficient at, that's great for you. This system probably has 2 bands. It probably has a band of efficiency that can go 7,000 nautical miles at 15 knots using just the propeller. It probably has a second highly efficient band when it kicks on the jet, the water jet rather, using the LM2500 turbine system. So the warp stands for the water jet and refined propeller. So we have CODAG, which is combined diesel and gas, because you have diesel engines and a gas turbine. The warp is the new thing that adds the water jet propulsion. And you see a wonderful picture of it coming out the rear end of the ship there in the bottom right-hand corner. So CODAG warp is going to be something we talk about more and more as we talk about modern warships now. This is relatively new, combining these two together. Sea Giraffe. This is a multifunction ASA radar, the same one that we use on our LCS, also called AN/SPS 77. Operates in the G band. That's between 5.5 and about 6 gigahertz rather. Can rotate at 30 or 60 RPM. Has a range of 180 kilometers. Can track both air and surface targets. Track capacity, public number is 800 surface plus air targets. But if you have that many air targets, you're having a very bad day, probably, all at once. It has enhanced ECCM, so it's built in the ability to counter another platform's countermeasures is built into the system here. And it's very compact. Like I said, we use this on our LCS. So they're using it on the Visby-class corvettes and on this ship as well. Here is the Saros 200 fire control radar system. They have 2 of these, one forward, one aft. This is built by Saab. A lot of systems on this ship are designed and built by Saab, despite it being manufactured in Germany. Saab and Germany work together a lot with military, especially naval, building naval systems together. But this one is ESM resistant. It's 360 degrees coverage. It operates in the KU band, which is up to 17,000 gigahertz, or 17 gigahertz rather, and has the high update rate in the X band. This is for guiding weapons in 8 to 12 gigahertz frequency. So those are the bands that you're going to see this operating in. What you want to know about the Saros 200 fire control system is that you point this thing at the target, the weapon goes to where this thing is pointed. Here's the electrical optical 500 system. Again, used to direct weapons and find targets and classify them, because this will have an operator steering this around. So it's designed to be used in part with the 9LV Mark IV modular suite. That's the suite of equipment that comes with it. It is dual axis, so it can look up and down and spin 360 degrees. It can look nearly straight up at 85 degrees azimuth, or elevation rather. It can look down negative 45 degrees. And that's really important for detecting those incoming unmanned surface vehicles that are trying to come alongside and detonate near the ship. You're going to use this to not only detect and track those things, but also direct the weapons that will engage them. This thing IOC'd in 2004. Here's the Vision Master navigation radar. It is essentially a commercial grade, well, military grade version of a commercial radar. It operates in the 3000 megahertz S band and has a mode for 9000 megahertz. That's an X band. I don't know why you would operate it at that rate unless you were looking for very small, near, as in within 20 or less miles, small targets. So perhaps whenever they put this into X-band mode, that's when they're looking for those stealthy unmanned vehicles, perhaps trying to sneak up on them and detonate. That's a little bit of speculation on my part. Just know that this navigation radar has the capability of detecting very small objects in the water. It also has clutter suppression. That's very common in navigation radar because anytime you're near a coastline, you're going to have rocks in shallow areas and even sandbars at low tide that will pop up. This will be able to distinguish those things from false echoes, which is always a problem near coastlines. And it can track up to, it says 100 targets with AIS 240. AIS, by the way, is the automatic identification system. So if you're in a very busy waterway, all the civilian and even military ships on the surface will have their AIS turned on. It can track up to 100, 240 of those. All right, here's the Ingra Regal ESM EA suite. This thing is what's going to save the ship from being detected and then targeted with a targeting radar. There's a lot of radar signature designs in this hull to make it less, make it more stealthy, less likely to be detected. But what's more important than being detected is being targeted. And those are two very different things. People misunderstand this all the time, so I'm gonna take a minute to explain this. Whenever a stealth plane or a stealth ship is designed, it can either be designed to not be detected at all, or it can be designed to not be targeted sufficiently to put a weapon on it. So if you look at the B-2 bomber, that is a very large vehicle that has like no corners, very rounded inlets, and where the cockpit is, it's very, curved in shape. That is designed to not be detected, period, right? But if you look at the J or the F-35 or the F-22, those are fighter airplanes or fighter bombers, if you want to include that. And those are considered stealth as well. And they're completely different shapes and sizes. And you're like, clearly there's a difference here. And that difference is in the stealth. We use the same word stealth to describe both, but they have different capabilities of stealth. The J-35 or the F-35, I keep saying J because that's what it used to be called. The F-35 is designed to not have a weapon put on it, but you can see it with a search radar. That's why Iran's always bragging about detecting our aircraft over the Persian Gulf and in the Straits of Hormuz and other places, because they can see our F-35s. But the moment they try to put a weapon grade X-band radar on it, they can't see it. That's the difference, folks. What this will do is if the ship is seen and begins to get targeted, they will use spot jamming, barrage noise, and noise coverage jamming to diffuse the target itself. So the weapon is targeting something that looks much larger than it actually is, and it doesn't know exactly where to go and where to hit. That's what this system does. Okay, so what the F-35 does by shape and system, this system does for the ship in similar ways. All right, this is the Umkhonto IR Block 2 surface-to-air missile. This is manufactured in South Africa by the Denel Corporation. It's also installed on board the Finnish Navy and the Valor-class frigates. Remember, the Valor-class and this class are very similar. This is just the Algerian version of that. Now, this surface-to-air missile has a range of 20 kilometers, which I would put that in short range. It's not a medium-range surface-to-air missile. This is going to be defending this ship from air attack and missile attack. It has a speed of Mach 2. It has a weight of 135 kilograms and can get out and hit a target. Now, this IOC'd in 2019, some 4 or 5 years ago at the time of this recording. Don't have a lot of details on this, but this is what Jane's Fighting Ships says this weapon can do. Here's the Leonardo 127 by 64 millimeter naval gun. This thing has been around forever. It can shoot 32 rounds per minute. It carries some 56 rounds in the mount itself. And when it's shooting the volcano ammunition, which is very expensive, it can reach ranges in excess of 100 kilometers. And that is an INS GPS guided round. So it can hit things very, very precisely. So, but it's not often used because of the price. But when they're shooting the volcano ammunition, we're talking long range, expensive, very precision naval fire ashore, or even on another ship. You know, they could shoot a ship with that round if they wanted to. But whenever I think of ranges in excess of 100 kilometers, I'm thinking that they're going to be doing shore bombardment on very specific static targets like weapon depots, you know, supply concentrations and things like that. All right, the RBS-15 Mark III, manufactured by Saab. This is the long-range subsonic anti-ship missile that's INS and GPS and active radar guided. What's cool about this weapon system is that it's very modern, so it has 3D waypoints and can detect 3D targets and 3D jamming. So if it's shot against another ship and that ship has its ECM on, so it's generating a lot of noise, it sees that noise as a three-dimensional shape and will do its best to attack the target inside that noise. So that is a relatively new capability for the weapons themselves to be seeing the countermeasures in that 3D environment. It doesn't depend on the ship to calculate that and then tell the missile, yeah, aim for the center of this because it's probably right there. It's doing it itself inside the warhead and the seeker head as well. This IOC'd in 2017. Here's the MU-90 lightweight torpedo developed by Eurotorp. And it's honestly, it's the European version of our Mark 46/Mark 54. Pretty capable. It's got a small warhead, 500 kilograms, pretty small for a weapon, but it's a shaped charge. So it's going to take that energy and it's going to punch a hole in a submarine and then let the ocean do the work. That's all it has to do. It doesn't even have to be a big hole. You put a small hole in a submarine, it's going to be hard for that submarine to stay submerged and not sink. So plus it can be used as an area denial tool as well. Honestly, if it's launched from a ship, they're probably going to launch this thing in a direction that they don't want there to be a submarine in, or if there is a submarine there, they want it to leave because the submarine will just get out of the way of this thing. But it is capable. If it catches up to you at its max speed of 26 meters per second, you math nerds out there can calculate that in the knots if you want to. It will catch up to you and put a hole in your submarine if you're within about 25 kilometers of the ship. That's it running at slow speed, by the way. If it runs at max speed, that range is about halved to about 12 kilometers. So very short duration, in my opinion. Area denial weapon. And if your submarine gets hit by this, you just didn't get out of the way in time, or you got way too close to the ship. You could surprise you with this if you try to get too close. Here's the the DS-30M Mark II remote control weapon system. Remember, they have two of these. This is the Bushmaster 2 chain gun, 30 millimeter. Can have both single and dual feed rounds fed into it. So rate of fire is 650 rounds per minute. I've seen these with the coaxial 7.62 mounted alongside. And the reason why you would do that is not every target needs a 30 millimeter round. Sometimes you want a higher rate of fire. So you put that 7.62 machine gun on the side for shorter range, highly maneuverable targets that are dodging your 30 millimeter because they're bouncing around out there in a small speedboat or whatever. So you turn on the 7.62, you get a higher rate of fire, shorter range, but much more likely to hit the target if it's highly maneuverable and closer. Then they have two of these, one forward, one aft. Here's the Super Lynx 300 helicopter. They have room for two of these. Speed is 324 kilometers per hour. Its endurance is how you normally measure any kind of aircraft. It can stay in the air for 5 hours. And in those 5 hours, it can go 350 miles and come back. So that's really all you need to know about the range of this thing. It does have dipping sonar. It can carry 2 MU-90 torpedoes, the same torpedoes that they're firing from the ship if they need to. It can also carry 8 air-to-surface missiles, the 8 Mokopa missiles. And it has one 12.7 millimeter machine gun that's pintle mounted with a firing rate of about 1,100 rounds per minute. Another beautiful picture there from TAFON for this lecture. Good looking helicopter. Very popular, very capable. All right, so my thoughts. I'm impressed with this ship. Algeria's got themselves a couple of really good frigates here. So it's based on the Mako A200 design, which is already a proven design. It has the Kodag warp propulsion, which is among the latest in naval propulsion. Probably the most well-armed ship in North Africa, rather, on the Mediterranean Sea coast. Sensor suite is next level, including an American sensor suite. The main radar, ASA radar, is the one we use in the United States for our LCS. The Lynx 300 helicopter are proven. They've been around forever. It shoots the RBS-15 Mark III anti-ship missiles that has a large warhead, and they carry a lot of them, 16 total of these anti-ship missiles. So the Aradi-class frigates, fitted with a wide array of both radars, sensors, jammers, and a ton of weapons, makes this a great weapon system for Algeria. So tip of the hat to Algeria. They chose a great design, and good job to both Saab and Germany for designing a good ship that they continue to export around the world. All right. Thanks for watching, everybody. This has been the Aradi-class frigate ship brief. See you next time. Welcome to the FDI frigate ship brief. The FDI stands for Defense and Intervention Frigate. Also may be referred to as the Admiral Ronarc-class. This is a French frigate that's going to replace the Lafayette-class frigates, and they're building 5 of them in France. The design of this is so good and impressive, the Hellenic Navy's already ordered 3 before the first one's even built. So this is they're off to a good start here, building these over at Naval Group. This is the first cyber-resilient frigate France is building, and its primary armament is going to be the Exocet anti-ship missile with the extended range mod installed, the Silver VLS system that's going to shoot the Aster 30 SAMs. It's going to have 16 cells that can shoot the Aster 30, which means it can also shoot the Aster 15. We'll discuss the difference between those 2 missiles in this briefing. It does have the inverted bow, similar to the Zumwalt-class. In some of the pictures you'll see here, it doesn't have that, but know that the finished design will have the inverted bow that you see in this photo. It is a stealth design and improved acoustic signature in that all machinery is rafted. And we can't go into detail on what that means, just know that sonar-wise, she's very quiet. And the lead ship is planned to be commissioned in 2025. So let's get started here with the FDI frigate. Here are the weapon systems on board. I love that they kept the big gun. They have the 76mm gun on the bow. That's wonderful. A lot of frigates these days, seems like the primary gun on the bow is getting smaller and smaller, but they kept the big one. On the bow is also those 8x2, so a total of 16 A50 silver VLS cells that shoot the Aster 30 surface-to-air missile. They have the 4x2 Exocet cells, or blocks, if you will. 4-porting port for starboard, shooting that very long-range anti-ship missile. They have the Nexter Narwhal 12mm gun. There is 1 port, 1 starboard, and they're catty corner each other, meaning one's forward and one's aft, and on opposite sides of the ship. And below that, there is the helicopter hangar that also has next to it the twin torpedo tubes. There's 2 on port and 2 on starboard side, and she carries 1 helicopter and 1 unmanned aerial vehicle. So a lot of firepower in this little ship, but she has a surprise. Her communications ESM suite is outstanding. We're going to talk a little bit about how these systems work together and how much they've improved since I was in the Navy years ago. So we'll break down each one of these radars for you and ESM systems. She does have the King Clip Mark II sonar system, which is a very good, bow mounted, or it's near the bow in these days. It's not on the bow anymore. Sonar system. And she does have CAPTAS 4 variable depth sonar. And that's the real submarine catcher right there. Because what they can do with CAPTAS is deploy it like it's a towed array off the back end. And then it's got little control surfaces, fins, if you will. And as they're dragging it like they're flying a kite, they can use the control fins to push the sonar system below the thermal layer that's typically between 200 and 400 feet, and then go active for submarines below that layer where submarines like to hide. And that will snap them up. So she is a very good anti-submarine frigate that has a strong anti-ship punch, a good surface-to-air defense out to a very long range, and her shockingly good ESM suite that I can't wait to get to. So let's get through some of the details here. They are contracted actually to build 5. These are already, being funded by the French government, being built by Naval Group in France, all at the same shipyard. They laid down one because this is the best way to build a ship. You want to build a whole fleet of these frigates, right? But you start with just one. You don't build 2 or 3 right away. And you learn how to build it efficiently. Like as they put this thing together, they're going to discover, oh, if we had done step X before step Y, it would work much better. And then you kind of hash that out on hull 1. Once you have hull 1 constructed, and before it's even like tested and at sea and in service, you take that process that you learned and just start pumping out hull 2, 3, 4 like it's an assembly line. And that's what they're doing. So this first hull was laid down in 2021. It's already been launched. I got a good picture for you of that coming up. And it will be commissioned into the Navy in 2025. The long lead time, that 3 years from launch to commission, is because they're working out a lot of the systems bugs in sea trials, pier side testing, at sea testing, and things like that. The follow-on ships will be much faster. Okay, that's where she's being built. It's a French name, so I'm probably going to pronounce it wrong, but it's spelled Laurent. I hope that's how they say it. And this one shipyard, that one assembly building, is just going to pump them out right there. That's what it's scheduled for right now. If they change that, I wouldn't be surprised because this appears to be a very strong design. Okay, the FDI frigate by the numbers. We have 4 16-valve 8000 M91L diesels. It's a very specific model number of a diesel. Just know that this is a very good maritime diesel, and they're running in a co-DAD configuration. So that's combined diesel and diesel. So the way this works, they have 4 diesel engines. They will always be running 2 diesel engines. Port side electrical bus, starboard side electrical bus, 1 diesel on each. That's turning on the lights, running all the equipment, and charging batteries, because I'm sure they have some kind of energy cell on board this thing, and also sending electricity to the electrical motors that then turn the shafts. Okay. But whenever you have all that load on 2 diesel engines, you could probably only make maybe 13 knots. I'm guessing about 13 knots. If they want to go fast, they got to bring on the second pair of MTU maritime diesel engines, and they can run all 4 at the same time. That's what the code DAD means. Diesel and diesel. So 2 diesels want to go fast, 4 diesels running. But 2 diesels, when she's away from the pier and not getting electricity via shore connections, she'll be running 2 diesels to keep the lights on. All right. She's a 4,500 ton diesel, or ton ship rather, when she's fully loaded and does 27 knots. Those are public numbers. I assume she goes faster than this. But if she wants to do her maximum endurance of 5,000 nautical miles between refuels, she'll have to make a speed of 13 knots. She shoots the Exocet Block 3 Charlie, that's the long-range anti-ship missile, and has 2x8 cell VLSs carrying the Aster 30 SAMs. And we'll get a little more into detail on that. Of course, she has the big 76mm gun on the bow. She shoots the MU-90 lightweight torpedo off the port and starboard sides, but the ASW helicopter drops the American Mark 46 or Mark 54 torpedo. I find that interesting because it would be more efficient to have one type of torpedo that you shoot from your torpedo tubes on board the ship and drop from your helicopter, because that's one supply chain, that's one maintenance kit. You don't need 2 different ones. But publicly, they're saying that they use 2 different torpedoes on this ship and helicopter. Okay, they also have a UAV. That's the Airbus VSR 700. Now, on the sensor side of things, this is really interesting. They do have the Thales Seafire 500 ASA radar. Great radar, long range, very accurate. Can track ballistic missiles and develop fire control solutions to intercept them. So they're not saying, and I'm not saying, that this frigate can intercept a ballistic missile, but with this radar, it can track it, and it can calculate an intercept point that someone else can shoot a missile and intercept it. So I haven't seen any literature yet stating that this ship can actually shoot it down, but with this radar, it certainly can provide the fire control information to do that. Now, they do have the Thales Steer 1.2 electrical optical Mark II fire control radar system. Because it's electrical optical, it also is visual as well as radar. They have the reconnaissance ESM Sentinel and the communication ESM ATSI. These are all, or ALTSI rather. These are all made by Thales, and we're going to break each one of these down. They have a Terma Scatner navigation radar that is possibly low probability of intercept. They have a Safran Peso XLR electro-optical system that they can use for directing the big gun on the bow. The King Clip Mark II hull-mounted sonar, like I said, and then the very capable CapTAS 4 variable depth system that is so good that we've decided to put this French, it's European anyway, sonar system on our frigates. It's so good that we've ditched our own design here in the United States to go after CapTAS 4. It's really good. It can track the new Yasin. They snapped up the Yasin with CapTAS 4. The Royal Navy did. Those Brits over there, clever little blokes. And once they did that, CapTAS 4 was the one to beat. We're like, if that's the sonar system we need to track that new Russian submarine, put it on everything. So there you go. That's the story behind the sales of that. That salesman had a great day. He's like, guess what we just did? Anyway, MTU 16V 8091L. This is that beautiful diesel engine. They got 4 of these things. Very big, very heavy. This thing is a monster, but it puts out a ton of power, 800 horsepower each. And then the only thing the sonarman cares about is this number here, 1150 RPM. Because it's a maritime diesel, that's her most optimal fuel efficient RPM. So she will stay at that range. She'll never move off that. They start her up, she goes to 1150. If they need more power, they'll just put more of a load on the generator without changing the speed of the diesel. Yeah, it's very clever how they do that. And that's how they get such great efficiency. And that's why running a maritime diesel is such a good idea. It's a little bit difficult to maintain. I'd say it's more difficult to maintain than the jet engine that they use on the Arleigh Burkes, the converted LM 2500 that we see so much. But this thing's reliable. It's hard to break. Yeah. All right, here we go. Let's talk about these radar systems. This is the Thales Seafire 500 ASA system. Think of this as the European Navy's version of Aegis. These ASA radars can all communicate with each other when they're in a fleet. And so they each have their own piece of the pie that they cover. And it can be 360, by the way, but they have, designated areas of responsibility, and they all communicate with each other to make it like one huge integrated system. It's beautiful. It works in the 2 to 4 gigahertz range, does both air and surface contacts, can track. Publicly, it says 800 contacts. It's probably twice that, guys. But just understand that they say that they can track up to 800 contacts all at once. Does support the Astra 15, the Astra 30, and the Astra 30B1NT, which is a very specific, I believe that's the anti-ballistic missile one, the B1NT radar. So you need this radar to track that ballistic missile, and then you need that specific Astra surface-to-air missile to go and get it. This frigate shoots Astra 30. So I'm not convinced that it can actually shoot down a ballistic missile, but we are certain it can track it. And the Astra 15, like we'll talk about here in a second, is just a shorter range version of the Astra 30. Basically the same missile. Okay, Steer 1.2 electrical optical fire control radar. So this is a radar with a camera on it. So you can use both or one or the other. You can see what you're shooting if you wanted to. It has both IR and color resolutions. Can do a complete 360, but they mount it on the bow. So if you turned it around, you'd just be looking at yourself. So, but just know that this thing can spin all the way around if it wants to. And it can look up at 120 degrees up and then 30 degrees down. Remember what I said about previous lectures? These unmanned surface vehicles are so fast and small. Looking down is becoming as important as looking up with these weapon systems. And if the radar system or the fire control system can't look down, it won't matter if the gun can. This thing has got to be able to see the target for the gun to hit it. Its range is... the X-band says it can go out 65 nautical miles. That's pushing a ton of power. If the X-band is going that far, that's pretty impressive, actually. I don't know if I believe that number, but hey, it's the 21st century. They could have an X-band that goes 65 nautical miles. I would love to see how they do that, but I'm sure they don't make that public. Anyway, terminal scanter navigational radar frequency is 9,500 megahertz. Typical navigation I want to call this a Furuno. This is what you're going to put on your little fishing boat if you're going to go out offshore fishing for a little bit. It's very accurate. It's X-band because of its frequency. The thing that makes this special is its pulse compression. This is a anti-detection or ECCM radar. So, but they don't claim that it's LPI, but all the descriptive terms that they have here leads me to believe this is low probability of intercept navigation radar, just like what Turkey has. But Turkey comes out and says, hey, you're probably not going to see our radar. Don't be surprised if you see our ship, you don't see us on our radar. This one just says that, hey, it's a pulse compression radar that has ECM capability, ECCM. Okay, range 96 nautical miles, so, can see the shoreline from a long ways away if it needs to. Here is that XLR Safran electrical optical system. This is what controls the gun on the bow. This has a third generation thermal CCD. The resolution is 1280 by 720. Or if you want to go full TV, it's just like watching your computer monitor at 1920 at 1080. So pretty good resolution, especially for that IR range. It's hard to get infrared in a high fidelity, and the fact that they get it to 1200 by 720 is pretty good. It does have panoramic view, TV and IR, integrated combat management system, or you can make it standalone. In other words, the operator can just take it and look around without moving the gun all over the damn place. And that's probably what it's going to be used for a lot, because you don't always want the gun pointing at civilian ships. If you want to take a look at a fishing boat off the coast of Yemen to make sure that they're not smuggling something, you would want to take a look at them with this so you get a nice clear picture, record them if you wanted to, and not have the gun pointed at them at the whole time, freaking out the fishermen. So it's capable of independent operation, but it does work with the combat management system, which means you can put rounds downrange on this thing with this thing if you want to. All right, let's talk about communication ESM. This is not something we say often on this in this series, but this ship has it. This is the Altese H, communication supported counter measurement and communications intelligence, or ComInt system. So CESM or ComInt system. Operates in the 500 megahertz range. These numbers probably don't mean a lot to most people. Just understand that its direction finding accuracy is less than 2 degrees. And then you split the beam and it can be less than 1 degree. So basically, you could get a near single bearing resolution on a comm signal, which is really good passively. But here is the thing that I'm most excited about. This specific model, this Altese H, has a brand new user interface, which doesn't sound like much, but because it's so simple to operate, they can take non-specialist sailors, literally the guy right out of boot camp, and give him an orientation course on how to punch the buttons, and he can collect intelligence. He becomes an instant intel specialist with this piece of equipment because they made intel collection so easy. Now, he's not going to be decrypting. He's not going to be reading, any foreign languages because he doesn't have that training, but he will be able to collect the information. The computer, the AI, and the algorithm will do everything else. It will decrypt it as much as it can. It will translate it into whatever language you want and spit out the results. And this is done with someone with almost no training other than how to operate the console. Compare that to 35 years ago when we were off the coast of Russia with specialists, a whole team of 8 to 16 people that had years and years of training in both language and encryption skills. The math that goes on in these guys' brains was incredible, and they spoke multiple languages. All that is done in the box now. It's all in the computer. And so all you need is a warm body to turn it on and recognize that there is a signal, which it can do too, but the operator can do it. And then it begins decoding, decrypting messages. Communication. This is a specific communication electronic support cell, as well as an intelligence gathering, which just means that it records it. This is a huge step because you're eliminating years of training that used to be required. Let's move on to the VLS. This is very similar to the American VLS in that it is in groups of 8. So you can have 8, And then you have 2 of those, so you have 16. 2 of those, you have up to 32. The lengths are, 4 meters to 5 meters and then 7 meters long. So it's not, or 7 meters deep. That's how far it goes down into the ship. The thing that's the problem with the silver A50, and I thought this was a typo, but apparently it's not, is that it can fire 1 missile every 15 seconds. And that's really slow. That's real slow. It should be 1.5 seconds. But apparently, for whatever reason, it might be some kind of treaty limitation that I'm not aware of, this thing will shoot 1 surface-to-air missile every 15 seconds. That's not enough. That's not enough to defend your ship against a cruise missile attack. You're going to need to get multiple weapons in the air to shoot down incoming weapons. So I'm a little concerned about the fire rate of the silver A50 VLS. Being 1 missile launch every 15 seconds. And I don't understand why it's that slow. The rest of this ship is amazing. Next generation, plug and play decryption for intelligence gathering, which is unheard of, But then it shoots 1 missile every 15 seconds. I'm pretty sure that's got to be some sort of legal agreement limiting that at this point. All right, let's talk about the gun. 76 millimeter rapid fire gun built by Leonardo. We've talked about this gun a lot. It's on a lot of these French and just European ships in general. Shoots 120 rounds per minute, so 2 rounds every second. Has 80 rounds in the mount and additional rounds below that. Has a range of 16 kilometers because that's about the ballistic missile range of shells being shot from a surface ship. We see 16 kilometers a lot on a lot of these guns. 8 kilometers for air targets. It does have an airburst shell. It weighs 7,900 kilograms and can go up to 85 degrees up and 15 degrees down. Because of its centerline placement, it's not going to be able to shoot very short range, but they do have the other 20 millimeter guns that can basically point straight down and shoot the unmanned surface vehicles. So you get too close to the ship, this gun won't be able to hit anything. But it's got a big punch. 76 millimeter round will put a nice hole in whatever it hits. And it shoots fast. All right, here's the Exocet MM40. This thing's been around for decades. They just keep upgrading it, keeping the same name. Essentially, it's a whole new missile. It's so different from the original version. This is the Block 3 Charlie with a range of over 200 kilometers. Yeah, it does INS, which is internal navigation. It also has GPS. Of course, in wartime, GPS would be scrambled, but our French allies would have the code, so they would still be able to use it. It has active radar guidance. It's still subsonic. We're not reinventing the wheel here. It's got a solid propellant booster motor that then goes into a turbofan jet sustainer carrying 160 kilogram IM warhead that has both impact fused and proximity fused. So it doesn't even need to hit your ship. Let's say it's a very small ship or even maybe an unmanned surface vessel, very small. It senses when it's close enough to be effective and explodes. So that's kind of a nice thing that it doesn't need to physically hit anything for the fuse to detonate. Very good missile. They'll never get rid of the Exocet. That thing's going to be around forever. All right, so the Aster 1530. I've been sitting on this knowledge, so now I can finally let it go. So the Aster family consists of Aster 15 short to medium range missiles, and then the Aster 30, which is a short long range missile. And that sounds kind of confusing, so I'm going to break it down for you. So the Aster 15 missile is designed to meet saturation attacks. So think of you're going through the Strait of Hormuz and you got the Iranian Canoe Club coming out to meet you and they have all those small boats. Well, if they start throwing up missiles and stuff, you can use this Aster 15, which is just the front, the white part in this photo, the top half gets launched. It's very short range because it doesn't have a big booster on the back, but it's extremely maneuverable. It can go out and intercept all those missiles that are coming at it from those small boats, right? This thing, I wouldn't be surprised if it could shoot down like an RPG, right? It's that accurate. It's extremely maneuverable. So what is the Aster 30, which is the rating of the VLS here? Well, the Aster 30 is the same missile with a high-performance booster motor on the back. And in this photo, if you're watching the video of this lecture, that's the bottom half that's in black. It is a huge, solid rocket booster motor that pushes this thing into nearly space. It then detaches and becomes essentially an Aster 15 at that point. Very maneuverable, can turn up to 15 Gs, which would smush a pilot, right? but this thing is just a missile and can intercept anything after that. So short range swarm attacks, you want to be shooting Aster 15s. If you're trying to go long range and shoot down that, incoming missile or bomber that's, 120 kilometers away, you're going to use the Aster 30 for that. And they can shoot both. An Aster 30 is simply an Aster 15 with a booster motor. All right. The MU-90 lightweight torpedo, this is the European version of the Mark 46 American torpedo. Very similar characteristics. Max speed is measured in meters per second. I'm not sure why they do it that way. They love their metric system so much they don't even want to use mile or knots anymore. So it's 26 meters per second. The range is 12 kilometers at max speed, but if they go into a lower, slower mode, they can get 25 kilometers out of it. You would want to do that if you were just denying an area. If you're not actually trying to hit the submarine, you just want to keep the submarine from, being right behind you. You could shoot this torpedo to kind of do a wake search or a snake search for 25 kilometers right behind the ship. The submarine would have to get out of the way of that thing, giving you time to escape the submarine. That's just one use that you could use this longer range, lower speed weapon for. All right, so the warhead is a 50 kilogram high explosive shaped charge. It does acoustic open and is electrically propelled, which means it gets up to speed quickly. So I'm going to point out something on this photo that I don't think I'm supposed to see because it's not pointed out anywhere, and it's certainly not in Jane's, but they messed up when they made this photo public and they did not censor it properly, in my opinion. It looks like it has a wire on the rear end of the torpedo. Now, that wire can do two things. It can enable the battery to begin creating electricity to turn the propeller and turn on the acoustics and all that. That's probably what it is for. Is the battery will not turn on essentially until this cable is pulled, and the cable's pulled when you eject it out the torpedo tube. But what if they developed a wire-guided lightweight torpedo and just didn't tell anybody, like it was still a secret, but they left it in this picture? So I'm going to say officially, I think this cable that's on the back of this weapon that's being ejected is to enable the battery to begin generating power. But it could be a wire-guided weapon, and if it is, that's why they're using the M90 and not the Mark 46. All right, Narwhal, 20 millimeter gun. They got two of these things. Developed by Nexter, it shoots 20 millimeter, which is like 90 caliber, commonly referred to as 20 millimeter, even here in the States. Muzzle velocity is up to 1,200 meters per second. That thing, it's a rocket, right? It shoots 740 rounds per minute. It only has a 20 round magazine, but 200 round magazine rather, but you can reload that. The elevation goes down to negative 15 degrees. It has the clearance to go farther than that, but publicly it says 15 degrees. And it will IOC in 2024, which is basically when the first ship is made in this class. Remember, the commissioning is in 2025. And fully loaded, it weighs 270 kilograms, which, that's pretty light for a gun this size. I'm shocked at how light it is. But this is what you're going to use for small surface targets. This, I'm sure, has the ability to shoot down air targets as well. But this, whenever I see this gun, I'm thinking small boats, unmanned surface vehicles. This is going to be your defense against those things. All right. The aerial assets that this frigate carries is the NH-90 Cayman helicopter. This helicopter has a max speed of 300 kilometers per hour, a max service ceiling of just over 5,100 meters, and can go 432 nautical miles or fly for 5 hours. This is uses the Thales Ocean Master radar, that is a surface search radar, and the L3 HELRAS dipping sonar with the forward-looking infrared, and of course the ESM suite is on board. It can carry up to 2 Mark 46 or Mark 54 torpedoes. For those of you that are new and may be wondering what is the difference between a Mark 46 and a Mark 54, a Mark 46 torpedo is a very reliable, low-cost, effective, American-built anti-submarine weapon. The Mark 54 is the same engine with a new logic and homing sensor on the nose that is very updated. It's very effective. It's very hard to get away from a Mark 54 once it finds you. Your best chance is to just run away and hope it runs out of gas, you know. All right. For the unmanned aerial vehicle, they're also launching with the helicopter the Airbus VSR 700 unmanned aerial system. Real quick about terminology here. The difference between an unmanned aerial system and an unmanned aerial vehicle is the vehicle is obviously the vehicle itself. The unmanned aerial system, which is being used more and more in the industry as a description, is all the equipment on board that controls it and the aerial vehicle itself. So you'll start seeing UAS be used more and more common in these lectures going forward. It's a more accurate term is what it is. All right, so this is still under development, just like the American was for years. Ours may still be under development as far as I know. It can do 120 knots operational speed, so pretty good, pretty fast helicopter. Looks like a helicopter without a pilot seat in it. The endurance is over 8 hours though, so this thing can stay up for a long period of time, and it can carry a 100 kilogram payload. So that's probably not enough for a torpedo, but it could carry, you know, a radar system or some kind of communication suite, maybe some sonar buoys. Yeah, you could probably put some sonar buoys on this thing and have it fly and deploy a whole field of sonar buoys. That's what I would use it for. But it does have some sensors, it looks like, on it. It looks like it has a surface search radar on this picture. None of that's confirmed because it's still under development. Who knows what they're going to end up with. All right, final thoughts on the FDI frigates. This is a new generation of cyber-resilient stealth frigates. So they're not just thinking about radar stealth anymore. We're a generation past that. We're thinking about network connectivity. You know, our ability to communicate with the fleet and command ashore and not be interrupted so that we can give fire control and targeting data for that ballistic missile that's coming to someone that can actually do something about it. They're currently building 8 frigates. 5 of these are for France, 3 are for Greece, assuming Greece will be able to afford them. But they did order them. They're under contract. Okay, all the ships are being built in France. They're all being built by Naval Group. And right now, they're all being built by that single shipyard that I only see one assembly building. And if that's the case, I can't believe they're going to build them one at a time. They usually build them side by side at the very least. But we'll see what they actually do. Maybe they have another assembly building that was outside that frame. I don't know. All right, these frigates will have anti-surface warfare capability with air defense capability and ASW capability. We used to call this a multi-role frigate, so I'm just going to call it that. This is a multi-role frigate. Main production is combined diesel and diesel, incorporating 2 diesel engines at a time, up to 4 total. And then the FDI frigates will have extensive sensor capabilities, which blew my mind that they were able to take a layman sailor with orientation training that maybe takes a week on how to operate a console, and he becomes an intelligence gathering person. I still don't want to call him a specialist because he doesn't have that training. But because the AIs and the algorithms have evolved to the point to where they can do all the specialist work, they just need a human to control the console and collect the data and tell the AI, hey, it's okay to start collecting intel, because there's still a human in the loop. You'll hopefully never get rid of that. You don't want these machines making their own decisions, even though that appears to be the way that we're going. We now at least have someone there monitoring the AI, watching it do the real work. And that's incredible. That is so good that they've got that ability now. And this is one of the first military projects, ships, if you will, that publicly have announced that. I'm sure there's other countries, including the United States, that probably have been doing that for a long time. But this one's now publicly saying, hey, we can take a sailor, give him a orientation course, and he is now an intel collection person. Great stuff coming out of France. I am super impressed with Naval Group right now, time of this recording. They are doing it right. And I love giving credit when people are performing well. Right now, Naval Group is showing up the Western world on how to build and maintain a fleet. Well done. All right. Thank you, Patreons and YouTube members. You guys keep this channel going. Couldn't do it without you. We're growing like you wouldn't believe. I promised you announcements. Just for the Patreons and the YouTube members, I will be in November in Washington, D.C. at the direct defense, rather, the Defense Connect Expo. It's like a convention. It's 4 days. I will be there gripping and grinning, having drinks, going to lectures. If you want to meet me in person, I will be at the convention center in Washington, D.C., November 27th to November 30th. Those 4 days. Love to see you there. If you can make it, let me know. I will look for you. All right. See you guys later. Bye. Freedom-class littoral combat ship, ship brief. The Freedom-class is one of 2 classes in the LCS program. And one of the things that makes the LCS very unique is her modular mission package capability. This is a small ship designed for shallow water operations near shorelines and can configure herself to any mission that's required, whether it's surface warfare, anti-submarine warfare, or mine countermeasure warfare. She can do any one of those. This particular class, the Freedom-class, is built in Wisconsin in the United States on the Great Lakes at a shipyard called Finnicateri Marionette Marine, or FMM for short. They planned on building 16 of these. They've only built 13 and already started decommissioning 5 of them due to problems they had. However, 2 of the remaining Freedom-class are for sale to Greece. That sale has not been completed at the time of this recording, but Greece has expressed interest in buying 2 of these ships. Now, some of the weapons that they can hold, and we're going to go in detail into all the different configurations, but something that might surprise you is that she can shoot 24 AGM-114 longbow Hellfire missiles, the same or a variant of the longbow missile that's shot from this system can shoot a naval version of that same missile. They all have the Bofors Mark 110 57mm naval gun, no matter what package they have on board, and a Mark 49 Ram point defense missile launcher. She has 2 Mark 46 30mm gun weapon systems in her surface combat mode and can operate unmanned helicopter craft. So let's take a close look at the weapons and countermeasures on board this. Starting at the bow, all the way at the front, is the Mark 110 57mm naval gun. The Naval Strike Missile is going to be placed right behind that forward of the superstructure. It is not in this picture yet. Something that will be kind of a theme here is this whole program has been around for many years, and very few ships have all the equipment they're supposed to have. But that's kind of above and beyond the scope of what we're talking about today. Let's continue moving down the superstructure past the smokestacks to the Mark 47 30mm GWS system. That's the gun's weapon system. And there's 1 port, 1 starboard, and they're remotely operated from inside the ship. This is in its surface combat mode. Behind that is where the AGM-114 Hellfire SSM short-range anti-ship missiles are located. And center line of that, right above the helicopter hangar, is the Mark 49 Ram launcher. Now let's look at the sensors, rather. We have at the very top, we'll start at the top of the mast, you have the AN/URN-25 air navigation system, and below that is the TRS 3D and 4D radar system, and we'll be breaking all these down for you if you're not familiar. Below that is a Faba-Duran EO, or electrical optical system, for targeting and searching in different modes, IR modes, thermal mode, low light mode, things like that are all available. The Argon ST ESM system, there's not much publicly available about it, but just be aware that there is a modern electronic support measure system on board the LCS, the Freedom-class. And all the way back aft is the AN/SQR-20 towed sonar deployable towed array when she is in her ASW module mode. Here are all the ships and names and times of commissionings. We're not going to read out each one of these out loud, but you can pause this if you're watching the video to see which one of your ships, these are all named after American cities, which one your city is named after and when it was made. All right, like I said, made in the USA, the Finnicateri Marionette Marine is built a shipyard here, or they took over an old shipyard a long time ago in Wisconsin, and they've been building ships for a long time. This is a very experienced, funded shipyard. Not many people know about it because it's not on the East Coast or West Coast. It's in the middle of the nation on the Great Lakes. And they build their ships, and they will take them through Lake Michigan, Lake Huron, through all the Great Lakes, into the Atlantic, where they then get either deployed to San Diego or Mayport, Florida, which is the primary bases that they're out of. All right, so let's do LCS by the numbers. Again, specifically Freedom-class is what we're talking about. They use a CODAG propulsion system. So it's combined diesel and gas turbine propulsion. They have a vectored thrust water jets that pushes them through the water to 47 knots. This ship weighs 3,500 tons, so she's certainly in the frigate class in terms of tonnage, but her official designation, because of her mission capability, is littoral combat. Shallow water, usually near shore combat readiness. She can make 3,500 nautical miles at 14 knots, so that is a significant fact. She cannot maintain 47 knots of speed for any length of time. She burns through her gas rapidly, but she can sprint at 47 knots. Cruising speed, 14 knots, which for the United States Navy is very, very slow. Crew members, 50 crew members is the normal number of crew on board, and they're the ones with the racks and are full-time. An additional 25 crew members can be attached to support the special mission. If she's in the ASW role, she'll get 25 sonar techs and sonar-related people, and mission support people. And then the 50 crew members operate the ship. That's how it's supposed to work. So you'll see the crew members fluctuate between 50 and 75. That's normal. I'm told by crew members in the United States Navy right now, they only have 50 racks on board. So whenever the new crew members come on, they had to camp in the helicopter hangar. So the AGM-114 surface-to-surface missile system is installed on the surface warfare package modules. The Mark 110 57 millimeter gun is on the bow on every one of these. The Mark 49 point defense missile system is aft over top of the hangar, like I said, and they can carry the MH-60R, which is the new Seahawk helicopter, or the smaller MQ-8 Bravo or Charlie Fire Scout. That is the unmanned, remotely deployable Scout helicopter. The TRS-3D 4D search radar is the rotating radar above the bridge, and we'll give you technical descriptions of these systems here in a second. The Lockheed Martin COMTAS 21 combat management system is the new Aegis. It is just stripped down to fit on these smaller, lighter ships, like the Constellation frigate that's being built has this frigate version of Aegis, and it's called COMTAS 21. You'll be seeing this a lot going forward. Fabadorn is the electrical optical director system. Think of it as a remote control camera, if you will, that can also track objects remotely or automatically based on their heat signature or their shape. If it can see a distinction of a contact, it will track that contact without the operator guiding it. But of course, you can manually do it too. They do deploy the AN-SQR-20 towed sonar system. That's part of the ASW module for whenever they have that on board. The Argonne ST-WBR-2000 electronic support measure or ESM system is on board with very little public knowledge, very little public facts about that. We don't have much to give you on that one. They do have the WSC-6 SATCOM system for communication worldwide and the URN-25 tactical air navigation system. Terma SKWS decoy launching system, also called Alex, is great. It can do all sorts of decoys, chaff, flare, infrared, combination of the two, and anti-torpedo decoys are all part of the Alex automated decoy launch system. All right, let's begin with the heart of the ship. This is the Rolls-Royce MT-30 gas turbine engine. It's a very high power and a derivative of the Trent Arrow engine. It generates 36 megawatts of power, although it is rated up to 44 megawatts if it needs to, but generally 36 megawatts of power. It weighs 32,000 kilograms of weight, my goodness. And it spins at a 3,600 RPM, twin spooling gas generation system, and it's fully integrated with electronic control system. So obviously they're not controlling this with valves in the engine room. They're doing it electronically from the bridge. And this IOC'd in 2006 for the LCS program. All right, so the Colt Peel Stick 16PA6B. I got very excited when I saw this diesel engine is being used on board the LCS Freedom class because this is manufactured by Fairbanks Morris. Fairbanks Morris is the company that makes the very reliable diesel engines for our American submarines, and they're making the very reliable diesel engine for the LCS. So if all else fails, I am confident as a sailor that this engine will always run and they'll have a means of propulsion despite other failures in the powertrain. This 16-valve diesel engine is rated up to 8,100 kilowatts. It spins at a 1,050 RPM and has a 96% efficiency rate. That is a hallmark of Fairbanks Morris engines. They're extremely efficient. And with just a little bit of maintenance, they'll last forever. Of this new version that they're building, there's only 840 worldwide. This is the top of the line in terms of naval diesel engines, in my opinion. That's the Colt Peel Stick 16PA 6 Bravo. Mission modules. All right, let's start breaking this down. This can get a little complex if you're only listening, so I'll try and go slow. Each one of these Freedom class can be fit with any number of 3 mission modules. First, we have the MCM. That is the Mine Countermeasure module, designed to detect and neutralize mine threats. Very straightforward. Then we have the Surface Warfare Package, which is the exciting one because you get to see all the weapons on it. And that is for maritime security and prosecution of small boat threats. Thus, the littoral combat mission, capability. ASW is to detect and classify and localize, prosecute enemy submarines is the last mission package. So those are the 3: anti-mine, anti-surface, anti-submarine. 3 packages. Now the Navy plans to procure 55 LCS ships, and on those ships, they are also procuring 16 anti-submarine warfare modules, 24 mine warfare modules, and 24 SU or anti-surface warfare modules. So you can see building and buying the modules is separate than the ship. They pay for the ship. The ship comes with a module installed, and in storage, essentially, the Navy has, NAVSEA has, all these other mission modules that they can put on any one of the Freedom classes. They can literally change the mission of the ship and its capability by taking out an old module and putting in a new one. Now, originally, when this was designed in the late 1990s, it was believed they could do this over a weekend. They could pull in on Friday, and by Monday, go from being an anti-submarine warfare ship to a surface warfare ship. That is not at all how this works in reality. This takes time. The numbers, no one will give me a firm number, but it's somewhere close to a month, close to 4 weeks to go from one module to another in that realm. So it's not done often. But know that they can do it, and the Navy has purchased more modules than they have ships. So they intend on certainly swapping these out depending on the needs of the Navy. All right, mission module. The MCM has an aviation asset, which would be the unmanned aerial vehicle. They could also use the helicopter as well. So the Mine Hunter USVs are unmanned surface vessels that go out and look for mines. With that, they have the USV payload. So these payloads come in large containers that they sit on the back of the ship, where the hangar is, where the flight deck is, by the way, which means it would be very likely that they would use the unmanned smaller aircraft in combination with the Mine Hunter USVs. And then they also have the Knifefish UUV, which is the unmanned underwater vessel that swims down and looks for the mines while submerged. So it can do an unmanned surface search, an unmanned underwater search, and have an unmanned aerial asset supporting the mine hunting. That's the MCM module package. Now, let's move on to the anti-surface or the SUW package. This has the gun mission module installed, which has the Mark 46 GWS. Those are the 30 millimeter cannons, port and starboard, over top the hangar on top of the superstructure. They shoot 400 rounds a minute. and they have 24 rounds in each magazine, and then they can push more ammunition up from the bottom if they need to. Surface-to-surface missile module, they have the surface, the AGM-114 Hellfire, long-range Hellfire missile. They also have the aviation module, MH-60R, that's the Seahawk helicopter. That's going to be supporting the mission. The Seahawk helicopter has weapons as well, and we'll get into that when we talk about the helicopter. And then finally, the Marine Security Module is 2 reinforced hull inflatable boats. She carries those internally. You can see a picture of it in the top right-hand corner there. They just drive right into the back of the ship on the Freedom-class. The Independence-class is shown in the lower left. We'll get to that in a different lecture. Finally, the ASW module. The ASW escort module has a variable depth sonar, and this thing was a mess. It was not engineered correctly, properly, and was the reason why the ASW module was nearly canceled because they just couldn't get the VDS to work properly. The Navy plans on going with a new variable depth sonar called CAPTAS 4. That's being installed on destroyers and the Constellation frigate. I have not seen it on the Freedom yet, but know that the VDS is the Achilles heel of the ASW module during construction and development. So it does have a multifunction towed array that's deployed with it. There are no problems with that. It's just a noodle you put out the back and it listens to things. The torpedo defense module is an acoustic intercept, which will give you a warning if it has a torpedo in the water. And they also have a countermeasures lightweight torpedo, or LWT, tow to decoy incoming torpedoes. For the aviation module, they would have the MH-60R as well. That's the helicopter, but configured with sonar buoys to support the sonar search. And a VTOL AUV. The VTOL AUV is the unmanned aerial vehicle that can support as well. I haven't seen both the VTOL UAV and the MH-60R on at the same time. I believe that's an either or in this case. All right, here's the TRS 3D radar. It's made by Heldsat, designed as the SPS-75 in the U.S. Navy, so you may see it called that there. It operates in the NATO G-band, which is 4 to 6 gigahertz. It can rotate between 10 and 60 RPM, depending on different modes that you may have it in. The elevation is -2, so it looks down just a little bit, all the way up to plus 70 degrees, and can track up to 750 targets, which is a very busy day for the radar operator if he has that many. This IOC'd all the way back in 1998. Not necessarily new technology by this point, but one of the things that's very reliable and works on this ship. Here is the TRS 4D MR-ESR radar, manufactured by Heldsat again. Operates in the 4 to 8 gigahertz, a little bit higher this time. And this was installed on the newer systems, newer ships rather. Remember, they've been building these LCS now for over a decade. And so the newer ones got the upgraded radar. This one can track up to 1,000 contacts and IOC'd on the Freedom-class in 2019. Here's the SQR-20 towed array built by Lockheed Martin. It's just part of the ASW module, can track targets out to 129 kilometers given the right conditions. Anytime you see sonar in a range, just understand that that varies wildly with sea conditions. But that's what we're going to say in a perfect environment, 129 kilometers. All right, here's the Alex decoy launching system. This is really cool. They put the protection of a ship, the soft kill capability, all in one system here, and it's called Alex. It's made by the Sipican Incorporation, or corporation, I should say. This does automatic, semi-auto, and manual mode launching of decoys, RF, IR, hybrid, and anti-torpedo decoys are all launched from the same system. They have deck-mounted launchers, and they have complex processors inside that control the operation of the system. So, for instance, if they had the submarine module installed, part of the anti-submarine module is a torpedo alarm or torpedo detector. Of course, that alarm would be audible and visual, and everybody in CIC would know about it. But it also send a signal to this thing that it's time to deploy a anti-torpedo countermeasure. Now, there's probably going to be a human in the loop on that. It's not going to just automatically do it, but just know that that's how these systems work together. The system making all that work together is the COMTAS 21. All right, let's move on to the Terma SKS decoy launching system here. This is for soft weapon kills. This can fire all existing 130 millimeter decoys, so there's a larger variety of different types of decoys they can launch from this one. This is consists of a DLD6 and 12T launcher groups. Those are different types of barrels that can launch different decoys, if you will. And the idea here is to render a weapon like a cruise missile coming in useless because it can't target the ship properly. Very old school way of defending ships, but it works. And this is their version of the Terma SKWS decoy launching system on board the Freedom-class. Here's the Mark 110 57 millimeter. Usually the first thing everyone sees when they look at this ship is they see the big gun on the front. 57 millimeter caliber, shoots 22 rounds per minute, has 1,000 rounds stored below deck, and it can fire 3 different types of programmable ammunition. One is point detonating, one is proximity, which would be good for shooting down aircraft and missiles, and then there's programmed modes where you can change the fuse for different types of penetration. And all that is above the idea of this lecture here, but just know that they have 3 different types of programmable ammunition, and the computer tells the fuse what to do before it's shot. This I also did in 2003. Here's the Mark 46 30 millimeter gun weapon system. Remember, part of the surface warfare module, they have 2 of these above the hangar deck and superstructure. These are the Bushmaster Mark 44 30 by 173 millimeter autocannons. They shoot 200 rounds per minute with a dual feed, so 200 and 200, and are remotely operated. Effective firing range of these guns is 2 kilometers. Very effective against small boats. Here's the Mark 49 Rams point defense missile system. Manufactured by Raytheon, carries 21 RIM 116 rolling airframe missiles. Can shoot at a max altitude of 12,000 meters. Has different variants. They have Block 1 and Block 2 that have different effective ranges. Block 1 is at 6.9 kilometers. Block 2 is a little bit longer at 15 kilometers. And they use different types of tracking techniques like inertial guidance, radar guidance, and infrared, as well as laser proximity and impact fuses on the missiles to ensure a good hard kill on any kind of incoming cruise missile or low-flying aircraft. This I OC'd back in 1992. Here's the AGM-114 L7 Hellfire. This is the naval variant of the Hellfire missile. Has a range of over 8 kilometers. Has a 9 kilogram high explosive warhead. And the saddle base guidance section replaced the RF Seeker. The first use of this missile was in 1989 with the Longbow Hellfire. This version that we're using on the Navy was IOC'd in 2018 and part of the surface warfare package module. All right, here is the RGM-184A NSM naval strike missile. This is made by Königsberg. So this is a new missile. This IOC'd in 2012 and is essentially, I believe, going to be the replacement of the Harpoon for the Americans. It's basically a stealthy Harpoon. It's still subsonic, has extremely long range. It's a very efficient missile. It can go out over 180 kilometers, and it's actually much higher than that, depending on the variant of the missile. It has 125 kilogram high explosive warhead with programmable fuses. Again, you can either do impact detonation or delayed, so you have impact, and then it goes into the ship and then explodes. All those different modes are available on this missile. This NSM is what we're going to call it for short. It is GPS, INS, and Terracom guided. Terracom is really important and something I honestly didn't know until we researched this. Terracom means it can fly over land because it's using terrain mapping to know where it is and to avoid things like buildings and mountains and power lines. That's where Terracom comes in. You can still use Terracom over the water, but on a calm day, it would just be flat. But just know that it's got an IR seeker on the nose, and it is radar guided as well. Okay. Here's the MH-60R helicopter. This is the manned helicopter that will accompany the ship, part of the surface warfare and the ASW package. It's powered by 2 GE T700 turbo shaft engines, has a max speed of 267 kilometers, range of 454 kilometer range, and that really depends. Helicopter ranges are funny. because with the ASW mission, they're going to hover a lot. When a helicopter's at hover, it is generally less efficient. It's burning through fuel faster than whenever it's flying through the air, because it has to create all of its own lift mechanically. Where when you're flying through the air in any direction, you can use the blades as a wing essentially and get more lift out of them. Anyway, less efficient at hover. She does still have 3.5 hours of endurance, has door-mounted machine guns, multifunction radar, electrical optical system for identifying targets, as well as sonar buoys in the ASW configuration. She can also shoot, well, they have the door-mounted gun. Let's leave it at that. Here's the MQ-8C Fire Scout. This is the unmanned helicopter that was originally going to be like the primary aviation source for the Freedom class, but they wisely, in my opinion, also added the manned helicopter support as well. But here's the unmanned made by Northrop Grumman. This is the Bell 407 helicopter chassis. They just modified it to be unmanned. It has a range of 150 nautical miles and has 15 hours of endurance, much more than the manned helicopter. So this can really stay aloft a long time, providing support for the ship with its electrical optical sensors, its Starlight radar option, which can do over-the-horizon targeting of small craft that are so far away the Freedom class can't see with its radar. It can send out the scout helicopter over the horizon, connect its radar with the ship, and then get an extra range in the very high fidelity too. Radar, like sonar, as range increases, you tend to get less and less detailed information. Well, with this helicopter doing over the horizon targeting, it's like you're resetting that range again and getting high fidelity targeting information from it. So very important part of the Freedom class module, no matter which module they have on board, having one of these greatly impacts how effective they are in terms of range. That's the MQ-8C Fire Scout unmanned helicopter. All right, my final thoughts on the Freedom class LCS. This was the United States' really first new ship on littoral warfare, and it was not managed well, to be fair. But now that we have them, we have 13 of these of this class, and they do a good job when they have their modules installed for doing that specific job. The real problem comes in is 5 of these, the first 5 they built, had a mechanical problem with the powertrain, which rendered them to 14 knots. They could not go to 47 knots. They could not combine their diesel and their gas and their CODAG system. That's what the problem was. They just decommissioned those 5 ships. They did repair like 2 or 3 others, but the gutting of the ship's propulsion system, the prime mover, was basically tearing the ship apart again and rebuilding it. They're like, why are we doing this? Why don't we just build new ships? Because that's what we're doing with the old one, except we're having to tear it apart first and then build it again. So it just made sense to decommission 5 after they learned the lessons of how long it would take to fix them. And that was really a big problem because of the cost and time that it took. The second part of the problem that is with both the Independence and the Freedom class is its maintenance. Whenever the ship was designed, part of the process was to research and develop new technologies. So this was a very new way of doing this. Normally, when you design a ship, you'll design as much of a prototype as you can on paper. Sometimes you actually build a prototype and then you don't commission it and you test it. It's a test ship. We had test ships for years in the 1960s and 70s, testing missile systems, and then they would rip that system off, put on a new missile system, and they were called test ships. Well, the Navy didn't want to spend the time and the money and the energy on a test ship. They were like, just build them, and we'll figure out the research and development in real time, and we'll call it sea trials, which is insane, and it did not work. It ended up costing a lot of money because with any R&D development, you're going to have failures. Only we were having failures on LCS-1, a commissioned naval vessel that didn't work because the systems were too far ahead of their time. They needed to have the bugs worked out, which is why you have an R&D process to begin with. But the Freedom class did research and development literally on a commissioned freaking vessel. And the whole program was designed to be like that. The second problem with the entire LCS program, and we'll get into this when we talk about independence, is the maintenance. Lockheed Martin, well, the designers of the ship, in this case, Finnicoteri, Marionette Marine, were very wise. They knew that they had the opportunity to make a lot of money here to recoup those R&D costs that they would otherwise spend, since there was no R&D problem, or program rather. So whenever the ships would come back from sea and need to be maintained, it would be the contractors of the ship designers who would send Tiger teams, if you will, the teams of people to wherever they are in the world, Mayport, Philippines, wherever, and go aboard the ship and do all the software patch updates. If something mechanically broke, which happened a lot, they would fix that too. The crew, the 50 crew, the core crew that operated the ship, did none of that originally. None of it. So whenever a ship pulled in to, say, Singapore, which was very common and still happens today, they have to fly a Tiger team from Wisconsin or somewhere stateside to Singapore. That includes a lot of logistical problems like passports and security clearances. And whenever they go to places like the Philippines, Singapore, Australia, some of the technicians were not allowed into the country. So there was all these other problems where only half the Tiger team would arrive. They wouldn't be able to do all the maintenance, and it was extremely expensive to get done. Those are just some of the problems with the maintaining of these ships. Whenever the ships are in home port, like Mayport or San Diego, where they're generally housed out of or operated out of there, I think there's a few out in Hawaii too, that's fine. It's still very expensive to fly a Tiger team out every time you want to update your software. Some of this maintenance has to be done monthly. So the Navy has slowly integrated the ship's crew into doing routine maintenance is the way it's done now, saving a lot of that frustration and cost. But the ship designers, because this was a whole new process, took full advantage of the Navy to maximize as much income as they could for the life of the ship. And ships today live to be 30 to 40 years old. And so they saw this as almost like a subscription service by the Navy to maintain these ships. Independence-class did it too, and we're going to talk about that in the next one. And for some reason, Greece wants two of them, and I don't know why. One, Greece doesn't have any money. They sure aren't going to be paying any kind of Tiger team to come out and maintain them for them. But we'll see if that sale goes through. It hasn't happened at the time of this recording. If it does, I'll let the Patreons know. I'll give you guys an update. All right, thanks for listening, everybody. This has been Freedom-class, for better or worse. We've got them now. They're in the Navy, so let's make the most of them. Have a great day, everybody. Welcome to the Gerald R. Ford class ship brief. Ladies and gentlemen, this is the largest and most capable aircraft carrier, not just built in American history, but built in naval history. This is an enormous ship that we're going to talk about today. There's one commissioned right now, the Gerald R. Ford. That's why the class is named after her. We have 3 under construction right now. We're building these 3 at a time because they take so long to build. They will be delivered in 5-year increments. The place building these is located on the east coast of the United States. It's a large shipyard called Newport News of Huntington Ingalls Industries, and that's in Virginia. Each one of these ships displaces just over 100,000 tons of seawater when she's at sea. This ship has a 20% more sortie and weapon capability than the previous class, which used to be the largest aircraft carrier class in the world, the Nimitz-class. This one is even larger than that. The defensive systems on this ship may shock you. She is quite capable of defending herself at sea even without the fleet or even the air wing. She has multiple missile systems on board for both point defense and medium range air defense that we will talk about. Iconically, she is the first aircraft carrier to use electromagnetic launch system called EMALS. This fits well with the large nuclear electrical generation capability of the ship to use electricity instead of steam to push our aircraft off the deck. The aircraft that operate on the Gerald R. Ford class are numerous. We have the FA-18, both E and F, single and dual seat fighter and attack aircraft. We have the F-35C, Operating off of her, the E-2D Hawkeye, airborne early warning and control aircraft. And of course, the MQ-25 is the airborne refueling unmanned aerial vehicle, operates off the Gerald R. Ford class. Of course, helicopters can come and go, and there is a helicopter attachment on board this ship when she's at sea with her air wing. The very long build and testing of this first vessel was approximately 13 billion US dollars. It was very expensive and very delayed because of all the new technologies involved and caused some criticisms. And I will leave those for the very end of the lecture, because for right now, we're going to celebrate what the United States has designed and built here, because it is incredible. Let's begin with these weapon systems that I talked about. Whenever we think missile systems, we often think of destroyers and cruisers and other ships. But this aircraft carrier has numerous ballistic and missile systems on board her. These are used for defensive purposes, by the way. This is not something that you would take into battle to shoot down aircraft or otherwise. But it's when adversaries attack this aircraft carrier, she has her own defensive layers. Let's begin at the bow. The Mark 38 remote control weapon system is a 25 millimeter chain gun, or I've heard it called a machine gun as well, that is designed to engage surface vehicles at about a 1 to 1.3 mile range. This is really for those unmanned surface vehicles that are being used right now in the Black Sea against the Russian Navy to come in and ram the side of the ships and explode. This type of weapon system would be ideal for engaging those drones before they hit the ship. But it could also be used for anything in the water, like a mine, a floating mine, for example, within 1.3 miles of the ship. This remotely controlled weapon system could easily engage and destroy things like that as well. If we move back from the bow a little bit, on the port side, we'll see the Mark 49 RAM. This is the rolling airframe missile system. It is a short-range point defense missile system, holds 21 missiles. It is infrared and inertially guided, and it's fire and forget. If a missile or low-flying aircraft comes within its engagement envelope, it will simply shoot it down. Directly across from it on the starboard side, we have the Mark 29 ESSM, accompanied by a Phalanx close-in weapon system. The Phalanx Sea Whiz is a ballistic-based system shooting a 20 millimeter round, and the Mark 29 ESSM is a medium-range surface-to-air missile. It flies very fast. It can reach out to about 12 kilometers and destroy anything in the air inside that envelope, and that is the medium-range portion of this defense. So we've seen ballistic defenses at short range, we have missile defenses at short range with the Mark 49 RAM, and we have missile defenses at medium range with the Mark 29. As we move amidships, on the port side only is a single, very lonely Phalanx close-in weapon systems. The Sea Whiz sitting out there protecting the port side all by itself. Probably why you don't see one on the starboard side is that's where the aircraft elevators are. So it appears as if there's just not a place for it on the other side. But if we move all the way back aft to the very stern of the vessel, every single point defense and missile defense system is repeated back here. On the port side, we have the Mark 38 remote control weapon system accompanied by the Mark 29 ESSM. That's that medium range surface-to-air missiles. So we have medium-range surface-to-air missiles on both port and starboard side. This is equal coverage. This is very important. On the starboard side, we have the Phalanx Sea Whiz. We have the Mark 38 25 millimeter remote control weapon system for those drones. And we have a Mark 49 rolling airframe short-range missile defense system. So all those are represented on the aft end. And one reason why you have the majority, or about half, of all of your missile defense systems on the aft end of the ship is that in conflict, it is likely that the fleet will detect that an attack is in progress. They may not have all the details yet, but they will have a general direction initially before that gets narrowed down. The fleet will move away from the attack most likely. That way, it points half of the defensive systems on board this ship in the direction of the oncoming attack. That is just one reason of why you would see so many of these on the aft end of the ship versus, say, the bow or even the sides that are so much bigger. Sensors. Let's talk about sensors. We have a single graphic at the top of this tower saying that we have satellite communication. That is a understatement. This platform has every single communication that you can stick on a U.S. Navy vessel because of the role that it performs coordinating a battlefield at sea with forces ashore, in the air, and at sea. And then informing civilian leaders like the President, Secretary of Defense ashore, it has the communication antennas to do all of that. So just know that the top of this tower is full of both sensors and communication arrays. Now, below that, on the actual tower itself, we have a bit of a unique radar configuration here. This is for just Hull 1, so just the Gerald R forward, but not the whole class. We'll have a combination of the Spy 4 radar and the Spy 3 radar. These two radars will work together in a dual mode configuration. This is very similar to how the Zumwalt operates. And we'll talk about those in detail in the radar section. Just below that, we have a couple fire control radars, and that's used for directing weapons in flight. Here we have the names of the ships that are being built. Obviously, the Gerald R. Ford was commissioned in 2017 after a very long production, construction, and testing process. Iconically or ironically, she was commissioned while still performing sea trials. So we'll get into that at the end of the lecture. Now, the next hull is coming in 2025. So we'll very soon have two of these operating, which is incredible. And she'll be the John F. Kennedy. John F. Kennedy is going to be hull 2. And John F. Kennedy is going to have a different radar configuration that we'll talk about in a second. And going forward, the next one, every 5 years, we're going to get one of these. The Enterprise will be commissioned in 2030. Doris Miller will be commissioned in 2035. Side note on Doris Miller, all of these ships are named after, iconic ships like the Enterprise or a president. Doris Miller is actually an enlisted man, and he is a hero, if you will, from the Pearl Harbor attack where he manned a gun and, helped defend an attack against the Japanese attack. And so he's getting an aircraft carrier named after him in his honor of his service. So that's a bit unique. They haven't named Hull 5 yet. They are going to build at least 6 of these, and 9 are planned, and we'll see how many they actually build. Because they perform 20% more air sorties than our current aircraft carriers, the Nimitz-class, we don't need to build as many. We have 11 aircraft carriers right now, so if each aircraft carrier can do 20% more, we don't need to build as many. So they may only build 9. We'll have to wait and see, but just be aware that we're definitely building 6 of these, and we've named the first 4. Gerald R. Ford class by the numbers. So this is a nuclear-powered aircraft carrier pushing 2 shafts. She does use steam to generate electricity with steam-driven turbines and turn these 4 shafts. So this is still an old-school nuclear-powered steam-generating propulsion plant, as the Nimitz-class is. Her crew is just over 4,500 souls when the aircraft's crew are on board, because that brings on a lot of people. Obviously, it's not just pilots, it's maintenance. There's so many more people than just pilots in the air wing, folks. The max speed of this ship is in excess of 30 knots. I was privileged to see some of the edited sea trial footage of her at sea doing high-speed maneuvers, and one that was a beautiful thing to watch, this massive 100,000-ton ship do high-speed turns, but she looked like she was doing a hell of a lot more than 30 knots, in my opinion. Publicly, 30 knots plus. She has unlimited range. That means endurance at sea. Much like submarines, she's only limited by food because she creates her own water for the crew, and she has nuclear power to produce electricity and drive the ship. So the limiting factor really is food, and because it's a surface vessel with its own air wing, it can shuttle food from ship to shore as needed. So it really is unlimited range. Until something breaks, this thing can operate for a long period of time. 25 or more aircraft can be in the air ring at once. And again, those are both unmanned tankers, which is that MQ-25. That includes the helicopter wing, which is multi-role, but I would say primarily anti-submarine warfare, in my opinion. And then, of course, the fighter attack air wing as well. Her Mark 29 October ESSM launchers, she has 2 of those, 1 port, 1 starboard. She has 2 of the Mark 49 RAM point defense missile systems. Remember, that's the short-range version. The SSM is a medium-range version. And she has 3 of the Mark 15 Bravo Phalanx close-in weapon systems. And 4 of the Mark 38 Mod 3 25mm remote control systems. On Hull 1 only, we have the dual band radar we talked about. That's Spy 3 and Spy 4. We're about to get into detail as to what those are. Just know that those 2 radars work together. You know, one is a S-band search radar, one is an X-band high frequency, high fidelity radar, and they work in dual mode, working together. Now that we have the Spy 6 radar, and that's being installed on Hull 2 and all the hulls going forward, Spy 6 and SPQ-9 radars will be working together on those future hulls. Now, Raytheon SPQ-9B air search radar is installed on these. They also operate the SPS-73 surface search and navigation radar. That's a very high resolution surface search radar that can be used for navigation, obviously. They have 4 of those Mark 9 fire control radars that I showed you on the tower. Those are for weapon direction and control. The SLQ-32 Bravo SWEP Block 2 electronic support measure system is a mouthful, but it's very important. This is the system that is used to detect and classify any kind of radar transmission that's out there, or communication, radio, anything that has electromagnetic signature. This thing will detect, classify, tell you all sorts of things about it, like what mode it's operating in, things like that. It's very powerful. The SRQ-6 SSEE mod of the electronic countermeasure system is secret. We will not be talking about it. It is installed. The SLQ-25 Nixie underwater decoy is probably the only thing about this ship that I think is vulnerable as far as defenses go. The Nixie, although it has been upgraded and modified throughout its life, is an old system. It IOC'd, I think, in the 1980s, maybe even a little bit before that, for testing. Every modern torpedo in every country knows what the Nixie is, what it sounds like, and how to avoid it. So that's a problem, in my opinion. But I imagine the modern Nixie that is on board modern ships probably has a new mode that I don't know about, and I'm going to give the Navy the benefit of the doubt because everything else about this ship is extreme survivability. You can throw everything in the kitchen sink at this aircraft carrier and it will defend itself. You know, you're going to have a hard time sinking this thing. You're going to have a hard time getting a weapon on target with this thing. Links. Links are communication links between ships, between platforms in space and ashore. So that's link 4, link 11, 16, 22. This is for target sharing, weapon control, you name it. It's literally a wireless network of communication that shares system information between radar, weapons, and their detections. So, for example, you can shoot a weapon from a ship, an Arleigh Burke, for example, and as that weapon is in flight, the communication from this aircraft carrier can update the target to the weapon, much less the ship itself, just as one example. It does things like that. It's very capable. Okay, so air power composition, like I talked about, is in excess of 25 airframes, whether they're helicopters or the F-18 Super Hornet or the F-35C. You can mix and match those as much as you want. Just know that they're going to have a lot. If we were to compare this to the Chinese aircraft carrier, its new one has a maximum, and this is just theoretical, they haven't even done this yet, but they can put 40 aircraft on that ship. So it's literally half of one of our aircraft carriers right now. And like I said, we're going to build multiple of these. Okay, let's talk about what we can about the A1B nuclear reactor. This is a new design, a new reactor for this class of ship. It is a steam-based nuclear reactor, so it's going to have all the bells and whistles and noise-making components and condensating, feeds of a normal nuclear reactor. But it produces 700 megawatts. This thing is huge in terms of power output. It's 25% more than what the Nimitz has. And keep in mind, the Nimitz has multiple reactors, and so does this ship. So it's still 25% more. This provides electrical power to everything. Hotel loads, the emails catapult system, electricity is not a problem. And this is by design, folks, because direct energy weapons are coming to the U.S. Navy. That's a sensitive program that's been in development for decades now. It's been forever because the direct energy weapons are very difficult to get right. But they are coming. And in order to use them, we need to produce enormous amounts of electrical power on board our new ships. So the Arleigh Burke Block 3, the Gerald R. Ford aircraft carrier, even the Constellation-class frigate has electrical power in excess to eventually power these high-demand direct energy weapons. Lasers are coming to this aircraft carrier. Also, it reduces the amount of maintenance you have to do by having things be more and more electrically driven versus mechanically gear driven. That reduces the amount of wear and tear, upkeep, and manpower on board to maintain these systems, which is how you can have such an enormous ship with only 4,500 people on board. Whereas if we didn't have these types of systems that were more electrical than mechanical, we would have well over 5,000 souls on board. And that greatly increases the demand on both personnel and keeping people at sea for longer periods of time, more people. So this electrical generation, this method of powering ships and systems through electricity versus mechanical is a great direction that the United States Navy is going. And then finally, of course, the emails electromagnetic aircraft catapult is state-of-the-art. We were the first to do it. The Chinese did copy us because they do have one as well now. But because we produce so much electricity, we can fire off our ships or our aircraft over and over again without having to generate steam. That's what makes that so great. Okay, emails catapult. Kind of already talked about it. It's manufactured by General Dynamics. It is simply a low maintenance, highly powerful, electrically driven sled that you can put the front gear that is reinforced of aircraft on top of the sled or in front of it, and it will literally push anything attached to that sled off the bow of the ship. Now, when this is an airplane, that's a great thing. So this is how we push our airplanes up into the air. Everything from, our supply planes that come down, little tiny cargo planes, to the F-18 fighter that you see here in the picture, gets pushed off the bow electrically now. And again, less maintenance, requires less people, and is more reliable. It's all around a great system. Dual band radar. This is only on Hull 1. It's also on the Zumwalt-class, but we're not talking about that. The Gerald R. Ford Hull 1 is going to have both the X-band Spy 3 multifunction radar, which is that high update rate, puts weapons on target. It's a multifunction. It does more than just weapons, but it's a very high fidelity radar. That's combined with the Spy 4 S-band radar. The Spy 4 is a volume surveillance radar. It illuminates entire swaths of the airspace around the fleet all at once. So imagine, older systems, if you were to go back to, say, even World War II, you're watching a radar go around and it has a single line and it's just spinning like the dial of a clock. Well, this is much more than that. We're projecting pie slices out into airspace and illuminating large portions of the air all at once. And that's directional too. We can move it around, of course, or just leave it static, and anything in that pie slice volume of airspace is continuously detected. Anyway, these two work together. So they'll have 3 fixed radar panels working together, and it was only used again in Hull 1 because Spy 6 has come along, which has even better capability without having to use 2 different radar systems like this. Also, these capabilities support SM-2 and ESSM. SM-2 is a surface-to-air missile. So again, you could be directing missiles with these radars if you wanted to. Missiles that are not shot from this ship, by the way. Missiles that are shot from neighboring ships that are maybe in the fleet. Okay, Spy-6 radar. This thing is really advanced. Made by Raytheon. It is an air and missile defense radar all at once. This thing spins around. And it's a 3D active electronically scanned array. Operates in the S-band, which is 2 to 4 gigahertz. And it has a solid-state Ganymede transmitter. Very high quality, basically. And it that allows it to use high power, like 1,500 kilowatts transmission. This is also used on the San Antonio LPDs. Those are ships that carry Marines and support marine-to-shore operations. So the San Antonio class, just as a sidebar here, was the first American ship to have the integrated power system, and is also a test platform because of that power system for direct energy weapons. So the San Antonio class also has this radar, so they generate enormous amounts of electricity, even though the San Antonio is conventionally powered. I should mention that. But just know that this radar is on all sorts of different ships, including the new Arleigh Burke Mark III, Block 3. This is our latest and greatest radar. The SPQ-9 radar is the fire control radar that's paired with Spy-6. So whenever you see Spy-6, think SPQ-9 as well. And this is a pulse Doppler, frequency agile, detects and tracks low radar cross-section targets. And that's really key because stealth, if I can for a second divert onto that topic, stealth has two major categories. You have the ability to detect something via radar that's stealthy, and then the ability to put a weapon on that with your X-band radar is completely different. For example, the F-35 Charlie, the airplane that is operated off this class of ship, is a stealth airplane, but you can detect it with a simple S-band search radar. So how can you possibly claim that this is a stealth aircraft if you can detect it with a simple search radar? Well, its stealth characteristics are designed specifically to defeat X-band and other weapon band radars. So yeah, you can see the F-35, but when you go to launch a missile at it, the missile can't see it. And that's what matters. So, but SPQ-9 Bravo designed to see those low radar cross-section targets and put a weapon on it. All right, peak power 1.2 kilowatts. Range may surprise you, 10 nautical miles. Very short range. Keep in mind, we're not taking the carriers directly into battle. So this is going to be, practically point defense range at this point. SLQ-32 Bravo version 6 is the Swept Block 2. This is the ESM and ECM working together. Electronic support measures is what ESM stands for. This is the most advanced electronic countermeasure system in the Navy. The Block 3, which is recently released, is on the Aegis Block 3. But these are very capable and can defeat and, I'm told, literally melt radar arrays if they get too close. These things are designed to jam radars, provide false targets, which they won't tell me how it does that, but apparently it can take this aircraft carrier and make it appear somewhere else on someone else's radar screen, which is crazy. And it could also do multiple ships. It could make this ship look like two. And so whenever a weapon's trying to attack a carrier, when it has 6 choices, which one does it choose is kind of the idea behind that. And it does much more than that as well. And this is only the Block 2. Like I said, the Block 3 is on the Arleigh Burke. These are very advanced systems. How they do what they do is a closely guarded secret. Just know that it's the best and it's installed. Electronic warfare system. Okay, Mark 38 Mod 3 remote control weapon system. This is made by BAE. This is an unstabilized machine gun, and it's designed to engage surface ships. Like I said, those unmanned surface drones or small vessels that are close by. If they get within 1.3 miles This gun can engage and destroy it. It's a 25 millimeter round. It's high explosive. It shoots 180 rounds per minute. Now, the most important thing in this description is that it is unstabilized, which means every roll the ship makes at sea is going to throw off your fire control solution. So there's always, in automatic mode, it's being corrected, but it's not self-stabilized in the component itself. It has to adjust its aim for every little movement the ship makes, causing it to be a little less accurate than it would be if it was on a stable, say, land platform shooting a static target. So that's something to consider whenever we're talking about naval guns. Most naval guns are stabilized. This one is not. Here's a Mark 49 rolling airframe PDMS. This is a self-protection defensive system, short-range surface-to-air missile. Has 21 missiles in its magazine. These can be reloaded. I've seen photos of them reloading this by hand. So there's no automatic reloader. You got to get sailors up there with a missile and shove it in the tube, I guess. This has a range of 12 kilometers, and it is INS and radar and infrared guided. It's fire and forget. Once you launch this thing, it doesn't need those fire control radars. It guides itself, but it gets up to speed so quickly, and the range is so short, its time in the air, its flight time is just a matter of seconds. It's very, very quick. Here's the Mark 29 ESSM, and this is that medium range surface-to-air missile defense. There's one of these port, one of these starboard side, and each has 8 missiles, and is just designed for air defense. This is a semi-active radar homing. That's Block 1, and then it has dual mode for Block 2. Max speed is Mach 3, and the range is in excess of 40 kilometers. So this ship does have the ability to reach out and destroy aircraft at those ranges, including incoming cruise missiles. Mark 15 Phalanx Sea Whiz, very common on board every single Navy warship in the fleet. Shoots a discarding Sabo round, APDS. Shoots multiple rates of fire. Just know they're all measured in the thousands of rounds per minute. So this thing can put a lot of lead downrange very quickly. Its effective range is about the same as that remote control weapon system, but this one is fully automated and well, kind of stabilized in that it has its own onboard radar system to kind of keep it on target. But you can take manual control of this and shoot it from inside the ship with a little joystick, just like you do the RW or the remote control weapon system. All right, let's talk about the air wing now. We're shifting from propulsion and point defense now to the offensive capability. The whole reason why we have an aircraft carrier is to put these planes on it. And the most common plane is the FA-18 E and F. That's the Super Hornet. E is single-seater, F is dual-seater. There's also a Growler that we'll talk about, which is a dual-seater as well. So Block 2 is in service now. Block 3 is being delivered. Matter of fact, at the time of this recording, Boeing, who makes this plane, just delivered a whole new batch of Block 3s to the U.S. Navy. So we are definitely employing Block 3s right now as you're listening to this, which is the latest version of the FA-18. It's a twin engine. It has capability of doing 1.6 Mach, so it is a supersonic fighter attack aircraft. The APG-79 is an active electronic scanned array radar. It also has IRST, which is infrared track capability, and it can shoot the new AIM-260, which is the Joint Attack Tactical Missile, or Joint Air Tactical Missile. It's a very long-range missile designed to complement the AIM-120 AMRAAM and eventually replace that. And the thing that's joint about that is, of course, the Air Force will be using it, and we'll be sharing it with our NATO allies as well. And so whenever everybody's using the same weapons, it makes that supply chain a little more efficient. And so that's the idea behind that. So the AMRAAM is being eventually going to be replaced, and it's going to be the AIM-260 JTAM that eventually does it. If you're watching the graphics here, you can see all the different weapon configurations on the right-hand side. I won't read those out, but just take a moment to look and appreciate how many different weapons the F-18 can hold. Now, if you thought that was a lot, take a look at this. The F-35 Charlie Lightning is quite the platform. This is a 5th generation fighter built by Lockheed Martin. It does have a single turbofan afterburning engine on board, which for naval aircraft is a bit of an exception. The U.S. Navy up to this point has consistently demanded from aircraft manufacturers that they have 2 engines on every aircraft, because if you have one fail and you're over water, you're not going to land, you're going to crash. So having that second engine in an emergency has been key. But for whatever reason, they've went with the single F-135 afterburning turbofan engine. Now, this single engine is powerful, and the fighter is light, so it can get up to Mach 1.6, which is the same as the F-18 in terms of speed. But it does have a lot of stealth characteristics. Remember, I told you about how targeting stealth or low radar cross-section aircraft work. You're going to have a hard time putting a radar-guided weapon on this aircraft. You're going to have to rely on other means like infrared or object shape detection, something else. She does have the APG-83 active electronic scanned array radar, which is an upgraded one, and electro-optical targeting system, which is a passive system. It can be active, I suppose, but you can passively track the shape of a target with this system. And when that happens, the target has no way of knowing it's being tracked passively. Also, it has a directional awareness system. That's really secret and sensitive. Not going to talk about it. Just know that this platform has a lot of capabilities, including it can play the role of, say, a quarterback, if you will, on a frontliner team of FA-18s and coordinate an air attack operation in flight in real time if it needed to. That would be a great role for this. So it does many things more than just carry weapons to the battlefield. It brings a lot of situational awareness and coordination, not just to the theater, but into the battle itself. And that's a great capability. All right, here are the weapons you can put on this thing, and it's a lot. So I'm not going to read these out. If you're watching this, take a moment to pause the video and just look at all these. But it's everything from external gas tanks to the Shadow Storm missiles and all the smart weapons you can think of, to internally stored dumb and smart weapons, air-to-ground weapons. Just about every single air-to-ground weapon in the NATO inventory can be dropped from this thing, including air-to-air weapons, of course, like the Air Intercept Missile 132 and the AIM-120 AMRAAM. And then a number of guided weapons as well, both internal and external weapon pods here. It pretty much does the majority of NATO's air weapon inventory. Here's the EA-18G Growler. This is a very unique plane that is not talked about much because it is extremely sensitive. It is built on the FA-18F twin-seater Super Hornet airframe, but it has a completely different mission. It is an electronic warfare airplane. It brings into the air a number of pods. This is called an AN-ALQ-99 electronic warfare system. And what it does is it gets up with the air wing, and it can look out for, long ranges at what kind of electronic environment are they in terms of air search radars that the opponent is using, where those radars are and what modes are they in. And then, because it has a backseater who's analyzing all this information, can specifically target and blind those radars, including missiles that are in flight. A lot of long-range cruise missiles are controlled and updated mid-flight by other means. Well, this can interrupt that communication, that link, if you will, between a cruise missile in flight and its update source, whether it's space-based or land-based or sea-based. It can interrupt that communication. Just as one example, it does much more than that, and it's all highly sensitive. Just know that it does carry the HARM missile, which is a anti-radiation missile that can go out long range. The extended range HARM is very long range and destroy a sea-based or land-based radar. It also has the ability to shoot the AIM-120 and AIM-9 Sidewinder missiles for air defense. That would not be its primary mission, but if it needed to defend itself against another airplane, it could. but its primary mission is electronic support and attack. This is an offensive capable electronic warfare platform that is not talked about. All right, one that most people recognize because of its unique shape is the E-2 Delta Advanced Hawkeye. This is an airborne early warning and control radar system. It has a whole crew on board, basically an air traffic controller in the sky that does both air search and surface search across hundreds of miles. And they coordinate all sorts of in-air activity. They're essentially the eye in the sky for everybody, not just the air wing, but the fleet itself, updating everybody on what's going on. It can stay in the air for up to 6 hours, and it can refuel, so it can stay in the air even longer than that. Because it's up thousands of feet in the air and it has a 360-degree radar, it has full vision in all directions of everything happening all at once. And something that you need to remember is that it's more than just air search. This can track surface contacts as well. The radar name is the AN-APY-9, Active Electronic Scanned Array Radar. Very long range. This particular version IOC'd in 2014, but we've had the Hawkeyes, these E2s, for decades. Here's the MH-60R Seahawk. This is, as far as helicopters go, the workhorse of the naval fleet for helicopters. Primary mission, in my opinion, is anti-submarine warfare, but these long endurance, 3.5 hours endurance, very durable, very reliable sea-based helicopters are multifunctional. They can do surface search. They can provide ESM capabilities and updates. They have their own onboard ESM system. They also have the forward-looking infrared and other passive optical systems for tracking and targeting and sharing information. But since they've gotten rid of the Vikings, which were the S-3 anti-submarine warfare fixed-wing planes from the U.S. Navy a few years ago, this platform, the Seahawk, has really picked up the mantle in getting over a submerged detection quickly, getting a sensor, whether it's a dipping sonar or a sonar buoy, on a presumed submarine, and a weapon on that submarine if need be, rather quickly. So even though we've lost the ability to use the S-3 Viking to do that mission, which was faster than a helicopter, this helicopter has really picked up the pace in terms of ASW warfare and capability. Honestly, in day-to-day peacetime operations, this helicopter is really used to resupply the fleet a lot. You'll see the air wing helicopter constantly doing vertical replenishment from supply ships and even the aircraft carrier in some case to other vessels inside the fleet. So she is, by definition and with pride, a workhorse of the fleet, keeping all the ships well supplied, as well as performing critical missions like ASW warfare. Here's the MQ-25 Stingray. This is an unmanned aerial vehicle used for refueling aircraft. It's been in development forever. I've seen reports where it is operational, and I've seen reports where it's not. So I'm not 100% sure what the status of this thing is, other than it should be operational by the time you hear this. And this is used, again, just to refuel the airplanes that are coming off the aircraft carrier. Before this system came online, that job was performed by an FA-18 with large external gas bags on board and a little drone like you see here, a little hose that other airplanes would come up and refuel with. And what that did was that took one or more of your F-18s out of your air wing and kept them from doing missions, because they had to do this refueling mission to support everybody else who was flying missions. Well, the MQ-25 Stingray is doing that refueling mission now, and it can autonomously do this mission, take off, do the mission, and then return to the carrier, land safely, catch that 3-wire, and do it all with AI. No human intervention at all, other than some simple communication commands if it needs it. But it's completely autonomous. Very cool technology. All right, final thoughts on the Gerald R. Ford class is this is really an incredible ship. It really is. It's not just about how big it is, even though that's quite a feat. We've built something here in the United States that no other country has done yet. This over 100,000 ton, behemoth of a ship. But with that size brings more capability in terms of air wing and offensive air power, in this case 20% more to each aircraft carrier. And we're getting our second one in 2025, folks. And we're going to get a new one, an additional one every 5 years after that. This is really great. The electronic email system for catapulting airplanes off the ship is great because that is lower maintenance, it's more reliable, and it can launch more aircraft without having to generate excess steam from the power plant on board. It just uses electricity, which greatly simplifies its operation and its maintenance and its manpower. So some of the downsides: this is the most expensive ship ever built, ever for a single ship. It was behind. It had lots of problems. It took about nearly a decade to get the thing working properly. It has a lot of new technologies on board, one of which was the emails program, but there's other smaller technologies that we didn't really go into that had to be tested. And that's what caused all the delays and cost overruns. But we're dropping 12 to $13 billion on each one of these now, but we are producing them, or delivering them, I should say, on 5-year intervals versus the 10-year, nearly decade it took to get the first one out. The UAVs are going to add to the capability by taking, that F-18 away from the refueling program, allowing more or every single fighter attack aircraft on board to perform that fighter attack mission versus conducting refuel missions for the rest of the air wing that I'm sure no pilot wants to do. They want to go out and do, their fighter role. They don't want to be a tanker. So the UAVs are a huge part of that. And this additional electrical generation is key. Do not forget about this. We will be installing direct energy weapons on our ships. The LPDs already have them, although those are one-offs and test systems. The Constellation, the Gerald R. Ford, and maybe the Arleigh Burke, if they have space for it, will eventually get direct energy weapons. And it's because they have this additional electrical capacity to power those. This is an incredible ship. It's incredibly expensive. It took an incredible long time to build. But now that we have these and we're producing them every 5 years, it's going to ensure that the United States Navy stays the most powerful Navy in the world in our lifetime. Thanks for listening, everybody. Welcome to the Halifax-class ship brief. This ship has been the backbone of the Canadian Navy for over 30 years now. They built 12 of these, and they're all still in service. But they did get an upgrade in 2010, and for 8 years they upgraded all 12 hulls. So these combatants are going to be gradually replaced over time, but for now, they are the mainstay of the Canadian Navy. They have a great sensor suite that we're going to go over today, and a medium scale or good anti-surface punch, as you'll see. They have some surface to air capability, but are primarily a shallow water, ASW focused patrol boat that patrols the Canadian shores and occasionally joins the United States fleet in fleet maneuvers over in the Pacific and NATO operations in the Atlantic. This ship entered service in 1992. Let's start with the weapon system here. We have the Bofors 57mm on the bow. That's the primary gun component of this ship. They have twin Typhoon remote weapon systems, 50 caliber weapon systems, port and starboard of the bridge there on the front. The Harpoon launchers are amidships near the smokestack and air intakes. They have the 3x8 vertical launch ESSM systems, which are the medium range surface-to-air missile threat component of the ship. They also have twin torpedo tube launchers. They shoot the 324mm lightweight torpedoes out of these launchers that are topside. And above the helicopter hangar is a phalanx close-in weapon system. As for sensors, she has quite the array, very impressive after her modification and modernization in 2010. Beginning on the bow, we have the L3 electrical optical IR sensor, used for scanning and tracking targets in those spectrums visually. The Saros 200 fire control radar. The Smart S Mark II surveillance radar is mounted on a small tower right above that, behind the bridge. The large mast carries the most antennas. First is the Raytheon navigation radar, the Sirius IRST. At the very top, we have the Sea Draft 180, which is a improved version of the Sea Draft 150 commonly seen on other ships. The ELSRA 9S9003A, which is a radar ESM countermeasure. Below that is the ECM, which is the Ramey's SLQ 503. The mast decoy launcher is mounted on the deck right below this tower and is controlled by the ESM sensors. The Cirrus 200 fire control radar is mounted aft on top of the helicopter hangar there, right behind the CIWS. And there's a C-148 Cyclone helicopter in the helicopter deck, and the Cantas sonar, which is a Canadian towed array sonar, the SQR-501. On the bow, accompanying the towed array sonar, is a hull-mounted SQS-510. So this is a all-round multi-purpose frigate with a primary focus on anti-submarine warfare, but is quite capable in surface warfare and anti-air warfare in a limited defense measure. They're all made in Canada. One is at St. John's Shipbuilding, and the other is at Davie Shipbuilding. The Halifax-class frigate by the numbers. This is a co-dog structure. That's combined diesel or gas. It can't run both at the same time, so it's one or the other. Her gas turbines are the LM2500. She has two of them, and she has a diesel engine. It's a 20 PA6V 280 diesel that is coupled to both shafts when it's running. She displaces 4,700 tons at a full load and comes in at a 440-foot length, 53-foot beam, and drafts about just over 7 meters rather. 29 knots is her max speed. She has a 2x8 cell vertically launched RIM-162 Charlie ESSM surface-to-air missile. This will be upgraded from Block 1 to Block 2, and we'll go over those differences here in the lecture. She has 2x4 canisters of Harpoon Block 2 anti-ship missiles. Those are the improved Harpoons. And she has two double torpedo tubes, one facing port, one facing starboard, that shoots the Mark 46 Mod 5 lightweight torpedoes. Phalanx Block 1 Bravo CIWS, and two mini Typhoon RWS weapon systems, which are 50 caliber, also called 12.7 millimeter. You may see it that way in some documents. The CH-148 Cyclone helicopter is a very good anti-submarine helicopter, but can perform other duties as well. She has the Smart S Mark II surveillance radar, supported by the Saab CDREF 180 surface and air search. The Raytheon navigation radar helps keep her safe in shallow waters near shores. She has two Saab Saros 200 fire control radars, one forward, one aft. She has Thales Sirius IRST and the L3 Westcam CEOS electrical optical infrared surveillance system on the bow. The Westinghouse SQS-510 hull-mounted sonar array is an active passive sonar array, and she has a towed array called a Cantas, which is an SQR-501. The Cantas is very similar to the American TB-16 in terms of capability, and we'll go over those frequencies and capabilities in this lecture. The ELSRA NS9003A is a radar ESM sensor suite, and this is coupled with the Lockheed Ramey's SLQ-503 ECM. ESM and ECM work together. One is a countermeasure, one is a support measure. The Lockheed Martin CMS-300 works with that, and the Rheinmetall mass decoy launcher is deployed based on the radars that is being received by the RESM sensors. In other words, when they are under radar attack, say from an incoming missile that has radar guidance in its terminal phase, that will deploy these decoy launchers when it's detected by the ESM. They also deploy the Nixie SLQ-25 Alpha, which is a towed acoustic decoy. This is designed to distract torpedoes that are coming at the ship so they don't hit the ship. They just do circles around the decoy. Here's the LM2500 gas turbine manufactured by General Electric. It's derived from the GE military TF-39 engine, and it is a two-shaft axial flow simple cycle engine. The big thing about this engine is it produces over 25,000 kilowatts and weighs less than 5 tons. The power to weight ratio is magnificent. It's also easy to replace and work on in a maritime environment. The Smart-S Mark II air surveillance radar is a 3D volume air and surface surveillance target designating radar that operates in the 2 to 4 gigahertz band. It's instrumented out to 135 nautical miles for air targets, 43 nautical miles for surface targets, and does complete 360-degree coverage. It can track up to 750 targets at a time and has an accuracy of up to 20 meters. It IOC'd in 2007 for the Canadians. The Sea Giraffe 180 Surface Search Radar. Now, this is a medium-range, multi-purpose search and track two-dimensional radar. It is an upgrade from the 150 configuration because this one improves detectability and tracking of low probability of intercept targets. So more stealthy targets are more likely to be detected and tracked with this Sea Giraffe 180 Surface Search and Air Search multi-purpose radar. The C-band or G-band is where it operates, which is 4 to 6 gigahertz. It has a range of 81 nautical miles, covers 360 degrees, and is capable of tracking 50 surface contacts and 30 air contacts simultaneously. It IOC'd with Hull 1, the Halifax, in 1992. Here's the Saros 200 fire control radar, created by Saab. It is a multi-sensor, meaning that it uses radar and optics to control and detect targets and then pass that data to the weapon systems. It operates in the NATO J and K band or the H and I band, depending on what mode it's in, which is everything from 15 gigahertz down to 8 to 12 gigahertz for the X band. The range is out to 54 nautical miles, covers 360 degrees because it's got 2 of them, one forward, one aft, and IOC'd in 2003. The Sirius Long Range IRST. This is the infrared search and track system. It's designed to operate with the evolved Sea Sparrow missiles. This will be assisting the guidance of the ESSM surface-to-air missiles that are being launched from those VLS-mounted midships. Scan rate's 60 RPM, so it can spin quite quickly. Detection range for sea-skimming missiles or targets is going to be 26 kilometers. That's for supersonic. For subsonic sea-skimming missiles, it's going to be about 12 kilometers. And for fighter aircraft, it's around 17 kilometers. Take all those ranges really with a grain of salt. The ULSRA Radar ESM is manufactured by ULSRA Electronic Systems Limited. It's integrated into naval electronic support systems like ESM and ECM suites. This is the digital version of the NS 9003 ESM. It does have 360 degrees of coverage and covers a frequency from all the way down to 1 gigahertz up to 18 gigahertz for both ESM support measures and ECM countermeasures. The emitter capacity is less than 10,000 sets of emitters and has an accuracy of 2 degrees. It IOC'd in 1979. It's an older system. The SLQ-503 Ramses ECM, manufactured by Lockheed Martin, Canada. The RAMES stands for Reprogrammable Advanced Multimode Shipborne Electronic Countermeasures, or ECM, and it's associated with the NS 9003 ESM. It provides coverage for 180 degrees and is pulse, peak, and continuous wave. Its dual capability and multi-mount jamming has the ability to timeshare against multiple targets approaching from different directions. And that's kind of how it works. It works together with all of its different sensors to timeshare targets. This IOC'd back in 1975. Time sharing of your sensors with your trackers was very common back then. It's something we had to deal with in the Navy with our older fire control and sonar systems. There simply wasn't at the time, this is the 1970 era on a 2000s ship now, where you would have more targets than you had trackers. And that's kind of the limitation that we're seeing here. The SQR 501 CANTAS, that's the Canadian Towed Array Sonar System, is a VL, very low frequency, passive towed sonar array. And she operates centered around 12 to 200 kilohertz which is a very large acoustic band, honestly, but centered right around 30 kilohertz. The bearing accuracy is plus or minus 1 degree of the selected range scale. So if you're at 10,000 yards, 1% of 10,000 yards for its active sonar system. She has both shallow and deep water modes, and this sonar system IOC'd in the 1980s. Here's the MASS decoy launcher. Primary contractor was Rheinmetall. MASS stands for a multiple ammunition soft kill system. So it's just decoys out there, trying to decoy away weapons and stuff that's coming at the ship. It's 130 caliber mortar system, essentially, can fire multiple rounds at the same time, multiple decoys at the same time. And these include IR decoys, distraction, seduction decoys, and have multiple different capabilities depending on what they're trying to decoy from the ship, like anti-ship missiles, things of that nature. This IOC'd back in 2002. Here's the RGM-84L Harpoon Block 2. This is a subsonic anti-ship missile, been around for ages. Has max range of 67 nautical miles, has a 221 kilogram high explosive warhead, and it is turbojet powered after its rocket boost launch. And this version, the Block 2, IOC'd in the 2000s. Here's the RIM 162 ESSM. This is the evolved Sea Sparrow missile. This one has a range of just under 30 nautical miles, so that puts it firmly into the medium range category. But they have a limited number of these, port and starboard, and 2 vertically launched launchers. This is a supersonic Mach 3 missile. The warhead is only 39 kilograms of blast fragmentation, but that's designed to shoot down, fragile, whether it's missiles or aircraft out there. It doesn't need a large warhead. It is semi-active homing, which is why you have those radars, fire control radars, forward and aft. And this IOC'd in 2004. Here's the Mark 15 Phalanx Block 1 Bravo. This is very common and popular close-in weapon system among American ships and many Allied ships as well. It's based on the Mark 61A2 Vulcan rotary cannon. Shoots over thousands of rounds a minute, has a magazine of 4,500 rounds for this current version, an effective range of about 1.5 kilometers. It can search and track and use optical guidance for tracking a target and engage it with its rotary cannon, firing 1,500 rounds a minute. This IOC'd all the way back in the 1980s and has been steadily upgraded over time. The version we have today is a little more capable than the version we had in the 1980s. One of the bigger additions is the addition of electrical, optical, visual systems that can guide the close-in weapon system. So it doesn't only depend on radar at this point. Here's the Bofors 57 millimeter gun, manufactured by BAE Systems. It's a 57 caliber gun, has it's radar directed, and has capable of firing 3 programmable ammunitions. So we have point detonating on impact shells, we have proximity shells, and programmed modes, which do special things. It has a 16-kilometer range. They keep 1,000 rounds on board in the magazine below decks, and this weapon IOC'd in 2003. Here's a CH-148 Cyclone helicopter manufactured by Sikorsky. It is a twin-engine, multi-role, shipborne helicopter. Operating speed is 165 knots. Surface ceiling is just over 11,000 feet and has a range of 444 nautical miles. The sensors are the L3 HELRAS sonar system, the Telephonics ISAR radar system, and also includes ESM and laser warning and IR jamming systems on board. It is a multi-role helicopter that focuses on anti-submarine warfare, which is the primary mission of both this helicopter and the ship, but the ship is capable of a multi-role mission. Carries 2 Mark 46 lightweight torpedoes or a 7.62 millimeter machine gun. This version of the Cyclone helicopter IOC'd in the 2018, relatively recently compared to the rest of the ship. All right, the Halifax-class, final thoughts of this ship. It is exactly what Canada needed in the 1990s. They were replacing the older Iroquois-class frigates, which were, aging out. They had been in service for many decades, and now the Halifax-class, after 30 years and one life extension called the Flex or Felix, is aging out as well, and it is time for this ship to be retired and replaced with the new OPV, which we'll be doing a lecture on here shortly. So look forward to that. But as far as this ship goes, it is extremely capable. It was a perfect fit for the time for Canada. They needed a frigate-style ship that could do multi-role, but focus on the anti-submarine portion, because that was the perceived threat during the development phase of the ship, which was the end of the Cold War. And that's what they got. And for 12 frigates in such a large coastline, they were able to get the most for their buck. So this was a very good investment by the Canadians, and it served the country for, well over, 30 years now. And these all plan to be retired in the 2030s by the new Canadian surface combatants that are coming in. And we have one of those lectures coming up called the OPV, which I think you'll enjoy. So look forward to that. And final thought on the Halifax-class is that it is a good ship. Well done. Thanks for listening, everybody. Welcome to the Harry DeWolf Ship Brief. So this is Canada's first line of defense in the Arctic. Is how the Canadian military and government promotes this vessel. The Harry DeWolf-class is an Arctic offshore patrol ship that is designed to patrol the very icy and cold waters. It has a medium reinforced hull, which means it won't tear open the first time it strikes some ice, but it also is not a heavy icebreaker. It is in that medium category, but it is designed to work year-round around the coastline of Canada, much of which is in very cold and frozen waters. And that's the purpose of this ship. The ship was built in Irving Shipyard in Halifax. It is a lightly armed ship, as we'll point out today. Keep in mind, this ship is in the Royal Canadian Navy. This is a warship. It is the first line of defense, as they constantly repeat that mantra during the commissioning of these ships, reminding the people that Canada does have a surface action navy. But the weapon systems on board this ship are very limited. Alongside that, though, they do have a multi-payload option. They can bring on shipping containers that can do different missions and different types of things. So in the United States Navy, we have shipping containers that contain SM-6 missile launchers. That is not the purpose of this ship, and it does not publicly use those type of containers. But those same containers do also support an underwater survey mission and are also about the same size, shape, and weight of landing craft. So this could be an Arctic transport vessel as well. And that is one of the secondary missions of the ship, apparently not widely publicized, is that it has the ability to carry pickup trucks, ATVs, snowmobiles, and provide rapid transportation for personnel, troops, Coast Guard people over land and ice all around Canada. So this would be a Royal Canadian Navy warship that is lightly armed with a primary mission of transport and surveillance over direct combat. Keep that in mind as we go through this. The ship entered service in 2021. They're going to have 4 total. They have 2 already. All right, so this is an Arctic offshore patrol vessel. What does it do? It provides Arctic security around the borders of Canada, seaborne surveillance, search and rescue. So a lot of the missions that the United States Coast Guard does would also be performed by this Canadian ship in a law enforcement assistance manner. There are some legal problems with a military unit conducting law enforcement missions. So in this case, by definition, it is just a law enforcement assistance ship, but it has a lot of systems and capabilities that a Coast Guard vessel in these harsh Arctic environments need. So they're going to provide logistical support, sovereignty protection through surveillance, aid to civil power. Moving people around in the Arctic is, there's places that are just completely isolated in the midst of winter. So ships like this can get in a medical emergency, for example, or if there's a power failure emergency, bring supplies to people in need during those times. But while it's doing that, Canada is claiming that this is also providing maritime domain awareness, Arctic security for Canada, which I question, which is why I bring that up. So here is the sheet, if you will, for the data sheet for the ship. It does have an all-purpose operational space. It's like a CIC. It's behind the bridge on the same level. And that's where they have the combat management system developed by Lockheed Martin Canada that connects all the sensors to the weapons and communication to people that go off board on boats via radio. That connects everything, including the very capable helicopter, the CH-148 maritime helicopter that goes with it, that comes with this ship. It's going to connect those sensors and communications together. It's quite good. In the back, you can see it has a 20-ton crane that is used to onload and offload vehicles, cargo payloads like we talked about. And those cargo containers can contain anything. And some of them do contain underwater sonar equipment and surveillance equipment. Some in the American Navy carry weapons. It can be anything that they want. And since they have the Lockheed Combat Management System, it can use most of the American containerized weapons. That's not public. They don't put that out there publicly, but it is a capability that is on board this ship should they choose to use it. It does have a diesel electric propulsion that we'll get into. It's two 4.5 megawatt main engines. The engines on board this are quite impressive, I'll be honest with you. It does have retractable active fin stabilizers as well as bow thrusters. So it's a very maneuverable ship. You'll want things like this in your Arctic patrol vessel because of ice and low speed maneuverability and stability is very important. It does have a BAE Mark 38 25 millimeter gun. And that's the main armament of this ship. You could also consider the helicopter an armament of this warship, but this helicopter is designed for ASW warfare and surface surveillance, not direct tactical combat. There are talks in the future of maybe adding some weapon systems to this, like the Hellfire missile, for example, but that is not confirmed and hasn't happened yet. So, as it stands right now, the main armament of this warship is a single Mark 38 25 millimeter gun on the bow. Now, she does have multi-role rescue boats. Those are often called ribs in the United States Navy. They're about 8.5 meters long. Center console with, you can have some men on board. Those men can, be Coast Guard, and they can also be Special Forces troops, transporting them around in the Arctic. And then finally, at the very top, again, we have the bridge that kind of coordinates all this with the multi-purpose operational space that's right behind them. And I'm going to show you pictures of all these. All right, so here we go. Let's talk about the weapons and sensors on board this ship. Mark 38 gun is on the bow. It looks really small on this ship because it is a very small 25 millimeter gun. On the top mast, we have search radars and the Sharp Eye Kelvin Hughes radar. I have information on both of those. We have multi-role rescue ships. Like I said, this is going to be a Coast Guard adjacent assistant ship in these harsh environments. Working up here in the Arctic, especially in wintertime, is very hazardous, and a specialized ship like this is required for safe operations in this environment. She does have twin, or two, I should say, not twin, 12.7 millimeter guns, one port, one starboard, for small caliber, offensive and defensive capability. And then at the very aft end of the ship, they do have the 20-ton crane that they would use to offload and onload anything from the ice or even ashore, on a pier maybe, onto the ship itself. And that is what would be used if they wanted to use containerized equipment. It would go right there on the flight deck. All right, these are made in Canada. These are all indigenous in the Irving Shipyard. It's located there on Prince Edward Island at Halifax. I've been to Halifax. It's very nice. Harry Default Arctic offshore patrol vessel by the numbers. They have an integrated full electric propulsion system with 4 main diesel generators, 2 GE power conversion induction motors, 2 shafts, and 1 bow thruster. It weighs or displaces 6,400 tons when it's under full load with the helicopter on board. It is 103 meters long with 19 meters beam, that's wide, and drafts 5.7 meters. It has a large freeboard ahead of that. It's obviously it displaces much less water below than above in terms of, it's a very tall ship is what I'm trying to say. And I imagine that must make it challenging in windy conditions, which obviously when you have no trees, the Arctic can be very, very windy at sea and over the ice especially. So I can imagine that being some sort of a problem, which I'm sure is why the bow thruster is so vital here, just to maintain position and not be blown around. You're going to want to have thrusters like that helping you out. The max speed is only 17 knots, which is ridiculous for a warship, but it is right in line with a civilian ship, which, by the way, this hull is based off of. This is simply a modified civilian ship. They put a gun on it, combat systems on it, and they made it and they commissioned it into the Navy, to put it simplistically. It's still a warship. It has a gun and a helicopter and some 50 cal guns. It has a 6,800 nautical mile range at its max endurance speed, that's respectable. That's good. The BAE Mark 38 Mod 2 gun and two 50 cal guns, one port, one starboard, and the Cyclone helicopter, CH-148, which is a good helicopter for anti-submarine warfare especially, are its main armaments. Now, on the sensor side of the house, we have the Terma Scanter 6002 air and surface search radar. There's a second navigational radar, which is the Kelvin Hughes Sharp Eye, a little bit higher resolution, but not as long range. You're going to need that to see the ice flows coming at you around. It's got that level of fidelity. That's all connected to the Lockheed Martin Combat Management System 330 that's made by them, that communicates with all Royal Navy ships and submarines and aircraft and allied nations as well, like the United States. SATCOM Link 16 is a data link for sensors and radars. The SAGEM Blue Natural Navigational System we'll talk about. OSI Maritime Systems Integrated Bridge Navigational System is on the bridge up there for navigating through those ice flows up north and all around navigation in general. And it has a 20-ton multi-purpose crane on the back. Like I said, now let's talk about these sensors and propulsion systems specifically. Here is the integrated full electric propulsion. And this is what I find to be one of the more impressive things on board this ship. Ships now being built now for just over 10, 15 years have, in most modern navies, integrated full electric systems into their power plant. So this is becoming the standard now. And I'm very happy to see Canada is keeping up with everybody by integrating this type of rugged induction propulsion system. So it has, less failures at sea. It's got, it's more reliable. It's more efficient. That 6,800 nautical mile range is very good. It generates 9 megawatts, which is respectable, using 4 diesel generators and 2 electric motors, spinning the 2 4-bladed screws that you see there, as well as the bow thruster up forward. Here's the Scantar 6002 surveillance radar, manufactured by Terma. It's an air and surface search tactical 2D radar, so it gives you range and bearing. It is X-band, 8 to 10 gigahertz. Max range is 96 nautical miles, and to the horizon for surface contacts would be 17 nautical miles. It can track 500 some surface contacts, 100 air contacts, and the scan rate is up to 48 RPM. That's the thing physically spins because it's a solid state transmitter and it's up there spinning around. Been in service since 2012. It's a good radar. Now the Sharp Eye surveillance radar, this is going to be the little more high resolution. It has a max range of 48 nautical miles, uses pulse compression, low probability of intercept. This is your military radar. So it's got military radar and military weapons. It's a Navy ship officially. And it will use this if it was ever trying to be inconspicuous, which is a little funny for a ship that's physically this large. Out of the water broadside, this thing would stand out like a sore thumb. But you could use this radar, and this radar will give you a better picture of close-in contacts than the other radar. But you would be running both these at the same time. They would not interfere with each other at all. This radar has been around since 2006. Obviously, it was on the first Harry DeWolf in 2021. Here's the CMS 330. This is a very good combat management system, coordinating sensors, targets, classifications, and then sharing that information, not just with other people on board, but with other platforms overhead, submarines at sea, even in other navies like the American Navy. This is a very good integrated combat management system, but think of it as a contact management system. It's a very good way to designate targets, and then if you need to engage them, who's going to engage what with what weapon. That all gets done seamlessly with this system. So if they're at sea, for example, and they have a maritime patrol aircraft overhead, they could see the radar picture in terms of contacts and designations and tracks of that radar on their screens here, as if it's their own radar, even though it's not on board. That's a great example of how this works. It's all open architecture. It has 3 modes: automatic, semi-automatic, and manual. That depends on how much intervention do you want the humans to have. You could completely make this automated, where it detects a contact, it assigns a tracker number to it, and it begins sharing it right away. Or a more realistic and practical way is to have a human in that loop, which would be like a semi-automatic, designating targets, verifying classifications, and then sharing it. And then you could do manual, where you're just doing it all yourself, which would be much more accurate, of course, but it would be a lot slower. And the reality is, the way most navies operate now is in semi-automatic mode. I've never, as a submariner, been in automatic mode, because you don't ever put anything in automatic. But this is a surface ship in another navy. They may actually use that. I'm not sure. It does have a synthetic environment advanced combat operator training CCOT system, which means you can inject training targets that look on these screens as if it's a real target out there, and then make decisions and conduct training at sea. You can be tied to a pier and then have this system appear as if you're off the shore of Halifax at sea conducting training. So you don't have to go to a schoolhouse and take up an instructor's time over there. You're on board training your own crew with your own officers on a Friday afternoon right before you get ready to go on the weekend liberty, which is, again, common in a lot of ships and submarines that I'm aware of. And that this whole system, I'll see it in 2010. Yeah, a lot of these displays are very similar to what I've seen on American ships going back that far. Here's the integrated bridge navigation system. So this is where the helm is going to be, the officer of the deck, responsible for the safety of the ship while it's underway. This is going to be manufactured by OSI Maritime Systems. It integrates all the radars and navigations onto one 3D chart where you can see all the contacts, including ice flows and stuff, navigational hazards that may be out there as you're navigating these dangerous waters. Conning display, you can have a snapshot of the engine and rudder status. That is really vital because there was a collision recently in the United States Navy, going back a year or so, where the rudder appeared to not respond to the helm's orders, which was executing the officer of the deck orders, and yet on their snapshot conning display, the rudder was not moving in the direction that the helm was spinning the wheel. So having that display backing up what the rudder's actually doing versus the helm, giving it an instruction is vital to safe navigation. Because in the case of the United States ship, and I believe it was an Arleigh Burke destroyer, they were in automatic mode. It might have been an LCS ship. But if you put the system in automatic, it's not going to take direct helm input. So if a shot like this or a display like this would help give more information to the officer of the deck and the helm to make sure that everything is responding the way that you expect it to. And there's a couple of other improves ship air integration system to reduce risk of accidents. These are like anti-collision systems or close ship warning systems that are all integrated on board. Very, very modern, very common. And a lot of these systems are also on civilian ships that this ship is based on originally. This is basically a civilian Arctic ship with combat military weapon systems and some sensors on board, including that helicopter. Here's the Mark 38 gun that we told you about. This is a modified version of the Typhoon remote weapon system. Obviously, in the Arctic, you don't want somebody out there on the gun, loading ammunition or anything. This is all automatic, and it's got infrared remote sensors, electrical optical sensors for aiming and tracking targets. It's just a small stabilized, small caliber gun. Has a range about 2.5 kilometers, not very long range at all. And it sits up, high on the bow, and can transverse 330 degrees because you have the superstructure taking up the rest of that. So it's not a complete 360. Here's the CH-148 Cyclone helicopter, and it's made by Sikorsky. This is a very good helicopter. This is one of the bright spots on this ship, in my opinion. It's twin-engine, multi-role, primarily an anti-submarine warfare torpedo-carrying helicopter. Shoots sonar buoys, has all sorts of the L3 sonar system, telephonics, ISR radar system, as well as laser warning in case they're taking fire. All these systems are integrated already on board this helicopter. And there is some talk that they may add a Hellfire capability to this model or version of this helicopter, the Cyclone helicopter, in the future. But that's still pending. Don't count on that. Just know that may be an update in years to come. They may give this air to ground capability. And that's about it. This Cyclone, I see it in 2018. You can see it there landing on board a Halifax-class warship, which is, in my opinion, a proper ASW warship. And that's it. That's the Harry DeWolf-class, guys, everybody. It's an Arctic offshore patrol ship. It has one main gun. It's got a couple 50 cal guns, one port, one starboard, and a helicopter. And it's primarily a transport ship. It can transport troops, supplies, vehicles. Has a 20-ton crane to get that stuff on and off the ship. It can transport containerized systems like underwater surveillance systems. And it has rescue boats, reinforced hull inflatables, RIBs, that it can deploy with small teams of, say, Navy Marines or Coast Guard personnel to assist in law enforcement actions. This is a odd bird in terms of U.S. or a Royal Canadian Navy warship, in that it's very underarmed for a warship, but it is a purpose-built ship for this Arctic environment in terms of support and transport. It's pretty much a support ship is what it looks like to me. But Canada continuously announces and promotes this ship as the first line of defense for Canada, which is questionable in my opinion. And we'll see what happens with them. I mean, it's not a bad ship. It's just not a warship, in my opinion. And that's the Harry DeWolf-class, everybody. I hope you enjoyed this brief. This one's kind of short. There's not a lot to talk about this, but we did want to talk about every single Canadian Navy warship and submarine, which is what we've done here. This completes the entire series for Canada, and we'll be moving on after this. Thanks for listening, everybody. Welcome to the I-class frigate ship brief. So the I-class frigate, this is the latest frigate coming out of Turkey, part of their Milgem corvette and surface ship program. It's a follow-on to the corvettes that we've already talked about in this series. This is the next step in size and equipable space. So they built 4 of the Adas. They're going to build 4 of these frigates, which is a larger ship. It will literally be hulls 5, 6, 7, and 8 in the Milgem. The first one is already built, basically. It's just not commissioned into service yet. They'll be doing a lot of sea trials this year, and we'll probably see it in service very soon. This whole system is reliant on a big thing, and that's stealth. We'll talk a lot about stealth today. This has a very low radar profile. This is essentially is the stealth, fighter, stealth bomber of the frigate fleets. So very low radar profile, and the emissions that these sensors will put out, we'll talk about more in detail, are very low probability of intercept. So the capability of this ship to move around a coastline without being detected is very high, and it serves the purpose of Turkey very well. They have a very large coastline, both on the Black Sea and inside that on the other side. And these ships can rove, stealthily if they need to. But they also pack a huge punch. They have 4 quad launchers of anti-ship missiles, 16 anti-ship missiles, which is, much more than, even some American ships have per ship, the larger ones. They do have a 16-cell VLS that shoots the HISAR 0 plus surface-to-air missile. And so it can do, air defense as well as an anti-ship roll, and do it really all without being detected until you can see it. It's really quite an advanced tech, and it's really shocking to come out of Turkey. I didn't see this one coming. It's been in development for a long time quietly, and now that they've actually built one, we can see what it's capable of doing, and it's very impressive. It's fully integrated into the Advent CMS, which is Turkey's network-centric system. They have a bunch of towers all over Turkey along the coastline and even some inland that connect all the forces of Turkey together on this private network. And this ship can communicate on that network and share data to artillery regiments, rocket regiments, Air Force, and vice versa. They can see the same targets all those services can see. So quite an integral part of the Turkish military now. This is a very exciting ship to talk about, and I'm glad we have it here for you today. So the lead ship's going to commission this year, and there's going to be 3 follow-on ships that we'll be talking about. Here's that Ada-class corvette that we've already done a brief on, and so this ship is literally just the larger version of that with significantly more weapons and a few more sensors as well. And so you can see the next 4 are coming out. It's F515 through F518. All right, here are the weapon systems. Beginning on the bow with a 76 millimeter gun, pretty standard armament for ships. Often, especially in the United States Navy, you'll see a slightly lower caliber, but Turkey doesn't mess around. They went with the big 76 millimeter gun on the bow. The 16 cell VLS is right behind that on the bow. That's that flat area. And then, of course, you have the bridge and the mast that we'll talk about next. Behind that are the 4 quad launchers of the Atmatica anti-ship missiles. They're basically like harpoons. It's Turkey's version of the harpoon, but that's not a negative. It's a modern version of it. It is a subsonic missile, very long range, and will blow your ship out of the water if it hits it. And they have 16 of them. They do shoot the Mark 46 torpedo and the new Orca lightweight torpedo that's made by Rocket Sand. And we'll talk about that. That's a relatively new weapon, so I don't have a lot of information on the Orca, but the Mark 46 is tried and true. Yep. They have 2 of the 25 millimeter Asalen's Stop RWS. That's the remote weapon system. These weapon systems are 25 millimeter guns that look out over the port and starboard sides. And if any unmanned surface vehicles are coming in on this ship, these are going to be the primary weapons that engage and destroy it before it gets hit. So warships now are being designed with unmanned vehicle defense already installed. So we've learned the lessons of the war with Ukraine and Russia, how effective drones can be. And so warships now are designed with drone warfare in mind. This weapon can engage close range surface targets. That can be a pirate. It can be, a floating buoy, or it can be an unmanned weapon scooting along the surface trying to explode a warhead alongside. This is the weapon that's going to stop that. And then behind that, they have the Sea Whiz, which is a very big double barrel 25 millimeter gun that spits out lead like you wouldn't believe. And we have some great photos of that coming up for you. All right, let's take a look at sensors. Starting on the bow, we have these fire control radars, these ARC-Ds. There's 2 of them, one on the bow, one on the stern. They each control 1 gun. One on the bow will do the 76 millimeter gun. The one on the stern will do the close-in weapon system. Okay, we have on the mast, we have the electronic warfare suite. Beginning at the top, we have the ASA radar. That's a very advanced, synthetic array radar. Below that, we have the ESM and the ECM and the EO suite. And what that does is it detects and counters and is offensive in nature against electronic emissions. Whenever they detect a radar, obviously you want the ESM at the highest point of the ship to get the most range out of that passive sensor. The ESM is going to be just collecting data, it doesn't emit anything. And that's why it's up at the top there. And then the ECM is designed to jam or otherwise interfere with that radar. And they do it very cleverly with this Ares 2SC. It's not just old school, put out power and try to overwhelm the radar. They can actually make false targets on that radar now, and they can take advantage of beamforming and create a false direction for that radar to appear to be jammed from. So home on jam will take the weapon away from the ship now. Yeah, it's very advanced. Very cool, good stuff coming out of Turkey. And this stuff is being tested now, so we're seeing it actually work, which has been kind of the thing that's been holding a lot of this back. Is like, up until now, this has all been theoretical. They're planning it, they're funding it, they're designing it. Well, they've got one built now, and it's going to go through sea trials, and it's going to be commissioned this year, and it appears to do as advertised, which is very impressive. That this is part of NATO The Turkish Navy, this is a significant leap in capability for them, this frigate here. And you can see they're going to build 3 more in 3 different shipyards. 2 things about this. They're building one right now. They're going to learn their lessons in building this first hull, improve the process, and then build it in the next 3 shipyards. So all 3 shipyards, 4 if you include the one that's building the one now, are going to get experience in building this frigate. So if they choose to go further with this program, they'll have shipyard workers who have done it before. All right, here you can see where they're building them. Istanbul, the Anadolu shipyard as well. You have Sefine shipyard and Sedef shipyard. All very capable shipyards, large dry docks, as well as a lot of pier space for maintenance activity. Turkey, whenever it comes to the Navy, is no slouch in terms of maintenance and construction as well. They're very good at that. All right, here's the I-class by the numbers. It's powered by our favorite engine in naval history, it seems, is the LM-2500 GE. This is the engine that has powered American and other NATO warships for the past 30 or 40 years. It just continues to get better because it's very reliable, very cheap, easy to fix. Everything about the LM-2500 gas turbine engine is great. It does have 2 shafts spinning 2 propellers, and those propellers are a controllable pitch, which means they can become less efficient if they want to be. So they can make turns for 15 knots, 3 knots slower than it sounds like, and that will throw off a sonarman. So controllable pitch, still a very effective tool in the 21st century. She weighs 3,000 tons, fully loaded, can do 29 plus knots, probably something more like 32. 32 is kind of the standard anymore, but public number, 29, over 29 knots. If she wants to go long range, she can limit herself to 14 knots and go over 5,700 miles, or just about that, without refueling. She has the 4 anti-ship missiles, 2 8-cell VLS that carry the surface-to-air missiles, 76 gun, as we said. We showed you all the guns topside there. 2 of the triangle or tri-torpedo tubes, 2 over 1, correction, 1 over 2. And of course, the S-70 Bravo Seahawk ASW helicopter, fantastic helicopter. These guys run that American helicopter with the ASW suite on board. It communicates and connects all of its sonar buoy data right back to the ship, where they beam for-orbit process it, and then can drop weapons on target quickly once they get it localized. On the sensor side of things, it's stacked. We have the ASA radar. We have 2 fire control radars for the guns. We have ESM, ECM for countermeasure jamming and detection. We have a low probability intercept navigation radar. And this one is important. Remember, I said stealth. The ship's all about stealth. Even whenever it's in a state of normal navigation, it is unlikely you will see this navigation radar. Unless you visually see this ship, you wouldn't know that it's coming even when you're looking for it with your sensors. I was shocked to see that they put LPI on a navigation radar, but that's how serious Turkey is about stealth. This ship is all about low radar cross-section, and the limited transmissions it needs to create for normal navigation at sea is probably not going to be detected by anyone else's ESM. This LPI, those 3 letters are very important. Has the ProCats EO system, as well as the CI EO system. That's electro-optical systems. We'll talk about those. They have the torpedo countermeasure system, the Heiser, which is very similar to a 21st century Nixie. We have a few details on that. That's all very sensitive. How to defeat a torpedo is not something they just put out there. They do have the hull-mounted sonar and the Advent CMS. It's combat management system that's integrating not only all the sensors of the ship, but all the sensors across the network that Turkey uses. Yeah, very, very powerful. Okay, there it is, folks. LM-2500 gas turbine. This one puts out 32.8 megawatts. Turbine speed is 3,600 and is on most NATO ships at this point. There's still a few out there that, Sweden likes its own thing. And, of course, anything over in Asia is making their own version of this system. But yeah, okay, so then the MTU 16 valve Rolls-Royce, very reliable, very high-end, 4-stroke diesel engine, runs at a constant 1,800 RPM no matter what speed they're going. Set your sonar systems for 1,800 RPM divided by 60, and you're going to find it right there. So that might be your first contact of the ship because of its low radar section, I'll just say. Now, obviously, if they have the ASA radar out there broadcasting, I don't know how stealthy this thing is. I don't believe it is. This is made for long-range aerial and surface detection of things. So if they've run in this, they're probably not trying to be quiet about it. Now, this thing has 360 coverage, can track 1,000 targets. IOC this year. It's being tested, like I said, with sea trials with this first haul that's happening this year. Here's the fire control system, one of two. Fire control radar, rather. This is the Aradi. This is the X-band. That's the high frequency, high repetition rate, close range. It's in the gigahertz. They have 8 to 10 and 20 to 40 gigahertz frequencies. And this is just designed to be very high fidelity, which means it gives the system a very high resolution picture of anything at short range. And then it can shoot it. And that's what it does, is it will calculate, an intercept point for a ballistic shell and just send that to the gun. It does do one target at a time, which is actually good. You don't want this thing to get distracted. You want to shoot down one incoming weapon and then move to the next and move to the next. And so these systems will work together, like the ASA radar, let's say, can track up to 1,000 targets. Let's say you have 10 incoming, 5 on the starboard side. Well, the gun on the starboard side is going to engage those 5 one at a time. As soon as it hits one, and then they'll just move to the next one. It'll get that next information from the ASA system because it's all connected via that combat management system. So that's how it works. So just because it's one target at a time, that's not a limitation. That actually means that it's focused. It's going to get that target destroyed for sure. And then it knows it's got 4 more because it's got an ASA radar or combat management system telling it, hey, there's 4 more. Hurry up with that one. 360-degree coverage because it can spin all the way around. Obviously, it'd be limited by the superstructure in some cases. And elevation is a -30 to +120. And looking down is very important. These UUVs or USVs, these unmanned surface vessels with 500 kilograms of explosives on board being remotely piloted into the side of Russian ships is how modern warfare is going to be. So it needs to be able to look down into the water, into the surface, as much as it needs to look up. All right, here's that LPI navigation radar. And you can see those 2 control boxes right there. That's the heart of it. That's what makes it low probability of intercept. So the definition of low probability of intercept is a transmission. It's going to be a pulse transmission, by the way. I don't care what it says here about continuous wave. Okay, so maybe I should be quiet. LPI frequency hopping, we're going to read the slide. It has a range of 36 nautical miles. And the public, it's an X-band radar. I know how they did the continuous wave. I get it. Let me just describe how I understand how it works, so I don't leave you hanging here. I don't like to tease and then not say what it is. So by definition, low probability of intercept is a pulse that is less than 1 millisecond. And that is extremely short. It's less than 1/1,000,000th of a second. But they do it repeatedly. They do it 1,000,000 times. So each individual pulse is not going to be intercepted. It's probably, it won't trigger the ESM into saying, oh, I just heard something, because it's so short. But they do it so often that the system can combine those 1,000,000 pulses, and I'm pulling that number out of my rear end, however many number of pulses per second, and in the beamformer of this radar, turn that into a modular continuous wave. Okay? It's actually a frequency modular continuous wave. So the frequency will be changing at the same time. So I understand how this thing works. It is a continuous wave, but what makes it LPI is that it's a very short pulse along that continuous wave. I don't know if that made any sense. I hope it did. Okay. CI electro-optical system here is a high performance. It has all the lenses, daytime TV, spotter camera, rangefinder. Being an eye-safe laser rangefinder is very important, obviously, to the operator, but they're almost all that anymore. You almost don't even need to put that in the briefing. But there are some out there, laser designators that weapons track. Those are definitely not eye-safe. So, but this one is. Problem with a laser rangefinder is anytime you use it, that's definitely going to be detected because the ESMs are set up for that now. So probably not use that often. Just know they can do it. This has the -20 to positive 105 degree elevation, and of course 360 degrees, all being IOC'd this year. Like I said, these are all new systems, and we're getting information now on how good they are, and apparently they're working as advertised. Keep in mind this information is coming out of Turkey, who is building this, testing this, and selling this. So there is that caveat. Here's the Ares 2N ESM suite built by Aselsan. Comprises of radar, electronic support countermeasures, that's ESM, and it does a 360-degree azimuth, covers all the way up to 18 gigahertz. What's important about that is, remember, some of our countermeasures go all the way up to 40 gigahertz. So this one is in the 2 to 18 gigahertz range. So there we got 0.01 is that picoseconds to 100 milliseconds pulse length. So that's the sensitivity of all the way that it's looking down to. So that's designed to look and find LPI emissions. So very good. It has a I believe that's a pico system, to 20 millisecond repetition range. Yeah, so it definitely has a chance to detect LPI. Okay, that's what they're saying there. Very good stuff. So it uses LPI, and it's also looking for LPI to make sure nobody else is out there pretty much doing what they're doing. All right, here's the ECM suite continued. This one is, this is the ECM countermeasure suite. This is RF radiation-enabled deceptive noise jamming techniques. What they do is they bend the beams in directions so they can appear to be jamming from different areas. So this will throw off any kind of home-on jam weapon. That's very advanced and very, I would say, recent. Digital radar frequency memory, or DRFM, for modern coherent threats. Stabilized high-gain directional horn antennas are in the radome. So they're covered up there. That's what those little balls look like. But inside there are these directional antennas, and he's describing them as the horn style. And these go up to 18 gigahertz. And check this out. The ERP, the pulse power, the radiated power is 80 decibels. That's like getting punched in the face. 80 decibels is an actual amount of force that you could probably feel. Like, imagine active sonar at 80 decibels. The diver would not only hear it, but he would feel it. So this is in a different density medium, being the air. So, but still 80 decibels is a significant amount of power. And if they can direct that into directional beams, it could almost knock a missile down, or at least, push it in a small way. And what that would do to the electronics in the missile, it would be devastating. It would fry the electronics for sure. But we're getting to the point to where we're actually exerting physical force on incoming weapons at this point, at those power levels. As long as they're focused on a beam, that would be quite something. All right, here's the Heiser torpedo countermeasure system. It's built by Aselsan and does localized torpedoes. The cool thing about this is this one did do a sea trial that we do have some data from. But let me describe it first. It's basically a towed array that you tow out behind you, and there are some countermeasure launchers topside that all work together. So the towed array does a couple different things. One, it detects the torpedo. That's your primary sensor. And then it also works to decoy that torpedo away from the ship by luring it onto itself. So you have the detection array, the torpedo decoy, the signal processing unit, of course, the user console, and then the launcher's topside. It has a low frequency of 3 kilohertz. I believe that's passive. If they do have an active transmitter on that, 3 kilohertz would blind most torpedoes. Let's put it that way. It wouldn't necessarily seduce them. It depends on how they use it. But they did use this in sea trials and detect a DM-2A4, which is a modern torpedo at 10 to 12 kilometers in trials. So that's really good because the DM-2A4 is sold and presented as a very quiet torpedo. And if they can detect that thing at that range, this is a very capable system. And it has a 800 kilometer tow cable. So it can be towed far behind the ship, if they want to. Of course, you can adjust that to be any length you want. But the low frequency 3 kilohertz is interesting. I assume that's active and passive. Passive would make sense if it's 0 to 3 kilohertz. And if it does a 3 kilohertz transmission, that's right in the window of a lot of weapon systems, torpedo weapon systems. So it could be used to either blind them or cause a false target for them. All right, let's move on to the Mark 360 Serbach, this is by BAE Systems. This is the chaff launchers that are port and starboard. They're 6 130 millimeter launchers. They're hand loaded, reloaded, just by, dropping in another replacement after one's gone off. I wouldn't want to be standing next to one of these when it ejects, but yeah, you can just walk up there and just replace it after it's done. And they have some of these port and starboard. And you can notice the angle. Some are set off at a 45-degree angle and some are at 60. Obviously, that's to get larger range of coverage on the bloom. And it's used by navies all over the world. It says here 19 navies. Yeah, the United States Navy uses this type of system. All right, here we go. Here's the hull-mounted sonar system. This is where I would be most comfortable sitting at this console, running this thing. It's a mid-frequency anti-submarine sonar, both active and passive mode, as well as a mine avoidance mode, which is very important. In wartime now, we're going to be running mine avoidance constantly because mine warfare, we've reinforced the belief that it's effective because it's been effective in the Black Sea. And so now everyone's back on, oh yeah, don't forget about mine avoidance. You can have the best ship in the world. You run into a mine, it ain't going to matter. So target capacity is 32 active targets, 8 in passive mode. It's interesting that they have a passive mode. Well, that's not everybody has a passive mode in mine avoidance or high frequency sonars like this. But good luck finding a mine in passive mode. It can be done, but it's about time you hit it. Active sonar frequency is going to be 5 kilohertz, 9 kilohertz. That's actually pretty good. Frequency for passive is going to be 3 kilohertz to 12 kilohertz. Not surprising for a small cylindrical array. These frequency bands are effective, but not as effective as... This is not a dedicated submarine hunter. That's all I'll say about it. It is capable of ASW warfare, but it is not fully capable, in my opinion, if these numbers are true. And they probably are. It's probably a size limitation. This is a small ship compared to the larger, say, Utiloys that have the larger, horse jaw systems that are the size of a small building, versus this thing is probably just a few feet tall. Range scales all the way up to 36,000 meters. Which, if you're in deep water, CZ, you could have a mode like that. What that means is they can just put out a lot of power at 5 kilohertz and hope to God they get something back. The only thing they're going to be finding at that power level is the bottom, but they may find a small mountain that's a long ways away. Let's talk about the 76 millimeter gun mount. ILC'd in 2000. Yeah, this is not a new system. Lightweight, reliable, negative 15-degree elevation, very important for shooting down on those incoming unmanned surface vehicles. 80 rounds a minute. 16-kilometer range is a ballistic limitation of like most of these guns. Can shoot a burst, like a shotgun round, at 8 kilometers for air targets. Muzzle velocity is 915 meters per second. That's pretty slow. I'm surprised at that. It's not higher. And it weighs 7,900 kilograms. So yeah, just a reliable... I've seen this on other Italian ships, and it's cheap, reliable, easy to maintain. Doesn't jam as much as the other competition guns do. So there's the 76 millimeter gun. Let's talk about this anti-ship missile. This is basically Turkey's version of the Harpoon. They probably don't want me saying that, but it's the truth. If you look at it, it's a Harpoon, right? You could also maybe make a fair comparison to the Exocet, which may be a little bit closer because they probably worked with Exocet engineers making these, to be honest with you. Anyway, it doesn't matter. It's Rocket-San is the company that makes these, and they make a lot of weapon systems. They make a lot of missiles. They make torpedoes now. Rocket-San is the company that Turkey uses for a lot of these systems. So 750 kilogram has a 220 kilogram high explosive warhead at a range of 220 kilometers. There you go. That's very easy to remember. The range and the size of the warhead are the same number. One's in kilograms, one's in kilometers. Subsonic at 0.8. Yeah, this is an Exocet. This is what this is. All right. Propulsion is a microturbo TR40 and could be replaced with an indigenous turbojet engine. Yeah, just like other countries, Turkey's really pushing hard to build everything in-house. And that's a lot of what this system is. We've talked a lot about that during the previous Ada-class ship brief. Big tip of the hat to Turkey to taking these systems, whether they're Harpoon or Exocet inspired, and then designing their own version of it to the point to where they're using their own turbojet engine. It's not just their own design, and they're not just building it in their shipyard. They're also building, in the future, the engine that will push it. Everything is going to be in-house eventually. Anyway, overall, very reliable system based on reliable missiles, Harpoon and Exocet. Okay, here's HISAR-D surface-to-air missile. Again, Rakuten VLS, this is the mid-last. They have many versions of this, at least 3 that I know of this missile. There's probably more than that. So this is the naval variant of the surface-to-air missile, defense missile. It's going to shoot down airplanes and incoming missiles. It has INS, IIR, which is infrared, and a one-way data link guidance, which basically the radar will tell the missile, hey, a little more to the left, a little more to the right, and then boom. High explosive blast fragmentation, designed to put up a cloud of, metal that the missile is destroyed in, the incoming missile is destroyed in. Dual pulse solid propulsion propellant engine. I believe that's for efficiency, so they can make it smaller and go farther. And then operational range is greater than 25 kilometers. So this is going to be primarily, a defensive weapon. They're not going to be shooting these very long range and then hitting something like a land target. And the only reason why I bring that up is that's what Russia's doing now with a lot of their surface-to-air missiles, is they're using some of them to attack land targets. So that's not what this would do. This is a short range. It's going to defend the fleet, defend the ship, less than or about 25 kilometers range. All right, here it is. Here's the Sea Whiz. This thing is a monster. It's 35 millimeters. This thing's thick. It's got 2 barrels. It's 3D search radar with its own fire control radar, as well as electro-optical sensors. Has a range of 4,000 meters. Rate of fire is 550 rounds per barrel, so 1,100 rounds total, 2 barrels. Ammunition is the Atom air burst ammunition, so it doesn't have to hit, nose-to-nose bullets. These rounds are going to air burst, like shotgun shells, and just tear up whatever's in the vicinity. So doesn't have to be as accurate, but it'll be much more effective at this high rate of fire and with that air burst capability. It's all controlled by the CMS, Combat Management System, and it's used on the corvettes or Turkmenistan's corvettes rather, and Pakistan's Babur-class corvettes as well. I believe we have a lecture on the Babur. Anyway, it's been in use since 2021. And the big thing about this is that ammunition atom round. That really makes this thing effective, in my opinion. All right, here's that Mark 46 Mod 5 torpedo. This will sink anything in the Black Sea as far as submarines go. So this is all they need. When I saw this, I was a little concerned they didn't have the Mark 54 or even the Mark 50, which is super expensive. They have the old school Mark 46, but it makes sense for Turkey to have this one. It has the Mod 5 upgrade, so it's a very smart torpedo, but it has the Mark 46 chassis and engine, which is very efficient and low cost. So it's kind of the best of both worlds here. It will sink anything in their region. This is a region-dominant anti-submarine torpedo. It can be surface ship launched, as you see here. Also air launched, because they have the helicopter. They can drop this off of that. It's a high-speed, lightweight anti-submarine torpedo. Has a 230 kilogram warhead, which is enough to punch a hole in the submarine, which is all you want to do with this. It's not going to be blowing the submarine in half. It's going to blow a large hole in it, and that submarine's going to sink, and the ocean will do the rest. That's the purpose of this. Does 45 knots. I'm surprised that they have that. But there you go, 45 knots. And the warhead is, I'm sorry, the 230 kilograms was the total weight. The warhead was 44.4 kilograms HE, which punches the hole to sink the submarine. Okay, it is both active and passive guidance. Works in both. I've got first-hand experience on this thing. Obviously active is much more reliable in terms of hitting your target and getting there. You are able to fool this weapon if it's in passive acoustic mode, but with the Mod 5 upgrade, I'm not sure. Maybe I'm sure they've improved that. So anyway, just know that it can do both. Now, Orca lightweight torpedo. I don't know anything about this. This is a new weapon for me. So this is from Rakuten. This is the Turkish military company that's building all their weapons, like missiles and stuff. They're also doing torpedoes. Still in development, high speed, fully autonomous, active, passive. It's got a very long range, greater than 25 kilometers at greater than 25 knots. We're falling into heavyweight torpedo range if those numbers are true. But this is a lightweight torpedo launching system. So we'll have to wait and see about that. All right. This is almost like, this is their sales pitch, I think. It's got a shaped charge. Now here's the thing, and I believe this, it will have a brushless DC electrical motor pushing a pump jet. That brushless DC electrical motor will be near silent. I don't know how submarines, I don't know how any sonar system is going to detect this. Like they'll have to have a dedicated, like they have on this ship, the towed torpedo decoy system will probably detect this because that's what it's designed to do. Okay. But man, this thing is going to be quiet. So they're kind of promising the moon here. They're saying long range, fast, quiet, high speed, fully autonomous. Of course, it's a torpedo. It's going to have to be fully autonomous. But I want to see sea trial numbers on this before I believe all of this. The only thing I'm convinced is true is the brushless DC motor, because that's pretty common now. But that range at that speed in a light torpedo would be quite the achievement if they do it. Let's move on, because we don't want to spend too much time criticizing a system that's not even been built yet. All right, the Stop 25 millimeter is one of the two guns. There's one port, one starboard, that will engage these unmanned surface vehicles as they approach the ship, if they do. Can also do things like destroy, pirate ships off the coast of Somalia. This is going to be your close range, close abort surface engagement gun. It is a 2-axis stabilized turret, has electrical optical sensors, as well as your fire control suite. Your gun bearing angle is going to be 160. Elevation is -15 to +25. 600 rounds per minute. That's pretty high rate of fire for a 25 millimeter gun. It holds 250 rounds in the turret. You can see little ammo boxes there on the left and right. And it's been exported to Bahrain, this gun has, Pakistan and Turkmenistan. So it's out in the fleet now. It works. And these are becoming more and more important with the rise of drone warfare. So this is going to be an important weapon system. And this is not necessarily a new one either. This one's been tested. All right, and here's the Seahawk, ladies and gentlemen. This thing's a beast. It's so reliable. Everyone uses it in the NATO countries. It's the S-70B. They have all different variants. I think there's like a Delta and Echo now. Anyway, they're using the Bravo version over there in Turkey. It does anti-submarine warfare and anti-surface ship warfare because it has a surface ship radar there on the nose. That's the big thing under the pilot. And, it can detect contacts, feed that information back to the ship. And this is important. It doesn't do its own beamforming. It's literally a power supply with a radar on board this thing. And then it takes the data of whatever the hell it's detecting, sends it back to the ship, where that data is then processed into something that can be put on a screen. So this is literally, they're out there moving a radar around or an ASW sensor around on this helicopter. That's its job. That's its limitation. And of course, it holds the weapons and so forth. Has a range of over 1,200 kilometers, a speed of 270 kilometers per hour, service ceiling of 12,000 feet. Can carry 2 Mark 46 torpedoes or a Penguin missile or 4 Hellfires now. They can fit those on that. There were 4 UMTAS. So those are small, surface-to-surface missiles, much like the Hellfire is. And so it would make sense to put Hellfires now on these if you're out doing patrol against, these unmanned surface vehicles that are out roaming the Black Sea or whatever. This would be a good platform to go and hunt those. At least defend your ship. Keep them out of your area. And it has the AQS-18 dipping sonar. That's the export version of the sonar. And the APS-124 radar. That's the surface-to-surface radar there. Very good helicopter. So overall, a very good package. I'm impressed with this frigate. It's a small ship, brand new, has lots of new technologies, but not so new that they ran into the problems that we did in the United States that had, they hadn't even invented the technology or the guns yet for the Zumwalt before they started building it and approved it for funding. They at least have these guns, in a lot of cases, they've been in use for years. And just a couple of the sensors are the brand new being used for the first time, which there's always going to be a ship that is the first time for something. And this is going to be it for a lot of the systems. So they have both reliable tested systems like that Mark 46 torpedo has been around for 40 years, 50 years, long time now. Of course, the Mod 5 is the new version of it, but still it is a tested weapon. They know that's going to work for sure. That ASA radar, that's going to work. So just some of the new systems are the only thing that are, kind of being, they're going to work to some level. Just how well they work is the only question. Okay. So the first 4 ships of this project were the Ada-class. I would encourage everyone to go watch that next to learn more about this MIL-GEM program. So Ada-class corvettes, and now they're going to build 4 I-class frigates rather that we're doing here. The first frigate was manufactured by Turkish defense industry. This is all going to be like in-house is what they're saying. This is all indigenous, with some minor things that are exceptions, like the rocket motor or the turbojet sustainer for their anti-ship missile is still not 100% in-house yet, but it's going to be. Okay. So designed by STM, built by the Istanbul Naval Shipyard. The following 3 frigates will be constructed in private shipyards that are there in Turkey. The main weapons are the anti-ship missiles, 16 of them. This is an anti-ship frigate with air defense capability, 16 cells of air defense. And the indigenization rate is around 90%. And that's rounding down. I think they're closer to 100%. There's very few things on this ship that isn't designed and built in Turkey. And I think they just need to move a couple things over, and they're going to have their own frigate that they can then export if they want to other nations. I think this will become an export frigate. I'm excited to see what the sea trials bring out. I don't know how much of that they're going to make public, but if I get any data, I can throw up a couple photos with some or slides with information on the Patreon for you guys. All right. Hey, and speaking of which, thank you, Patreons. All of you are great and amazing. Love you. You guys make this possible. This is your reward for supporting me. Big credit to Typhoon Ozbek, who is the primary naval journalist that researches all this data. He's from Turkey. He's seen these ships and systems. He knows so much about them. It's great. So I do appreciate all of the work he does as well. And you guys pay, his salary basically. So please keep that up because we want to keep him. All right. He does a great job. All right. Thank you again, guys. Honestly, we'll see you in the next one. Okay. Bye. Independence-class ship brief. This is the second of the 2 littoral combat ships that the United States has built over the past 13 to 15 years. LCS are really characterized by their ability to move at high speeds. They both employ trainable water jets and are able to get from 0 to very fast in a short period of time. They're made of composite lightweight materials and have unique designs. The Independence-class is probably the more radical of the 2 hull designs because of its trimaran design shape. 2 of the ships have already been decommissioned, which when compared to the Freedom-class is a success because Freedom-class has had some 5 or 6 decommissioned already. And eventually all of these will be pushed out of the Navy or sold to other countries. Like the Freedom-class is being proposed to be sold to Greece, for example. But this is the Independence-class, and she shares some of the same weapon systems and sensors as the Freedom-class. In the Independence-class, we also are shooting the AMG 114L7 Hellfire missiles, and they have the Naval Strike Missile anti-ship cruise missile on the bow. Keep in mind that that anti-ship cruise missile is only installed on a limited number of the 17 hulls. They don't all have that system. But they do all have the Bofors Mark 110 57mm naval gun, a CRAM point defense system with rolling airframe missiles, and 2 Mark 46 30mm gun systems that we'll talk about today, including all the sensors and combat systems that connect these weapons together. Let's start with weapons and countermeasures. On the bow, we have the Mark 110 57mm gun. This gun has a limited depression capability. In other words, it doesn't shoot down very much, if at all. Right behind that is the AGM 114 vertical launch missile system that shoots the anti-surface missiles. These are basically the same longbow missiles that the Apache helicopter shoots, just a naval variant of it. And I'm told confidently that it has a slightly longer range than the Apache version, or the helicopter version. Behind that is the RGM 184 Alpha, which is also called the Naval Strike Missile. Very capable, modern subsonic, but stealthy anti-ship missile. And behind that is the superstructure with the bridge. And on top of this bridge, we have two Mark 46 30mm gun weapon systems, one facing port, one facing starboard. And amidships in the center at the very top is the C-RAM point defense missile system. The Mark 137 decoy launcher is on either side, and we'll talk about those. It's just a combo launcher. We're talking chaff, flare, torpedo decoy, all combined into one now. It's a very, very good system. Let's move on to sensors. All these weapons are great, but if they don't have targets, they're not functional. So the way we get targets is at the very top, we have the electronic support measure system called ES3601. None of this information about the system is public right now. Just know that it listens for radars, and it processes and tells the crew what radars are out there and what modes they're in, what power levels they are. That is all done millions of times per second by this ES3601 ESM. Very advanced. Below that, on top of the bridge, again, another high point of the ship, is the Sea Giraffe anti-missile ballistic radar. It can track ballistic missiles in low Earth orbit, technically not an orbit, but a ballistic trajectory going in its area. It doesn't have any weapon systems to do anything about it, but it can see it happening. It will be part of the sensor network tracking ballistic missiles that will then be engaged with presumably a different platform. But the cool thing about the Sea Giraffe is that it's a combined surface search and air search radar all in one, and it can track hundreds of targets at the same time, including ballistic missiles. The Seastar Sapphire 3 EOS is the electrical optical system just forward of that radar. You can see it there. It's circled on the picture if you're watching the video of this. And right in front of that is the Bridgemaster E navigation radar, just used for normal everyday navigation. Kind of a poor placement for a navigation radar in that about 45% of its field of view is blocked by superstructure. But other than right behind the ship, it can see everything in high detail and is used for navigation when close to shore. Here is a great breakdown, a great drawing of the inside of the LCS. And I apologize to those of you only listening to this, but I will try to describe it. It is a cutaway drawing of all the different mission modules and locations of the rib boats and unmanned vehicles that are accompanying this ship, because it can use not only helicopters like the MH-60R, but the unmanned version of our helicopter systems, as well as unmanned surface vessels. We have both manned rib boats that you see here in the drawing, and later on we'll show you a photo of an unmanned surface warfare vessel that the Navy's been using for years, and we got a picture of one. So that's great to include in this little lecture here. It's coming up. Okay, forward is the ISR suite that's used for intelligence, surveillance, and reconnaissance. So you can stick one of these off the coast of another country and just listen to what's going on. They do support that kind of capability, as well as mine warfare and surface warfare capabilities. The ability to track ballistic missiles is a huge advantage in that this is a relatively fast, low cost when compared to, say, an Arleigh Burke destroyer ship that you can put off the coast of, say, Japan and watch North Korea, just as an example. This would be a great place to use this kind of ship, freeing up an Arleigh Burke that's currently doing that mission, steaming in a box that's 10 miles by 10 miles, very small for a ship, for months at a time, just to keep an eye on that country. A great use of the Independence-class would be to position this some 50-man crewed vessel in that 10 by 10 box watching North Korea with its Sea Giraffe radar. All right, let's move on to how many they made. They made 17 of these. They decommissioned 2, and they aren't building anymore. This is the end of it right here. And this is all their commissioning dates. From the date the keel was laid down for the first time in 2006 to the final commissioning of USS Augusta all the way back in 2023. They're done building this class. Independence-class LCS by the numbers, they use a CODAG system, and that's a combined diesel and gas engine, or gas turbine, excuse me. They use 2 GE gas turbines to push 4 steerable water jets, propelling the ship in excess of 44 knots through the water. Now, if you want to go long distance, you can't go full speed. The max range of this ship is 4,300 nautical miles at 18 knots, which is still better than the Freedom class. You can get from point A to point B with a 40-man crew, but if you want to have a mission module installed, whether that's mine countermeasures or anti-surface warfare, or even ISR, keeping an eye on other countries, you're going to have a 75-man crew. And so that's why you'll see two crew numbers on both LCS class frames. You have the crew of the ship, and then you have the mission crew. So 24 AGM missiles are held in the bow. That's the AGM-114L Longbow Hellfire missile. They can carry 8 RGM-184 Alpha naval strike missiles, and they have the 57mm gun on the bow, like I said. The search radar is the TRS 3D and 4D search radar, the exact same radar that the Freedom class has. The Northrop Grumman ICS combat management system connects all of the sensors and weapons and internal communication, that's like bridge to the engine room, all together in the ICMS. Bridgemaster E navigation radar is the navigation radar right above the bridge. It looks like the letter T and it spins around. And it's basically a short range but very high fidelity radar that will give you the position of very small ships. Like a sailor, a fisherman in his little John boat will show up, as well as the coastline. And so you're literally mapping the coastline on your screen as you drive alongside of it. Hopefully not into it. The ANKAX-2 electro-optical and infrared system is on board just forward of that navigation radar. That is simply a system that can track objects by shape, whether it's physical shape or heat signature shape, and it can be steered manually for searching, and it can also track automatically. Once you have a target, you lock onto the shape, and it'll track that shape. You have the ITES 3601 RESM, which is the electronic support measure, telling you what kind of radars are being transmitted out there. They have the WC6, which is the SATCOM, satellite communication system, allowing them to talk to other ships and to shore, make reports. That's very vital when you're in that ISR position. ISR is often done by lone vessels. Submarines, ships like this would be perfect because they're relatively low cost, least likely to be detected, and if destroyed, it's not a big loss to the Navy as a whole. And so having this communication system is like having an eye in the sky, or in this case on the sea, right off the coast of another country, keeping an eye on things. The BAE nuclear active RF decoys are combo decoys that do chaff, flare, and other things to deceive incoming weapons, primarily cruise missiles, but other sensors as well. And then finally, the helicopter systems are the MH-60R, which is the most recent form of the U.S. Navy helicopter, as well as the MQ-8 Bravo Charlie Fire Scout. Fire Scout is the name of the unmanned helicopter the United States Navy has been employing for years now, and unmanned surface vehicles are used in there. So this is the LM2500 gas turbine engine, manufactured by General Electric, used in navies around the world, mostly NATO navies though. China copied this for their navy. It is a 2-shaft axial flow simple cycle turbine engine. It weighs only 4.7 tons and generates just over 25,000 kilowatts of energy. So you put a couple of these on your ship and you're going very fast very soon. It doesn't take a long time to get up to speed with these, which makes them very valuable to a ship. And more importantly, from a crew point of view, these things are extremely easy to maintain. And in the case that you need to replace them, it's a simple, relative to another ship, it's a simple job to pull into port with a crane, pop open the top, and then crane this thing out and crane a new one in say, a weekend. Compared to ships that don't have modular systems like this, which would require probably a dry docking period to do a similar function. Siege Raft anti-missile ballistic radar, manufactured by Saab. That's right, the same people that make the Saab cars that used to be here in the United States. Haven't seen one in a while. Also make a lot of military equipment. They're very proliferate in military in the military industry, and they make this radar. It's designated as the SPS-77 in the United States Navy, but it's used in other navies around the world, called the Sea Giraffe. It operates in a very narrow range. It's 4.5 to 5.9 gigahertz with a peak power of 25 kilowatts, which is pretty respectable, but it is a very narrow range of frequency operation, which would make it very easy to classify to another ESM system out there looking for it. Not necessarily a limitation of it at all. It's just you're making, it's hard to hide once you start rotating and radiating with this thing. You can rotate at 30 to 60 RPM per minute. That's how fast the thing physically spins around on top of the ship. It has a range of just under 100 nautical miles, can track hundreds of both air and surface contacts, and IOC'd in 2003. It's a very good system. Here's the ES-3601-3601 RESM, made by L3 Harris. It's a tactical radar electronic support measure system. It scans anywhere from 2 gigahertz up to 18 gigahertz, can track up to 500 different tracks, which would be emitters. Remember, one platform can have multiple emitters, so it's important that you can do multiple of these. It's 360 degrees coverage anywhere their elements are facing, they're looking at. It comes with its own emitter library, meaning that once it sees an emitter, it compares it to the library, gives you a classification. So it makes the operator's job a lot easier because he doesn't have to memorize every single radar system in the world and its capabilities, even though a lot of ESM operators out there can do that and have that knowledge. Having this type of library on board is extremely beneficial, especially to young, inexperienced operators. This will help them classify radars quickly, which is vital to the job. All right, here's the active RF decoy manufactured by BAE Systems. This is a lingering decoy with an RF emitter. This thing will actually transmit itself as a target, trying to deceive and lure weapons away from the ship. It has solid rocket fuel propulsion to get it up and out of the tube and into the air. It has a short cycle time, which is a fast reaction time. Absolutely vital for decoy. Whenever a ship is surprised by an attack, which is probably how it's going to happen, they need to get this system functioning quickly. Of course, it's always going to be on when you're at sea, but you need to be able to mash the button and get the decoys employed quickly and effectively to save the ship. This can be placed in an automatic mode and a manual, so probably manually operated, but it does have an automatic mode. All right, here's the Mark 110 57 millimeter naval gun, 57 millimeter caliber, 70 caliber barrel length, shoots 220 rounds per minute, is radar guided, capable of shooting programmable ammunition, has multiple types of ammunition from point detonating to a proximity fused to other programmed modes. So it's a wide variety of different capabilities. This thing can shoot at incoming aircraft missiles with the proximity fuse. It can shoot at lightly armored vehicles like small pirate ships and stuff off Somalia with point detonating, which would be devastating to any kind of small craft. Or it can go into program modes where you're fighting against a naval craft that has a small amount of armor, so there's penetration before detonation of the round. It does all those things. The one downside that I see to every single weapon system on this ship, and this is a little bit of personal analysis, none of these guns look down. And in the world of sea drones, unmanned sea vehicles that we've seen in the Black Sea and Ukraine used against the Russian Navy, you need guns that look down and can engage automatically with radar guidance, not with crew members on board with small arms, because that's ineffective. So I'm very concerned. I imagine this gun must have some amount of negative depression, but it doesn't look like it's very much. Anyway, shoots has 1,000 rounds deployed below deck, so it can reload. Has a maximum range of 17 kilometers and weighs just under 7,000 kilograms. Here's the other gun system. This is mounted very high on the ship. So again, not going to be looking down, shooting down very much. So at the very top of the ship, up next to the navigation radars, are two Mark 46 30mm gun weapon systems. These are manufactured by General Dynamics. This is the Bushmaster Mark 44. Very reliable gun system, easy to maintain, great choice. Location, poor location, in my opinion, especially in modern warfare. You need to be able to shoot at the waterline to small incoming objects, like USVs. Shoots 200 rounds per minute, has a dual feed, 200 rounds plus 200 rounds coming onto each side, and it can be remotely operated from the CIC down below. Has a maximum effective range of 2 kilometers. Here's a CRAM point defense missile system manufactured by Raytheon. Raytheon makes, I think, inarguably, the best weapon systems, missile systems in the world. And so it's good to have them on board for our point defense. This is based on the Mark 15 phalanx mounting, but with the twins. This is based on the Mark 15 phalanx mounting, but with the 20 millimeter Gatling gun is replaced by an 11 cell, so 11 missiles of the RAM variety. That's rolling airframe. Fires the RIM 116 rolling airframe missiles, search and track radars, as well as forward-looking infrared and electrical optical system. And so if it's out there and moving, it can track it and see it in all different kinds of spectrums. Has an effective range of 15 kilometers if it's using the Block 2 missile, which presumably it will be. And this ILC'd in 2009. This defends the ship from attack. Now, AGM-114L Hellfire, manufactured by Lockheed Martin, vertically launched missile system, surface missile system. This one certainly could engage unmanned surface drones, vehicles coming at the ship, for sure. It's a short-range anti-ship missile, range of 8 kilometers, 45 kilograms weight, 9 kilograms high-explosive anti-tank warhead with a proximity fuse. This enabled, or IOC'd, I should say, in 1989, but that was for the Army, and this longbow version for the Navy IOC'd in 2018. And finally, we get to the RGM-184 Alpha Naval Strike Missile, manufactured by Kongsberg. Long-range anti-ship missile is in excess of 180 kilometers. It is subsonic. It's got a 125 kilogram high-explosive warhead. Uses GPS, internal navigation, and Terracom guidance with an infrared seeker to find its target. And there you can see, if you're looking at the video of this, there are 2 quad launchers. So one facing port, one facing starboard, total of 8 missiles. This IOC'd in 2012 is essentially the replacement for the Harpoon, and it is just the next generation long-range subsonic anti-ship missile. Here's the MH-60R helicopter. This is the Seahawk, the latest of the Seahawk variants. It uses 2 GE T700 turboshaft engines. Has a range of 450 kilometers, can stay in the air about 3.5 hours before having to come back home for fuel. Has door-mounted machine guns, multifunction radar, electrical optical tracking systems. That's that big round thing on the nose right in front of the pilots there. And also has sonar buoys. This has ASW capability. And here's the Mark MQ-8C unmanned helicopter, manufactured by Northrop Grumman. It's based on the Bell 407 frame. That's why it looks a little bit like a miniature Huey, in my opinion. It's the RR. It's powered by the Rolls-Royce 250 C47 Bravo turboshaft engine. Creates 813 shaft horsepower. Can stay in the air for 15 hours, much longer than the manned helicopter can, but carries a lot of the same sensors, including electrical optical sensor systems and a starlight radar option. I also am told that this has sonar buoy launchers installed. However, you don't see them here in this picture. So this probably can support anti-submarine warfare as well. And finally, here's the RIBs, the unmanned naval platforms. We have the RIB boats are manned, just to be clear. The unmanned naval platforms are the one you see on the left. This is one of the first pictures I've been able to get from the DoD for our lectures here. This is a completely unmanned vessel. It can go out and perform the same duties other than boarding operations, which requires an actual person to go board another ship. This can go and communicate with other ships. It has its own navigation system. It's completely autonomous. You give it a mission, it goes and does it. It's quite incredible. The United States Unmanned Naval Program, Unmanned Systems Program, whether it's aviation, surface or subsurface, is extremely advanced compared to other countries. We don't talk about it because it's very sensitive and very secret. It's one of our major advantages in this generation of warfare we find ourselves in. And we certainly aren't going to brag about it. But this is a great photo. And full credit to Tafon Osbrecht, our technical writer, for getting this photo. This is his work. And well done, sir. So that's a brief glimpse into what one of our unmanned naval vessels look like. These things are hoisted in and out of the Independence class. I imagine that's not a very rapid procedure at all, but that's how they do it. All right, final thoughts on the Independence class is that, man, this is very different than the Freedom class. They went with 2 wildly different designs here. And arguably, the Independence class is better than the Freedom-class because they haven't decommissioned as many Independence-class as they did the Freedom-class. Now, comparing your success to the Freedom-class is not the best comparison because the Freedom-class is a disaster whenever it comes to many things, including staying commissioned. It's not very good at that. So the problem with the Independence-class is this is the ship that had the hull cracking where the bow met the trimaran hull, right where that pointy nose meets the hull. That sees a lot of wear and tear, a lot of stress when at high speeds. So there was an order given out to the Navy saying that thou shalt not go above 15 knots because you're cracking the hull of these aluminum trimarans. And so they were limited in speed for the longest time. Yeah, they could go more than 44 knots, but they would rip themselves apart doing it over time. And that's still being addressed because that's a design issue. They had to reinforce where those hull pieces meet, which has been done, by the way. So that's the design issue with the Independence-class. Obviously, the Freedom-class had the gear transmission ratios were incorrect, so the transmission ripped itself apart when you combine the gas turbine with the diesel. With this design, they don't have that issue. They can use both and go very fast. But now the hull is the weak point, not the engine. And the hull literally is ripping the bow off. And of course, that would be catastrophic for the ship if it completely failed. And so they are decommissioning this as well. 2 have already decommissioned. The others remain in service. And it is a really good platform at low speeds. It's very good at ISR. It can track a ballistic missile submarine at a very low cost in terms of manpower. So that's great. Ballistic missile launch, rather. It can track a ballistic missile coming out of China, North Korea, wherever, freeing up other assets to do more important jobs or more flexible jobs like the Arleigh Burke-class can do. And that's really where the Independence-class lies. It is a flawed system that is functional, and the Navy will use these for as long as it can, but the decommissionings have already begun. All right, and that's Independence-class. This concludes the LCS series of 2. We are moving on to the aircraft carriers, the ballistic missile submarines, and finally the Arleigh Burkes. We will be doing those next. Welcome to the Zumwalt-class helicopter destroyer ship brief. The Zumwalt-class is a class of 2 ships that are designed for anti-submarine warfare by carrying anti-submarine helicopters to the fight into the Pacific waters around Japan and its chain of islands. It is operated by the Japanese Maritime Defense Force and is a replacement to the Shirane-class destroyers. One of the big reasons or purposes of this ship for replacing a destroyer is the size of the theater, the Pacific Ocean, specifically the Western Pacific around Japan, even as a defensive force, is simply too large to efficiently cover an ASW search with destroyers. So Japan decided to build aircraft carrier style ships, but limit them to only helicopters for the purpose of ASW warfare. That is the primary mission of the Zumwalt-class. But the Zumwalt-class is undergoing a transformation right now with the help of the United States. They are working with the Marine Corps at the time of this recording in 2024 to operate F-35 Bravo VTOL aircraft off the coast of San Diego. They're undergoing this change and will be fully converting both of these ships to F-35 aircraft carriers. That's in progress in 2024. The size of the ship is still quite impressive. It is 248 meters in length and displaces close to 27,000 tons with a full load of aircraft. This number will change slightly between helicopter and F-35 Bravos, but not enough to be significant. Just know that it's in the realm of 27,000 tons. The propulsion system here is the COGAG system. It is combined gas and gas turbine propulsion. She has a total of 4 of the LM-2500s. For defensive weaponry, she has 2 C-RAM point defense missile systems and 2 Mark 15 Phalanx CIWS systems. The offensive capability of this ship comes solely from her aircraft, whether that's the SH-60J helicopter for ASW warfare or the F-35 Bravo for air combat and air-to-ground strikes. Let's start with the weapon systems that are on board the ship. There's only a few. If we look at the bow center line, right in the middle of what would normally be a flight deck, but off the bow of the ship, is a phalanx close-in weapon system. That's one of two. Behind that, on the starboard side, just below the bridge, is the first C-RAM point defense missile system. Now, both the C-RAM and the C-Wiz use the same sensor suite, so that's why they look similar to each other. But what's different is the payload. The C-RAM uses the RIM 116 rolling airframe surface-to-air missile for self-defense, whereas obviously the phalanx uses the Gatling gun style 20mm gun. On the aft end of the ship, there is a C-Wiz and a C-RAM, one port, one starboard, for a total of 2 C-RAMs and 2 phalanxes working together to protect the ship from all angles. For the sensors and countermeasures, she has quite a few, but not anything that you wouldn't expect from a sub-hunting ship. Beginning at the top of the mast, we have the surface search radar, which is an OPS-28. All these systems are based on American systems, but built in Japan. They're indigenous of American designs and performances. So the surface search radar, like I said, is the OPS-28. The ops radar, OPS-50, is the ASA style active ESA radar system. The NOLQ-3D1 EW system is a combination offensive and defensive electronic warfare suite, right on the center mast there. You can see more of the OPS radar plates, those flat ASA radar plates, aft along the superstructure. They need 4 of those to cover 360 degrees around this rather large superstructure. Just below the flight deck on the starboard side, you can see the Mark 36 SRBOC, or SRBOC, which is a decoy launch system that launches a combination of different chaffs, flares, torpedo decoys, comes from the Mark 36. And then on the bow, because this is a submarine hunter, it does have the OQQ-23 bow-mounted sonar system, which is based on the American equivalent. Here's a close photo of that mast with those radars on it. You can see the OPS-28 surface search radar there, and right below that is the OPS-20E navigation radar. Those are high update, high fidelity, but shorter range radars. For example, when you're using a navigation radar, you're operating generally near a coastline, so you want to see that coastline very accurately. Also, a lot of small vessels will be operating near the coastline. So the OPS-20E is very good for that. You can see a great picture of the NOLQ-3D1 electronic warfare system and the SATCOM array that's next to it. I will mention that the NOLQ-3D1 looks very similar to the American SLQ-32 because it is based on that. It's not the exact same, does not have the exact same parameters, but visually it looks very similar to it. And I love this photo for how close you can see the OPS-50 flat ASA radar plates and get an idea of just how big those things are. Very powerful, continuous wave transmission, volumetric search radar. Here's the refit that's going on right now. So the refit is more than just a change from helicopter to aircraft. It is a complete change of mission for the Zumwalt-class. Japan's, self-defense maritime force is designed to be defensive in nature and hunt submarines with these ships in a defensive, purpose. But Japan is going through a military and cultural change now from a defensive military to one that can project power offensively. And these ships are part of that change. So by switching or changing its operations to an aircraft carrier, it can conduct offensively capable missions. And that's what the United States F-35 Bravo is bringing to the 2 ships of the Zumwalt-class. The primary role will be switching from anti-submarine warfare to aircraft carrier missions. Here's the deck of the Zumo here. You can see it compared to a previous class, how much larger it is. It's quite an impressive beast. But again, Japan only has 2 of these, but both are going to be going under conversion to the F-35 Bravos. The smaller ship in this photo is the Hyuga-class, much smaller. So both Izumos were built and commissioned in the 2010s. So the first one was commissioned in 2015, and Kaga Hull 2 commissioned in March of 2017. And they've operated as ASW platforms until 2024. The Zumwalt-class by the numbers is quite straightforward. Like I said, she has 4 of the LM2500 IEC gas turbines. Those are spinning up, working together to propel the ship to over 30 knots. That's a key speed because she needs to be able to keep up with the American fleets and the Australian fleets, with which she works with regularly now. The full load, the displacement, like I said, is going to be in the vicinity of 26,000 to 27,000, depending on how many aircraft and helicopters they have on board. You don't want to get too caught up by those numbers. Just understand the range of how much displacement these ships have. The crew is just under 1,000 total people with the aircraft crew on board. So it's ship's crew complement plus the air wing complement. Comes to about 970 personnel. She can carry 28 aircraft, 7 Seahawks or MCH-101s, or F-35 Bravos after refit. I expect this number to be updated after sea trials and all the operations that are going on now off the coast of San Diego, but we expect them to be able to operate 28 aircraft. She has, of course, the 4 total defensive weapon systems. 2 are phalanx, 2 are C-rams. As far as sensors go, again, she has the OPS 50 ASA radar. That's the primary long-range search, air search, and can be surface search as well, combination radar. She has a dedicated surface search radar, the OPS 28, and her navigation radar is the OPS 20E. A bow-mounted sonar on a ship this large is not common, but she does have one called the OQQ-23 sonar system. The NOLQ-3D1 is the electronic warfare system that is both offensive and defensive, and the Mark 36 Serbach decoy launch system launches everything from combination chaff flares to torpedo decoys. She has a floating acoustic jammer and an OYQ-12 combat data system that connects all these weapon systems and radars together so they can be displayed in the control rooms. Here's the LM2500 IEC gas turbine, very popular, very reliable and easy to maintain system. It's derived from the GE military TF-39, and commercial CF-6 high bypass turbofan aircraft engines. It is a 2-shaft axial flow, simple cycle, can generate 33,000 ship horsepower. It's quite a bit. But this thing only weighs less than 5 tons per engine. And they have 4 of these on board working together. They don't have to run all 4 at the same time. That's what co-gag means. They can bring 2 up, they can bring 4 up, and still operate. Here's the OPS 50 radar, developed by Mitsubishi. This is a dual-band 3D surveillance and fire control radar. It operates in the 4 to 8 gigahertz for search and track, and then the X-band is 8 to 12 gigahertz for, I like to call, putting warheads on foreheads. That is the weapon guidance radar. Now, this is kind of an interesting place to be because all the weapons on board this ship are self-guided. They have the ballistic phalanx, they have the C-ram, which is a self-homing missile, but they do have the ability to guide weapons with this X-band radar if they need to. They have the GASAS ASA radar elements. The gas is the material that the ASA radar is made out of, which is important. It's a very high quality material. And the coverage is 360 degrees all the way around the ship with the multiple facing plates that go down along the side and forward and aft part of the superstructure. And this is a continuous wave illumination module. So it's very similar to volumetric search. It's just continuously transmitting in its direction, providing the data to the operator. Here's the OPS 28F radar. This is developed by the Japan Radio Company. It is an air and surface search, surveillance, and navigation radar. Operates in the 4 to 8 gigahertz range. That's NATO G and H band. So it's developed to detect track targets and sea skimming missiles. So whenever those cruise missiles are coming in, low to the ground, high speed, this radar will be one of the radars that will see it coming. Quite honestly, the ASA radar will probably see it as well, but this radar is very good at detecting it. This is a traveling wave tube, or TWT, and cross-power amplifier tube used for radar transmitters. This IOC'd back in the 1980s, but has been modified several times throughout the years. Like I said, these ships were commissioned in 2015, 2017, so they have very modern designs to this older system. Here's the OPS-20 radar, developed by the Japan Radio Company. It's a two-dimensional air and surface search radar. Notice how there's so much redundancy here. All these radars are dual-purpose air and surface search so far. This operates in the X band, 8 to 10 gigahertz. Pretty high update rate, but because it's a navigation radar, you really want that so you get, one, detections on small craft, very important, and then of course the coastline. This will literally on the display show you the edge of the coastline within range of the scale that you select on the display. It's developed to track and detect surface contacts, like I said, uses a composite antenna, which means it has a main and a sub antenna, and it is a continuous wave with reduced detectability integrated into the system. That is the OPS-20 radar. Here's the NOLQ-3D1 electronic warfare system developed by Mitsubishi Electric. This is a combination ESM and ECM suite, like I said. A fully digital system, very modernized, looks very similar to the American SLQ-32, which it is based on. It has multiple antennas arranged at 45 degrees centerline from the ship, giving a total of 360 degrees of coverage. This detects radars, it classifies them, it gives that information to the operator, and offers jamming functions for the radars that it detects. All in one suite, IOC'd in 2018. A very good ECM system. Here's the Mark 15 Bravo Phalanx close-in weapon system developed by General Dynamics. This is based on the M61A2 Vulcan rotary cannon shooting the 20 millimeter APDS ammunition. It can shoot down and up. This is an important fact in modern warfare with unmanned drone warfare coming on, across the surface. This gun can look down, shoot down, and destroy close-in targets, as well as any aviation targets that come within range. It fires about 4,500 rounds per minute. There are different modes with different rates of fire. Just know that they keep about 1,500 rounds in the magazine at any one time, so it can burn through that magazine really fast. Effective range is about 3.6 kilometers, and that really depends on your target. It is both radar and electro-optical guided. You can also take manual control of this from inside the ship, CIC room. It has multiple sensors on it, visual, radar, infrared, forward-looking infrared. This variant is from 1999. It's very reliable. That's why it still works. We have some great graphics here for you to show you some of the ammunition and a detailed breakdown of the antennas that are inside the Mark 15 Phalanx. You have the video trackers on the side. The main R2-D2 looking hub actually houses a low sideband track antenna. So that's what's inside there. And on the top of it, at the dome portion, is the search antenna. Here's the CRAM Point Defense Missile System. Uses the same, or very similar, radar tracking system that the CWIS uses, but this is launching up to 11 RIM 116 RAM air defense missiles. These are used for standalone point defense, fire and forget, has an effective range of about to 15 kilometers with the Block 2 missile, used to shoot down low-flying aircraft and incoming cruise missiles. This is a very fast missile, and it's a point and shoot. Very simple. This IOC'd in 1998. Here you can see a breakdown of the sensors, which are pretty much the same as the CWIS. And here's a great photo of the RIM 116 Charlie Block 2 missile. This is the one that can go out to about 15 kilometers. This is a very accurate missile. All right, here's Japan's version of the SH-60 helicopter called the SH-60J. It's very similar to the American one in performance in terms of it has 5 hours of endurance. It can carry multiple weapon systems, including Mark 46 torpedoes. It can fire the AGM-114 Hellfire missiles if it had an ASUW mission. You can also mount 7.62 machine guns in the door, and it has the HPS-105 search radar. That's that, large flat disc that you see right under the pilot. That's the radar, surface search radar. It also has a sonar buoys and MAD detection, forward-looking infrared, a very capable helicopter. Here's some of the torpedoes that it could fire. A Type 12 torpedo would be the Japanese version of the Mark 46. There's the AGM-114 Hellfire, and there is the door-mounted machine gun. The operator, the crew chief, if you will, on the back there can get on that if he needs to. Those are not always, or I would even say normally, installed. All right, here is the queen of the ship right here. This is the new capability that they're getting. It is the F-35 Bravo Lightning II. This is a 5th generation fighter, vertical takeoff and landing aircraft. It has one F-135 afterburning turbofan and a lifting fan. Many people don't know that when it's doing the vertical takeoff and landing, there's an additional fan in there to help keep the nose up, because the exhaust from the engine itself is in the rear. So to balance things out, and we have a great photo of it coming up for you, there's an additional lift fan. The max speed of this when it's in the air and in horizontal flight is 1.6 Mach. Quite impressive for a VTOL aircraft. It has lots of stealth characteristics that we can't go into. Just understand that it is 5th generation, very low probability of detection, and you aren't going to put a weapon on it. A radar-guided weapon is not going to get on this. As far as heat signature goes, it has multiple systems to diffuse its heat signature, so you would have to be very close to get an infrared guidance on a weapon on this aircraft. It has its own electrical optical system. It has directional awareness systems because there's multiple sensors all the way around this aircraft. And it is very good at coordinating a fight. Think of this aircraft as a quarterback in an air battle. It can even coordinate action on the ground and at sea. So it can take in data from multiple sensors, including its own, of course, which are quite powerful, and then share that data with other aircraft, like say the F-18, for example, who may not have the target. But this aircraft, one of its many purposes, would be to help other platforms employ their weapons with target guidance and data link from this aircraft. Here is the laundry list of weapons that the F-35 Bravo can carry. It is quite literally everything in the U.S. Navy and Air Force arsenal as far as air-to-ground and air-to-air goes. Everything from the 2,000-pound paveway down to the 500 or the 500-pound paveway. She can carry the Storm Shadow, which has garnered quite the reputation in Ukraine and Russia war right now, as well as the JSAM and other cruise missiles. Air-to-air missiles, she can shoot everything from, the AMRAAMs to the Sidewinders, so short, long-range, radar-guided, infrared-guided. She has quite the laundry list of capabilities, both external and internal. Now, there are limitations on what can fit in the internal tank. And on the screen here, if you're watching the video, you can see the weapon systems that will fit inside this aircraft so that it can maintain its stealth characteristics, and the weapon systems that would need to be on the wings. And if you did that, you would lose much of your ability to remain undetected. The lower right-hand corner, by the way, is the great photo we found for you showing you the lift fan. The lift fan is used during takeoff and landing. It helps keep the plane, level as you go up and down. That normally is not used during horizontal flight. All right, Final thoughts. The Izumo-class helicopter carrier is quite impressive as an ASW platform because it can employ, more than 24 aircraft searching a large area of the ocean around Japan looking for submarines. It's very capable, and it has its own built-in hull-mounted sonar system. So very good ASW platform. It can go and control an entire area and deny access, essentially, to submarines operating in that large area. But what's really important here is the change that's happening in Japan. This is a cultural shift. This is a military shift. This is a different way of thinking. They are going from becoming a maritime defense force to an offensive capable Navy and military in general. And one of the big steps in that is converting these 2 ships that are of the Izumo class to aircraft carriers. And that is in progress. That is happening right now. It's very important. One of the reasons why this is happening now in this cultural shift is the aggression we're seeing out of China. China is a big purpose, a big reason for this capability being needed now by Japan. Japan clearly did not want to do this, but after seeing how China's been behaving for going on 25 years now, since the mid-90s, they're learning that China will not stop its expansionistic endeavors until they meet a force that can stop them. And that's why Japan is increasing its military budget and its military capability, and the Izumo-class conversion from a helicopter destroyer carrier to the Izumo-class aircraft carrier is happening. And the United States is helping them do it. And like I said, a little extra for you is as we're recording this, the sea trials with testing and operating and learning how to do operations with F-35 Bravos is happening right now off the coast of San Diego with the Marine Corps Aviation Air Crews. And happy to see it because we need all the help we can get in the Pacific. And these are strong allies, and having a stronger ally is good for everyone. So this is the Izumo-class helicopter carrier lecture. Thanks for listening, everybody, and we'll see you in the next one. Welcome to the Jamaran-class frigate ship brief. All right, where to start with this thing? This ship is the backbone of the Iranian Navy. And I suppose that we should begin by discussing that Iran has 2 navies. They have the Iranian Navy, which is a more conventional force, and they also have the Iranian Republican Guard force. Those are the ones that go around on the small boats with the RPG launchers and machine guns and capture tankers and all that. That's a completely separate force from what we're talking about today. We're talking today about the actual Iranian Navy that has a traditional Navy mission of defend the nation from the sea and guard the coastlines and whatnot. So the Jamaran-class frigate is operated by the Islamic Republic of the Iranian Navy, or the IRIN, and consists of 4 vessels that are built domestically between 2007 and 2021. The Jamaran-class frigates are significant in advancement. This is the most modern ship that they run, but they keep the ship up to date by reverse engineering a lot of technology. Like they still have, from the 1970s, some American technology that Iran was using back when they had friendly relations with the United States. So they've continued to try and manufacture 1970s level of systems, as well as buying foreign systems from China and whatnot, like we'll talk about today, to upgrade and keep these ships modernized. For example, they shoot the C-802 subsonic anti-ship missile. And they've also reverse engineered to make that their own, called the Gadir, which has a little bit longer range of 200 kilometers than the typical C-802 has of about 120 kilometers. They also shoot the SM-1, which is an American surface-to-air missile, but certainly isn't the American surface. They're not buying them from America. They're simply reverse engineering the ones they had from the 1970s and making improvements on their own, but it still looks and performs much like the SM-1 Block 5 does. Now, there are different weapon and sensor configurations on every one of these 4 vessels. So we're going to go over those differences in detail in this lecture here, okay? And I should mention that there are 3 additional ships under construction, so they're not done building this class. Like I said, it is the backbone of the Iranian Navy. All right, so where are they built? Well, they're built in Bandar Abbas, and because Iran also has a shoreline on the Caspian Sea, they have a shipyard up in Bandar Anzali for their Caspian Sea fleet. So 2 fleets for Iran, Caspian Sea, and then the Blue Water Navy down in the Persian Gulf. All right, let's talk about weapons and differences here. So this ship is pretty well equipped, has lots of weapons, as you can see here. The IRIS Jamaran, which is the lead ship, has 4 SM-1 missiles. But the Dina has 2 Menrab in its place. The third ship, the Sahand, has 2 Saivad and Saivad 3 missiles. And there's a 24-cell launcher that's only on the lead ship there on the front. And what we're going to do is we're going to break down each one of these ships for you in this lecture so you can see the difference. But this is the lead ship you're looking at right now. These are the missiles that came with it. And for whatever reason, they did not build consistently these weapon systems on every ship in this class. It was probably due to a lack of availability, but that's just speculation on my part at this point. Let's look at sensors real quick. So each ship also has a different sensor configuration. So we're looking at the Jamaran. This has the ASR 3D air search radar and the Decca 1226 nav radar right there. But the Dina has the ASR 3D radar with the Decca 1226 and a Sayman radar, which is derived from the WM28. Now, don't let all these names and numbers confuse you. We're going to break all of this down. The big thing you want to take from this right now is that of the 4 ships constructed so far, even though they're the same class, have very different weapon and sensor configurations. So let's look at some of these differences. Let's begin at the top with the red bubble. Here we're comparing the lead ship Jamaran with the follow-on ship Dina. The red bubble, Dina has the Seaman WM28-like radar there at the top. You can see it's a little round ball, right? Whereas the Jamaran has the older style radar. Let's move down to the weapon systems in the green bubble on the bow there. The Jamaran has a 24-cell launcher, where the Dina has 2 Emran SAM, surface-to-air missile launchers. If we look at the blue bubble, this is the ASD 3D radar for the Jamaran there at the top. And look at where they put that 3D radar on the Dina. You know, it's a different location. And then finally, the yellow bubble. Here you can see the Jamaran has an SM-1 launcher and the Dina does not. So it's hard to believe that these are all the same class, but they are. They're just wildly different configurations for each one. So here's the construction list for you. These were originally laid down in 2004 and continue to be built today. As of right now, there are 4 active duty ones. And this ship has a bad reputation as being a cursed ship class because they've had some incredibly unfortunate and unlucky accidents. The first one we'll talk about is the one that happened in 2018, where one sank in a storm in the Caspian Sea, but was refitted and refloated, and so they did not lose the Damavand. The Damavand was simply blown off of its pier. They didn't get navigation up in time, and they were reportedly blown into a jetty that ripped a hole in the side of the ship. It was partially flooded and sunk and then refloated. And then finally, one that's under construction right now, the Talier, did accidentally fall off of its blocks. It overturned during construction. And that is something that is very common if you're not careful when you're building these ships. The keel blocks are very finely balanced. And if you put too much weight on one side as you're building the ship than the other, they can fall off. So here's a picture of what happened to the Damavand. As you can see, it was blown against that jetty there, and those rocks just ripped that hull open like the Titanic, and it sank. But it was so shallow, it couldn't be completely submerged. So they were able to repair it enough to refloat it and move it off the jetty back into the dry dock, where they did a complete repair. And this ship is returned to service now. So it took them a long time to fix it, but they did. The IRIS Jamaran, the lead ship of this, was conducting a live fire exercise in May of 2020. And they accidentally shot a support vessel that was participating in the live fire exercise. I believe it was the patrol ship that was keeping other traffic away from the live fire exercise. And the missile after launch, which was the C-802, which is based on the Chinese design, locked onto that ship instead of the target barge and killed 19 people. Bit of a tragedy there. Also very unlucky, but they didn't follow proper, range live fire procedures. And this is what happens whenever you don't have, a rigid routine of safety around these. You don't see this happen in the United States exercises that we do. And that's because we have a strict set of rules that keeps everyone at a safe distance. Clearly, Iran did not exercise those style of rules, even if they have them. They may not in this exercise. And there you can see the ship that fell off the blocks. It's been under construction and continues to be under construction, but it fell off the blocks in Bandar Abbas in 2021. Sadly, this did kill a shipyard worker. So this is a cursed class. All right, so Jamaran, by the numbers, has 2 or 4 diesels, 2 shafts and bow thrusters, can produce 20,000 horsepower. About 1,400 tons fully loaded, can make 18 knots, which is reasonable for the amount of horsepower that they can generate with those diesel engines. Has 4 NOR C-802 or C-802 Alpha anti-ship missiles, and that's the main weapon here. This ship is designed to go out, detect aircraft, and deal with it if it needs to. But carrying around these 4 anti-ship missiles is the purpose of this ship. It also has 4 standard SM-1 Block 5 on the lead ship, surface-to-air missiles. The other ships have different surface-to-air missiles, more domestically produced. A 3-cell launcher for the Syed 2 or Syed 3 is on hull 74. 2 Mehrab is on hull 75, and a 24-cell launcher is on hull 76. They have 76 millimeter main guns and a 140 millimeter or 30 millimeter defensive gun there on the side. They also have 20 millimeter and 12.7 millimeter machine guns mounted port and starboard, and 2 324 millimeter torpedo tubes. Those are the pneumatically launched lightweight torpedoes that go out and are anti-submarine torpedoes. They don't even see surface ships. They have a ceiling on them that whenever they launch them, they go down below that ceiling, whether it's 20, 30, 40 feet, it's variable, and they'll never come back up above that, so they can't hit a ship. But it'll look for a submarine in the vicinity and find it and hit it if it can. Okay, so the AB-212 helicopter doesn't have a hangar here, so they cannot store the helicopter. But the helicopter can land, bring supplies, bring troops, and also provide support. So because of the no hangar problem, they have to stay within range of a helicopter facility if they want to use the helicopter, which means, in effect, this is a coastal defense frigate, which serves the purpose of the Iranian Navy. They're not projecting power outside the Persian Gulf. They're patrolling the Caspian Sea, they're patrolling the Persian Gulf and into the Arabian Gulf a short distance, but they don't need to go very far to achieve their goal. They also have on the sensor side, like I said, the ASR 3D radar. That's on hulls 75 and 76, or the Peasley AWS on hull 74. They have the Rakel-Decca 1226 radar on hull 76, or the SPS-10, which is based on an American retrofit or reverse engineering on hull 74. They have the Sea Hunter fire control radar and the Samian fire control on hull 75. The Furuno navigation radars are common throughout the world. Those are actually commercially available, but it's not uncommon for countries like Iran and even China to buy a Furuno radar and stick it on a warship. It's a very good navigation radar. Okay, so the Decca RDL A2AC radar warning system It gives them a bearing and power level, pulse rate, and other information of radars out there. The Rascal FH5 high frequency and direction finding system does the same thing. Give them a bearing to a radar. And finally, they have the Mark V rocket flare launchers, so they can illuminate and fire other things out of these launchers. To my understanding, this is not an ASW capable rocket. It's simply chaff flare and defensive rockets. All right, so now we're going to start breaking down these systems. I've thrown a lot of names at you to this point, and I understand that. So here we're going to talk about them in detail. Let's begin with the main air search radar, the ASR 3D radar. It's indigenous. It is both passive electronically scanned and long-range radar. Mounted on Hull 76 and 75. It operates in the S band, which is the NATO EF band, 2 to 4 gigahertz. Instrument range is out to just over 110 nautical miles, can be deployed on shore or ships, and is a 360-degree radar. Can track over 100 targets, really, but publicly 100 targets. It's been in use since 2013, and it may have been in service before that, because this is just the first time we saw it operating was 2013. So that's not always the first time it's been used. Let's move on to the other radar, the AWS-1 air surveillance radar. This one, this is the former radar of the Jamaran and is active on board Hull 74, the IRIS Sahand, right now. Let's see, it's probably going to be upgraded in the future to the ASR 3D radar. This operates in the S-band as well, 2 to 3 megahertz. And has a range of about 75 nautical miles, a little bit less range than the previous radar. So we will expect this to be upgraded eventually. Here's the Contravas Sea Hunter fire control system. It's the mainframe fire control system for designating surface and air targets for the guns of 30 millimeters and above. It's on board the Jamaran and the Dina, which is Hull 76 and 75. Field of view is 6 degrees. It's kind of directional. Has lots of sensors, and max range is 24 nautical miles. This is a fire control radar for directing, guns and such. The same in FCS. This is derived from the WM-28 fire control system. Like I said, they're reverse engineering a lot of these older systems. Operates in the S and X band, is capable of tracking 40 surface targets and 1 air target. Not sure of that limitation, but that's the public information out there. And this has a range of 24 nautical miles out there. And that's that big egg-shaped radar on the top of Hull 74. Could be upgraded in the future as well. It really depends on, the time and the budget. How much money do they want to invest in these? It might be better, and this was what they appear to be doing, is just building new ships, because we're going from 4 to 7 of these, right? 3 under construction. We'll probably have the newer ASR 3D radar instead of these older ones. All right, the SM surface-to-air missile. This should look very familiar to everybody that is familiar with American systems, because they basically have kept the SM-1 alive by reverse engineering the old ones they had and building these. This is a command guidance semi-active homing radar. It's on board the IRS Jamaran. That's the lead ship only. Has a range of about 20 nautical miles, 115 kilogram warhead. Was inducted by Iran in 1988. So as you can see, it took them 10 years to figure this thing out. It does Mach 2, has a solid propellant ignition, and a ceiling of about 82,000 feet. This is a surface-to-air missile that will knock your plane down. But being a very old design, modern evasion techniques can probably defeat this thing pretty easily. It's not nearly as good as even the SM-2 that we still operate in the United States Navy. We stopped operating the SM-1 and its other variants years ago. And moved on to SM-2, SM-3. We even have SM-6 now. Anyway, but back to the Iranian Navy. They're operating these on their most capable ships, despite being 40 years old. Now, they haven't stopped developing their own systems. So this is important to understand. As much as we're going to talk about the accidents and mishaps and old equipment that they're reverse engineering, Iran is working with Russia and China to develop indigenous weapons. And this is one of them, the Syad-2, Syad-3 surface-to-air missile. It's a canister-launched missile. It's been reverse-engineered from the RIM-66 SM-1 and is mounted on the Sahan-74. And range is somewhere between 60 and 120 kilometers. Okay, so we really don't know the range, but obviously the Syad-3 is probably 120 kilometers. All right, here's the C-802 NOR missile, Indigenous Development Long Range Anti-Ship Missile. This has internal guidance as well as radar guided for terminal homing. Has a large 160 kilogram warhead with high explosive semi-armor piercing capability. It's a sea skimmer. It's subsonic, has a range of about 65 miles. This is very much a harpoon. This is the Chinese ripoff of our harpoon from the 1980s, like the original Mark I harpoon. Yeah. The harpoon of today is very different, but this is the old school 1980s harpoon, copied by China, sold to Iran, who then made their own version, and it's still only 65 nautical miles. But hey, it'll hit a ship if the ship doesn't evade. All right, Sancta Moskva. Anyhow, the C-802 missile. This is an upgrade version of the NOR. This is the Alpha they got here. This has the longer range, slightly larger warhead too. More ECM resistant, but take that with a pinch of salt there. These are still not as ECM resistant as today's standard is in the United States Navy anyway. It's really unfair to compare these, even China weapons, to the American system, so I should not do that. But just keep everything in perspective. We're talking about essentially a developing country using Chinese reverse engineered or stolen IP to build their own version of these reverse engineered weapons. So they're never going to be as good as the original. And they're decades behind anything the West has. All right, the 76 millimeter Fajar 27 gun. This is the unlicensed copy of the Italian 76 Malrana gun, which is a good gun. The Italian gun's really good. So if you're going to copy one illegally, you might as well copy a good one. So good job for doing that. They didn't choose the Chinese copy that jams all the time. Has a fire rate of 85 rounds per minute and has an elevation of nearly vertical. So this thing can be used, depending on the round, against ships or airplanes, which would mean that it would need an airburst shell as well as a high explosive shell. Here are the point defense weapons. You can see the Kamen gun, very similar to the Russian design. Yeah, it's an AK-630 clone. This is mounted on the Shahad, which is hull 74. Has 6 barrels, 5,000 rounds per minute. Has a range of 8,000 yards or meters, but effectively only out to 44,000. Magazine capacity is 2,000. Now, we're going to go with that number. Just know that other variants of this style of weapon have a battery that can reload it, but this one, I believe it has the 2,000 rounds just in the turret itself. And because it's point defense, if 2,000 rounds doesn't do the job, you're probably not going to have a chance to reload it anyway. And finally, the 40 millimeter FAT gun, which is an unlicensed copy of the Bofors. Again, Bofors, excellent gun. The Bofors 40 millimeter L70, outstanding. So again, they're copying good systems. Just understand that these are not indigenous. They did not come up with these on their own. Rate of fire is between 240 and 330 because you can do several different settings. And it's mounted on the Jamaran, which is the lead ship, hull 76, and the Dina. And there's the helicopter. Since it's just a helicopter pad, I suppose you could land any naval aviation helicopter, medium-sized helicopter on it. These Bells have been in service since 1972, all the way back when the Shah of Iran was cool with the United States, and they managed to keep these old girls running. The Bell helicopter design is fantastic, and this is a testament to its design and construction, and as long as you maintain it, it'll run forever, it seems. Speed's about 140 knots, service ceiling is just over 16,000 feet, over 200 nautical mile range, crew of 2, weighs over 6.2 kilograms there. But just be aware that more than the Bell helicopter can operate on these ships because it's literally just a helicopter landing pad for small and medium helicopters. All right, final thoughts on the Jamaran-class. Like I said, it's the backbone of the Iranian Navy, and they actually do a really good job of coastal defense. which is their primary. They don't harass shipping. They don't capture tankers. That is a different branch of the armed services that Iran has. Okay, these are real sailors with real, traditional roles. All ships are built in Iran. It's all, indigenous, if you will. But they all have different configurations, which makes this a very difficult lecture to understand. And I completely encourage you to go through the slides that are provided as well as the photos so that you can see for yourself how each ship is a little bit different. And not to mention, all the equipment is some form of reverse engineering of another system. So that adds to the complexity here. But feel free to, listen to this lecture as many times as it takes to get a good idea of what's going on here. But this is the state of the Iranian Navy. This is just how they operate. They're doing what they can with limited resources. So the Iranian defense industry generally uses reverse engineering. Like I said, these ships represent the blue water capabilities of the Iranian Navy. Keep in mind, this includes the Caspian Sea that is often not mentioned in the West. But obviously the countries that, including Russia, that border the Caspian Sea, it's very important for them. So let's keep an open mind about that. And finally, and I'm sure I'll get comments on this, so let's correct this now. Iran does call this ship a destroyer, but it's not. It's at best a light frigate. It's a light frigate in build, in size, and in mission. But Iran, wanting to make their ships sound more capable than they actually are, will call this a destroyer. So whenever you go onto the wiki page or whatever other public sources out there, you may see different descriptions of this, including the ship class. Iran has its own indigenous name for this class. There's an Iranian name for it that's not Jamaran. But NATO calls it Jamaran, and that's what we're sticking with to be consistent in this series, is we're using NATO names. All right. And that, my friends, is the latest on the Iranian Navy's most capable ship. It is a frigate, and this is what she can do. All right. Thanks for watching, everybody. Welcome to the Kee Lung-class destroyers ship brief. This is a very interesting story of American and Taiwan and even Iranian naval history. These destroyers were originally the Ayatollah-class, as they were named by U.S. Navy personnel while they were being built in 1979 and 1980. 81 was when they were, 3 of the 4 were commissioned. The last one was commissioned in 1982. And they were approved originally by Congress in the 1970s to be built for the Imperial Navy of Iran. At the time, we had very good relations with Iran, and we were building 4 of these ships based on the Zumwalt-class destroyer hull and systems, but they were going to be called the Ayatollah-class, and 4 sold to Iran. Well, as you may know, in 1979, the Shah of Iran fell, and a new leader was installed, and there was a loss of confidence and all sorts of relationships between the United States and Iran dissolved, essentially. And so we had these 4 ships that the Navy immediately canceled the sale to Iran because of the coup and the change of leadership in Iran. And originally they were going to just scrap them. They're like, we just built these 4 new ships, don't know what to do with them. They decided to commission them anyway into the U.S. Navy as the Kidd-class. This is how the Kidd-class destroyer was born. It was originally a Zumwalt-class destroyer, modified to operate in warm weather with more cooling systems for the engines and other systems on board, as well as additional air conditioning to operate in those hot Persian Gulf and near equatorial environments. And the Navy used these 4 ships for 2 decades in the 80s and 90s as the Kidd-class destroyers, basically a modified Zumwalt-class. And then we sold them to the Republic of China, Taiwan's Navy, where they serve to this day. And that's what this lecture is about, is the Kee Lung-class destroyer, formerly Kidd-class destroyers, and even formerly before that, Ayatollah-class destroyers of the Taiwanese Navy. So these 4 ships that are built, they have 2 Mark 45 Mod 2 127mm naval guns, 1 forward, 1 aft. They have 2 Phalanx 20mm close-in weapon systems for point defense. They have 2 Mark 26 twin-arm missile launchers, one forward, one aft, and those can carry SAMs, they can carry the RUR-5 ASROC, they can even shoot the Harpoon missile, and they have additional Harpoon missiles on board, 8 in quad launchers. 2 Mark 32 triple launchers, triple torpedo launchers, that's one port, one starboard, for shooting the venerable Mark 46 torpedo. And we'll go over all these systems in detail today. Here's the weapon systems. If we begin on the bow, we can see the Mark 45 gun there, and behind that, the very unique silhouette of a twin arm launcher standing vertically. Below that is the weapon's missile magazine, and there's a number of different kinds of missiles in that magazine, including SM-2R and RUR-5. The quad box launchers are midships, 4 tubes face port, 4 face starboard, and they'll shoot a modified version of the Harpoon missile. It's the 84L. They have the Mark 15 phalanx systems. One's above the bridge and one's above the helicopter hangar, forward and aft there. And then on the aft end, just behind the helicopter pad, is another rail launcher, twin rail launcher, and another Mark 45 127mm gun. If you were to look at this and see a Spruance-class destroyer, you would be forgiven. It is very similar in appearance and all that. It's just the systems on board, the climate control and the other cooling systems that are not visible from the outside are modified. So here are the sensors. Your standard set for Cold War, late Cold War era U.S. Navy sensors. We have the SPS-55 radar at the very top, and we'll go over all these. SPS-49 radar, which is its